Hello and welcome. In this session, we are going to see how to set up an EC2 instance with password, and we are trying to get rid of the private keys. So I have listed all the steps on a notepad, and we are going to launch an EC2 instance for testing our PostgreSQL installation and doing a lot of testing on that. We start with the introduction of EC2. In EC2 instance, by default, they do not allow the password authentication. So if you need to log into an EC2 instance, you have to go with the private authentication. That means you have to use the private key so that you can authenticate, and it is going to allow you. But for our testing purpose, wherein we have to do a lot of testing, wherein I believe hundred of times you have to install the PostgreSQL, you have to do a number of things. For that purpose, just to do it on a fast forward manner, you have to launch EC2 instance. You have to set the password authentication. Though from the cloud perspective, it is not recommended to use the direct password. But for just our testing purpose, we are going to launch EC2 instance, and then we will get rid of the authentication, which is through the private key, and we will set up the password authentication using user ID and password. So let us quickly go and launch an EC2 instance. This is the prerequisite. So you need to have this console ready. So I'm going with the free tier only. I'm going to launch Red Hat Linux. So we are not going to discuss what are all these details. So it is just quick, and we just wanted to have it accessible from our local system, and we are just going to access it using SSH. So we'll say just launch, and we are going to launch the instance. So within 30 seconds or so, this instance will be up and running. So what do you need is you need an EC2 instance which is getting launched. You should have the putty already available on your system, and once it is ready, what we will do is we will using the public DNS. So if you just scroll it up, what all you will see is this is still coming up. So this should the 2 by 2, this should be up and running. So it is still so to log in, you need to use the public DNS, and this is the public IP. On the left hand side, you will be able to see the private DNS and private IP. So for the login, we are going to use this, and okay, this is getting initialized. I have the private key already downloaded on my system, so I'm going to use the already created authentication key. So let's quickly go ahead, and so I'm just waiting for this to get launched. So once it is done, we will go with the steps. So these are the steps. The first thing, that you have to log into the EC2 instance using the username and the password. In my case, it is RHEL. The user is EC2-user. If you have Ubuntu or Debian, so make sure that you use the proper user ID and the private key which you have already downloaded, or you need to create it, and you should have the access to it. In our case, we are going to use the putty, and let me check. Still, it is getting initialized. So once you are able to log in through the console on putty, what you will do is um, because EC2 user, if you do the sudo, it has the sudo access by default. So if you simply say sudo PASSWD and the username, in the logged in user is EC2 user, so it will enter for the new password. So you just change the password, and from here it is going to start. And in the next step, what you have to do is you have to look for this file etc ssh /sshd underscore config. So what you have to look in for is password authentication. What you have to do is you have to modify the password authentication. By default, it is no. You have to modify it to yes. In case you wanted the root login for any purpose, but in our case, we don't need it, but you can search for the permit root login, and you can prohibit password to yes, and then you can say permit root login to yes, and then you save and exit. Finally, you need to restart your SSHD services. One more thing, extra thing we are going to do is we are going to disable the SE Linux, because that creates a lot of problem for our testing or demo environment. So we are going to remove it. And what we will do is then we will log into the EC2 instance using the user ID and the password which we had set up in the earlier step. And there is one more step which we will do is we will set the host name. So we will say sudo host name CTL set host name, and we will give some name. That's the way we are going to do it. I hope by this time this should be up and running. So instance is up and running. So let's go ahead and launch it. So I have given the access location to my EC2, um, the private key. The EC2 hyphen user is the user ID. It's logged in. Let's go to the first step. The first step says we need to change the password. So you say sudo passwd and the currently logged in user. So we are saying sudo passwd EC2 user. Just give some strong password. So I'm setting up the password. Oops, seems. Yes, it is done. We have set the password for EC2 user. Now the next step we will do is uh, we will look for this file etc ssh sssd underscore config. So you need to use sudo, and the first thing which you need to look for is password authentication. So by default, this has been set to no. We have to make sure that this is password authentication is changed to yes. This is changed to yes. And in case you wanted the root login and those details, you make sure you do this thing. But for our demo, this will never be required. We have the sudo access, and we will give the sudo access using EC2 user only. Now let's save it. This is saved. And then the next step is restart the SSHD service. So we are saying systemctl restart SSHD. So it is restarted. If you wanted to check the status, just check it because it doesn't prompt for anything. So it is up and running. The next thing which will you can do is for PostgreSQL we have to disable the SE Linux. So by default you will see there is something called as enforcing. So you need to make sure that you change it from enforcing to disabled. The next step which you will do is let's log in, or what we can do is okay, let's go ahead and log in. I'm opening a new putty session. I will feed in the public DNS and just say open. It is going to prompt for the password. So you can see that it has prompted for the password. So just enter the correct password which you have. Okay. So I'm able to log in now. You can see that this is the user ID and this is the private host name. So what next we need to do is, though we have made the necessary changes, one more action we have to do is, because most of the time this is not the desirable host name. So we will say sudo host name CTL set host name to some host name. Let's say I'll say this is PG host. And if you say host name now, you will be able to see that host name is changed now. And that's all about it. Like how we are changing it from private key login to password login. And next thing you can do is you can reinstall install your PostgreSQL 13 from here onwards. This is not advisable to use without the proper security, but this is just for our short demo wherein you can do the testing and you can destroy the system. So for my purpose, I have already done it using the password, and in case I need to install, I'll do it. I'll play around it, and then I'll destroy it. So just to recap, what we have done is there are just 4 steps. First step, you normally log into the EC2 instance using the private key. The second step, you just change the password using sudo passwd and the username. In the third step, you have to modify the sshd_config file, and there is a line which will say password authentication. By default it is no, you have to make it to yes. Then you restart the sshd service. Then you disable the SE Linux from enforcing to disabled. Then with the new password, you open a putty session, fit in the public DNS, and user ID is EC2 admin user, so EC2-user, and then it will prompt for the password. Put in the password, and then you will be in. In case you change the host name, because for our demo we will be doing that, so we will change the host name. This is our EC2 instance with RHEL, so you just need to do where is the command, sudo systemctl set host name, and you have to give the new name, and it is going to change from the default host name, which is the internal IP of internal private IP that it shows as the host name. So we will make it more readable format so that that can be used. I hope this is going to help. Thank you. Hello and welcome. In this session, we are going to learn why PostgreSQL has been so famous and who are the top cloud providers which are providing the PostgreSQL as a managed service. So you can see I have put 3 logos. So I'll be just talking about those. That's a basic introduction, who is providing and in what form. And then we will talk about the basics of PostgreSQL. Okay, so these are the 3 top providers of PostgreSQL in cloud. So the first one we are going to talk about, it is AWS. So AWS is, if we talk about the open source databases, so open source relational databases has been in demand because of their increasing popularity, because of no licensing, and in the terms of the features which they are being added on regular basis, the new versions which are coming up, and they are according to the requirement of the industry. So let's talk about the Postgre, because we are talking mostly about Postgre in this slide, like who are the top providers and in what form it is being provided. So if we talk about the AWS, AWS is providing PostgreSQL as RDS in terms of the managed database instance. So they provide PostgreSQL as PostgreSQL RDS instance, and that is having all the major releases so far. I think 13.3 is the current release which is being provided, and same is for the Amazon Aurora cluster as well. So Amazon Aurora cluster is having the 2 engine. One is for MySQL compatible and another is for PostgreSQL. So this is also being in good recent news because of its popularity and the amount of the clustering solution it provides for the Postgre. It's tremendous. On the parallel side, we'll talk about some of the open source databases which are very popular and being provided as a managed service from AWS. So it is MySQL and MariaDB. So if you have worked on MySQL, then MariaDB you will not feel any kind of difference because it is a fork out of MySQL. We are not going to talk about the Redshift cluster, wherein at the backend it is going to use the PostgreSQL database as an engine, and it is really used as a data warehouse. And using your database migration services, you can convert the schema from other database engine to PostgreSQL. Let's say you have a big data warehouse of Oracle database, and in case you wanted to convert it to PostgreSQL as a data warehouse solution, so you can use the Redshift cluster. So back behind the scene, it is going to use the Postgre as the database instance. So that's the basic about the AWS, which is providing the open source relational database PostgreSQL in cloud. If you talk about the Google Cloud is also providing PostgreSQL in terms of Cloud SQL. So when we say about the Cloud SQL, it is an umbrella which provides three types of relational database service. One is managed MySQL, like AWS is providing, and another is PostgreSQL, which we are talking about. So this is really doing a lot of things, because if we see its report in 2020, fourth quadrant, this has been in news because it is doing tremendously good. So Cloud SQL is really going good in terms of the PostgreSQL and managed MySQL. We are not going to talk about the enterprise level database, a relational database SQL server, but Cloud SQL, it provides PostgreSQL as Cloud SQL. If we talk about the another major cloud service provider, it is Microsoft Azure services. So you can Azure is also providing PostgreSQL as Azure database for PostgreSQL. If we talk about another relational databases, so it is being providing for the MySQL and MariaDB. So you can see PostgreSQL has been so popular that all the top service providers for the cloud, they are providing it as a managed instance. And the reason being is on continual basis there has been a lot of development which are going on at the community level for the Postgre, and this is one of the most favorable relational databases which are available in the market, and it's day by day it is trying to phase out the enterprise level database. So we are not going to talk about the why about the comparison with the enterprise level relational databases with the PostgreSQL, but yes, the kind of the extensions which are coming up, the kind of the development which are happening back behind the scene, and the PostgreSQL is doing great. So the current stable version is 13, and current preview version of 14 is in testing phase. There's just a basic which we have seen earlier as well, like what is PostgreSQL. PostgreSQL or Postgre, they are one and the same thing. It is a free and open source relational databases, and there is a big community which works behind the scene, and they work mostly on the extensions. Day by day developments are happening, and then it is given to the community. If we talk about the relational database like PostgreSQL, it has an SQL compliance. So if we are not already knowing about the SQL compliance, that means there is kind of directory which says I believe it is 177 features of SQL compliance. Say for example, the create table, select table, insert in the table, or these are some kind of SQL compliance. So there are about 177 SQL directory list. Out of that, PostgreSQL is meeting the condition of 170. So this is one of the relational database which is so close to the SQL compliance, and this is also known as the world's most advanced open source relational database. And as you have seen in the previous slide, all the topmost service provider of the cloud, they are working on it and they have given it a place as a managed service. If we talk about the history, it was first in 1996, it was named as the Postgre, and it is it is successor of the database which was called as Ingress, right? And in 2007, it was renamed to PostgreSQL because of its compatibility with SQL. And so PostgreSQL or Postgre, they are one and the same thing. What are the features of the PostgreSQL? Since we know it is SQL compliant, so it supports transaction. And if you say about the relational database, it has to support the ACID property. Say, for example, the bank application. Each and every transaction which is happening, it has to be atomic, consistent, isolated, and durable. We are not going to talk about what are those, but it is like it is so popular that it is trying to make its own place in the industry, right? And it is also being used as a data warehousing solution like Redshift cluster, which is being offered by AWS as PostgreSQL database managed service. And most of the database service providers in the cloud, if you talk about AWS, you talk about Google or Azure, they have provided the inbuilt support. They have the database migration services. What is that doing? It is making sure that whatever uh, uh, enterprise databases you have, using their service, you can transform that to, you can convert them to PostgreSQL. So it is not like 100% migration is automatic. There are some of the things wherein you have to take manual action because there is a difference in the engine, and it is a kind of heterogeneous migration. But the idea behind this is, if topmost service providers are providing this kind of migration services, that means PostgreSQL is doing great. And this is something which is asking all the engineers which are in this field to learn and work on about it. This is just a basic of the background history. Like 1982, it was called as Ingress, then it was called as Postgre, and it was being used in Berkeley. And then for the first time in 1994, it was released as Postgre. 95 version was released, and now it is version 3. And from 1996, its first release version 6.0 was released. Since then, it is in news, but in recent years, it has been very, very popular because of the kind of the community work which is happening and the kind of support it is being brought up. And all the service providers, we talk about the cloud, they are offering new features and the extensions which are in place. So one of the most important feature of PostgreSQL is multi-version concurrency control. So it is like you can have concurrent access to data. And in the multi-version concurrent model, what is happening irrespective of the current state of the database, you can see a snapshot of the database, like how it was sometimes uh, ago. So it is something like you can see the data which was available earlier as well. Though there are a lot of pros and cons which are causing the slowness in the database, and you have to perform some kind of vacuuming, you need to delete the dead tuples, but it is part of, and it is being offered as one of the best feature from PostgreSQL. It is synonymous to your locking mechanism, which is there in your enterprise level relational databases. So since it is not offering that kind of locking, uh, so it is becoming so popular. There is a concept of a schema like other enterprise relational databases. So you have this kind of concept over here. So you can create a schema over here. So multiple schema, and if you wanted to use the same name, so those can be used over here. So nothing different from others, but it is like these features are available. There is a huge support for different kind of database data types, and some of the newer type of data types which are not available in other databases. We are talking about both open source and the enterprise level relational databases. Asset compliance, we all know what it is, and PostgreSQL is compliant with that. That's why it is being used in most of the OLTP applications where this kind of compliance is required. We have a lot of database administration tool which are available. So if you're working in the cloud also, and since you do not have the access to SSH because we are using the service as a managed service, so port number 22 or that kind of accessibility to the operating system is taken away, but you have the tools using which you can connect to the database which is hosted in the cloud. So you can use PSQL, or you can use the PG admin, or if you have PostgreSQL Studio, so you can use these. So as a cloud native tool, so PSQL is supposed to be one of the strongest tool in terms of the CLI. If you are familiar with the PG admin, the administration of PostgreSQL is very, very simple. So these are some of the service providers which are there apart from the three most uh, successful service provider of PostgreSQL in the cloud. So in 2007, it is Heroku who started providing the PostgreSQL as a managed service in the cloud, and it has been very, very successful. Looking on the footprints of those, PostgreSQL came up as an enterprise database by the company Enterprise DB, and it is providing a lot of features which are not being provided by other cloud service providers. So it is really doing great. When it was so successful, then the big cloud service providers like AWS, they started releasing it, and in the 2013 the first version of PostgreSQL in the cloud was released as a relational database service. In 2016 only, it released Aurora cluster which is a clustering solution, Postgre cluster, which I believe it has some 15 read replicas which you can create out of it. I believe that's the correct number. And then in 2017, Microsoft Azure released the Azure database for PostgreSQL. So the three big players, they have already released it. And then you have the Alibaba Cloud and IBM Cloud. They also released similar kind of PostgreSQL service. So in short, open source relational database service like PostgreSQL is making its place in the cloud, and it is doing really great. And that's all about it. I hope it's going to help. Thank you. In this session, we are going to learn how to launch an AWS EC2 instance and how to deploy a PostgreSQL instance on top of that. So what we are going to do is, since PostgreSQL is one of the most world's famous open source relational database, and the way it is growing up, it has taken the attention of all the cloud service providers. So if you are already there in PostgreSQL in your on-premises environment, there may be two options. Either you go for the managed service like AWS RDS, or if your applications are logged in due to some reasons, then in that case it is good to lift and shift. In that case, whatever databases you have in Postgre in your on-premises environment, you wanted to let the database run in same way in the cloud also. So you have the possibility of using the lift and shift. So what we are going to do is we are going to launch an EC2 instance, and on top of that we will deploy the the binaries of PostgreSQL 13, and then we will enable the remote connectivity, and then finally we will try to connect it using some GUI tool. So just the basics of like why we wanted to be on the unmanaged service like infrastructure as a service or EC2 instance, so wherein we have to manage all the infrastructure which is related to the management of backups, patching, the patching of the operating system, and the databases and everything we have to taken care. Where in the managed service we have everything covered up, but because of the n number of reasons, the way it works is in RDS the SSH control has been taken away, and there is a lot of restrictions which has been imposed. And if you wanted to continue with the way you are working in your on-premises environment, you just go and use the database in EC2. So whether we are going to use the EC2 instance or the relational database service, it entirely depends upon the way the application works, and it is all the ask of application only. So what we are going to do is it is a 5-step process. We are going to launch an EC2 instance using the AWS console, and then we will try to log in it through the putty, and then we are going to configure the remote connection from the local system. Then we will try to connect it using the pgadmin and the command line interface. So let's quickly start up. So I'm already logged into AWS console. I'll say just launch instances. Okay, let me create an instance. So we are going to use the free tier instance. So the best way of learning and practicing the open source relational databases or the NoSQL databases is just go ahead and quickly launch some of the free tier EC2 instance or from some other cloud service provider, the lightweight virtual machines, and then you can log into that. Or if you have already some local virtual machines, you can use that as well. So I'm going to launch RHEL 8 system, which is in free tier, and that's more than enough, one virtual CPU and 1 GB of RAM. I'll just say next, configure instance details. We are going with all default settings. We are not going to get anything which is non-default, so everything will be default only. And we'll say next, add storage. We are going to use 10 GB of the storage, which is more than sufficient for our testing purpose. And then we will say add tags. We are not going to tag anything. Then we will say configure security settings. So this is very important if you talk about any relational database or any other database. You need to ensure that from where you wanted to access your system and what port. So one of the things we will be doing is we will be accessing the putty session using port number 22, and I'll be using my IP address. So, or you can mention the IP address of your system, so it will pick up that as well. So let us say my IP, and I'll add one more rule. This is for PostgreSQL. Once we install that, I wanted to allow the port of PostgreSQL as well, so that we can access it remotely. Let's go with I will try with those and we'll see how it works. And then we will say review and launch. I have already created a key pair. I'm going to use that. So I do have an access, and we'll say launch instances. It is not going to take more than 1 minute or so. Once it is available, then we will see how to connect with that. Still it is in pending state. It is still initializing. So once it is done, it is still initializing. So okay, we have all the details over here. We will go to the networking, or simply we can say action or connect. Still it is getting initialized. We'll try to access it using the putty session, and okay, this is the public DNS which we have to use. And let's go to the putty session. This is the public DNS, and we have to go to authority, and we have to give the location of the key. So it is ec2-user. Those details are already over here. So we are logged in. Now what we are going to do is we have completed the first two steps wherein we have logged in. Now one of the things which we should do is we should disable the firewall. So just say, I think I have mentioned the commands over here. Okay. SC status. So as of now it is enabled only. So we are going to disable it. So vi config, and instead of enforcing we will say disabled. I should have used a sudo and just mention disabled. We might have to reboot the instance. Okay, this is done. Well, the next step which we have to do is we have to download and configure the PostgreSQL 13 on Linux EC2 instance. So what you need to do is you need to go to this site, and there you have to select the Linux and the version. If you simply select that, it will show you what all steps you have to do. So these are the steps which you have to follow. I have already copied it on the notepad, so we are going to just run it off. So we have to use sudo to install the requirements of Postgre. It is just 5 steps. We are getting the repository for Postgre. And there are some default modules which are available, so we have to disable those. Just disable them, and then you have to install the Postgre 13 server. It's very fast. Within 5 to 10 minutes your EC2 instance having PostgreSQL will be up and running. You will be able to access it from your local system either through the command line or through the GUI tool. Whatever you feel is better, it will be ready. You need an internet connection to perform all these steps. This is done. Go to the next step, initialize the database. This is initialization of Postgre 13 server. Then we have to enable it so that after reboot it should come up. And finally we have to start the PostgreSQL server. What we will do is, so when you install the Postgre on your system, by default it creates a Postgre operating system user, and it creates a database also, which is Postgre, and there will be a user also whose name will be Postgre. So let's switch to Postgre OS user, who is going to be the owner, and this is the command line psql, and there is a user also with the name Postgre. We have to change the password. So let's change the password of the user. We have changed it. Now the next step which we are going to do is we are going to verify if we are able to do the remote login on the same server. So it doesn't make sense when you have to say you have to log in on the same server with the IP address. So what we are going to do is so I'm logged in as PSQL. We'll say show config underscore file. So this is your postgresql.conf file. So we have to add the IP address of the system where this is running. So this is running on this. So we are going to add this. So we'll say vi. Okay, I'll show you from here. So by default, Postgre do not allow the remote connection. So anything which is on the local host, it will be allowed. So what we need to do is we need to change this. So we will say vi and listen address we have to change. Listen address we are going to change, and we are going to make it the IP address of the system. And the IP address or the host name, we'll try with both, which one works fine. Where is the IP? Okay, here it is. There is a caveat using it, but just for testing we are doing this. We have added it, and the next thing which we have to do is we have to add the IP address from where you are going to access this. So there is a file which is called as hpa underscore pg underscore hba.conf, which is Postgre host based authentication. We are going to add that as well, and at the bottom of that we are going to say who all are going to access the system. So these are the virtual IPs of the system from where I'm going to use it. So you need to check out on which system you are going to log in. So it should include those. Okay, so I have added IP addresses. In your case, you have to add the IP address of your local system. This is done. So once this is done, you need to restart the Postgre server. I'll exit from Postgre operating system user, and then I'll say sudo systemctl restart. I haven't given the permission so that Postgre can restart it. So it is done. Now let's check the status. We'll check the status. I need to reboot the server because CLinux might create some problem. And we will try to log in through the host name from the local system. And I need the host name. So the host name is, where's the public host name? This is the public host name. We'll mention it over here. So if I simply say PSQL-u Postgre and the password, which we have just set, you will be able to log in. But what if we have to mention the IP address or the host name of the system? It is saying this IP address, it should have been added in postgre hba.conf. So let me check if this is the IP address which is added or not. Okay, I think we need to reboot the system as well, and then it may work. Okay. Or we will try rebooting the system from here, and we will say reboot instance 194. Okay, let us reboot the instance. It is getting rebooted, and within a minute this should come up. I should have mentioned the IP address, sorry, the host name. Let us check the status. This is the public host name. We'll say restart the session. EC2-user. We'll say sudo su space -postgre. And let's log in. PSQL, it is not accepting, so that means it is still down. We'll restart it. Sudo systemctl restart, and then we will check the status. I need to use it from this user. So okay, this is done. Let's check the status. This is running. Now let's try to connect it remotely. So it will show us, this is my PG admin which is running on local system. So I'll say connect. I'll go to create, and from here I'll mention the IP address. Let's say public IP address is this one. The only problem will be if the ports are not opened, and it in inbound rules that should be opened, or hba.conf that should have that entry. Okay, this is saying 122.80. This is not there in the hba.conf, so we are going to add that entry over here. So it should be in this format. So what we will do is sudo su space -postgre, and we will add the postgre-hba.conf file. Go to the bottom and add this line. let's restart the Postgres services. Check the status. Okay, this is working fine. And now try to connect remotely. Okay, we already have the connection. Just say okay. Um, 122. Okay, let me check. If config okay. One 122.80.200.23. So let me check. Oh, I missed one over here. So let's switch to Postgre user and added the file. This should work now. The IP address which I mentioned for host base access authentication, it was wrong. Restart the service, check the status, and retry the connection. It shouldn't work now. You are connected. So you are connected remotely. Your database is installed on EC2, and this is what we have done. So just a recap of what we have done is we have launched an EC2 instance, and we are trying to replicate a scenario wherein we have to migrate our application or the workload to EC2 cloud. In our case, this is just an open source relational database which is Postgre, which is still running on the older versions. The newer versions of the RDS support 9.6 onwards till 13, and 14.0 it's in the preview version. And this is what we have done. As a prerequisite, we should have then access to the AWS console. We should have PuTTY and PuTTYGen downloaded on our system. We should have a GUI client. In my case, it is PG admin. Then we logged into AWS console. We created an EC2 instance with RHEL 8 image, and then we connected it to using the PuTTY. Then we downloaded the PostgreSQL 13 and started it. We enabled the remote connection. And the two important things which were here is postgresql.conf file, wherein you have to remove the local host with the IP address of the server. And then we have a postgreshba.conf file, wherein we have to add the IP address of the destination from where you wanted to connect. So those IPs we have mentioned, then we have checked the status. And one of the thing in PostgreSQL is when we install Postgre or download Postgre using yum, it creates your Postgre OS user, and by default there is a Postgre database also, and Postgre um, uh, database user. Postgre database is also there. Sorry, so there are three Postgre, and Postgre OS user is the owner. And this is how we have done it. If you wanted to transfer the workload from here, it is the things will be almost same the way you work in on-premises environment. I hope it is going to help. Hello and welcome. In this session, we are going to learn something very, which is a basic part in PostgreSQL, that is setting up the kernel parameters for PostgreSQL when it is deployed on a Linux-based system. In this case, in our case, we are going to do everything on a Okay. So everything what we are going to do is everything will be there on a Linux system, and we are going to see what are the basic kernel parameters that we need to check or set to ensure that Postgre keeps on running properly. So the discussion topic is how do we manage the kernel parameters for PostgreSQL? So this is a very basic thing. Whenever you install a database on a Linux-based operating system, then you say that if the parameters of the kernels which are required for properly running, if it is not properly set, then you may run into problems. Talking specifically about the PostgreSQL, you may run into problem if you have the multiple instances of PostgreSQL which is running on the host, or there may be a case if your database size, I think this spelling is wrong. In case your database size is very huge, in that case, there may be an issue with the kernel parameters. The default one may not be sufficient, and you may have to adjust some of the parameters. I'm talking particularly in case when you have very large database application connecting through the n number of connections. You are not using any kind of connection pooling like PG bouncer. So that's the basic kind of scenario. So before we go and discuss what are the different kernel parameters and their usage, we will see a few things which are important. So we are going to see the details about shared memory and semaphores. So buffer, it is very important component of PostgreSQL like any other relational database. So there are two terms which we will be talking over here is SHM max. So this says the maximum size of shared memory segment. By default, this is at least 1 KB, but on your system, this will be always higher than 1 KB. So uh, I think where is my, okay, yeah, it is back. So I have a Linux system which is running over here. It is EC2 instance, so it doesn't make much of sense when we check the details over here. But let's talk about the SHM max. So this is maximum size of the shared memory which will be available for your Postgre. I'm assuming either there are multiple copies of Postgre or the database size is too huge. And the another component which you need to understand is SHM all. This is total amount of shared memory available. So these two are normally same, but when you see the value of SHM all will be different because it is divided by the page size in our case as well. Then you have an important parameter which is called as SHM min. This is the minimum size of shared memory segment. So in any case, this is the least value, which is 1. So that's more than sufficient for the minimum value because that's the minimum which can be available. There are two more parameters which are SHM MNI, which says the maximum number of semaphore identifiers. And there is another value which is called as maximum number of semaphores, which is on the system wide. So these are the five parameters, kernel parameters, which you need to check when you have the Postgre running. So this is SHM max and SHM all, which are related to shared buffers, and SEM MNI and SEM and MNS. So these are the five parameters. Why number 5 and number 6 parameter, they are very important because they have a dependency on some of the PostgreSQL components, which is max connection, the number of connections which is allowed to the PostgreSQL, the auto vacuum maximum number of workers which will do the auto vacuuming in Postgre. Then max wall sender, so this is the sender parameter for the wall files. Then you have the max worker processes. And these parameters are very, very important. The moment you increase this, it has the dependency on these as well. So when you increase this, you ensure that these parameters are also taken care because they are interdependent. So you need to check these 6 parameters, 1, 2, 3, 4, 5, and make sure that according to your RAM, these parameters and according to the parameters which are set in PostgreSQL, they are set. So we'll have a dedicated session on this shared buffer. So we'll see in that. So what about the default shared memory? So if you are having a system with only one instance, and if it is just the basic kind of system, then you will say the default shared memory is more than enough. In case you have to change your settings, because let's say I have 24 GB of RAM available on my system and I wanted to allocate let's say 16 GB to my operating system, so that they will be given back to the shared buffer. In that case, we will say set the SHM max and SHM all to these values. So you can, the moment you change the 16 GB to other value, you make the approval. So this is 16 GB and this is 16 GB divided by 2048, and we will see how it is taken care. So this is divided by the huge page size. And if you have, once you have changed it, you need to either reboot your system or you need to recycle the sysctl.conf file. So sometimes the for permanent settings, you need to reboot your server. So resource limit, this is another important parameter which you need to take care. If you have multiple instances running, then you sometimes you get the you might get the error that maximum number of open files exceeded for this particular user. And in our case, this is Postgre operating system user for Linux based system. In that case, you will see this kind of error. In that case, you need to adjust the parameters so that by default the parameters which are available, they are more than sufficient. But sometimes sometimes it may be you may be in a situation wherein you need to change it. So there is a limit for the entire kernel, and for each users also you will have to check it properly. So you can check for the maximum number of open files in this, or they can be changed in your sysctl.conf. Before we go down with the Linux memory overcommit, let me show you what is there. If you simply say sysctl-a, this will show you sysctl-a. Okay, I need to come out of Postgre as EC2 user. And if I say sysctl-a grep, what is the amount of SHM max which is present in my system, which is running an EC2, this is huge. This is huge. I haven't calculated it, but this is huge because it is an EC2 instance, so they would have given set it according to the best maximum possible value, but you always have the capability to change it, so you can change it according to your requirement. And you can check the other parameters whatever you wanted to check, and if there are any changes required, you can change it. And that's what I was talking about. SHM max and SHM all, they are same value, but sometimes they may be represented in terms of SHM max divided by the page size. So just don't be confused if sometimes you see it as a different value. It is the way they are stored. And there is an important thing which you might see, and sometimes it happens also, like you will see out of memory, and this is very, very common on in Linux based system, where in operating system memory is exhausted and your PostgreSQL process may get terminated due to this. So whatever processes are running, incoming connections were already available, they will continue to work, but it is not going to allow you the new connections because there is no memory available to cater those requests. So what you can do is there is swap space which you can increase at your operating system in case you feel that you have some shortage of RAM on your operating system. Then increasing this can sometimes help you to come out of this, and it is always a good practice to have the enough virtual memory available or swap enabled on your system, just in case your physical memory is exhausted, then it is going to be used from your swap. So what is the spatial consideration if you are seeing the over usage of, and this is going to be very important. We need to check if there are too much usage of memory. Then in that case you need to check the postgresql.conf for some of the parameters which directly take the value from your RAM. So it is shared buffer, your work memory, hash memory multiplier. If you see they are not that much used, then you try to lower down their value just to avoid the issue which is coming out of memory, right? And the one of the problem with the Postgre is the maximum number of connections, because at the back end it is going to spin up one more process, and it is going to exhaust the memory on your system. If you see this kind of scenario is available in your environment, then you might test out the connection pooling, and you might try out some of the connection pooling software as well, like PG Bouncer. In that case, you will be able to manage the connection pooling, and you may adjust the value of the overcommit as well, which is more than sufficient in most of the cases. So this is something which occurs very frequently. So it is not just the operating system, RAM, swap. It is your PostgreSQL.conf parameters as well that you need to take care. What is the value you have assigned, and whether they are overused? They are oversized, and in that case you need to trim it off. Linux huge pages. So this is a great parameter if it is being used. In that case, what you have to do is you can start your Postgres without the Linux huge page. So we'll do a separate session on that. So let's see what is the current huge page. Let me switch to the Postgre user. And you simply say head minus $L $pg data postgre master post.pid. Then it will show you the parameter, and then using this parameter you can calculate what is the requirement of let me paste it over here. Yes, this will show you what is your Linux use page requirement, and you can adjust it accordingly. So let me check out. This is the default huge page which is there. And if in case you wanted to change according to your requirement, you should be able to do it. So you have the formula available, and you can use it accordingly. So this is the formula which is available. In case you wanted to change it, you can change it according to your requirement. And we have already checked what is the current value set on our system. So what happens by default, if it is available, then it is going to use it, and when in case if it is not available, then it will go fall back to the non-available value of of your huge pages. So this is going to be important, and just test it out if it works well for you. So just a recap of what are the important kernel parameters. So you should keep a check on SHM max, SHM all, SEM MNI, and SEM MNS. The formulas are also given, and you need to make sure that uh, you understand the different PostgreSQL parameters, because your kernel parameters are at the system level, and your PostgreSQL parameters, they are interrelated, and you have to make sure they are properly set. In case you wanted to change you wanted to assign a specific amount of memory for your kernel parameters, you set it accordingly, because your PostgreSQL shared buffer is going to pick the value from here. Resource limit, you have to specify it if it is you have too many Postgre system running, and in case you are facing some issues which is related to the maximum limit of maximum number of open files or something like that, then in that case you may need to sometimes, most of the times, not sometimes, most of the times, the default values are more than sufficient. Then you have Linux memory overcommit. This is a very, what do you say, the regular kind of behavior in PostgreSQL. And in that case, what you need to check out, what are the different memory-based parameter in your PostgreSQL. If they are oversized, then you have to change it accordingly. Otherwise, you need to make sure that physical RAM and the swap, they are properly configured according to the best practices or not. And this is a very general problem, maximum number of connections in your PostgreSQL. If it is too much, then try to bring it down, and make sure if you are not using the connection pooling like PG bouncer, in that case you may try to use it, and you may find it very useful. Linux huge pages, if it is enabled, that gives you the best performance in your Postgre, and just try and see what is the value which is required based on the formula which is given, and you can set it accordingly. I hope this. In this session, we are going to have an introduction to Postgre default user. So as a general info, when you install the PostgreSQL on a Linux-based system, let's say I have just installed the Postgre on my EC2 instance, and uh, this is how it looks like. So I'm already connected to PuTTY, and this is the shell. And the commands which I have used is sudo dnf, and these commands are available on the PostgreSQL website. And if you go there and you are just select RHEL8, it will show you all the commands. So this is just a list of 6 commands which you have to execute on the server, and this will install PostgreSQL database on your operating system, which is Linux in my case. So once this is installed, what is the next step which we have to do, and what are the default Postgre user in PostgreSQL instance that we are going to see? So Postgre is the default OS user, and it gets created when you install Postgre on the Linux or the Linux-based system. And there is a database user also created, which is Postgre, and this is the super user, admin user, which is going to be the owner of all the objects inside the PostgreSQL database. So you can check the authentication mode of the Postgre. There is a file which is called as pg_hba.conf, and by default, post installation, the authentication method is set to peer for all the users which are by default created. In this case, it is Postgre, and it can be MD5 in case you wanted it to make it to be password authenticated forcefully, right? So let's see how it happens. So I have just installed Postgre binary on my system using DNF. These are the commands which you can find it out, and if you just check the status sudo systemctl status, this will show you that this has been done. So see, using the sudo systemctl command, we have been able to see the status is active and running. Let's come out of this shell, and when this binary is installed, the database is up and running. We need to make sure there will be a service account who will be able to make it up and running, and that will be the owner of the PostgreSQL instance. So in this case, how to find out those details? So if you know some basics about the Postgre, so at the operating system, if you just grab etc passwd and grab for Postgre, that will show you that an OS user called Postgre has been created when you are doing the installation. And this is the home directory where the binaries are installed, and this is the bash profile. And how does the authentication happens in that case? So Postgre is the service account owner in this case. So we will switch to that sudo su space minus Postgres. And if you say PSQL, and if you locate the data directory, show data directory, there will be two important files which decides like how the authentication are going to happen. So you can see this is the location of the data directory, and inside the data directory there is a file which is called as hba pg_hba.conf. This file is responsible for host-based authentication. If you see the first line which says anything which is coming from the local, so let's say all the users or all the databases, they will have the by default authentication method peer. So in this case, I'm logged in as operating system user Postgre, who is the service account owner of Postgre instance. And how is the identification is going to happen? So there is a file which is called as, if you navigate to that particular location, there is a file which is called as pghba. Where is that another file? pg underscore ident.conf. If you see this file, it will show you how the mapping is going to happen for the particular user. So it refers to the Postgre. This file controls Postgre user name mapping. So it maps external usernames to their corresponding PostgreSQL username. For example, we have just created, or an OS user Postgre has already been created, and there is a database user which is already there. So they are mapped with each other. Right, so that's way in basic forms this works. So if you simply say sudo su space minus Postgre, which we have already done, and if you simply say PSQL, and if you see the list of the users, that will show you post installation what are the users which are created by default. So if you say /du, this will show you there is an database user which is Postgre created. It is super user. It has the create role. It has create database, replication, and the other details it has. You can find out the details using select username from pg underscore user command as well. So you can see that there is just one user which is created by default. And how can we check the privileges assigned to particular user? So you just mention the username and it will show you what all details it has. So this is the command. This is good, helpful command. Select table name as a schema and table name as table. Privilege type as privilege from information underscore schema dot table privilege. So this will show you what all it has privileges, what all this particular user Postgre database user can do, and where all it can do the things like insert, update, delete, truncate, those things. So I think there are 1,300 and something still it is going on. Since this is the database super user, so this will have so many things. All right, and let's create one user which is called as test user, and if we say /du, this will show you how many users are there in that particular PostgreSQL instance. So we have just two users. One is the default admin user, and the other is the user which we just created. And after that, if you simply say select username from pg underscore user, this will show you that test user and postgre user, these are the only two users. We can see the information related to the test user as well, and since there are no privileges, it will show you over here. So just a recap of the default Postgre user. So when you install the Postgre on Linux based system using yum or DNF, by default it is going to create a Postgre OS user. That Postgre OS user is mapped to Postgre database user, which is created at the database level, and there is a database also created by default whose name is Postgre. So just you need to make sure that there are three names which are available when you work on Linux based system. Postgre OS user by default, which is created, and that can be verified using the command etc/passwd, and if you graph for Postgre, that will show you the information over there. And there are few more files which maintains like how the authentication is going to happen. So there is pg_hba.conf, which controls the host based access authentication. So in this case, it is our local host only, wherein this authentication is going to happen at the peer level. And there is something called as one more file is there. Yeah, let me show you once again. This particular file name is called as pg_ident.conf. This particular file, this helps in mapping the OS user with the database user. So in our case, there was an OS user Postgre, and there was a database user Postgre. So that way it has automatically got mapped. I think it is going to help, and thank you. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is Postgres all about and its architecture. So the first slide is about the introduction. So what is Postgre and why it is so famous over a period of time? And this is one of the most sought database nowadays. So one of the most important feature of your Postgre database is it is an enterprise class open source relational databases. It can support SQL, which is a structured query language, and JSON, both format for querying, and it is there in for more than 20 years with the community development. If we talk about the usage, it can be used for the data store. You can use it for data warehouse, you can use it for geospatial application, you can use it for analytics. You talk about anything and it is available. It is good for all the data types, and it is well suited for all the advanced data types. And in terms of the performance, it is good like any other database which is licensed and which is very costly. If we talk about the features, Postgre is having the MVCC architecture, which is multi-version concurrency control. That means, let's say if I have fired a select statement from EMP table at one particular point of time, in a particular row I wanted to fetch, and at that same time the row has been updated, then there will be some inconsistency if I try to read data. But what happens when such operations happen, there will be a snapshot available of the previous data so that the data don't get messed up. Although this is not the feature which is only available in Postgre, but all the relational databases like Oracle and others, they do have this features inbuilt. And the important thing is this is free of cost. This is open source. And you have the granular access controls. You can give the access to the particular database to the role, or you can give access to the tables, views, or the procedures, triggers, a particular column. You can give the access. So those things, you have the granular access control. You have the concept of table spaces, or the other than your default table space, you can create a separate table space. You can keep all your data over there, and that will be useful when you are trying to take the backup. So it is just a logical kind of separation from other databases. There's a feature of asynchronous app replication, which is very good in terms of Postgre. The backup features that is tremendous in Postgre. You have the online backup. What you can do is at one particular point of time, if you wanted to restore your database, you can use the hot backup using uh, PG base backup, wherein something called as the log files, which is known as the write ahead logging, that will be enabled. If you take a backup of your base backup and all the files which are there in val, which is write ahead logging, if you take those backup, you can restore at one particular point of time, and that is useful when you create the standby database or the replication environment. It has the support for the international character set, so that is one of the other important feature. No wonder whatever the size of your database, it is going to support that. And when we talk about the fault tolerance, the write ahead logging features make it perfect suited for any particular disaster recovery when you have to recover your database at one particular point of time. Licensing, this is always bothering the organizations. If you talk about the famous RDBMS, you pay the cost in terms of the codes which you are going to use. Let's say talk about the Oracle, then you have to pay a lot of license cost. And if we are talking about Postgre, there is no license cost. And uh, more if you're going to use it on a compute where the number of CPU cores are more, then we always fear of paying more license cost to the proprietor, that is the organization from which we have purchased, let's say the Oracle Corporation. What in case of this Postgre, that if it is open sources, who's going to support it? So there is a dedicated team of contributors and those who continuously work on it. If there are any bugs, they are fixed, and the new versions are released over a period of time. So licensing, it is open source, and you have the code. You can use it, and you can use it any way you want it to. If we talk about the history of the Postgre, so PostgreSQL project was initially launched by Michael Stonebreaker at Berkeley University, which is University of California, I believe. And the original name was Postgre, which refers to the older version of the Ingress database, which was famous at one point of time. And I believe this project was kicked off in 1985, and after 10 years of development, this project was renamed to PostgreSQL because of its support for the structured query language. So who supports or who works on the development of this product? If there are any bugs or fixes, who does all so this is done by the PostgreSQL global development team. If we talk about the language support, that is awesome. It has support for Python, Java, Perl, .NET, Ruby, uh, C++, and ODBC. Everything is there. Let's talk about the architecture of Postgre. So it is a client server model. So the client sends a request to the Postgre environment. So Postgre, we have something called as memory parameters. So we have memory in the center. Then we have outside we have the background processes. So the main process when the server starts, there is something called as postmaster. So when an application, when there is a request from the client, it comes directly to the postmaster. The postmaster will check if it has all the required permissions to log in into the database. If it passes that, then there is a Postgre process spawned, and then the actual work begins. So let's say a select statement has been fired and that is stored in the data file. Then first of all, those values come to the shared buffer, and the Postgre is going to read it from there, and then the value is returned back to the client. So the application connects to the Postgre process, the postmaster process. The postmaster checks the application write, and if it is successful, then it connects the client application. The instance doesn't write or read the application directly to the data files. It puts it there in the shared buffer. And the PostgreSQL process acts on shared buffer and val buffers. Val buffers is the, if let's say some data modification has happened, then this particular buffer area will be dirty, and using the write ahead log background process, those will be returned to the val files, which are kind of log files wherein all the information will be returned, and then that piece of information will be permanently saved to the data files when there is a commit. So it is awesome in terms of the kind of work it does. Then there is a checkpointer process as well, which checks checkpoints, and at one particular point of time, your database will be in consistent mode, so that the data in the data files and memory that will be flushed to the data files. So this is just a basic. So we have the memory area, we have shared buffer, wherein the red value of from the data files are there. Then you have val buffers, wherein any data which is supposed to be, which is changed, it has to come into this area, and using the val, it is returned to the data files. Then you have work memory and maintenance work memory. If you have enabled the archiver, then the val files are moved to the archived val files. So this is just the same diagram. So we have the postmaster process, which is the main process. Then we have Postgres process. Then these are the some of the important memory areas: shared buffer, val buffer, work memory, maintenance work memory, and then you have some of the important, very important background writer, which writes the dirty buffer to the data files. Val background process, what it does, it picks up uh, the uh, the the changed value from val buffers and write it to the val files. If you have enabled the archiving, then it will be finally returned to the archived val files. Uh, the next one, it is just a description of the different. So when you say systemctl status and PostgreSQL, then it displays you these processes. We'll see it on the demo. So the first process, which is spawned after the postmaster, is the logger. So what it does, it writes the error log file to the log file. Then we have the checkpointer. When a checkpoint happens, so there are some predefined interval wherein the checkpoint happens, and all the dirty buffers, the data which has changed, it is returned to the data files. Then you have writer. Writer again, this is the background writer, which it periodically writes the dirty buffers to a file, otherwise the checkpoint happens. Then you have the val writer, which is a background process which picks up the information from the val buffers and write to the val files. Then you have one of the very good feature, which is called as autovacuum launcher. So it is kind of releasing the unused space when there are a lot of inserts, update and deletes, and a lot of space has been released in the tables. Then it does a maintenance work on that. So we'll have a separate discussion on that. Then we have archiver. So when you have the val enabled, so write ahead logging enabled, and you wanted to keep all the transaction logs, so you have to enable this so that you can safely recover your database at a one particular point of time. Then you have a stats collector. Uh, it will tell you about the table usage, statistical information. So these are the background processes which are spawned when you start your uh, uh, Postgre instance. Memory area, you have shared memory wherein database caching and the transaction log caching happens. Then you have shared buffer. So this term you can see in almost all the versions, all the engines of the database. So what it does, it minimizes the disk I/O, and what it does, it puts all the bigger tables into the buffer, and it minimizes the access time when it has to pick the data from the data file. So it puts it into the shared buffer. Then you have the wall buffers. What it does, it temporarily stores changes to the database, and when it has to write to the wall files, the wall background process picks up picks it up from the wall buffers and write it to wall. It is useful for backup and recovery. Then you have the postmaster process. So what is the postmaster process? The postmaster process is the first process which is started when you start your PostgreSQL instance, and it performs the recovery. It initializes the memory area. It runs the background processes, and the last, which is last but not the least, which is your work memory space, maintenance, work memory, and temporary buffers. These are the different memory areas which are used for sorting. So when you say work memory space, this is used for sorting and temporary bitmap operations and hash join. So the default value is 4 MB, and maintenance work memory if you have the auto vacuum enabled. So and this is used for mainly for your create index and vacuuming. Temporary buffers, this is used for the temporary tables in case you use the temporary tables. And that's it. So we'll see a very small demo which says systemctl status. So let me fire this. Systems ctl status PostgreSQL 12. So when you fire this, you will say that the status is running, and you will see all this. So you have the process ID. The main PID is 1115 postmaster, and this is what we had spoken about in the architecture. This is the first process, background process, which starts, and then the other processes are started. Logger, which logs all the error message file in error log. Then you have the checkpointer. Then you have background writer, which writes the dirty buffers. Then you have wall writer, which picks up the information from wall buffer and write it to wall files. Then you have auto vacuum launcher. It writes it does the auto vacuuming work, like when you there is a create index happening, or when it has to release the space, unused space in a table. Then you have the stats collector, and then you have logical replication launcher. So this is basic of the architecture of your uh, of your Postgre environment, and we'll quickly do a recap of what we have done. So we talked about the introduction of Postgre environment, why this is so famous. Then we talked about different features. We talked about the licensing, which is free, open source. Then history of Postgre. Then the architecture, memory architecture, background processes, and different physical data files where it is written. And then we discussed about how the data is flown when a client requests the information, and the, the definition of different background processes, and memory areas, and the work memory, area related components, and that's all. Then we checked the system CTL status PostgreSQL 12. Then we saw different background processes. Then we saw one more thing. You can see the PS3-P1115. So this shows like what is the relationship. So postmaster is the base. From here, rest of the background processes are spawned. And if you see 1271, it corresponds to the logger. I hope this is going to help, and thanks for watching. Welcome. In this session, we are going to learn some basics about the logical and physical PostgreSQL architecture. So I have placed everything in a notepad, and we are going to continue from there. So this particular topic is all about the logical and physical architecture of PostgreSQL. So the first thing is PostgreSQL has been popular from so many years because of this is one of the most famous open source relational database. And if we say in terms of its position, it is considered as number one position in terms of the open source relational database. So just talking about the few of the concepts, the first thing in this PostgreSQL is what is a PostgreSQL cluster? So if we say PostgreSQL cluster, this cluster doesn't mean the cluster which we know about in the clustering world. It doesn't mean the n number of nodes which are joined together to form as a unit. In case of PostgreSQL, a cluster is a collection of databases which is hosted on a Postgre server. So that's all about the PostgreSQL cluster. So in one cluster, there may be many databases. In one database, there may be many objects, and a data object is it can store the object at the same place, or it can refer to some remote location as well. So in PostgreSQL world, we'll say a database is also called as the database objects. So just to show you a small a bit of demo. Uh, so it's all about so when you install the cluster PostgreSQL, when you install it, let's say on Linux, then one of the final step which you perform is you execute PostgreSQL version number setup and initdb. That means you initialize the database. Once you do that in the particular location, it is going to create a number of directories and subdirectories, which stores the information directories of and files. So we discussed about PostgreSQL cluster. Then we are going to discuss about what is OID, which is object identifier, right? So in PostgreSQL, the object identifier or OID is called as the objects inside the PostgreSQL. They are stored as object identifier. So they are just 4-byte integers, and that holds some kinds of relationship. So let me quickly show you how it works. So let us create one database, and then we will see what is an OID of that particular database. So let's say PSQL. We have these many databases, and if I simply say select dat name, OID from pg underscore database, and we created a database with the name testdb. So this is the object identifier. This is unique inside the PostgreSQL cluster. And you can find the relative name as well using this command, which is for pg underscore class. So here also, oh, okay, I should have given the table name over here. Again, we will have this thing in going forward. So let's talk about the physical structure of PostgreSQL. So when you install the PostgreSQL cluster, so the one thing which comes is the base directory, right? So I'll show you how it looks like. So this is my data directory. If you simply say ESQL show data underscore directory, then it will show you this location where all the database related files are stored. So this creates all the directories and files when you initialize your database. And when we are talking about the base directory, it is created at this location. So if you see, there will be a directory called as base over here. Can you see this? This is base directory. Coming out to discuss about some of the files and subdirectories under the base directory. So let me show you over here ls-r ls-ltr grapconf. We just wanted to see what are the different configuration files. So one of the important file over here is pg underscore version. So where is that pg underscore version? Here it is. So if you view this, you will be able to see the version of the database. That's the major version of this PostgreSQL cluster. Along with that, there are n number of configuration file. One is postgresql.conf, which consists all the configuration related parameters of PostgreSQL cluster. And there is another file which is relevant to this, which is postgresql.auto.conf. That means if you have executed any alter system, and if there is a dynamic parameter which can be changed while the database is running and it doesn't require a restart, then it will be stored over there, and your instance, PostgreSQL instance or cluster, is going to read it from here. It will be overwritten by the alter system command. So there is another file which is very, very important. It is pg underscore host based authentication dot configuration file. That means the client authentication happens through this file. So all the information related to the client, like how they are getting authenticated, what should be the database name, what should be the IP, and what kind of authentication it has to go through. That all is mentioned in pg underscore hba.conf file. So if you just view this, it will look something like this. So this has the host name and let's say what is the database name, what is the username, what is the IP, and what kind of authentication method it has to go through. So that is there in hba.conf file. There is another important file which is called as pg underscore identity.conf. This file contains the information related to user mapping. So that information is stored over here. So we discussed 5 important files, and then moving on to the directories and subdirectories. So I will not uh, from here we will not try to navigate, but that will be confusing. So I'll show you base. So when you initialize your cluster, this is my location, you will see something called as base over here. If you cd to base, you will be able to see these files which contains the OIDs of the different databases which are created in your PG PostgreSQL cluster. So base, it is having per database subdirectory. So these are the OIDs of the different databases which are created inside this PostgreSQL cluster. Second one is global. This particular directory contains the information related to the cluster-wide tables. So if you just go through that pg this global, you will be able to see these files. We will discuss what are these FSM and VM related names. We have something called as pg underscore commit underscore ts. That means it contains the information related to the transaction commit timestamp data, and this is present from 9.5 and the later version. PG underscore clock, this is obsolete. You have something called as PG underscore DY and SCHEM. So this contains, if you see, dynamic, this stands for dynamic shared memory. So DYN is dynamic, SHM is shared, MEM is memory. So this contains the information about the dynamic shared memory. We have something called as PG underscore logical. It contains the data related to the logical decoding, and most of these features are available from 9.4 onwards. We have something called as PG underscore multi-exec. It contains the information related to multi-transactional status data. You have something called as PG underscore notify, which contains the information about the listen and notify related data. You have something called as PG underscore wrap slot. So this particular directory is required, or this particular configuration is required when you perform the replication from one node to another in PostgreSQL. You have something called as PG underscore serial. It contains the committed serializable transaction. You have something called as PG underscore snapshot. It contains the exported snapshot, and this has been available from a version, I believe, 9.0 onwards. You have PG underscore stat, which contains the information related to the statistics. You have something called as PG underscore stat underscore temp, which is related to temporary files for the statistics subsystem. You have something called as PD subtrans. It contains the information related to subtransaction status data. We're not going to discuss the detail because this is going to be very, very lengthy, and we'll try to see it in some other session. So we have something called as PG table space. It contains the symbolic link to the table space wherein you are going to store your data. You have something called as PG underscore true phase, which contains the information related to the prepared transaction. You have the next one is PG underscore wall, which is write ahead logging, and you have something called as PG underscore exec and xlog. These are the different directories which are available over here. So you simply say ls and you will be able to see it. It is not important you learn about these, but you should be knowing most of these. Then we have files layout structure in database. So a database is available in the subdirectory under the base directory. So if you cd to base, you will be able to see a few directories over here. So these are the OIDs of the different databases which you have created. So you can see one demo database and one test DB, and there is 1, 2, 3, 4, 5, total 5, and you will be able to see total of 5 directories over here. So these are related to the different databases, which are some of the system databases, and remaining are user created databases. So if you wanted to relate it, you can just execute this. Select dat name, OID from PG underscore database. So you can see 16390, it is the OID of test DB. If you try to find out the OID of the default database, which is Postgre database, you will be able to see it. It is 14172, 14172. So this is how it is related. And if you wanted to know how is the layout of the different tables and indexes which is stored inside the particular Postgre database, then you can do it like that. So let's say let's switch to some table, connect to one of the database, which is testdb. And let's create a table. So we'll create a table called as course. We'll select data. Table is created. Let's verify the rows. There's nothing. Let's insert some rows. You can see there are 3 rows inserted, and if you simply say find out the OID and other information related to that particular table, you can execute this, and you can see that OID of this particular table is 16397. And let us go where we have created it. We have created it inside the test DB, and let's come out of this, and let's go to test DB. Test DB is 16390. 16390. This is the OID of the database, and we created 2 tables over one table over here, uh, uh, um, and the OID is 16397. That should be available 16397. So this is the OID of the table which is created. So this is how it is related. And if you simply wanted to see the relevant path, it will be available inside the base. So I hope you are already aware what is pg_data, which is a global variable for displaying the location of the data underscore directory. You can find out the complete location using this command as well. So we'll say psql/l. Let's connect to test DB and execute this command. So you will be able to see the complete relational file path name of the table which we have created. And inside that we have seen in that particular OID, we have seen some of the files with the name FSM and VM that contains the information related to the table. So that data is stored over there. So if the file size of the table and index it goes beyond 1 GB, then it is going to create a new file with the relative file node, and .1, .2, and this way it goes on. So if you wanted to change the size, you can do it. You can make the change using the hyphen with the segment size name, and it is going to work. So that's all about the physical and logical structure. So just to recap, PostgreSQL cluster, it's not the cluster, it is just the instance which you create on one of the node. So it is cluster only, right? In one cluster there will be several databases, and one database can have many objects. The simple things like any relational database. So you have OIDs. This is the important thing in PostgreSQL. So all the objects, including your database also, they are identified with the object IDs, and this information is stored inside the database, inside the some of the important catalog tables. Then talking about the physical structure, you have some of the important file. There are 4 important configuration file. One is postgresql.conf, which contains the information related to the PostgreSQL cluster. You have something called as auto.conf, PostgreSQL auto.conf. So if any dynamic changes are made and that doesn't require a restart, so those information will be stored over here. So you have PG_HBA, which is host based authentication relation details are there. Then you have identity related details are stored over here. These are the subdirectory details, and this is available inside your data underscore directory. And we have seen some of these important directories and subdirectories which are available. Files layout, we have seen how the OIDs are displayed on the operating system, and that's the way it is mapped to the database. And inside the particular database, you can find the different tables which are stored as the OIDs. And finally, we saw how the tables are stored inside the database directory, and how their relative relational file path name we can locate using some commands. And the data is actually stored in these 2 formats, _FSM and _VM. and you can check the size, or you can control the size till what size it can grow, and it has to create a new file, and that's how it works. I hope this is going to help. Thank you. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to use PostgreSQL .conf on Postgre in Linux environment. So the first thing is, what is PostgreSQL.conf file? So PostgreSQL.conf file is a parameter file which is available on Postgre server when the Postgre server is installed, and the parameters are read when the server starts. When the server restarts, it means when the Postgre server restarts, and most of the parameters are global parameters, and they are read when the server is starting up. And let's see some of the facts about the server parameter file, which is postgresql.conf, like what is the location of postgresql.conf on Linux environment, and how do we change it, how do we check. So let's see a small demo. This is my PostgreSQL server. So I'll just say systemctl status PostgreSQL. Uh, the version is PostgreSQL 12, so you can see the status is active and running. So what I'll say is pSQL, and I'll be connected to the Postgre prompt. So by default, PostgreSQL.conf is located in data directory. So if you say show data underscore directory, it will be available at this location. Or if you wanted to see the exact location, you will have to say uh, show config underscore file. So you can write show config underscore file. So this will give you the complete location of PostgreSQL.conf file, and you can view it using the view command, or if you wanted to modify some of its parameter, you can uh, save the changes using vi, and some of the parameters require server reboot, some of them may not require the server reboot. So that is a very interesting point, like how to check which one is requiring the. Okay, this is my PostgreSQL.conf, and how do we check the parameters? So it is the parameters are listed in pg underscore settings. So if you say select name comma settings from pg underscore settings, you will be able to see all the parameters. So you can see allow system modes. So it is in alphabetical order. So I think it is close to some 300 parameters. So 314 parameters are there, and you can see the values on the right side, the parameter name on the left side. Let's see how many distinct parameters are there. So we'll say select distinct context, context from pg underscore settings. So if there is a context as postmaster against any parameter, that means when you try to modify that parameter, at that time you need to restart your PostgreSQL instance so that the changes are reflected. So we discussed about postmaster context. Okay, let's move on to the next slide. How to modify PostgreSQL.conf parameter. So we checked how to check the parameter, and then we will see how to modify it. So let's see some of very basic parameter. Like if I say show port, it will show me at what port this Postgre is listening. So it is listening at 5432 port number, or or there is a very basic parameter which is max underscore connection. So if I say show max underscore connection, so there are 100 connections allowed at one particular point of time, and if you go beyond this you will not be allowed to connect it. So let's see how do we uh, make changes to this parameter from 100 to 200. There are two ways. One way is either you edit the parameter file using BI editor and you restart the instance, or you can use there is something called as alter system. You just say alter system set max connection equal to new value. So in this case, we are trying to increase it from 100 to 200. So I'll say alter system set max connection equal to 200. So let's do that. So it has changed to 200, but this requires a reboot, so this will not be reflected as of now. So if I say show max connections, it will still show 100. So where do we find like it has gone to? So let's go to the data directory and show data directory. I think we already executed it, and so this is the location of postgresql.conf cd, one step back, and this is the data directory. So if I say ls-lrt, so there is a file which is called as postgresql.auto.conf. So if you view this file, you will be able to see the alter command which you just fired. So max connection equal to 200. So what happens when you restart your instance? When you restart your instance, this value is picked up from here. First of all, your postgresql.conf is read, and then this postgresql.auto.conf parameter will be read. So let us restart the instance. Sudo systemctl restart PostgreSQL 12. So instance is restarted. Just check the status. It is in the running mode, and now let's uh, log into the command prompt psql, and we'll say show uh, max underscore connections, which we updated using set parameter alter system. So you can set the parameter globally using alter there. So there are some parameters which are applicable for global. There are some which are at what do you say, the session level. There are some at your user level, so you need to classify them. Okay, moving on to the next one. So there are different components which are available in postgresql.conf. So there is something called so when you open it or when you view it using the view command or edit it using the VI, you will be able to see something called as connections and authentication, which will have listen address equal to localhost. That means um, this particular tutorial is not about defining what are the different parameters like, but this will give you a kind of glimpse of what is postgresql.conf, how to modify it, where it exists, and what all can be done with this. So there is, in this particular section, connection and authentication, you have listen underscore address equal to localhost. By default, Postgre do not allow the remote connections, so it is equal to localhost. So if you have to allow remote connection, you need to change this value from localhost to the IP address of the server. In my case, the IP address of my system is 71.192.168.1.71. So in case I have to allow the remote IP address connection, so I will have to add the IP address of the server itself, where server is running, Postgres server is running. Port is 5432. Max connection is equal to 100 at this present time. So you can see on the right hand side of each parameter there is change requires restarts. If you try to restart, change the value of max connection from 100 to 200, you need to restart the server, sorry, the my Postgre instance. And let's move on to the next one, connection and authentication. Then you have something called as a resource usage. So how much of resource you wanted to give to Postgre server. So by default, for our system where I have 2 GB of RAM, I have given 128 MB. So when you are tuning such parameters, shared buffer, you need to set to some minimum value, let's say 15 to 20% of the RAM. Then you need to gradually increase till the time you find the optimum usage of the RAM. So if you try to update any of the parameter like huge pages or shared buffer, it says the change requires restart. So you need to restart the change. But there are some parameters you will not see, like change requires restart, like work underscore mem is equal to 4 MB. So uh, uh, this is work area when some temporary rearrangement has to happen in the memory. So you can see it is some 64 KB, and as of now it is 4 MB. And if you have to increase the value, you do not need to. I think this can be done on the fly. The next one is well, which is write ahead log. That means whenever any change is made to the database, so before writing to the database, it has to be written to a file, which is a val log. So you have these replication parameters also mentioned in postgresql.conf. So you have sending servers, you have master server, you have standby server. We'll have a separate session for replication. In postgresql.conf, you have something called as query tuning also. You can enable the hash join or index scan. So by default, they are on. If you wanted to turn it off, you can do that as well. So you have a lot of parameters, some 312 parameters we saw in postgresql.conf. So based on your requirement, you can turn it on or off. Reporting and logging, like let's say where I wanted to record all what is happening, so you can put it into where to log. Then you have when to log and what to log. So you have all the flexibility available. Auto vacuum is one of the greatest feature in Postgre. So any unused space or any kind of maintenance activity happens by in this auto vacuum. So by default, it is enabled. So we have a separate session on auto vacuum. Client connection or defaults are available. Then you have lock management is also available, like what happens when the deadlock is the instance faces the deadlock situation. How many locks per transaction it can support in particular point of time. Then you have version and platform compatibility. So this is somewhat related to your backward compatibility. Error handling. So when your instance suffers some kind of error, what it's supposed to do, it is supposed to exit or restart or what it has to do. Config file includes, so this will give you the location. So this option allows settings to be loaded from file other than the default postgresql.conf. In case you wanted some non-default postgresql.conf, so you can do it in config file includes. And that is it. So just a recap, what we saw is we did a small demo, like how to find the location of postgresql.conf, and then we saw if the context is postmaster, then in that case you have to restart your instance. And if you there are parameters which can be changed globally using alter system set command, and there are some parameters which requires restart, And when you say older system set, and if it requires a restart, it goes to postgresql.conf auto file, and it is read when your instance is coming up. So the first one is to be read is postgresql.conf, and that is the second one in that. And there are several other parameters which are available in postgresql.conf. Let us see how it looks. So let's go to the data directory, ls-lrt, and this is postgresql.conf. If I just say vi, if I wanted to add it, I'll have to do this. So this is postgresql.conf. So the file consists of lines in the form name equal to value. So there is a parameter, and on the right hand side there will be a value. So it is mentioned over here that this file is read on server startup, and when the server receives a sign up signal, if you added the file on a running system, you have to sign up the server for the changes to take place. Run pg underscore ctl reload or execute select pg underscore reload underscore conf. Some parameters which are marked below requires a server shutdown and restart to take place. So you can see there is one parameter section which is file location, like what should be the location of data directory, HBA file, ident file, external PID. Then you have connection and authentications. Listen address is very important if you have to enable remote connection. So I have mentioned the IP address. Port is by default this one. Max connection is 100. Super user reserved connection is 3. So this is under connection and authentication. Then you have the second parameter section, which is resource usage. Like you can mention the amount of the RAM which can be dedicated to shared buffer or work memory, and so on. And so there are a lot of parameters which you can do. Then you have val log parameter. So a lot of things are there in each section. Then you have replication section, wherein you can uh, once you have the replication set up, you can enable the parameters. So we'll have a separate session for this. Then you have something called as query tuning. So it is there is a great scope available in postgresql.conf. Then you have reporting and logging, like we here to log what to log, and like rotation also is available. What, when, and where. So everything is available for your this thing. Then you have process title, like what should be the Postgre cluster name. Then you have statistics section. Autovacuum is there. Then you have client connection defaults. We are not discussing the individual components. Then you have log management. You have version and platform compatibility. Then you have error handling component. I'm just going through the different components which we have. So there are 312 parameters which are available. So, and uh, and it depends, like if parameter has postmaster attached to it, that means underscore pg underscore settings, then you have to restart the instance. Otherwise, you don't need to do so. So I hope it is going to help, and thanks for watching. Welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to use pg_hba.conf. So I have done some pre-work, so I have listed all the steps which we are going to perform for this particular pg_hba.conf. So first of all, let's understand what is pg_hba.conf. So it is a file which is available in the data directory on Postgre server, and it is known as Postgre host-based authentication file. And this is responsible for four things like which host or which IP address are allowed to connect through a particular role, how the clients are authenticated, like they will be using some password or MD5 or some crypt, or and then which PostgreSQL username they can use, or with which role they will be able to log in, and which databases they can access. So all this information is mentioned in pg_hba.conf file. To demonstrate this, let's perform a small demo, and then we will go through all this theoretical part. So the demo which I have is I have two server. One is will be acting as a server where PostgreSQL 12 is running with the IP address 192.168.1.71, and another is 61, which is a client. So let me quickly log into the server, and what we are going to do in this demo is we'll log into the Postgres server. We will create a role with the name user2_remote. We'll give it a login access, and then with this role, we will try to log in from the remote server, and we will see what all steps we have to take care when the this particular role is trying to connect from the remote server. So we will be doing two things in since by default the Postgre do not allow remote access, so we will enable that access, and then we will mention the IP address of the remote server in our Postgre server so that it allows the access. So let's start. So I'm already logged in through the mobile external, which is a GUI tool, and this can store your IP address, user ID, and password. Since this is a demo environment, so this is good to have it. So I'll just say sudo systemctl status PostgreSQL -12. So you can see the status is active and running. So just switch to PSQL. So I'm onto the command prompt. I'm going to create a user with this particular command. Create role, role name with login and then password. So just say /du and you can see the role. User2_role is created, which is having the uh, login access. It is not having cannot login, so it will be able to log in. Let's quit out of this prompt and then log into the remote server. From remote server, we will try to log in with the details. So the command to log in from the remote server is this one. So I'll just have to say psql-u, which is username. The user which we have created is user2_remote -w postgre, and this is the IP address of the server. The server is running on 1.71. Just press enter and feed in the password. So password is password. So this is saying that it is not going to accept the connection, and once the connection is accepted, you will have to, it will prompt for another one. So we will make two changes. One is uh, there is a file which is called as postgresql.conf. So this particular file, there is a parameter which is which we need to tweak, and the parameter name is local_address. By default, Postgre do not allow remote connection. So just to allow the remote connection, what we have to do is we have to remove the local host entry with the IP address of the server itself. So this will be removed with the IP address of the server itself, which is 192.168.1.71. When you make this change, you have to restart your service. So just make sure that you do that. So we'll save this. And then there is another file which is pg_hba.conf file. So what you have to do is in this we will mention the rule, like how the remote server will be able to access. So if you open this file, which is owned by Postgre and Postgre, so you scroll down and there is a section called as IPv4 local connection. So there are 5 entries which you have to mention. There is type, like we will say it is host based. Which databases you wanted to use? So we'll say all databases. which user you want it to connect with. So I'll say user2 underscore remote. With which IP it is coming from. It is coming from 192.168.1.61. And then what authentication method it is using. So there are several. In our case, we will be using MD5 so that the password doesn't come in plain text. It will be encrypted, and we'll just add this line. So I have already added that line and just uncommented. The detail is first is host, all, then the user ID, all, this is the database, all the databases, this is the user ID, this is the IP address, and this is the authentication method. So just save this. So we have made two changes, one in postgresql.conf, where in the local host is replaced with the IP address. In pg_hba.conf, we added the details of the remote host. And we need to restart the service of PostgreSQL because we have changed our parameter. So just restart it. Just check the status. The service is active and running. Now let's try to connect it from the remote host. You can see you are able to log in. You can see all the databases because you have mentioned all. You need access on all the databases. So now let's come back to the theoretical portion of this since we have done this demo. So the first thing is, what is pg_hba.conf? The pg_hba.conf is a Postgre host based authentication which takes several parameters. So mainly it is 5 parameters. One is the host, another is the IP address of that host, then which databases you wanted to access, and then the method using the password, peer, or trust, or reject. Now, if let's ask few questions and answer it ourselves. What is the usage of pg_hba.conf file? So this file is used for client authentication, which is available on the Postgres server, and this is for the client IP, username, and the database name authentication. It has a number of entries. Mainly there are 5 columns, which defines like which host, what IP address, which database, which user can access. What are the contents of the file? So it has a number of parameters, mainly 5 parameters. So it is all related to the particular host, user ID, and the database. And when is the pg_hba.conf file is read? So whenever an application requests a connection, the request will mention a Postgre user ID and password. In our case, it was test2_remote. So when PostgreSQL receives a connection request, first of all, what it will do is it will check the pg_hba.conf file, which is Postgre host-based authentication file, and it will verify that the machine details are available in that or not. So as soon as it finds the detail, it will either accept the connection or reject it. So it is just the connection. It will not give. It is not related to giving the access to the tables or other stuff. So next question is, do I need to restart the PostgreSQL post a role creation and access connection? So whenever you create a new role on a PostgreSQL server and a new connection is requested based on that created user ID or the role, you mention a matching entry in pg_hba.conf, then it checks whether that entry is available or not. And once it is verified, the access is granted. So you do not need to restart the PostgreSQL server, Postgres server every time you add an entry in pg_hba.conf. So what is the sequence of reading the elements in pg underscore hba.conf file? So it is like when a connection is requested, the Postgre will read one entry at a time from top to bottom. So if I show you this, this is my server, and uh, if you view this hba pg underscore hba.conf file, if we scroll down top to bottom, so it will be coming top to bottom. So in this case, as soon as it finds an entry, let's say I'm trying to connect through this IP address, if there is an entry available, so the access is granted. So you can give the host and then database, either it is all or the particular database name, or let's say there are 5 databases, so you can give let's say that 5 databases are A, B, C, D, and E. So I can mention A, comma B, comma C, comma D, or comma E. Or if there are n number of databases, you can put all the database names in a file, and you can mention the file location over here at the rate and the file location, so it will read from there. And you can mention the user ID over here. If it is more than one, then I think also that is possible. I have not tested, but this should be possible. Again, the concept of more user ID, uh, keeping in a file, you can use that. And then the IP address or the range of the IP address. In this case, /24, that means only first 3 will be constant, and this can be anything between 1 to 254, I believe. And this is the authentication way. The next one, which is very, very important, if you haven't, if you do not know like how to find the location of pg underscore hba.conf file onto the Postgre server. So you log into sudo su space hyphen Postgre. Let me clear this screen. And what I will say is PSQL, and then you have to mention show HBA underscore file. So this will tell you the location of HBA file. If you do not know this parameter name, then by default this is available in your data directory. If you have changed the data directory, you need to check this. So data underscore directory. So most of the time I keep it handy so that I can copy and paste. So this will be available in this particular location. If you don't know much about these commands, if you do not know if it is this is the first time, then you can use the Unix based as well. Or there is a direct command, so you can say psql-t-p format is equal to unaligned, and then you can say show hba underscore file. So it is like it will directly connect to PSQL and then give you the output. This is the file name. Or you can use the find command, which is the Unix command, and this will show you. It takes some time, so let it come out. Till that time, what we will do is we will go further. So this is a sample pg underscore hba.conf file. So there is one local section wherein the concept of Unix socket connection comes. So all the local users, they can be put over here and they will be able to connect. So by default it is all users which are created which try to connect from locally from the server. If it is remote, you have to put the entry in IPv4 local connections. Make sure that your postgresql.conf file has the listen underscore addresses replaced from localhost to the IP address or the star in the previous version. And then you have to mention this particular entry local host all the IP address, and then the subnet, and then the authentication method. If you wanted to enable all connections using IPv6, you have to mention this. And if you wanted to reject also. So there you can mention the IP address and mention reject. All right, so let's see an example of single host entry. So it is host, which we have mentioned in our case. Either you mention the database name or all the databases, you mention the username, the IP address, then the subnet, if it is like this, or let's say the first three will be constant and this can change. So let's make 8 3s are 24, and this is trust, not good, but let's make it MD5. This should not be suggested even. If there is a rejection entry, then you mention the details and particular IP address, fixed subnet, and then you mention reject. If it is script, then also it will look like this. If you wanted to mention about a small network, so just mention host. This is the database or the list of databases. Let's say template 1, 2, 3, 4, or at the rate file name, which consists of n number of databases, or username, or n number of users, and then 192.168.1.0. So 1 to 254 IP address, so they can access, or you can, uh, or let's say you these two will remain constant, and anything in here in between 1 to 254 and here also, so you have a bigger network. And if it is like this, only this will be constant and this will keep on changing. So this is how, so small networking part, but most of the time you will have something like this, only these two might change. So just a recap of what we have done. We did a demo where there were two server, one was server and another was client. We created a user with the name user 2 underscore remote. Then we try to log in from the remote server using this particular command. This is my remote server. So initially when we tried connecting PSQL-u username, w database name -h, the IP address of the server where Postgre is running, we got this connection refused because initially it was allowing only the local connection. So you have to remove that local connection with the IP address of the server itself. Make sure you are not adding the entry of the client in postgresql.conf, which is the server parameter file. And then we made two changes in two files. One is postgresql.conf and another was pg_hba.conf, wherein we added the details of the server, the client where it is running. So we mentioned it like uh, host name. So let me quickly show you this. So the entry which we added is like this. Host, I wanted to access all databases with this particular user ID and this IP address range, and the authentication method is MD5. So this is how this, so this is very important file, because every time you try to make some changes, you create a new user, you create a new role, and it is trying to connect from a particular IP address, then you need to mention those details over here. And so postgresql.conf and pg_hba.conf, they go hand by hand. So the first file which you need, if it is your first time, the postgresql.conf, you change it from localhost to the IP address of the server, or replace it with a star if it is 9 or the older versions. And then you work on hba.conf file, wherein you need to mention all the details related to the remote environment, role, which databases, and the IP address. I hope this is more than enough, and in another tutorial you can see more about postgresql.conf. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to enable remote access to Postgres server. So I have listed all the steps in a notepad, and we are going to walk through that followed by a demo. So when you install a PostgreSQL, so by default connection to the Postgre are not enabled. So if you try to access the PostgreSQL server from remote server, you will not be able to access. You will get the message that PSQL could not connect to server connection refused. This is because this is the behavior by default. So if you have to enable the connection to the remote server, you need to make some changes, and in this demo we will see how to make those changes. So in this demo setup we have two server. One is 192.168.1.61, which is my server where Postgre service is running, and the Postgre 12 is running over there. And we have a client with the IP address 1.71. From the client side, we will try to access the Postgre. So let me show you the setup which we have. So this is mobile Xterm. So I'm logged in to mobile Xterm to both the IP addresses. One is 192.168.1.61 and another is 71. So what we are going to do is, in the first step, let us check the status of the service which is running as of now. So we'll say systemctl status PostgreSQL 12. So you can see that a status is running, and if I have to log into the server, I'll just say sudo su hyphen postgre, and we'll just say PSQL. So this will take me to the prompt on to the local server. So if I say /l, this will list down all the database. So there is a database with the name node 61. So what we will do in this demo is we will try to access all the databases from the remote server. From the remote client. So the client IP address is 192.168.1.71. So how do we connect from the remote server is using PSQL-U. Username is the Postgre -h is, and the host name of the server where Postgre service is running. So we will run this command from the client side. So let me run this. So PSQL-U Postgre -h and the server where Postgre service is running. You can see that could not connect to the server, connection refused. But if I try to ping, this is pingable. The port is open, so everything is fine with that. But there are some settings which are not enabled, so we are not able to access it. So what we will do in this demo is we'll go through the steps. So there are 3 steps which we need to perform. In the first step, there is a file called as pg_hba.conf where we need to add the client authentication record. And once we open this file using the editor, I will be using VI editor, and this is the location in my case. And there is a section which is IPv4 local connections, and there I will mention host, all, and the IP address of the client /subnet and the authentication method. This is the first step which we will do on to the Postgre server. In the second step, we will add it postgresql.conf, and we will search for a parameter called as listen_addresses. By default, this is mentioned as localhost. So only the connection from the localhost is allowed. When we have to enable the connection from the remote environment, we have to mention the IP address of the server itself. If you have more IP addresses assigned, so you have to mention all those. So whatever NIC card it is listening, you have to mention the IP address of that. Please make sure that you mention the IP address of the server, not the client. The client IP address is to be mentioned only on pg_hba.conf. In the third step, we'll restart the service. In the fourth step, we will access it using the command prompt. So let's go to the first step. In the first step, let's log into PSQL and say show data underscore directory, and we will find the location where this hba.conf file is located. So you can see I have navigated to that step, and then what we will do is we have to edit that file pg_hba.conf. I'm using the VI editor, and then what you have to do is scroll down till you find IPv4 connections. And here you mention the IP address of your client. So I'll be mentioning it as host all IP address of the client and authentication using MD5. So let me give some spacing. And you can mention like which client it is, or you can mention the list of the IP address or the conditions also, like which all are eligible to connect. So we have added the IP address of the client. Then in the next step, what we will do is we will edit postgresql.conf file, and it is in the same location, data directory. And here what we will do is there is a parameter called as listen addresses, which is by default localhost. So you have to replace localhost with the IP address of the server. The IP address of the server where this is running is 192.168.1.61. The IP address of this server itself. Where I'm typing the command, this is the server only. Just save it. And in the third step, what we will do is we have made two changes. We have mentioned the details IP address of the client in hba.conf. And what in the second step, what we have done is we have edited the postgresql.conf, and we have replaced uh, localhost with the IP address of the server. It is not the address of the client, it is address of the server itself. The service is restarted. It is running as expected. Now we will try to uh, fire this command on remote server. So it is psql-u postgre-h. There's prompting for the password. I have mentioned the password for the Postgre user as password only. So you can see that I'm able to log in. And if I say /l, I can see that it is connected to the remote server and a node 61 database we created, and it is available here now. Or we can try one more step. We can create one more database. So we'll say create a database test now. And this should be visible here, /l. So test now is visible from the remote server. So this is the way we access the Postgre from a remote server. So just to recap, um, we edited pg_hba.conf, and in IPv4 local connections, we mentioned the IP address of the client. And then in step 2, we edited postgresql.conf, and we replaced localhost with the IP address of the server. And then in the third step, we started the Postgre service. And in the fourth step, we tested the remote connections. So this is how we access the Postgre remotely. I hope this is going to help. Stay tuned for another video. Thank you. E-MultiSkills video tutorial. In this video tutorial, we will learn how to install Postgre on Windows. So this is the list of steps which we will be performing on installing the PostgreSQL on Windows. First step is downloading the executable. Second, we will install the PostgreSQL from the binary or the executable that we have downloaded. And in the third step, we will access PostgreSQL using command prompt and pgadmin4. So let us start with the first step. So what we are going to do is we are going to download PostgreSQL. So in your browser, just search for download PostgreSQL, and you will see the first option, downloads hyphen PostgreSQL. Just click that, and we have to do it for Windows. So just click Windows, and then the first option, Windows Installer, Interactive Installer by Enterprise DB. So just download the installer. So here you can see that table which says the first one is PostgreSQL version, then which operating system it is, and that's it. So we are going to go with the latest version, which is 12.3. The other versions are 11.8, 10, 9, 9.5, 9.4, etc. 9.3 is not supported. So most of the time when we download the binary, or when we download some software, we get in touch with the application owner who instruct us like which version of PostgreSQL has to be installed. Since this is a demo environment, so I'm going with the latest version, which is 12.3. So just click, so you can see this download for Windows x86-64. Just click that, downloads, and the download will start. So I'm not going to do this because I've already downloaded the binary on my system. So I'm just going to start with the installation. So I have downloaded PostgreSQL 12, and we are going to install this on my system. So it is a Windows laptop, so we are going to install on that. The installation is very, very easy. There is nothing great like any other software which we install on Windows. It is like that only. So the tricky part will be when we are going to make some changes on it. So I'm waiting for the first screen to appear. So you can see that setup PostgreSQL, welcome to PostgreSQL setup wizard. So just say next. And the first screen which comes up, it says the installation directory, the location where all the data files will be located. So we'll go with the default location, which is C program files, PostgreSQL/12. Just say next. And there will be 4 options which will be installed by default. The first is PostgreSQL database server. We are going with that. The second is pgadmin4, which is a graphical tool for managing and accessing your PostgreSQL database and the server. Then we have something called as Stack Builder. If you download and install this, this will help you in installing additional tools, drivers, and applications. So this is good to have this. The fourth default option, which will be downloaded, is the command line tool, like your pg base backup, pg dump, or pg restore. So these will be installed by default. So let's go with all the default options. First is the database server, then pgadmin tool, which is a GUI tool. Then is a stack builder, which we should include in case we wanted to have something extra downloaded later on. So this is required. So command line tools, this will have all the command lines tools installed. So just go with the next. And please provide a password for database super user. So this you have to remember. This is the database user, which is Postgre, and this is a super user. So I'm just giving some password. Make sure that you remember this, because when after the installation for the first time when you access your database, you will need this password. Please select the port number. So by default, PostgreSQL works on 5432 port number. We'll go with the default locale, so this is fine. Just go next, and you can see that there are a lot of things like installation directory. By default, all the data files will be here, and C colon program files PostgreSQL 12. This is your installation directory, and data directory is also same. Database is on port 5432. It is listening on this port, and database super user is Postgre, and rest of and I think that that's more than sufficient. Just go with the next, and this is going to install Postgre on the system. This is going to take at least 20 minutes for that time being. I'm just going to pause this video. So once it is installed, I'll resume it, and then we will see how to access PostgreSQL database using command line and pgadmin 4. Welcome back. The installation has just finished. Now you can see the final screen which says completing the PostgreSQL setup wizard. So I'll just press finish as the installation is finished now. So this is the stack builder screen which will appear in case you wanted to add some more drivers or features, so you can use that. So just I'm saying cancel, and my installation is done. So now the next step is just go to your Windows screen and look for Postgre. So this was PostgreSQL 12, so we are here, and you need to look for SQL shell. Just click that, and you will see a screen which says server localhost. Yes, we wanted to log into the same host, so it will be localhost. Just press enter. Database is Postgres, Postgre, which we wanted to log in. Port is 5432, the default one. Username is Postgre, that is fine. And now it will prompt for the password. This is the same password which you have feed in earlier. So just provide the password, and you are on to the Postgre SQL command prompt. So just say /l, and this will list down all the databases, or /du. This will list down all the databases, the roles which have been created. And now let's do one more thing. This is how do we access using the command prompt. In case you wanted to access it using the pgadmin 4, just go to PostgreSQL folder, and look for pgadmin 4. This is the GUI tool which is used to access your PostgreSQL. The management is very easy. Everything is there in the GUI mode, so it is good to have this handy. And so I have just clicked the pgadmin 4, and this is coming up. So this is management tool for PostgreSQL. And now you can see on the screen as a saying starting pgadmin 4 server. So this should come up any moment. So it is appearing in the browser, localhost colon 57414/browser, and let me reset the master password for pgadmin 4. So I've set in the password for pgadmin master, and now you will have to connect to the PostgreSQL 12, which is installed on your local system. So it is saying please enter the password for the user Postgre to connect to the server PostgreSQL 12. So just feed in the password and say OK. If everything is fine, then it will connect. You can see that there are some things populated downwards. If you click the database, this will show that by default there is a Postgre database which is installed and owned by Postgre role. So this is created, and there are a lot of things in some other tutorial we will see how to use it, but this is how do we connect to Postgre SQL using command prompt and pgadmin GUI tool. So just a recap of what we have done. We have installed PostgreSQL on Windows. We downloaded the executable from Enterprise DB. We went with the latest version, which is 12. Then we installed using the PostgreSQL installer, and then we access the PostgreSQL using the command prompt and pgadmin 4. Just you need to remember that the Postgre password which you have provided during the installation, that you need to remember so that you can connect using the command prompt and pgadmin 4. So this is the basic of how do we install it on Windows, but there are a lot of things apart from this. So in some other tutorial, we'll see how to work on those. For now, it is bye from me, and see you in the next tutorial. I hope this is going to help, and thanks for watching this. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to move data directory on Postgres in Linux 7.5. So these are the list of steps which we will be performing on a Postgres 12 database which is installed on Linux 7.5. So first of all, let's understand what is Postgres data directory in Postgres 12, which is installed on a Linux environment. So all the data files related to the Postgres instance is stored in a location which is known as a data directory. And over a period of time, the storage allocated to that gets exhausted, and either you need to extend the storage or you need to move the data files or all the files which are related to the database to a new location. So in this demo, what we are going to do is we are going to move all the data files to a new location. So the setup which I have is having the OS 7.5. I do have the access of root and Postgres OS user. The Postgres instance which is installed is 12. So I have already logged into to the instance to the server using the MoveXterm, which is a GUI tool. You can store the IP address, user ID, and password. You just click and you will be able to log in. So I have already logged in with two terminals, one with root and another with Postgres. So let me walk you through the steps which we are going to perform. In the first step, we will log into PostgreSQL like sudo-u postgres psql, and we will check show data directory. That will show us the current location. As of now, the current location is the default location, which is /var-lib pgsql/12/data. So in this demo, we are going to move all the data files which are located on this current or default location to a new location, which is postgres/data. So in the first step, we will identify the existing location and the new location. In second step, we will shut down the services using systemctl stop postgres 12. In the third step, we will prepare a new file system. I'll change the ownership of the new file system, which is postgres/12 to postgres:/postgres, and the ownership will be given 750. And we will navigate to the existing data file location and copy everything to new location. In the step number 4, we will update the configuration file. We will added the postgresql.conf, which is located as /var live pgsql/12/data postgresql.conf, and we will update data directory location with new location, which is /postgres/data. In the step number 5, we will start the Postgres, and step number 6, we will verify that the new location is updated or not. So let's start with the step number 1. In the step number 1, we are going to log in as a Postgres user. So I'm logged in as root, so let me say sudo -u Postgres PSQL. So I'm logged into Postgres command prompt. Now here you have to type show data underscore directory. So this will display the current location of the data directory. So this is the current location, and this is the same location which exists when you install the new version of PGSQL PostgreSQL. This is the default location, so this has not been updated. So we are going to change this location to a new location. In the step number 2, we will check the status of Postgres. Let me log in. So you can see on this terminal I'm logged in as Postgres. So you just need to say sudo systemctl status Postgres 12. So you can see that the status is running. What you need to do is you need to stop the service using sudo. I'm assuming we don't have the root access, although I have shown the first step as root. In the second step, what we will say is stop the service. Sudo systemctl stop system Postgres 12. Check the status once again. The status is inactive. It has been shut down. In the third step, what we will do is we will give the ownership on new file system. So let me quit out of this, and I'm logged in as root. So these should be done in advance. So what I'm going to do is I'm going to change the ownership of Postgres/data to Postgres:/Postgres, and the permission which we will be giving it to is logged in as Postgres. We will change the permission as chmod-r 750 Postgres/data. So let me see if there is any data, because I have done this demo earlier. So I need to make sure there is nothing. Yeah, so there is nothing in that. In the third step, we have verified the new location. We changed the permissions accordingly. Now we will navigate to the old location, or the existing location, which is var live pgsql/12/data, and we will copy everything from this location to Postgres/data. So we'll say cp-r star Postgres/data. So this is very small, so it is copied immediately. Let's navigate to Postgres/data and say ls-lrt. So you can see that the files are copied to the new location. Now in the step number 4, what we have to do is we will take a backup of Postgres configuration file, which is located at var live pgsql12/data postgres:/sql.conf. So let's take a backup of the configuration file. We have taken a backup. Now add it the postgres:/sql.conf. So you can see we are inside the Postgres configuration file, and what I need to do is I need to update the data directory with the new location. So just uncomment and give the new location. In our case, it is Postgres/data. So I have already added that, and you just need to uncomment and save it. This is saved. And in the next step, what we are going to do is we are going to start the Postgres service. Just start the Postgres service. And one more thing, you need to make sure that you can check the alerts in case there is any issue. So just tail-10f/var log messages. So this will show if the system has come up perfectly or not. So it is saying started PostgreSQL 12 database server. Check the status as well. So it will say sudo systemctl status Postgres 12. You can see that the status is active and running. So this is perfectly fine. And the last step is we will log in to Postgres command, and we'll say sudo-u Postgres PSQL, and we are on the command prompt. And here you just say show data directory, and you are done. So our new location is updated Postgres. So now onwards, whatever data comes into the database, it will go to Postgres/data. So we have successfully moved our data from existing location to new location. So what you can do, you can leave it as it for some time and delete the unwanted data later on. But it is a very small amount of data, so we can leave it like this. Just to recap, what we have done is we checked the current location of data directory, then we stopped the PostgreSQL, then in the step 3 we moved all the content from existing to new location. In the 4th step, we updated the configuration file. In 5th step, we started the PostgreSQL, and the 6th step we checked the new location, and it was done properly. I hope this is going to help, and stay tuned for next tutorial. Thanks for watching this. In this session, we will learn how to stop and start Postgre services or Postgre server on Windows system. So we'll directly start with the demo, which is very easy. And here we go. So I have listed all the steps on a text pad. So there are two ways we can stop and start the Postgre services or the server on Windows. Both of them are very easy. The first one is using the pg_ctl, and the other one is using the Windows services. So in the first way, when we say pg_ctl, the first thing which you check is you check the data directory location. So you log into PSQL command prompt, and then you say show data directory, or you simply say select settings from pg_settings, where name is equal to data_directory. In our case, the location is at this place. C drive program files PostgreSQL 13/data. So once you find this, you have to execute pgctl utility. So you say pgctl_d, which it stands for data directory. You mention the complete location of the data directory. Then you say either stop or start. So let's go with the both the way. So I have logged into two command prompt, so they are open. The first one, what we are going to do is we are going to log in as PSQL. Just wanted to see if it is working fine or not. I'll say /l, it will list down all the databases. Now if we say show data_directory, show data_directory, this should show you the location of the data directory. So there's data directory location. There are a couple more methods you can find, but let's stick with this. Then what we will do is we will execute the pgctl command. So we will go with the pgctl-d C drive program files and either use say let's say status. It is saying server is running, and you can confirm from here as well that I'm able to log into the database and we are able to see the databases, or we have just queried the location of the data directory. Now, the next thing which we are going on to the left one is we'll say pgctl -d complete location of the data directory, and then we will say stop. We wanted to stop it. The server is stopped. Now, if we say /l connecting to PGSQL, this should show some error. Yes, it is showing the connection to the server was lost, and that is fine. We'll quit out of this, and then we will try to start it. So the way to start it is simply same. We'll say pgctl -d complete location of the data directory, and then start. Server started. You can check the status, so that should show you the status, and server is running. Now let's try to connect using pgsql-u postgre and fill in the password. If everything is fine, you will be able to log in. Yes, you are able to log in. You can list down the databases, so everything is fine. This is how we do stop and start. You can do the reload as well if it is required, if it doesn't require the bounce of the database. The other way to do is you can use Windows services. So press Windows sign and R, go to run, just say services.msc. This will open services.msc, and you will be able to see the Windows services, something like this. So you can see PostgreSQL -64 -13. So this is Postgre 13, and it is in the running status. You simply there seems to be some issue with this. PostgreSQL, right? Yeah, we just stopped it. Let's start. Oops, there seems to be some issue. Okay, I think I have two. So I'll try to do it separately, but as of now, let's stick to this one, wherein we say that's you use the pgctl, and you will be able to see the status. Okay, this is not running. Just say start, and this should be started. Still running. I think the refresh was not proper, so it was not showing the correct details. Sometimes it takes longer than what is required. You can check the log files for more details. But this should be fine anytime. Did not start in time. Let's start it again. It just take a couple of seconds only. You can cross-check. Oh, system is shutting down. Examine the log output. Let's try to start it once again. You can go to the logs also to find more details. Server started. You can try this one, and this will show you over here. Yes, you are able to log in. Yeah, sometimes it is my system problem. As of now, everything is okay. You can go to services.msc also and PostgreSQL, and once either you stop it or start whatever service you wanted to do, you can do it. I hope it is going to be helpful, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is a user role and a group in PostgreSQL. So the agenda of this tutorial is what is a user or a role in Postgre, what is public schema, what is a search path, and how do we revoke public from a role, how do we create a read-only role or read-write role, and how do we create a role, and then how do we grant privileges to the user which is created. The first one is the users and role. So what is a user and role in Postgre? When we say create user in Postgre, that means it is equivalent to create role plus login permission. That means the only difference between user and the role is user is able to log in, but the role will not be able to log in. And the role has its own advantage. So if I say a SQL statement to create the PostgreSQL user, so I'll just say create user, username, then with password, and I'll give the password. If I have to create the same user with the create role SQL statement, I'll say create role, role name, and the only additional thing which I have to add is with login, and then we need to give the password, and that's it. So in Postgre, create user is equal to create role plus login permissions. So by default, all the new users and roles, they inherit the permission from the public role, and we'll see how it plays an important role. So what is a public schema and public role? So whenever you create a new database, let's say you created a new database, DB1, then by default, when you check the schemas which are available in that particular database, so you will see a schema with the name public. That means a user who has access to this particular database will be able to select or create the objects in that particular schema. So it is by default, the design is like that. So all the new users and roles, they have the default access to the public role, and they can create the objects in the public schema, which is not good. Then what is the search path? If I'm connected to a database, let's say, which is called as DVD rental, and if I say select a star from actor, actor is one of the table, and if I don't give the fully qualified name, then how Postgre will come to know like from which schema it has to pick the information. So that information is mentioned in something which is called as a parameter search path. If you log into Postgre prompt and say search path, show search path, it will show you two values. One is $user, another is public. Let's say if I'm connected to Postgre user on Postgre server, then by default, when you fire any query, it will search for a schema which is equivalent to the name of the user which is logged in. Let's say then it will look for that particular user. So by default, a schema with the same name will not be present. What is present is a public schema. So any user who is connected to that particular database will be able to see the objects or create the objects in the public schema. So as I mentioned, a DVD rental database, if I am just saying select a star from actor, then it will search, and I'm logged in through the Postgre. So it will try to look for the schema, which is equivalent to the database username, which is not the case. So it will look the information in public schema. So instead of saying select a star from public dot dot actor, I'll simply say select star from actor. So it is going to search from the public. If you have a schema with the name, let's say Postgre, and your object is lying over there, then it will look into that and it will display the result. This value can be changed. You can change the schema name so that by default it will look into this. So that's the importance of the search path. And it plays a very important role. What you should do about the public schema, you should revoke any creation of object onto the public schema, because if a number of users are using that particular database, and then it may be a messy task. So you should remove the create on schema public from the public, and you should also revoke all on database from public so that anybody cannot use that particular one. How do we create a role? Create role is, it's very simple. It's, you say create role, role name, and to that particular role, what you can do is, let's say I have an application. I wanted to create a read-only a role for some of the tables. So I can create the role, then I can say grant connect on that particular database. So my database in this case is DVD rental. Then I can give access to this particular role, and that particular role can use the app schema if I have created a schema with the name. So you can do a lot of things with the role, and finally this role can be granted to the application user or the user which you have created. Also, what we can do is we can grant any kind of, let's say, select, insert, update, delete, whatever you wanted to do. But as the name suggests, it is a read-only schema. So I'm just going to give select on all the tables, or a table like actor or film to that particular role. Or what also you can do is you can give all table access on that particular schema to that particular role. So you created a blank role, you gave it connect access to the particular database, then you said like you use particular schema, then you gave select access on a number of tables, and this way it is very, very useful. So you create a role, and then how do we create a database user? So you simply say create user, username, then with password and password name. And finally, you can grant the role to the user. So any user who is joining that application, so any user in that application group, you can grant the role. So it is very convenient. So any changes which is happening to the app underscore read only will be applicable to all the users. They will be impacted. Any table which is added or removed, the impact will be on the role, and the role is finally granted to the user. And now there is a demo which is following up. So this is the demo. So let me close this presentation. And this is the demo. I have listed all the steps in the notepad, and we'll perform this either on the, so I'm connected through MobiXRAM on my server, which is on a Linux server 192.168.1.61, and I'm connected through the Postgre user, which is having the sudo access on this. So what I'm going to do is, so what we saw earlier is um, we are going to create a user, and we'll see how it is different from the role. So we say create user is equal to create role plus the login permission. So I'm just going to create a user. Let's name it as create user app user one with password, which is equal to the password. Not a good practice, but this is a demo, so we are using this. This is the wrong password. The role is created. You can see the user is created, app user. So where is the app user one? So this is the app user one, and there is no attributes cannot log in. That means it is able to log in, and that is the only difference between user and the role. Roles cannot connect to the it's not able to log in, but uh, uh, user is able to do that. If I create a role, let's say app user role 1, and if I say with login, then it is equivalent to the create user statement. So that is what we discussed in the first slide. Create user is it's already existing. So let's create another one, app role 2. So if I say /du, you will be able to see app role 2, and it is able to log in. Next one is what is a public schema and public role. They just to showcase this, I'll log into the PG admin GUI tool, and I'll connect to my database, which is on Linux environment, and I'll connect to the database, which is DVD rental. So here we go with the DVD rental. And what happens? Let me delete the role which I have created. Okay, so I have a database with the name DVD rental, and when I created it, it was a blank database. So whenever you create a database, you get a schema which is called as the name public. That means any user who is having the access on this particular database will be able to use public schema. That means any object which is created will go into this. Let's say if I say I'm connected through the Postgre user in DVD rental database, and if I say create table A, so that table will be created in public schema. So that's the way. If you wanted to use a specific schema for the particular user, you need to create using the create schema command. So we'll see right away how to use that. Search path. So I'm connected as Postgre user, and let's see how many databases we have. Let's go to DVD rental, and I'm switched on to the DVD rental database. If I say let me see the data tables we have. We have actor table, and it is there in the public schema. If I say select star from actor, or select count star from actor, I don't want to display the entire details onto the screen. I'll be able to get the details, but how Postgre is knowing, how the server is knowing from which schema it has to pick it up. So I'm connected to the DVD rental database, and there is only one schema, which is public schema. And there is something called as search path. If I say show search path, I'll be able to see two things. One is $user and another is public. So by default, if a user is connected, let's say my username is app user, then it will look for the schema whose name is equivalent to the user which is connected. If that is not present, it will look for the object in the public schema. So either I say select count star from actor, or if I give fully qualified name, which is schema name dot the table name, it will display the same item. So if I just wanted to omit using the schema name, I need to mention the value in search path, and that can be set. All right. What we will do is we will do a small demo. We will, as a best practice, we will revoke privileges from the public role. So let's do that. So we'll say revoke create on schema public from public, and revoke all on database DVD rental from. Just in this demo, what we are doing is we are using DVD rental as the database. I'll go to the PG admin, and we will do it over there. So let me connect to DVD rental. Then I say query tool, so it will open a query editor, and we will execute all the statements from there. All right. So what I'm saying is we will revoke creator. So by default, nobody will be able to use that schema. And on all the database DVD rental, so that will also be revoked. So just execute this, either F5 or execute. Both will work. Okay. This is done. Now what we are going to do is we are going to create a role which is app read only. Then create role name. Then we are going to say uh, it is going to connect to the database DVD rental. Then we are going to create a schema, app schema. Then we are saying just use that particular schema, and then we are going to select all tables in that particular schema, and that will be granted to that particular role. Let us create this particular role. We use the command prompt or the GUI tool, but it is good to watch it over here. So create role, then connect privilege, then create a schema, then grant usage on the schema, and then all the tables in that particular schema will be given the select access to that particular role, and that's it. Role already exists, so let me drop the role. So let's drop it, and then we'll execute it. Okay, so there are, let me change it instead of, so we'll say, we'll create a new role, which is app read and only underscore one. We'll say replace all, and we are going to use this. And we are using PG admin 4. I'm just clearing the screen, and we are creating a new role. It's very, very easy. There is nothing tricky in this. So this, it is displaying the last message. So this is completed. Now we are going to create a read write role. Here what we are saying is in read only role we gave only the select access. Here what we are going to say, we are going to give insert update delete on all the tables in that particular schema. So let's create role read write. Let me see if that role is available or it is not. Okay. So read write. Okay, it is not. So let's execute this. So we are going to create a role read write, then it is giving the connect access on DVD rental. Then we are going to create a schema, app schema, which is already created. And you can use the name according to your requirement, and we'll execute all this statement. Read write already exists. So let me create, instead of read write, we'll say app underscore read write 1. Let's create the role. It's very, very easy. It is done. The next one is we'll create a user which is called as app reporting user one. We'll give some password. Then we will create another user app reporting two. Then um, then what we are going to do is we are going to grant the privileges. So this we have seen earlier also. There is nothing special. It is just the user and the role. The only difference is they have login access. This is done. And finally, the roles which we have created can be assigned to the user. So we had app read only, and we have app read write one. So let's grant all this. So this object level things are very useful when you work for the application team and you have to grant some kind of access on the tables or a schema to the roles, and that role has to be assigned to the user. So just to recap what we have done, we have seen what is a user. User is nothing, just a create role plus login permission. Then we saw what is public schema. Public schema is something which is available by default in our database, which is newly created, and the user has the access on that, which is connected to that particular database, and then they can create the objects into that. That is not a good practice to have that in place, but it is by design, so you should remove the access over there. Then we saw something as search path. If you say show search path, it will show you two value $user, comma public. That means a user which is connected to a particular database by default. It will look into the schema with the same name as the user connected. If that is not available, it will search for the objects, or it will create the objects which is there in the public schema. So instead of saying select star from table, uh, or instead of giving the fully qualified name, select star from schema.table, you simply say select star from table. Then it will check this criteria, and if it is validated, it will display the results. Then we saw how to create the user. Then we created a role, read-only role. Then we created a read-write role, and then we created two users, and then we assigned the roles to the user. I hope this is going to work, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn about Postgre cluster. So okay, so what is a Postgre cluster? So when we say cluster, it means n number of nodes which are connected together and they are serving as one unit, or multiple database instance which are connected together and called as a cluster. But this is not that cluster in PostgreSQL. When we say Postgre cluster, it means it is a collection of databases which are managed by a single Postgre instance. So that instance will have its own background process, and it will have its own PG data. So what are the different components of the term cluster in Postgres? So we have something called as data directory. So let's say when you install Postgre on Linux system, or on let's say Windows system, there is something called as data directory, wherein all the files which is related to the database, tables, and other logical entities are created, and they are specific to that particular instance. By default, we create only one instance if there is no need to create another instance. So that data directory is being managed by the Postgre processes. So it manages all the data directory files and interfaces of those contents. So when we say cluster, it means two things: combination of data directory and Postgre process. What is the use of having one more cluster when you already have one instance? So you can say it as it is a temporary database which you can create outside of the existing instance. You can make any changes in the new PG data directory, let's say postgresql.conf or pg_hba.conf file, and that is separate from the default instance which you have installed. Or there is another purpose. You can have a different version of the Postgre at the same time. So you create one more instance, you test the environment, or you can have multiple versions, or you can create the database in the new instance, or in layman language we'll say having one more instance with its own data and the background process. So how can we create a new instance? So to create a new instance, you have to create a new data directory for the cluster. So you log into your existing cluster. Let's say in my case, it is a Linux system. So I'll say sudo su hyphen postgre. You can check the current location of PG data, create a new location, and then you initialize that particular location using initdb and the new data directory location. Once the instance is instantiated, you have to configure the cluster. By default, in the existing cluster, you will have the port 5432 active. So you cannot use the same port for the new instance. So you have to change the port to a new number. So instead of 5432, let's say I'm going to use 5433 or any other. I need to change the Unix socket directory from existing. The current one will be your var run PostgreSQL, and let's say create a new location, and your Unix socket, which is required for connection from the same host, that will be used. Then you start the Postgres server once the initialization, and you have changed the parameter port and Unix socket underscore directory in postgresql.conf. You initialize it using pgctl-d, give the location of new data directory, and log file, that is optional, or you just say start. Then you can check whether your new instance has come up with the new processes or not using ps-xf. So that will show you the tree structure with the postmaster at the base and other processes following that. Then once your new instance is instantiated, you can connect to that using psql-h localhost, new port, and the super user, which is Postgre. If you have to stop it, you just say pgctl-d, the location of the data directory, and if you have to give the log file name, you give it, then stop. If you have to reload, if let's say you have done some changes, which then you have to reload it, just say pgctl-d, the location of new directory, and reload. So it's very simple. pgctl location of new directory, either you say start, stop, or reload. Then we are going to perform a demo on a Linux environment. So let me take you through that. So I've listed all the steps. So I have a IP address 192. So the IP address of my host is 192.168.1.61. Operating system is 7.5 Linux, and Postgre, which is already installed with one instance, is Postgre 12. So we are going to log into that. So this is I'm logged in as root. So let's say the first step, let's say just switch the user to Postgre. So now I'm logged in as Postgre. Now just say for the existing setup, just say where is my existing data files. So echo pg data. Just go to this location and you will see these many files. And it has its own background processes as well. So you can just say psxf. So this is my current setup with one instance. So you can see postmaster is there, then these are the rest of the background processes. Now what we are going to do, we are going to create a new cluster with the new location of the data file. So what I'm going to do is I'm going to create a new file uh, wherein wherein we will keep all the data files. So let's create it in this location. Let me log in as root, and we will say mkdir, and we will create a data directory instance 2. I think I sudo su space minus postgre. This data directory is already owned by postgre user ls-ld, and let's say check the permission. So it is already owned by Postgre. Let's create this directory instance 2, wherein we are going to keep our data files. So this is created, and along with that, what we will do to keep the what do you say um, the the socket file, we will keep will create one location. So we'll create one location like um, mkdir-p home instance 2. Just give the ownership to Postgre to this particular file wherein the socket file can be created. So we have done that. Now let's start the first thing which we will do is we have created the directory, then we will say initialize db and the directory location, and everything we are going to do as Postgre user. So initdb and the new data directory location. So you can see the file belonging to this database will be owned by the user. Postgre database cluster is getting created. The user will also own the server processes and fixing permission on existing directory, creating subdirectory. So it is going to create all the files which were there in the existing cluster. Now it is saying if you have to start the cluster, you have to use postgre-d or pgctl-d command, directory location and the log file name, and followed by either start, stop or reload. That three things you have it. Now let's create the Postgre cluster. Configuring that means we have to change the two entries. One is the port number and another is the socket directory location. So we'll say vi slash postgresql.conf, and we have to change two parameters. One is the port, because we cannot use the same port. This is already in used by the existing instance. So let's change it to 54333, and we will give the Unix socket directory as the new directory wherein the socket file will be created, and this was slash home slash and we created with the name slash home instance 2. So let's create put this. We have done this. Now we have to restart. First of all, we have to start the instance for the first time. So we'll say starting Postgre server. So we'll say pgctl-d and followed by the directory location, then log file, that's optional, and you can say just start. So starting, so this will start within a couple of seconds, and we will check using ps space xf. So if you execute this, you will see one is with my new location, new data directory. So this is my new data directory, and this was the old data directory. So these set of background processes for old instance, and this is for my new instance. So we have created one more instance. Now how to connect with that? So we will say psql-h localhost-p, port number is 5433, and the user is Postgre. Just execute this, and we are logged in to the new instance. Just quit out of this, and we will see one more command, how to stop the server. To stop the server, everything remains same. You just have to replace your so we'll say pgctl-d directory location where all the data files are there, then -l log file name if you want to give, then stop. Just say stop, and it is going to you can see that server is stopped. If you say ps if you try to connect to new instance, it is showing that there is some problem. The problem is it has been down. And if you just say psxf, it will show you that the background processes are obviously down for new instance. This is the old instance. And in case you have to start it again, just say start bgctl-d directory location and start. You start it, it is starting. And then finally, if you have to reload, uh, you made some changes, and if you have to reload it, then just say pgctl-d directory name -l log name, then reload. So signaled, and it is done. You can see our background processes for new Postgre is available now. So this is how we create a new instance. So just a recap, we create a new directory where the data file will go. The data file will go to this location. Then you just say initdb and the new location. Then you modify port number and Unix socket directory. Then you start the instance using pgctl-d directory location, and then you have to check the process has came up or not, psxf. Then you can try to log in psql-h localhost-p port number and the username. And this is how we create a new instance on Postgre. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is PostgreSQL schema. So in this slide, we will learn what is Postgre schema. So if you have already installed PostgreSQL software either on Linux or Windows system, you will know that by default, there will be one instance. If you wanted to have more than one instance, you can do that. So at the top label, you have instance, and in the instance, you have databases. So you can say that a PostgreSQL database cluster contains one or more named databases. And in turn, a database can have one or more objects which are called as schemas. What is a schema? Schemas in turn can have tables or different types of objects, or it is just a container which can have different types of objects in it. So if I say in a particular database, if I am connected to, I can create multiple schema. Let's say I create a schema 1, I can create a schema 2, or n number of schemas I can contain. So what will happen have over there? Let's say I have created a table which is called as actor in schema 1, and another table with the same name in another schema. So let's say the name is again actor in schema, so schema 2. So two schemas with with different name, schema 1 and schema 2, but same table name, which is actor. So it is good to organize the tables in different schemas. And so if you talk about a schema, is it synonymous to anything? So it is something like directory or folder at the operating system level. There is nothing more than that. In that folder, there will be different objects like tables or views, or what do you say, the functions, etc. So this is a brief introduction of a schema. Schema is nothing, just a logical container which can have different tables and data types. So why do we need to use a schema? Is it something new? So no, it is not something new. So a schema allows you to organize database objects. Let's say I have a database with the name DVD rental, and if I have two schemas, let's say schema 1 and schema 2, and I have one table which is known as actor. If I wanted to access it through two different schemas, I can do that. So it is easier to organize the objects in the schema. And if I wanted to take a backup of the particular schema, if I have to restore it, then it is very easy to do that. And organization in particular schema will be easier. What I can do is I can restrict the user to work onto a particular schema, and I can say you don't have access on other schema. So it is good to have schemas in place. It is something like mandatory. You should use it. There is something called as public schema when we talk about Postgre. Public doesn't mean that it is available for entire public or all the users which are connected to the database. Sorry, I mean to the mean to the instance. So when you create a database in Postgre, by default there will be a schema, which is the only schema present, which is known as public. That means if you have not created any user-defined schema, then all the objects which you create will be there in the public schema. So any uh, role which has access to the database, or user which has access to the database, can create the table in public schema. And public schema is available by default in all the databases which you create, and that is the only schema which is available. So there is something called as search path. What happens if I say, if I'm connected to uh, DVD rental, let's say my database name is DVD rental, and if I say select star from actor, so in which schema it is going to look for? So there is something called as public schema. So by default, it is going to look into the public schema. If you say show search path, then it will search either in user dollar. There is something called as user dollar, and the other one is public. So if the schema name is equal to the username, then the uh, s- object will be searched in that particular schema. If not, then it will be searched in the public schema. So what is the building block of Postgre? So we have a PostgreSQL cluster. That means there will be one set of software. Let's say Postgre 12 I have installed. So by default, there will be one instance. If I wanted to create another instance, then I can do that. So each instance in Postgre will have its own set of background processes plus memory area, and in each instance you can create different databases, and each database will have the container which is called as schema, and schema can contain different types of objects. So this is the hierarchy. So you have Postgre instance or the cluster, you have inside the cluster or instance you have databases, inside databases you have schemas, under schemas you have objects. It is just like folders. That's it. So let's come back to the demo. So I'll show you I'm already connected to uh, pgadmin 4. This is the IP address of my server 192.168.1.61. I have 6 databases. I'm going to use DVD rental. So if you uh, click this, you will be able to see different options. And by default, there is one schema which is with the name public. It doesn't mean that it is available for the entire users. No, it is not like that. So by default, when you create or select the object, it comes from the public schema. So what we will do is um, so as of now, there is only one schema. Let's create two more schemas. I'll create two schema with the name schema 1 and other again with the same schema 2 name, schema 2. Okay, and what I'm going to do is now um, either you can use the command prompt or pgadmin 4, and let's do, okay, I'm already connected over here. So I created two schema, schema 1 and schema 2, and in my public schema there is a table called as actor. So if I simply fire one statement like select star from actor, okay, let me do one thing. This is my command prompt of 192.168.1.61. So I'm connected as mobile xterm. So what I will do is I'm connected as Postgres user. So I just say PSQL. I'm connected to Postgre prompt. So if I say uh, switch to database, the databases which I have is these many. So I wanted to connect to DVD rental. I'm connected to DVD rental. And if I say select star from actor, so I'll be able to see the data, right? So this is my actor table, which is available in public schema, and I have created two more schema, schema 1 and schema 2. So what I'm going to do is I'm going to create the structure in these two schemas for our demo. By default, I click this icon. So okay, let's go to the query editor. I'll go to schema 1, uh, expand this. You can see the public schema. Just go to schema 1 and say um, query tool, and I will create a blank table with the name actor. Just execute this. So this is a blank table. All right. Create another table in the schema 2. Let's create that as well. All right. So if I have to select the data from individual tables, so what I will have to do is I will say, if I say select star from actor, by default, it comes from the it comes from your public schema. And if I have to say the specific schema, I have to say schema 1 dot actor. So I'll say select star from schema 1 dot actor. So you can see that we created just a blank table and there is no row. And similarly, we did it for the schema 2 also. If I say schema 2 dot actor, so it is coming as again blank. There is no data because we created the structure only. And if I say select a star from actor, it it displays the data from public schema with the table actor. So how this all is happening, we will see. And if you wanted to drop a schema, just say drop schema name, and if there is any object, you will have to say drop schema name and cascade. There is something called as schema search path. So when I'm saying select star from actor or select star from schema1 dot actor, how it is actually doing, or if I'm just saying select star from actor, is there any parameter which is deciding like from where it has to pick the information? So there is something called as search path. So if we go to PSQL and say show search path, it will show the two output. One is $user and another is public. That means the user which is connected. So by I'm connected through the Postgre user. So when I am going to create any object or select any object inside this particular user, by default it will look for Postgre user schema. If it is present, it is going to create object or select object from there. If that particular schema is not present, then it will go to public. So if I, oops, again I clicked this. So this is my DVD rental database. So I have three schemas. By default, I'm connected through the Postgre user. If if the schema is not present with that name, it will look for public. Why? Because that thing has been mentioned in search path. Either the schema should available with the username, or the second option is public. So if the first option is not available, it is going to look for the public schema. What if I wanted to say select star from actor and it picks the information from schema dot actor? So what we have to do is we have to tell to the instance, you go and look into schema 1. So we will have to change the settings. How do we do that? We can, if I say show search path, we have user public. So instead of user, by default, I wanted it to come from schema 1. So I have to set that. So we'll say set search path to schema 1, comma public. So that means it will first look for schema 1. If that is available, it is going to show the data from there. Let's verify it. Yes. And if I say select star from actor, so I have a blank table available in schema 1, so it should show that. So you can see that. And if I have to search from the public schema, I have to explicitly mention select star from public dot actor. So you can see that. So how everything is being controlled? Everything is being controlled through search path. And you have some schema and privileges as well. So by default, uh, users do not have access into the schemas which they do not own. That is true. You have to give the permission. So what is the usage pattern? You should issue revoke create on public schema from public. That means you should not allow any user to create or select the object from there. Selection is fine, that's not a problem. If you wanted them to create the object inside that, that should not be allowed. What if there are multiple users and they wanted to create the object with the same name? So it is going to be a problem. So what you should do is you should remove the public schema from default search path. So what we did right now is we changed it to from user dollar comma public to schema 1 comma public. So you should do similar for the application user, right? Remove the public schema from default search path by issuing alter role all set search path equal to. So it is a good practice to have the schema name with the same name so that they can create the objects over there. So the conclusion of this is you should not use the public schema. So just a recap of what we did is we learned what is a schema. Schema is just a kind of folder or container which contains objects which you can see in. Um, Sorry, I clicked again. So I have a database which. Oops. Where is the screen? Okay. So I have a database DVD rental. Inside DVD rental, I created by default there is one public schema, so everyone will be able to. So those who have access to this particular DVD rental database can select from public schema, and they will be able to create the objects over there. What you should do is you should create the named schema where in the application owner can create their objects, or they are the owner of this schema. And how to modify that, you should change the search path so that by default it doesn't go if that user dollar is not available. That means if the schema name which is not equal to the connected user is available, that will go to public. So you should remove that. In that way you can organize your objects better. And if you just right click on one of the schema, then you can see you can do a lot of things. You can create the script, you can backup, you can restore, you can grant the wizard, you can search objects. There are a lot of things you can do with that. So schema is a great object in your Postgre, and you should use it wisely. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is Postgre table space. So this is an introduction to the Postgre table space. So if we say in the layman language, we'll say table space is a space or a storage location where all the tables or objects occupying the storage are stored. So what is table space? So it is a location on the disk, whether we are talking about the file system on the Linux or drive on Windows system. So this is the location where Postgre stores data files, and how Postgre is letting the instance know where it has to store the file, that is referred in the table space. So what table space actually does, it map a logical name to a physical location on the disk. So in the demo, we will see the logical name and where does it corresponds to. So you would already be knowing that there is something called as $PG data, which denotes to the data directory location in Postgre, where by default all the data files or objects occupying the storage are stored. So when we talk about the table spaces are nothing. They are just a logical name which corresponds to a physical location on the disk. Let's say you have installed your Postgre instance on the on database in Windows system. Then in your C drive at a particular location, you will have the data files located. So by default, there are two kinds of table spaces mentioned in Postgre. One is known as the PG default, which stores all the users' data will be stored over there, and PG underscore global, where all the global data is stored. So when an instance is created, you have two table spaces. One is PG default and another is PG global. Default means the one where user data is stored, and global means where all the global data is stored. So it's good to ask, what is the advantage of using table spaces? Let's say I wanted to create a new table space. So does it mean something? So by default Linux, the data files are located in slash var lib postgre. Let's say the version is 12 and slash data at this particular location. But the storage in slash var, which is the default location data directory, is not unlimited. And if you wanted to create a new file system, if you are unable to create extend this storage, and if you wanted to use a new file system, and in that case you have to create a new table space, and you have to point that particular location to the new file system or drive. Or there may be a possibility that you have high performing storage and you create a new table space and you put your high performing objects which requires the high performance in that table space, and it is good for the performance of PostgreSQL instance. So what is the default storage in PostgreSQL? So when you install your Postgre, let's say on RHEL or Windows. So in Windows, everything will be done automatically by the run installer. But in Linux system, when you install the binary, then it asks you to initialize the database. So you initialize the database using pg underscore ctl hyphen d, the data directory location if it is non-default, and initdb. So you start the instance following the initialization. And what happens during this course of action, there is a location which is created, which is called $pg data, wherein all the data or data files related to PostgreSQL is stored. So by default, there are two table spaces which are created when you install a new instance. One is pg underscore global, which refers to the global system catalog uh, catalog files, or what do you say, uh, the shared system catalogs. Or there is something called as pg underscore default, where your user data is created. So we are more interested in pg underscore default because your user data will be stored over here. And how do we create a new table space? For creating a new table space, you will have to log in into Postgre command prompt and just say create table space name, location, and this is the physical location on your Linux system or your Windows system. And on the Postgre prompt, if you say slash db plus, so this will show you all the table spaces available. So how do we create the object in a new table space? So you simply say, let's create a new database, create database db1. And if you don't want to mention the default table space, and if you mention a new table space which you have created, you simply say create database name, which is more than sufficient. And if you wanted to have these database created in a new table space, you just say table space and table space name. So you switch to the new database, and then any table which you create inside that database will be automatically created in the new table space. That means it will go to the new file system or the location which you have mentioned. Otherwise, what you can do when you create the tables using create table command, you can mention the table space name. So either you say table space, new table space, or table space, the existing table space, which is pg underscore default. So it works this way. So now we'll see the demo, how it works. So we will initialize instance, and once the initialization is done, we will check what is pg data, which we have already discussed in the previous tutorial. And then we will see what is postgre table space, what is the default table space, and then we will see the location of the default table space. We will create a new table space, the objects in the new table space, then we'll move objects from one table space to another, and then we will see on the instance label how to change the default table space. So this is what we are going to do on Postgre demo. So this is the list of steps which we are going to perform. And let me close the PowerPoint presentation. And this is my Linux box. I'm already logged in as MOBA Xterm tool. So I'll just say sudo su hyphen postgre. Sorry. Let's clear the screen. And what we are going to do is either you create a new instance or you initialize the existing one. So we are going to initialize the existing one. We will say pgctl hyphen d data init dv. So let's do this. So, okay, let me do one thing. Let me stop the instance, or let's create a new instance. I'll just say mkdir-p and create this location. And then let's instantiate it. pgctl-d, the directory location, so that a new instance is created in a particular data directory, and initdb. Oops. It is also not empty. Let's create another one. Let's say 2. Create this directory. Done. Then start do the initialization. This is also existing, so let me see what all I have done. Instance 1, instance 2 is also available. Let's create instance 3. mkdir and then initialize the database. You can see that fixing permission on existing directory. This is data directory. So this is how you create a new instance. So let's initiate or start this particular instance. This is starting. This is how do you start the instance. So what I will do is I'm not going to use this. This is just how do you create a new instance. I'm going to the existing one, sudo system ctl status PostgreSQL -12, and you can see there is something called as pg data for the default instance. So I'll go to cd $pg data. If I say ls-lrt, you can see n number of files are over here. And then what I'm going to do is inside, if you see the content of the files or the folders or the subdirectories under this, you will be able to see these many number of files in PG data, right? So by default, when you create the objects, where does it go? It goes into PG data. So this will go in this particular location. So over a period of time, this particular location will keep on occupying more and more storage as the user data is inserted, created, or it is done. So how it happens? So it happens due to what do you say, the table spaces. So let me log into um, to the browser using the uh, pgadmin 4 tool. This is the IP address of my server 192.168.1.61. So just click it and you will be able to see something called as table spaces. So by default, these are the two table spaces which are created, pg underscore default. So you can see that I have a database DVD rental. So DVD rental will find the storage in pg underscore default, whether it is sequences, indexes, or there will be the tables also. So these are the tables. So you can see that these are existing in pg underscore default, and when you see the pg underscore global table space, you will see the catalog related tables or the indexes. And table space in actual uh, uh, corresponds to what you say as the pg data location. So PG data, PG underscore global table space is used for shared system catalogs, and PG underscore default is for default table space. So this is how it works. Let's create a new table space. I'll say TBS2 MKD. The first step which we have to do is we have to create a directory location or folder location in Windows. So mkdir-p, I have created that. Then what we have to do, we'll have to log in as pSQL, and then we have to fire the command. So by default, when you say /db plus, this shows you all the table spaces which are existing as of now. So I already have two more table spaces which I created in another demo. So these are the two table spaces which are created by default. And if the location is not mentioned, that means it is corresponding to PG data, which is the default data directory location. If you have changed the data directory location, it must show it over here. So the next step is we have to create a new table space. So the command is create table space name, and the physical location on the file system. So you can see there is a relationship between the location and the table space name. Table space created, just say /db plus, and this will show you the new table space which we have created. So this is the new table space tbs2, and this is corresponding to this physical location. So what we will do next is there is something called as pg underscore table space location. uh, pwd, I'm inside cd data. This is your default data directory, and there is something called as pg underscore table space. If you go inside that and say ls-ltr, this will show you a symbolic link. In our case, this is the object ID, OID, unique object ID for the new table space. The Whenever you create a new object in a new table space, it goes to postgres /data /tbs2. So all the information is still there in pg data and in pg underscore table space. So it has created the link automatically. So now let's create the object. So we'll say create, we have already created the table space, uh, and now let's create a database. Create database db2 table space tbs2, which is already we have it. Oops, I entered the wrong password. All right, just say create database name and table space name. So that means this particular database will be created in new table space. So any object which is created inside this one will be automatically uh, created in new table space. So that's obvious. So let's switch to the new database, which is DB2. And now let's create the table. When we say create table, tab 1, so it is going to create that particular table in your new table space. Let's say create table tab 2, and if you mention the table space name, then also it is going to create in the new table space. Or if you wanted to mention the table space name, it will. So there is nothing great in this. You just mention where you wanted to create it. Let's say I wanted to create a new table space in default new table in default table space, so I can do that. So the problematic part is when you have to mention the table space name. So how can we do that? Can we move the objects from one table space to another? We can do that. Or can we alter the uh, change the table space from one to another? We can do all of that. So if I just say alter table all in table space, and we set it to default table space, it is possible. We can do that. But whenever you do all this operation, there will be a lock on the table and nobody will be able to use that. What if I wanted to utilize the new table space? So any new user who comes in wanted to use the new table space. So let's do a demo for that. So let's create a new location, mkdir-p postgres/data new table space 2, and we'll say the table space name is tbs 2, and this is the location, and we are going to create a table in new table space. So this is this is the time taking process, right? We create a folder. This is an administrator part, so that has to be done without any you cannot skip this step. The second is when you create you have to create the location, you have to create the table space with the new location. And if the application team wanted to create the table inside the new table space, they have to mention the table space name. So create table, table name, table space, but this is problematic. Let's create a new table because this table already exists. Oh, this is also existing. So it is create table, table name, table space, new table space name. Yes. So this is done. But it is always very problematic when you have to mention this. So can we do something so that the default table space has changed? So we can say set default table space to uh, the new table space name. So we can set this. Let's just say show default table space. So there is one default table space. And let's change the default table space to the one which we have just created. You can see the default table space is changed from pg underscore default to so any user now who is going to create the data, uh, either table indexes or anything, so it is going to find the storage in new location, which is this location, and which is corresponding to this particular table space. Since we have already mentioned it that default table space is this, so any object which is created will be created in this particular table space. So if I simply say uh, create table foo3, then it is going to create the table into new table space. And if you wanted to cross verify, what you can do is just refresh it. You will be able to see the new table space and the objects will be here. So still it is showing fetching dependent information from the server. So this is the foo 2 and the 3 which we have created. So this time we have created foo3. So by default it has gone to the new table space. So is there a way we can so the problem will be when you have to take the backup. So the command is already mentioned, pg underscore base backup, which we have already seen in previous tutorial. You just mentioned the format, and you have to mention the location of your new table space which you have, the additional table space which you have to create. So you have to just make a note of that. And finally, why is table space used for? So table space just used so when your database is growing, so you wanted to go to a new location, so you mention it using the new table space. Or it may be possible that you have a high IOPS or SSD disk which you wanted to use for your objects, so you create a new table space and move your all objects over there. So just a recap what we have done. We initialized an instance, and then we saw what is PG data. PG data is nothing but all the data in your instance goes to this particular location, which corresponds to the default table space. Default table space has two components. So by default, when an instance is created, you have two table spaces, pg underscore default, pg underscore global. Pg underscore default is a table space wherein user data is stored, and pg underscore global where global data is stored, which is related to the instance. And then we have seen what is the default table space location. Default table space location is pg data, and then we created a new table space. So you create a new physical location using mkdir, then you create the table space, then you mention the location, so it will be linked. Then you say slash db plus, so this will show you the all the table spaces. And when you go to cd2 data and pg underscore table space, this will show you the symbolic link. That means all the information is still in pg data, pg underscore table space, and new location will be mentioned over there. And that is a kind of symbolic link. So you can see we created this particular tbs2. This is the unique object id, and this is the new location, and it is available in uh, pg data inside pg underscore table space directory. Then we created a new table space, and you can create the table ending with the table space name. Either it is pg underscore default or the new table spaces, or if you wanted to set the table space parameter at the instance level, you just say set default table space and table space name, so that the new objects which are created, they will be created inside the new table space. And how do we back up the additional table spaces? You can use pg underscore base backup. You provide the table space mapping, and that is it. And finally, why is table space used for? Uh, Table space is actually used when your database is growing and you wanted to go to a new location, new physical location on the server. And so you bind the logical name with the physical name. The logical name is your table space, and physical name is the location on the server. And there may be a scenario also wherein you wanted to keep the frequently accessed indexes or the tables into that particular high performing disk, and you create a new table space and you move all the objects over there. So this is all about the table spaces in general. So I think this is more than enough. I hope you have learned a lot about table spaces in Postgre, and see you in another video. And thanks for watching. And welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to perform the routine maintenance task in PostgreSQL using pgadmin for graphical tool. So what is the requirement of doing the routine maintenance task in PostgreSQL or any other RDBMS? So uh, it is very, very important to perform the routine maintenance tasks so that whatever uh, uh, degeneration of the file system or fragmentation has happened on the table or index level or the file system level, that can be reclaimed. We will not be talking about the file system. We will talking about only the table and the index fragmentation and some of the other commands. So there are the certain tasks which we have to perform to attain the optimum performance in PostgreSQL. Some of them is here, like vacuuming. We have a separate tutorial, detailed tutorial on vacuuming. What is vacuuming? And vacuuming is nothing like whenever there is an update or delete in Postgre tables, the rows which has to be deleted or updated do not go out of the table. They remain there in that particular table as the dead tuples. And if there are too many updates or deletes, then the size of those dead tuples, dead rows will keep on increasing. That leads to the uh, degeneration in the table performance, so that whenever any query is using those tables or the indexes where vacuuming has where data pulse has happened, then it is going to degrade the performance of the query. So using the vacuum, what we do is we try to remove those dat tuples. If you are doing the standard vacuuming, what it will do, the dat tuples will be removed and it will be available as free storage in that particular table. When you do full vacuum, what it does, it creates a new table and it removes all the dead tuples from there. And there is another routine re-indexing. If the table has what do you say, the fragmented, and then it is surely going to depend the impact the index as well. So what do we do in database maintenance? We do the defragmentation of the tables or the indexes or the data files using some of the methods which is given by default in the pgadmin tool. And why those fragmentation happen? It is due to it is happening due to the insert or the delete operations on the tables, which is causing or leading to the dead tuples or bloating as well. So when we do the maintenance, it helps in reorganizing the table and the indexes and enhance the performance of the database. So we'll be talking about the four maintenance process. One is vacuum, wherein the data tuples will be removed from the table. If we are doing a standard vacuuming, then those data tuples will be available as free rows and they storage, and they can be used later on. When we say analyze, analyze is going to analyze the tables, and that will be used by the query optimizer so that it can pick up the latest uh, statistics of the table. When you say re-indexing, re-indexing is going to what do you say, create the new index wherein there will not be any fragmentation. And last is the clustering of the tables. So vacuum, we have already discussed like what is vacuuming. Then we have discussed about what is the use of analyze. Analyze, what it does, it tells the query planner to update the statistics, and it is going to generate a good plan when those tables are getting involved in the query. And how do you generate the statistics on those tables using the analyze command? It is one of the optional step in vacuum. By default, it is disabled, but you can enable it. Reindexing can be done to remove the fragmentation from the index. So we will see how to do that. And the last one in this is the demo. We'll see how to perform the demo. Let's and the and I'm logged into to pgadmin 4 GUI tool, and I have some of the database which I had imported. One of them is DVD rentals. What I'm going to do, just right click and say maintenance, and a window will be popping up, and you can see there are four things: vacuum, analyze, index, and cluster. Vacuum by default it is no, because when you say full, Full vacuuming, that means it is going to lock all the tables, it is going to freeze all the updates, and this that means you cannot do any kind of update on the table. And if you say analyze, you can do the analyze. So by default, full is no, freeze is no, analyze is no. And if you just say verbose, you can run this analyze vacuum command. Just say okay, and it will show you the progress. So more details, we will see how it is going to do. It's just a vacuum verbose command on the particular database. So it is a standard uh, vacuuming happening onto the database, but it is not going to log the tables, or it is not going to run the analyze command. If we have to do it, you can see that it is successfully completed. You just go and just say maintenance, and if you are sure that it is a complete downtime, you just say full vacuuming, and depending upon the size of the tables, it is going to take its own time. So you will have to do some kind of testing how long it is going to take. And if you wanted to analyze, which should be done if you believe that the table statistics have changed, then you need to, let's say, the insert or the update and the deletes have changed at least 10 or 20% of the data, and it is going to impact the performance of your database, then you can run this. Just say okay, and you will see that maintenance job is created, and it will pop up. Yeah, so more detail. So what it is doing is vacuum full, freeze, verbose, and it is going to run this command. So in the first, we saw that vacuum verbose only. Now it is doing the full vacuum. It is freezing the tables also, and it is showing you the output as well. Successfully completed. Since it is a database which is just in KB, that's why it is taking lesser time. Going to maintenance again and just doing the analyze. If you just do analyze, it is going to analyze all the tables in this particular database. Just say okay, and you will be able to see what it is going to do. So the maintenance job is created. It will pop up. Just say more details, and it is saying analyze verbose. That means it is going to analyze all the tables which are there in this particular database. So if you see, the data tables over here are these. So it is going to analyze all these tables. So you can see here also analyzing public.address, that is one of the table. And if you see, it should be somewhere here. Yep. So it is going to analyze all the tables. So analyze increases the performance of your uh, uh, database, because the query planner updates the statistics, and that is used during the execution of the SQL query. We can check one more thing, and just right click onto the database, just say maintenance, and you can do the reindex. Just say okay, and you just have to tap on that particular tab, whatever you wanted to do. Just say more detail, reindex, database name, and it is going to reindex the entire database. So reindexing is completed. The final in this is the last one, which is maintenance, and you just say cluster. And if you just say OK, and this is not the task which we have automated. This is just we are doing an ad hoc. If you wanted to do it in a scheduled way, either you do it, put it into a cron job, or you do it using the PG agent as well. So we are doing the cluster verbose, so it is going to run it. It is showing successfully completed. So this is how do we do the routine maintenance in Postgre using the pgadmin 4, and it is very easy. You just right click onto the database, just do maintenance, and all the 4 options will be available. I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is vacuum and auto vacuum in PostgreSQL. So first of all, let's see what is vacuum in PostgreSQL. So uh, Let's consider a situation wherein you have a table with over 1 million of rows, and your application continuously updates and deletes the rows into the tables. Let's say thousands of rows are getting updated or deleted every hour. So just to maintain the MVCC architecture in PostgreSQL, what it does, let's say the 1,000 records has to be deleted due to the nature of the application, then those 1,000 rows are not getting deleted. What is done by the Postgre is they are marked as the dead tuples. That means they still occupy the space into your table, and the table size keeps on growing. That particular row is not usable and it has no dependency. So those are marked as dead tuples. So every hour, let's say thousands of rows are getting, let's say, piled up in your table, and within 24 hours, let's say you have 24,000 rows which keeps on accumulating. So Postgre came up with the process which is called as vacuum, wherein those dead tuples, they will be cleaned up by a process which is called as vacuum. So what is vacuum? Vacuum is used to free up the dead tuples into the tables, and these rows can be reused. So you can use that rows later on. There may be an option also wherein that row can be returned back to the operating system. So let's see what is vacuum at a glance. So what happens? When you do the vacuum, which is a command on your Postgre. So Postgre vacuum command will remove those dead tuples, or those rows which accumulated when they have been deleted or updated from the table, and they are valid both for table and the indexes, because when you update your table or delete the data in your table, the corresponding indexes are also altered. When you do the vacuum, it is not going to return the unused storage to the operating system, but those particular storage area, let's say this is marked as the tuple, which is has been deleted. This is no more usable. When you do the vacuum, this will be returned back to the table, and this can be used. So when you do the vacuum, it takes the compute from your system. It is going to take CPU, it is going to use the IO. So this has to be done only when your application activity is low and you have enough storage on your operating system. You can do something called as vacuum full. When you say vacuum full, it is a process which takes lots of compute, which is CPU and memory, and it is going to return back the storage to the operating system. So only when you say vacuum full, this is going to return the unusable storage to your operating system. But this is a very challenging task, because when you do the vacuum full, it is going to log the table. That means it is a kind of complete downtime for your application. You cannot do any operations. Even select operations are not allowed. When you do the vacuum full, it is going to create a new copy of the table, so that those data tuples will be completely removed. So you need to have double the storage, which is a kind of challenging task in your production environment. This can be only done when you are going to refresh your entire system, and consider this only if you have enough storage. So most of the time this is not possible. So what happens when a table with millions of rows in a day, and 24,000 rows are updated or deleted? The statistics of the table also gets changed. So instead of 1 million rows, there will be a minus 24,000 rows lesser in that table. So when the query execution happens and that table is part of the query, then it is not going to have the current statistics. So what you need to do after such activity wherein the table is heavily updated, then what you need to do, once you have to do the vacuum so that the unused the dead tuples are removed, and once the dead tuples are removed, you have to update the statistics of the table using the analyze command. So this will update the statistics, and the latest statistics or updated statistics are used for the query during the execution plan, and your query will be able to execute in in a lesser time. So when you do the analyze, you can do it for the entire database if you think the fragmentation has the updation has happened so much. So you do two things: you do the vacuuming and you do the analyzing. Vacuum we do because a lot of dead tuples has accumulated. Analyze you do because the corresponding tables and indexes, what do you say, the stats has also changed. Uh, Postgre came up with the with what do you say, the process which is called as auto vacuum. So instead of you doing it manually vacuum, Postgre will do it on your behalf. So by default, auto vacuum, the vacuuming and analyze is happening automatically at the database level. So by default, this is on in Postgre. So you need to remember some of the important parameters of the auto vacuuming. So auto vacuuming is when the vacuum is done automatically by the database. So by default it is on. So in postgresql.conf, if you say auto vacuum, this should be on. That means your auto vacuuming is working. Then there is another parameter which is known as log auto vacuum minimum duration. As the name suggests, log. So it is going to log the auto vacuuming activity when the value has been mentioned. If it is -1, that means it is not going to log the activities. If you mention the value greater than 0, then it is going to mention capture what all auto vacuuming it has done. Then another parameter is auto vacuum max workers. That means by default there will be one auto vacuum process. So that is uh, uh, in case you have n number of tables where this vacuuming has to be done, then one worker will not be sufficient. So you need to increase the number of auto vacuuming workers. So by default it is 3. So along with your auto vacuum process, there will be 3 more sub workers which will do the vacuuming process. There is something called as auto vacuum nap time. So once the auto vacuum has launched for the first time and it has finished its task, then after what time, after sleeping for how many minutes, it is going to execute again. So it is going to execute again after 1 minute. Then we have another important parameter, which is auto vacuum. Vacuum threshold is equal to 50. If 50 rows have been updated on a particular table, then auto vacuuming is going to happen on that particular table. So vacuuming and analyzing, they work together. So once the vacuum has happened and there is a updation of 50 rows on a table, then it is going to launch auto vacuum. So vacuum and analyze is going to happen on that. There is something called as auto vacuum scale factor equal to, by default it is 0.2. That means if a table which has 100 rows and if 20% of the rows have modified or there is a change, then auto vacuum is going to launch and it is going to remove the dead tuples and it is going to update the statistics. So vacuum and analyze is going to happen. So auto vacuum analyze scale factor equal to 0.1. That means if a table which has 100 rows and if 10%, that means 10 rows have modified, then the analyze command is going to execute on that. And similarly, you have auto vacuum, vacuum cost delay. That means the default cost value for the auto vacuum. This is 20 milliseconds, and default vacuum cost limit. This is by default -1. So now let's proceed with the demo. So So I'm going to put this in the comment section. So what is vacuum? Then what is a manual vacuum command? Then what is vacuum full command? And how do we check whether vacuuming is enabled in my system or not? And then we'll see some of the parameters. So let's close this first. I'm going to close this out. Okay. I'm logged into the MovaXterm tool, and I'm connected to my database server, which is 192.168.1.61, and I'm on the command prompt. So I'll just say select name comma setting from pg underscore settings, where name equal to auto vacuum. So by default this is on, so this will show that auto vacuum is on. And we discussed about the auto vacuum parameters, like auto vacuum on, this is by default. Then when auto vacuum has to log all the activities. If it is -1, it is disabled. What is the maximum number of workers that should launch along with the master auto vacuum process? Then you have auto vacuum nap time, for how many minutes it's going to sleep between the second execution. Then you have auto vacuum threshold. That means if 50 tuples have accumulated, or 50 rows have updates minimum, then it is going to execute. Then you have the analyze command is going to execute when there are changes in 50 rows. Then there is vacuum scale factor 20%, 0.2. That means if there is a change in 20% of the data, then vacuuming is going to happen on the table. And similarly, analyze is going to happen if there is a change in just 10% of that. Those were the important ones. And again, that why Postgre creates vacuum, it is just to maintain the MVCC architecture, that those dead tuples keeps on accumulating after deletes or update. And finally, we'll see. Let's list out the databases. If I switch to DVD rental database, it will be like this. And if I do a vacuum process, vacuum verbose analyze, this is how do we do it. So you can see that it is doing, although there are no dat tuples, so it is going to do it on the indexes and the tables both. So you can see if I fire this command, so this will show how many. So it is select rel name comma n underscore dat tuples from pg underscore states underscore user underscore table. So this will show the tables in my current database, which is DVD rental. So how many dat tuples are there? If there are dat tuples, then you can vacuum it. Otherwise, auto vacuum is going to happen automatically. You can check this storage utilized by all the tables. Let me do it this way. Let's see the size of all the tables. So rental table has this much of size, and so on and so forth. So if you are doing vacuum full, it is going to take this much of storage again, and this is like creating a new copy and deleting the old one. And you can see when the vacuum has last happened on this particular list of tables, since we did it right away. So this is the current timing, and you can check. This is the way you check it. So just a recap of what we have done is We checked what is vacuum in PostgreSQL. A vacuum means it is just like that tuples keeps on accumulating in a table when those are deleted or updated, and you have to either manually remove it or it is removed by something which is called as autovacuum process. So vacuum is nothing. It is like the dat tuples keeps on accumulating in your tables and indexes when the related data is updated or deleted, and it accumulates uh, in your table. And this keeps on growing the size of the table unnecessarily, and the performance get decreased. So you have to remove those dat tuples from the index and table using the vacuum command, or auto vacuum does it itself. If you say vacuum full, then it is going to lock all the tables, and it is going to use the double storage. It is going to create a new table as well. So we discussed about the plan, updating the planner. So it is like in auto stats, in auto vacuum, your vacuum and analyze work together. So once vacuum happens, the corresponding statistics of the table also changed. Let's say in a table with the 1 million rows, 100,000 are updated daily, then you have to update the statistics of the table as well using the analyze command, or auto vacuum does it automatically. Then we discussed about what is auto vacuum. So when vacuum happens automatically by the database, it is known as auto vacuum, and by default it is on, and there are some corresponding parameters, and the important ones are like auto vacuum max workers and the nap time, etc. What is vacuum threshold, vacuum analyze, um, like 50%, 50 rows are updated, then this auto vacuum is going to launched, or if 20% of the rows are updated or 10% of the rows are updated, then analyze is going to kick off. And finally, we saw a very small demo. You do the vacuuming manually, and it works that way. So I hope this is going to give you a brief idea of how this auto vacuum is working, and we'll see new property of Postgre in some other tutorial. I hope it is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is bloat or bloating in PostgreSQL. So let us see what is bloat in PostgreSQL. So let's take a scenario wherein an application is trying to update an existing record in a table of a particular database. So when a update happens, it does two actions. First, it creates a new record, which is a result of the update, and the previous value of that particular record is still existing in the database or in that particular table as a dead tuple. So let's say in that table, due to the application behavior, the rate of generation of those dead tuples is more than those tuples are getting removed. It is known as bloating. So you must have gone through the auto vacuum process, wherein the dead tuples in the tables are removed due to auto vacuum. And if the rate of accumulation of the tuples in the database is more than the rate of the removal, it results in the existence of those dead tuples that they keep on accumulating. So that is known as bloat. Let us see a bloating scenario, how actually it happens. So I'm just taking the same example again. Our application is trying to update or delete the records in the database, let's say particular table. In a minute, there are about hundreds of records. They are updated or deleted. And due to the behavior of Postgre, when 100 records are updated or let's say deleted, it results I it results in two action. If it is an update, 100 new records are generated as a result of update, and exact 100 records are accumulated as the dead tuples, which has the previous value. And if my auto clean process is running, which is used to remove the tuples, and let's say my auto clean, which is known as the auto clean process, is trying to remove those tuples, which is known as the auto vacuum process. It is removing 90 records per minute. So every minute 10 records are getting generated or accumulated as dead tuples. So this is leading to bloating. So in 1 minute, where 100 records are updated, 10 records are keep on accumulating. So you can understand how many dead tuples will generate in an hour or in a day if those dead tuples are not removed. So what is the problem they may cause to the PostgreSQL? First of all, the number of records, they will be more, although they will not be visible, but in terms of the size of the table, it increases. So what it does, it decreases the performance of overall query execution, wherein that particular table is involved, where bloating has happened. And when the bloating is there in a particular table, let's say there are 100 records, 1000 records in a particular table, and due to bloating, this has become 2000 or 3000. I'm assuming that those dead tuples are not uh, uh, removed, or due to let's say we are not knowing, or due to any reason, so we have not removed those dead tuples. So it leads into the inaccurate statistics of the table. So when the query having that particular table is executed, it gives the wrong statistics of the table. Instead of having the actual 1000 rows, it has more than 3000 rows. It has to traverse. So it gives the inaccurate statistics when the execution happens for that particular query wherein that table is involved. So when a query executes there, it generates an execution plan, and if the table statistics are not correct, then the execution plan will also not be optimum, and instead of giving the best results on a best time period, it will give you the result in an appropriate time. Let us suppose the execution time should be 10 seconds. Then due to this bloating, and it depends upon the number of bloated rows, it may be more than that. So it is causing a lot of problems. So it causes the performance degradation of overall database, where bloating has happened in those tables. So what are the options for removal of those? It has to be removed. So you can go for the vacuum full, which is a manual process. When you do the vacuum full for the entire database, let us suppose we are going to do the vacuum full for the entire database. It is a kind of complete downtime for the database. You cannot do anything in that particular time. So it is just like it is going to create a new copy, and the tables will be logged during that time. And you need to have double the space. uh, let's say your table is of 10 GB, then you need additional 10 GB so that it can create a new copy and can delete the older copy later. So this removes the bloat. Second is PG repack. So this is an online option to rebuild your tables where bloating has happened. And when this is not available by default, so you need to install this package. And once it is installed, you can do the online repacking of your database or the table. So what it does, it creates a fresh copy of the table without those dead tuples, and it is as good as your full vacuum, but this is not going to lock your table for like your vacuum process is doing. And last in this is the demo how to remove the bloat. So I have listed the step over here, and I'm logged in as a Postgre user. Let's log into pSQL prompt, and let us see the number of tables which I have. Let's say the databases I have. Let's go to DVD rental. So what we are going to do is we are going to do two things. One is, let us assume, although there is no bloating, I have not deleted or updated anything. So I'm going to run a vacuum verbose analyze. So what it is going to do, it is going to do, uh, let's say, vacuum full, and we can give the table name, or let's do it for the entire database. I'm not okay. Let me switch to DVD rental database. Yes, and now execute the vacuum command for the entire database. So you can see all the tables in that particular database are getting vacuumed. Although there is uh, no dat tuple, but it has done everything. So you can see uh, vacuuming this particular table and the index. Let's say here also public.film. This is the table name, this is the index name. So it will remove, since this is a very small sized database, but in large database it can take its own time, and this takes a lot of CPU and the compute resources, so you need to plan it during the complete downtime. And second is PG repack. So what I can do is my PG underscore repack binary is available at this. We can do some kind of dry run for the database. So let's do this. So PG repack hyphen dry hyphen run DVD rental. So we are going to do a dry run. Oh, okay, this is, I have to come out of this, clear the screen, and let's do the dry run. So you can see repacking is happening. So it is going to repack the table again, so that all the bloating is removed. This is a dry run, and when you do it, actually you will be doing it like this. Uh, PG underscore repack hyphen D, then the database name, or you can give the table name also. So you can give hyphen hyphen table and the table name. I'm doing it for the entire database. So let's see how it is happening. So repacking table. So this has done. The first one was dry run, how it is going to happen. Then there is the next one is the actual run. So just a recap of what we have seen is, what is bloating? Bloating is nothing, just the dat tuples which keeps on accumulating into the database, and when your auto vacuum process is not able to remove it, the number of data tuples keep on accumulating. That is known as the bloat. Bloating scenario we have taken wherein an application is generating a number of, it is going to update a number of records, and few records keep on accumulating as dat tuples, resulting in the bloating, and leads to the poor performance of the database due to the size of the table, which has increased enormously, and the indexes go as well. The statistics of the table change because the actual records are named not same as the records which are present, because of the dat tuples, the query execution plan go haywire because of the wrong statistics. And then we saw how to remove the bloating. We saw vacuum full, which locks all the table. Uh, and it requires downtime. Then another is PG underscore repack, wherein the repacking for the individual table happens, or for the entire database, and this is an online activity. And this is good. And I have installed it separately, and once I have repacked all the tables, I'm going to remove this particular package. So then we saw how to remove the bloat using both the process uh, vacuum full and then PG repack. I hope removal of bloating process is going to help, and thanks for watching. Welcome. In this session, we are going to learn what is vacuuming fundamentals in PostgreSQL. As the name says, vacuuming, it is actually going to do the vacuum of PostgreSQL. So as usual, everything is there in a notepad, and we will walk through this. So one of the fundamental thing about the databases or any software product is if you do the regular maintenance of those products, which is the suggested one, the performance will be good. The same goes with the PostgreSQL. PostgreSQL suggests you should do the periodic maintenance so as to avoid any kind of overhead which comes when you don't do the maintenance activity. One of them is the auto vacuum. As the name says, auto vacuum is a vacuum process which removes the dead spaces, which is in the form of the tuples from the table, and it improves the storage utilization, and it removes the dead rows, which are also known as the tuples. One of the thing which is for the Postgre is to maintain the MVCC, which is multi-version concurrency control. Whenever a row from a particular table is updated or it is deleted, it is, and if the same row is being used by some other concurrent session which is going to read, and the other session which is going to update or delete that particular row, in that case, just to maintain the lower category of the locking mechanism. What it does, it retains the previous version of the data in the table in the form of the tuples, and that will be visible to your SQL query, the active transaction till the time they are in use. The moment the data or that particular row is updated, and the concurrent session which is reading the data of the older one, it is marked as the frozen one, and it is called as the tuples. What happens over a period of time, that particular the number of such dead rows, or they are known as the tuples, they will keep on increasing. Fundamentally or basically, they are not going to get removed automatically. Somebody has to remove this, and there is a process which is called as auto vacuum, which is available as a background process in PostgreSQL. It is going to do all the stuff which is known as the vacuuming. So what vacuum does, it reclaims the storage by removing uh, the unused, or the not the unused, I'll say the dead tuples or the unwanted rows which have been actually marked as deleted or removed or updated from the table. So if you don't remove those rows, what it will do is over a period of time, it will keep on accumulating the size in your table, and the performance of the table will go slow. If you are doing the vacuuming, which is a background process known as the auto vacuum, then what it will do is it will periodically check the tables. It will check if there are unwanted dead rows which are not supposed to be there, and it is going to clean them. And it is a very frequent activity. It will check for some conditions. Say, for example, if there are 50 tuples, or if 20% of the total rows of the tables are changed, and that means there will be so many numbers of the dead tuples in your table, and through some way you are supposed to remove it. Postgre very, very strongly suggests you should not disable the auto vacuum process unless or until you have done some deep research which says some of the tables which are very, very large in size, it is very volatile in nature. The number of the rows which are updated, they are very high, and they are not able to keep up with the kind of auto vacuum thresholds which are there. So in that case, to particular table, you can do the vacuuming according to your requirement. So that's the basic. So why is the vacuum required? A vacuum is required to remove the tuples from your table, and it is going to release that space back to the table so that the new rows can utilize that. And there is other way also in some of the scenarios. If you use the full vacuum, with in that case it is going to release the storage back to the operating system. In that case you can use that. This is one of the reason why vacuum is required. This is removing the tuples. The second is the data in your table. If the statistics is not properly generated, in that case the query planner, which plans the execution plan of your query, in that case it will not have the enough data. It will not able to generate the proper SQL plan for your query. In that case the performance of the SQL query can go down. The third one is known as the visibility map. In that case, if the visibility map is not properly updated, then it is going to impact your query as well. The last but not the least, it is about the transaction ID wraparound, which says if your transactions in your database they cross 200 millions, then you need to perform the vacuum. Now we'll talk about what are the different types of vacuum. There are two types of vacuum. One is called as the full vacuum and another is called as the standard vacuum. By default, the vacuum which runs using the auto vacuum launcher, it does the standard vacuum. What it does, it removes the dead rows, and those dead tuples, they are given back to your tables, which can be used for the rows which are being inserted or the new rows. But this will not be given back to the operating system for so that you will not see the any space which is released at the operating system. But for the production environment or any environment wherein Postgre is very active, you are supposed to use the standard vacuum, because it is not going to interfere with the normal operation of the table, because it is a recurring activity. Every time it is going to check whether, if we go with the default setting, which says that 20% of the table data must have changed, or 50 tuples would have generated since the last execution of the auto vacuum process. In that case it is going to execute, and also it is not going to interfere with your normal application which is interacting with the database. Any sort of insert, update, delete, whatever operations it is not going to interfere. Only there is just one case. In case your database table definition changes, in that case the when the definition is changing, it is going to put a exclusive lock, and in that case the standard go vacuum is not going to work. But in case if you go with the another type of the vacuum which is known as the full vacuum, in that case it is going to create another copy, temporary copy of the table. And one of the thing is you might already be suffering with the storage scarcity, and if you try to do full vacuum, that means it is going to be a kind of complete downtime for the application. You don't have the storage, and it is going to pick up all your CPUs. So it's not suggested to do unless or until you have a very strong reason which says we should be doing this because of our auto vacuuming is not able to suffice our requirement. And one of the thing observation is whenever the vacuum process is running, the IO on your subsystem is going to be high, and this what it does, it slows down your application. So how the disk is storage is getting released? One is if it is a standard vacuum, the storage will be given to the table, and the free spaces can be utilized by the new rows. The other one is full vacuum, which is like creating a new copy of the table, but it is going to completely lock your table, and in that case the application cannot use that particular table for the activity, so it is considered as a complete downtime. But full vacuum, it is going to recreate a fresh copy of the table wherein all that tuples will be removed. But the suggestion is not to use the full vacuum. You go with the auto vacuum, which is suggested, and you can tweak around the different parameters which are available. And one of the thing is, what is the difficulty with doing the vacuum according to the fixed schedule? If you try to do vacuuming according to a fixed schedule and your application is again active, let's say I disabled the auto vacuum, I enabled the manual vacuum, I put the vacuum command in cron job. Every night at 2200 hours it is executing, but because of the lot of application activity, it is I'm not able to perform the complete vacuum process in that, and the window is over. That means the number of data tuples will keep on increasing, and this may lead to a scenario wherein you have to do the full vacuum. That will be the only case, because you have already lost the chance to reclaim the storage using auto vacuum process. When to schedule it? If you are not using the auto vacuum, and if you wanted to use the manual vacuum process, in that case it is advised to use it when your application activity is low. And in that case, you have to ensure that the table is not being utilized. So if you are going with the full vacuum, in that case, you have to make sure that the you have enough storage to perform the vacuuming processes. And one other thing is, if there are some tables which are going for very high deletes, or let's say all the contents of the table will be deleted. So it is recommended, though this may not be a very usual scenario, but it may be possible that the entire table content is deleted. So the entire content will go back to the dead tuples, and they will occupy the space, and you will see the increasing number, the size increase, because the dead tuples relies over there. The second important function of your auto vacuum process is it updates the planner statistics. So planner statistics is updated when you perform the auto vacuum. So when you perform the auto vacuum process, it executes the analyze command on the tables in the database. So it means when the analyze commands happen, so your planner will be knowing that what is the statistics of my table, and that leads to the good performance, because the execution plan will be according to the statistics which is generated on the table. And it is highly recommended your table should be analyzed properly, and it is more important when your database is highly volatile, the tables are highly utilized in insert, update, or delete kind of operations. So you have something called as the visibility map, VM, which is like it is going to each heap relation has a visibility map which keeps tracks of which pages contains only the tuples which are known to be visible for all the active transactions. So it is stored along the main relational data in a separate fork. So what visibility map actually stores it stores the heap page information. That means if it has the frozen what do you say, the tuple, so it is not going to be visible, because the query which was using the active transaction or the table, it's had already completed. And you can check it using the pz underscore visibility module, and it can show you the required information. And the last most important thing about the vacuuming is it helps in preventing the transaction ID wraparound failure. So because of the MVCC transaction, what happens is in case of PostgreSQL, if you believe the transactions in your Postgre is going to be more than 4 million transactions, then you have to be very careful, and you have to set some of couple of the parameters to avoid any kind of loss of the data. So this is very important. So just to recap, there are four important functions in PostgreSQL for vacuum. We'll go them one by one again. So one is you can recover the storage using the vacuum command. If you're doing it manually, which is not suggested, you should go for the auto vacuum. Second is it helps in generation of the statistics on the table. The third is the visibility map, which helps in speeding of the index only scanning. And the last, which is related to the loss of the data due to the multi-exact ID wrap around. So this is just a basic about the vacuum, why we should prefer doing it. In another session, we will see some more details about it and how to tune it further. I hope this is going to help, and thank you. Welcome. In this session, we are going to learn what is max connection. If we increase it, what is the impact on the performance, and why it is always increased to use the connection pool in Postgre. So as usual, everything is mentioned in this notepad, and we'll start the steps one by one. The first thing is, what is max connection? So when you go to PostgreSQL and you just search for, if you say show config underscore file, that will show you the, okay, this is typo. This is the location of my configuration file, which is postgresql.conf. In case you directly wanted to see what is max underscore connection, you simply say show max underscore connection. So as of now, it is 101, and the default value is 100. So we will talk what is max connection. So max connection is maximum number of concurrent connection that is allowed to PostgreSQL. By default, it is 100, and it depends upon the kernel parameter which your operating system is going to support. And this is set when your server is started. If you have a standby server which is attached to your primary server, in that case, this parameter max underscore connection should be slightly on the higher side, just as to allow the extra connections to be executed on your standby server. If you talk about 100 concurrent sessions, that is not always allowed for the client connections. There are few which are reserved by the super user also, and that is this is called as super user reserved connection. That means there are three sessions which are three concurrent connections. They can be used by the Postgre super user in case they have to do some maintenance, and all of the users concurrent connections, they are utilized. So one of the question which arises is, if the max number of connections has already achieved, and what action do you need to take? Do you need to increase the number of max underscore connections? Definitely not. This is going to impact your entire system. What happens if all the 100 connections, that is 97, which is used by the application, if they all concurrently access your environment, then they are going to take all of your CPU of the system, or IO subsystems will be burdened. And more the number of connections, you are going to have more issues with the RAM which is allotted to your Postgre. So in general, it has been observed that each connections which is connected to your PostgreSQL in general consumes something between 5 to 15 MB, even if it is not doing anything. So the resource requirement for the database connection. So on your host where your PostgreSQL is running, you have the limited RAM, and if you increase the number of connections, then the RAM which will be allocated, not exactly the RAM, the memory which will be allocated to each session will keep on decreasing. And there may be a situation wherein your system will run out of memory because there will be not enough memory to cater the application requirement. And there is something called as work underscore memory. By default, if you check, this is going to be show work memory. This is going to be just 4 MB. So if you, in case you wanted to, there is some mathematical calculation which you can try. This is difficult to achieve. So if you can see over here, max connection, this should be within lesser than your maximum number of cores which are there on your operating system. Then parallel IO limit, which is divided by the session busy ratio multiplied by average parallelism. So number of cores, parallel IO limits, that is number of concurrent IO requests. Session busy ratio, this is a fraction of the time when the connection is active. And average parallelism is average number of blocked processes working in a single query. Difficult to calculate, but this is a formula which is provided, which this can be used. But in general, the max number of connections should not be increased without having a detailed analysis why there are more number of connections coming out, because this is going to bring your system on knee. One of the way to tackle this is you should have a connection pool. So connection pool is a kind of software that retains n number of the database connections open, so that once your connection is done, it is not going to lose that. It will be given back to the pool, and some other session which is trying to access it, it will be given to that. So there are two types of connection. One is application side pooling, which is called as the connection pool at the application server, and another is the database level. In application pool, the pool takes care of the concurrent session, so it doesn't close actually. What it does, if a new connection is coming from the application and the previous one has already closed doing it, then it goes back to the pool, and once a new request is coming, that will be given to the new connection. That's the way it works in application layer. And it is good to have, because every time you open a new connection, that means you are going to exhaust the resources from your PostgreSQL server. The another way is you can use some of the connection pool at the Postgre level. You have PG bouncer and PG pool. They can be used to minimize the number of connections, and it creates the pool. The pool will be optimally used for making the connections. These are some of the decision making stuff which you can do, but there are more than that. If you have to increase the max connections, then what is that you need to check? So is there any application which is connecting to your Postgre, and it is not getting closed, or it is getting leaked? Are you using the PG bouncer or PG pool for in use? So it is like, it is questioning, are you using the connection pooling? Yes or no? If you are not using, is there any reason why you are not using? Because you are increasing the number of connections. And the other thing is, if nothing works, you have to decide on increasing the number of max connection. There is no way left out. So max connection depends internally on the shared buffer, which internally depends upon the kernel SHM X, which is at the operating system level. So when I say max connection, it is the maximum number of concurrent connections. In general, it is 100 when you do it, when you install your software, and it has to be shared with it actually depends on shared buffer and kernel dot shm max. So we'll see what is that. So kernel.shm max is the maximum size of shared memory segment. Let's say my system has, this is my current setting, max connection is 100, shared buffer is 128. I wanted to make it double. So um, let's say I make it 200, then you have to increase the shared buffer as well, so that the shared buffer which is allocated to your Postgre, that should also increase accordingly. So we say max connection and shared buffer. Shared buffer is how much memory you are going to allocate to the PostgreSQL for caching the data, and SHM max is the maximum size of shared memory segment. A shared memory, SHM max is how much of RAM you wanted to allocate so that it will be reserved and it should not be given back anywhere. So if you have 1 GB of RAM and if you check the SHM max, let's say 30 GB, 30% of that you have given to your system, then you have to convert it into to bytes. So let's say 300 MB, you convert into bytes and you set it to your kernel.shm max. So you can convert 300 bytes. In normal traditional servers, the normal cloud servers where virtual machines are allocated, the higher value is always more than sufficient. But in case if it is not, then you have to change it. The other thing which you have to change is the shared buffer. By default, it will be 128 MB. You need to increase it in case you are going to increase the max number of connection. And you can check how many connections are being thrown at your system. So these are the maximum connections reserved for the super users, three, and there are six which are in use. But you should check what is the active, inactive, and total number of connections which are being thrown to your PostgreSQL. So in short, max connection is not a straightforward parameter that can be increased without digging too much. If you are going to increase max underscore connection, you have to think about the shared buffer. You have to think about the SHM max because they are interrelated with each other. And above all, you need to make sure that connection pooling is enabled in PostgreSQL because PostgreSQL is, we say this is memory hunger system because it is going to take more memory. If you keep on increasing, your system will run out of memory. So in short, just check if there is connection pooling at the application layer or at the database layer, something like PG Bouncer or PG Pool, or if not, you have to make sure why there are so many connections which are coming out, they are not getting closed or they are getting leaked. In case if it is finally decided you need to increase the number of connections, just make sure you optimize the shared buffers and SHM max. There is a very good tool which is called as PG underscore tune. If you see this, there are details related to this. So if I make the version 13 OS type this web application, and if I say I have 4 GB of RAM on my system, there are two virtual CPUs, the number of connections are 200 if I'm increasing, the storage is SSD storage, and it will give you what is the optimal number of the shared buffer which you should keep. So I personally feel that this is a good tool to give you some sort of suggestion. These are the optimum suggestions which can be utilized. So in case you do not have any calculator which says how to calculate it, and if you have these things handy, the version, the Linux, the operating system type, memory, CPU, number of connections, then pgtune is going to help you. I hope this is going to help, and thank you. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is PG Repack, or what is the utility which is used to rebuild the tables online in PostgreSQL. So what is PG Repack utility in PostgreSQL? So PG Repack utility is a utility which is used to rebuild PostgreSQL database objects online. So this particular utility, PG underscore repack, is not available by default. This is available as an extension, and when you wanted to use it to remove the dead tuples or bloating in the tables or the indexes, you have to use this PG repack extension. You have to explicitly download it, use it as an extension for removing the dead tuples and bloating. So this is somewhat similar to the auto vacuum which we use to remove the bloating or dead tuples in the tables or the indexes. But what it does, apart from what auto vacuuming is doing, it is restoring the physical structure of the clustered indexes, and and uh, uh, it actually removes the bloating, which is sometimes not possible by the auto vacuum process. What are the advantages of using PG Repack? PG Repack utility, it releases storage from the table to the file system. So the dat tuples which is occupying the storage in the tables or indexes, which is leading to the slower performance of those tables which are included in the query, it removes those storage back to the file system. And this can be used for rebuilding a table wherein bloating has occurred and auto vacuum process is not able to remove it. And when you rebuild a table, it of course reduces the IO because the size of the table becomes smaller in terms of the number of pages which it is going to use. And it actually releases the dead tuples which has accumulated as the bloat in the tables, which auto vacuum process is not able to release. So now we'll see the demo on PG Repack. So there are 3 steps. So we will see how to install PG underscore repack because this is not available by default. You need to explicitly download this utility. Then we'll see how to bind it to a particular database wherein we have to use this PG underscore repack utility. And then we will rebuild a couple of databases and we'll see how it works. So let's see the demo. And so I have a Linux system where the IP address is 192.168.1.56, and we will see how to perform it. The first step is how do we install the PG repack extension. So we'll say yum install PG underscore repack. I'm using the version 12, so I will be using this PG underscore repack 12. So this is going to take less than a minute or so, and I have the internet connectivity on this server. I'll just say yes, and this utility will be installed within no time. This is done. The next step is you switch to the Postgre user. We'll switch to the Postgre user. And once it is done, we'll just run PSQL. Just run PSQL. Okay, let me see if we have started server or not. Sudo systemctl start PostgreSQL 12. So let's fire PSQL. Okay, it was down, that's why we were not able to connect it. Then next what we will see, what we will do is we will say set shared underscore preload library is equal to PG underscore repack. You need to get this enabled, shared preload library, so that we will be able to use it. It is saying that shared preload library cannot be changed without restarting the server. So let's restart the server using the next step, wherein we will say pgctl-d $pgdata restart -mf. So let's restart it. This is restarted. Let's see PSQL. Yes, we are able to connect again. And then what we will do is we will create the extension wherein we are going to rebuild the tables online. So just let's see the number of databases we have. PSQL -l. You can see that we have DVD rental database, DVD rental underscore new now, and we are going to rebuild the tables in that particular database. So what we will do is just change to that particular table, switch to that particular user, table DVD rental. And now what we will do is, this is very, very important. Whatever database you wanted to use this PG repack to run the online utility to repack the table and the indexes, you have to run this. So if I say create extension PG underscore repack, and what we are doing it is in DVD rental database. So once the extension is created, then only you can use it. And the final step is we will rebuild the tables online. So just quit out of PSQL and what we will say is we will rebuild the tables online. So there is a table called as actor in this particular database. So first thing we can do is we can do a dry run. Let me clear the screen. And then we say pg repack hyphen hyphen dry hyphen run hyphen d database name hyphen hyphen table and the table name. And the table name is actor. Okay, I need to give the complete location because um, I have couple of instances running, so I need to tell the exact. Either I set the location using path, I set the path location, or I can use the complete binary location. So let's say pg repack hyphen hyphen dry run hyphen d database hyphen hyphen table name. Okay, dry run enabled not executing repack. So just to, this was a dry run. So let's do the actual run now. And same thing without hyphen hyphen dry run. Okay, uh, I need to give, or I should have, let me export path equal to $path colon, let me give the binary location. Okay. pg repack hyphen d database. So you can see that repacking is done. Let's try it for the entire database. So first we will do the dry run and then we will do the actual run. pg repack hyphen hyphen dry run hyphen d database. So let's perform this. So dry run enabled, not executing repack. So let's do the actual run now. It's very simple. What we are saying is uh, pg repack hyphen d, then database name hyphen j, the number of threads, and we are going to run it in parallel. So you can see that it has taken all the indexes, tables of that particular database. So this is done because there was no um, dat tuple and the what do you say, the bloating in the database tables or the indexes, so everything was fine. That's why it came out. Otherwise, depending upon how many dat tuples or bloating you have, it is going to take its own time. You can run this utility remotely as well. If you wanted to drop the extension, you just say drop extension, extension name, and you can remove that. If I try to run this command onto a database where this particular extension is not enabled, it will not work. So if there is a database with the name dvd rental underscore new, so let me show you that. PSQL hyphen L, you can see that dvd rental underscore new database is there. So let us try to um, execute this dry run in that particular database. So dvd rental underscore new, we are trying the dry run. So dry run enable not executing repack. Let's try to actually run it. I'm not sure if I actually executed the extension command in that. If it is done, then it will work. I think I have already done it. That's why it is showing. Otherwise, it will throw you the error that first the extension is not enabled. So in that case, you have to enable it and then you have to execute it. So just to recap, what we have seen is PG repack utility is used to rebuild the Postgres databases objects online, and it removes the bloat from the tables and the indexes, and it restores the physical order of cluster indexes. So what you have to do is first you have to install this extension. So I have a Linux system, so I just mentioned yum install pg underscore repack 12 because I have the instance 12. then you have to set the shared preload library, which is equal to pg underscore repack. Then I have restarted the instance. Then the particular database wherein you have to enable this online activity, you just create the extension in that particular database. Then using the PG repack utility, we have done a dry run for the database. Then we actually removed that hyphen dry run. Then we actually did it for one table. Then for the entire database, we have tried it. And in case you wanted to drop the extension, you have to just say drop extension name, and then finally if you, because once your activity is done, you can remove the PG repack utility. And this is all about the PG repack. I hope this is going to help, and thanks for watching. And welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is a password file in PostgreSQL. So this is all about the password file, which is occasionally used in PostgreSQL. So the password file is also known as, the name of the file is .pg pass, which is password file in Linux system. So and it is available in the home directory of the Linux user who is the owner of Postgre software. So when you try to log into Postgre, let's say I'm trying to log in to PSQL using Postgre user. So if I say PSQL-u Postgre, it will prompt for the password. In case I wanted to avoid using the password, I wanted to keep the password stored in a password file, and the password will be read from there. So the file name in Postgre is known as .pgpass. Dot stands for the hidden file, and the password is saved in this particular file in text format. And when you fire PSQL-u Postgre, then the password is going to be read from this. That's the password file in Postgre environment. So what is the location and ownership of password file? So location of password file in Linux system is in home directory, and the name of the file is .pgpass. In Windows, it is in app data PostgreSQL, and the name of the password file is pgpass.conf. What is the permission on the password file? The permission on the password file is 0600 in Linux, and in Windows, the user who is using that particular software should have the full permission on that. Then you have the permission to use the password file. Then what should be the kind of entry in the password file? When you added the pg password file, pg pass file, let's say in Linux, then you will see the format is with the 5 entries. First is the host name, colon port, colon database, colon user, colon password. And what is the usage of password file? The usage of password file is when you do some kind of automation and you do not want to feed in the password on the command prompt, then it is going to pick the password from the file. But it is sometimes so it is a kind of security breach as well. So what is the cons of using the password file? The pros is that you can store the password file in the text format, and your command is going to pick it from there. But when you put the entry in password file, it is visible in the text format, and anybody who has access to it can read it, and it is a kind of password breach. Now let's see the demo. So logged into Mova Xterm as let me close this session first. The Okay, this is my Linux system, and if I try to log in normally with the PSQL command, so I'll be able to do it using PSQL. Okay, let me write it manually. So PSQL -u username. Let's say I'm trying to use Postgre user on the port 5432, which is the default port, and if I enter, it is asking for the password. So let me feed in the password, so I'm able to log in. If I wanted to avoid putting in the password on the command prompt and I wanted to save it somewhere, so that is what we say is the password file. The password file location is in the home directory. So let me create a password file. If I say ls-asl, then all the hidden file with dot extension with dot prefix will be visible. So if I say vi.pgpass, I'm just going to create a new one. So in the beginning, let's add some kind of instruction like with the commented line, like format is as below. The first is the host name, then port, database, username, and the password. So let me put this detail, so I'll explain what it is. So I'll be logging to localhost on the port number 5432 using the Postgre user, Postgre database, and I'll be using the Postgre user, and the password is password. So now when we tried earlier, it was asking for the password. So now this time it should display it without password. And now it is showing that permission should be 600. So this is mandatory. So what I will do again is, it is mentioned over here, so you need to mention the special permission as well. Otherwise it is not going to read it. I have given the 0600. So if I say ls-asl, you will be able to see the permission. It is read write permission of the owner, which is Postgre. Otherwise nobody is having any other permission. So let's execute it once again. PSQL-u username-p port name, and you can see that we are able to log in without password. So this is the usage of using the password file. So just a recap, so format is in the host name, colon port, database, username, and the password. So what is the usage? That it contains the password which is used in the connection which requires a password. And what is the location? In Linux, it is in your default home of the software of who's the owner of the software. In PostgreSQL, it is Postgre, so it is present in the default home directory, and the name of the file is .pgpass. In Windows, it is available in app data PostgreSQL, and the password file name is pgpass.conf. About the ownership, in Linux, it should be 0600. In Windows, it should have full permission so that the software owner can read and write over there. And about the security, this is not one of the best way, because it is available in the text format, and anybody who has access to that particular folder will be able to read it, and it's a kind of password breach. So I hope this is going to help, and thanks for watching. In this video tutorial, we will learn what is WAL in Postgre and how to enable archiving in Postgre instance. So first of all, we will learn what is WAL. So WAL is a short form of write ahead log. So whenever a transaction is performed onto the database, let's say insert, update, delete, or any other which is modifying the Postgre database, is first written out to into a file which is known as write ahead log file. Then it is actually saved onto the actual data files of Postgre database. And whatever changes are happening onto the Postgre, they are sequentially written into the WAL file. So it is a kind of if there is some kind of disaster, you have to recover your database, and if you have the WAL files, then you will be able to recover it. So you can replay the changes which has happened onto your database. So this is a short summary of WAL. WAL is nothing. It is write ahead log. So whatever changes are happening to the database, they will be returned to a file which is known as WAL file, which has a particular location in the database, and there it will be saved. So the next thing is what is the location of these val files? So val files are located under data directory. So let me quickly open a shell. So I have, so let me say sudo systemctl status PostgreSQL. Sudo systemctl status PostgreSQL 12. I have PostgreSQL 12 version installed on my Linux system, and I'm connected through Movaxstrom. So you can see that the status is active and it is in working manner. So the next thing is how do I check the location of val? So 9.6 onwards, it is into a particular file which is known as pg_val, which is under your data directory. So let's go to psql and just say show data underscore directory, and you will be able to see the data directory location. So just navigate to that location and just say ls-lpr, and you can see there is something called as pg_val. So just cd to that location, and you will be able to see a number of val files which are written over there. So this is the default location of your val in Postgre environment, and the version is 12. How can we control the val? Well, let's say how many val files should be there. Let's say at this point of time I have 1, 2, 3, 4, 5 files. Let's say, will it be an unlimited number of files? So what will be the size? What will be the maximum size of those files? So there are two parameters. One is val keep segments, like how many number of these log files you want to retain on your Postgre system, and what should be the maximum size of these max log max val size. So you can see the description in postgre.conf. So let me I'll just say cat postgre.conf, and we'll just grab the value which we are looking for. So we wanted to know about the val keep segment. So there is some kind of description also mentioned. Grab minus, let's say, -i. Let me see where, oh, I'm in the wrong location. That's why it is not working. Just say it again, cat postgresql.conf grab. So without entering, I just wanted to see. So you can see that val keep segments equal to 0. At this point of time, the it is disabled, and we can keep it according to our requirement. Let's say I wanted to keep 10, then I have to change this value, val keep segments equal to 10. Then there is another parameter which is max val size. So what is the maximum size which I wanted to keep? So just search for this and you will see some kind of description over there. So as of now, the max val size is 1 GB. So in this particular file, the val file, you can see this particular file in scenarios, it can grow up to maximum of 1 GB, but if there are big transactions, then it can grow beyond the allocated value as well. So the next one is archiving vals. So what happens if this particular location, the number, let's say 10 numbers are already created, then what after that? So is it going to overwrite that? So in that case, what we have to do is we have to archive those val files to a safer location so that we can store it over there, and in case of requirement we can restore it from there. So we will see how to archive those val files in some other
directory or location, or so the archive command can be used. So uh, there are some commands you can say archive command in single quotes CP, and then you can mention the destination. So from its default location, it will be copied to a new location, so that it is not getting overwrite. So you have always a copy available on your disk. So if you wanted to keep it in S3 bucket on AWS, you can do that. You can keep it on Google Cloud bucket. So those options you have, or if you wanted to just archive it to a particular location, you can do that. So let us see this particular archive underscore command. So cat, I just wanted, without entering it, I wanted to see archive command. So you can see that archive command to use to archive a log file segment. The next one is wall level. So there are 3 wall levels in Postgre 12. We have something called as minimal. This is required when your system goes down, and it contains the minimum information which is required to bring your system up. Then you have something called as archive or replica. So archive or replica, in earlier versions it was archive, now it is replica. By default it is as replica, and it has enough information which is required for your WAL files. Then replica is the information which is required to for read-only queries, in case you are building a standby server. And logical, that's the highest level, so you can extract the logical changes which have happened. So to enable the archiving, if I have to enable the archive, the wall level should be greater than archive. In our case, it will be replica. Archive timeout, what is that? So let's say I am the archive logs, this WAL files are created when the application modifies the data, and in case let's say the application is not accessing the Postgre, and there is no activity happen, then is it like WAL file is not getting created? So you can mention archive timeout equal to n number of minutes or hours. So let's say when we say archive timeout equal to 1 hour, so after every 1 hour, when the counter starts, a new WAL file will be generated even though there is no activity onto the database. And the next one is how to control the size and number of the WAL file. So you can control the size by using max wall size. You can keep it up to the n number of GB. So in our case, we will keep it to 1 GB. And how many wall files you wanted to keep it? So let's say if I say wall keep segment equal to 10, then it will be returned to 10. Let's perform the settings. This is a demo which we are going to do, the archival setting. So the number of parameters which will be impacted is wall level. So let's vi this. Let's edit this file, postgresql.conf, and search for the first parameter, which is wall level. So it has everything. So you can see that here wall level equal to replica is already set, and this is so you have 3 values: minimal, replica, or logical. So in our case, it is already set as a replica, so we already checked. And if you wanted to modify this particular parameter of postgresql.conf, this requires the restart. So this is the first parameter. Then you have max wall size. What is the maximum wall size or WAL size? So as of now, it is set to 1 GB. how many segments of val you wanted to keep at one particular point of time into the mentioned location. So in our case, it is set to 0. That means it is disabled, but we will make it 10. Then you have archive mode. By default, this should be off. So archive mode, you can see here, archive mode equal to off. To enable archiving, we will have to set it on, and this also requires a restart. Then you have archive command. So archive command is, in our case, we will use the cp command, and we will copy it to a different location. And then we have archive timeout. I think timeout is also disabled, so it is 0 at this point of time. So what you can do is either you use VI editor, edit the value, save and restart the instance, or just for this demo we can use alter system so that these value will go into postgresql.conf, and when you restart it, it will read it from there. So just for this demo we are going to perform this. So wall level is already set to replica. Then you have max val size, so we will set it to 1 GB. So what we have to do is, I'm already logged in as Postgres OS user. I'll say PSQL, and we'll say alter system set max val size equal to 1 GB. Perfect. Then we will, how many val files we need? So we wanted to keep 10 files, so we'll say alter system set val keep segments is equal to 10. So let's keep 10 val segments, and let's enable the archiving so that when from its default location, the val files will be copied to a new location when we give the cp command. So we have to, for that to happen, we have to set it on. The archive mode has to be set on. And then we will have, so what we wanted to do, we wanted to keep the archive logs to a particular location, which is postgres /log. So what we will fire the command is alter system set archive command equal to, in single quotes we'll say cp %p, and the destination is postgres /log, and the archives will be copied in the form of archive _ val and a unique value. So let's fire this command. Preferentially, you can use VI, make the changes there, and then restart the system. Ensure there is at least one val size for archive timeout duration. So what we will do is, even if there is no activity for this Postgre environment, let's say there is no data getting changed in 1 hour, there will be a switch happen, and the val file will be generated. So we have made all the changes. Now we will restart the instance. Let's come out of the pSQL prompt. Yes, and restart the Postgre 12, and now check out. The first parameter for archiving is show val levels. So it is set to replica by default. So you have minimum, you have replica, and you have logical. So for our case, for archiving, this is more than sufficient. Then what should be the maximum size of val files? So it is set to maximum of 1 GB. How many val files we can store at one particular point of time? So we have set it to 10. Have we enabled the archiving so that these can be copied to a new location? So archive mode is on. Then what is the archive command to copy the val files from their default location to a new location? So this will be copied to this particular location. So we will navigate to that and we'll see. And finally, archive timeout. So even after 1 hour, no activity happens, which generates a val file before the data gets returned to the data files. A switch will happen and an archive evolve file will be generated. So if you would have worked in environment like Oracle where archive logs are there, and in there are transaction logs in MS SQL, then you have bin log in MySQL. So it is I believe synonymous to that. Just quit out of this prompt and we'll see if there are some logs generated or not. So we have given a dedicated storage file system for storing the archive logs of val. So you can see that this has happened and it is in the format of archive_val. So just a recap, what is val? Val is just a short form of write ahead log, and this is not a feature of this particular database. In fact, most of the RDMS has this. So before the data is modified data is actually returned to the data files, there is a, a file which is created so that you have that when there is some kind of restoration required, you can restore from those files. So in Postgre, it is known as write ahead log, and whatever changes are happening onto the database, they are first returned to the val files. So what is the location? Location is data underscore directory, and it is returned under pg underscore val. So how can we keep control the size of val? So you have two parameters. One is val keep segments. How many number of vals you wanted to keep, 10, 20, 30, or whatever you have according to your requirement, you can keep it. Max val size, what should be the maximum size of val? So it is 1G in our case. Archiving vals, so you can archive the vals when your archive mode is on, and you have to use some kind of CP command so that you can copy those files from default location to a new location. Then there are the val levels. You have minimum, replica, and logical in 12. Archive timeout is when there is no activity on the database, there will be a val file generated. And how to control the size and the number we have already seen. And finally, the archival settings. So we have to set val level equal to minimum to replica for archiving to happen. Max val size, which is the size required to keep the maximum size of val files. Then you have how many numbers you wanted to keep. So in our case, we wanted it 10. So val keep segments equal to 10. Then we have archive mode equal to on. This is mandatory. Then you have the archive command. In our case, we used cp %p and the destination. And finally, the archive timeout. These either you use a VI editor, since this was a demo, so I used outdoor system set, and I restarted the instance, and we checked all the values, so everything was reflecting as required. So archiving is happening as of now, and after 1 hour, when the timeout happens, there will be a switch also happening. So this is all about the val, what is val, how to control the different parameters, how to do the archiving. So I hope this is going to help, and stay tuned for the next tutorial. Thanks, and thanks for watching.
Hello and welcome. In this session, we are going to see how the connection in PostgreSQL can be monitored, and on top of everything, when the connections goes beyond a limit, then how we shall decide on cleaning up those unwanted connections. So this is lesson number 26, wherein we are going to see what is the connection in a PostgreSQL. So we know that in case of PostgreSQL, there is a client and server model. And based on that, whenever a client process requires a connection with the PostgreSQL, then one client process is resulted into one server process. So if there are many requests from the client side, it is going to lead several server processes. That means each time a new connection request is requested, then there is something called as Postgre in case of PostgreSQL, and that is going to spawn a new server process in PostgreSQL instance. So that master process, which is called as the Postgre, it allows all the incoming connections from the client, and it results into a new server process. That means a single client is going to result in a single server process. If there are 10 client requests, that means there are going to be 10 server process. So this keeps on increasing if there are many uh, connection requests from the client, and internally it is going to use your more shared memory and more of the semaphores. That means the memory and the process, it keeps on growing in terms of the consumption. So one of the thing will be you should have some capping, like if my connection goes beyond 80% or 70% or 85%, in that case we should get an alert according to your monitoring tool. So let's say the default connection is 100, and if you set some kind of monitoring which says if it grows beyond 70, then we should get an alert. The alert should be planned in such a way that it should bifurcate the idle connections and the active connections. So whenever the client requests for the connection, it is going to read or write the data to the PostgreSQL. The status of those connections may be in several formats. So it may be active. When I say active connection, that means it is the active transaction, and it is whatever it is, a read or write transaction is happening, and it is alive. The second one is idle connection. The connection idle means that it has connected sometimes back according to the requirement, and as of now it is not doing anything. It may be idle for a long time, and if there are several connections which are coming like this, and if the number of idle connections keep on increasing, that means it is adding up to the total number of the connections. That may lead up in a scenario wherein this may result in some sort of outage, resulting no new connections will be allowed. There is another category where we say idle in transaction. That means there is a bad job or something like that is happening, and as of now the transaction is in the idle format. And the last one in this status state is idle in transaction, which is in the aborted state. The idea is you need to identify what is that we need to take the action. So the first thing which you need to check out is show max underscore connection. You need to find out. So I have an EC2 instance where Postgre 13 is running, and I'm connected as PSQL. If you see, I have 100 default max connection settings, which is available over here. And I wanted to see, so you have a very good catalog view which is available, and its name is pg underscore stat underscore activity. That will show you how many idle connections are there in this particular database, in this PostgreSQL instance. So what I have done is I have connected this is my EC2 instance where Postgre is running. There was 7 DVD rental databases, and what I have done is just I did the right click and I say query tool, and similarly, so this is like I am just establishing a connection. Query tool again with DVD rental restore underscore 1, and similarly the last one I'll try to connect. So whenever I do this, and I check the status of the connection, you will see the number of connections has increased, and there is no activity happening when I connected through the pgadmin 4, and I just being silent over there, not doing anything. So my connection is in the idle state. But if I keep doing this 97 times, which is the maximum allowed connection, in that case, the new connections will not be allowed. Let's say that is a real connection which is coming from the application. So that will result in some kind of no connection which will be allowed to the application. So the thing is, what shall we do next? The first thing is you have to identify what are the connections whose state is idle. Either you can use I'm connected to the putty session, or I can go to here as well, and I'll just say select star from pg underscore stat underscore activity where state equal to idle. You can see that there are a lot of databases, DVD rental 1, 2, 3, and so on. And you can see the PID, process ID. They are not doing anything. And apart from this, it is going to show you a lot of things like the PID, which is for our requirement. It is going to show us the client IP address from where this connection is originating, and it is also going to show us at what time this transaction has started. So those information you will be able to see and fetch from here, and it will also show what kind of wait event it is waiting for. So you can see that it is waiting for the client read. It as this point of time, this is idle in the state. If you just remove the idle and just say select start from pg underscore stat underscore activity, you can fire and you will be able to see all the active and the idle connections. So what else we can see? We can see some more information in this format. I'm just filtering out some of the important, okay, you can see here. So I just filtered the username, application text, the PID, which will be required in case when we interact with the application owner and we say, hey, look, these are the idle connections and they don't seem to be doing anything. Can we go ahead and clean up those connections so that it will be available for another connections, the client request. So what we can do is, once you find it out, what are those connections, and there is some more SQL statement which can be used, like either you go with the show connections, or you can fire this SQL query which will say there are 19 used connections, there are 3 super user connections which is allowed, and maximum number of connection allowed are 100. And finally, what you can do is you can find out the details of the idle connection the way we have found out over here. And I'm just finding out, let's say, this is our connection which we are supposed to kill, and the PID is 2753. And if it is decided that this is no more required, this is in the idle state, we can go ahead and we can kill it as well. So I'll go to here and I'll say the connection PID is 2753. So I will say this is 2753, 2753. And using PG terminate backend, you can kill this. This is done. And you can verify the number of the connections which are available, or I'm not sure if we kill the connection which we are connected as of yet. So let us see. This is just to show like what a script you can use. Okay, this is gone. The one which we had fired, so that's gone away. So its ID was 2753. So we are not able to see 2753, and yes, it's gone. So this is how do we manage. So we cannot increase the number of max connection because it results in other way. It is going to consume more resources. It is going to use your shared memory, the semaphores. So what you need to do is you need to find out the idle connections you need to share with the application or not, and then you need to decide whether they have to be terminated or application team needs to close it from their side so that it's gone from here. I hope this is going to help, and thanks for watching. Hello and welcome. In this session, we are going to learn the PostgreSQL backup strategy overview. So back behind the scene, we will see it actually for the Azure, but it is going to be unique for either you go for the on-premises or on infrastructure as a service on any of the cloud. So here we go. So the topic is all about the PostgreSQL backup strategies. So mainly there are three approaches to backup your PostgreSQL database. So the first one is using the SQL dump. The second one is file system level backup. The third one is continuous archiving. The popular of all these three is the basic one, which is SQL dump. So when we talk about this SQL dump, it is going to create a file with SQL commands, and when you restore it on your same host or the new host, it is going to recreate your database in the same state as it was when you have taken the dump. Just to show like how it is going to work, we will see a very small demo for the first item only, not all the three items, because they have been already shown the demo in some other sessions. So by default, PostgreSQL provides the utility program which is called as pg underscore dump, which is being used for backing up the particular database. So how do we use it? So this is used as pg underscore dump. You provide the DB name and then you redirect it to a particular location. Say for example, I have this is my uh, PG Postgre 12, and if I show you, I have DVD rental database over there that has 15 tables in it. And if I have to take the backup of this database, the easiest way is using the command using pg underscore dump. So how it works, pg underscore dump, the database name, hyphen v verbose if you wanted to see the output on the screen, redirect it to a particular file where it is going to store it. So you can see that it's been created, and if you wanted to see the content, you just go ahead and view the content using the VI or cat, whatever it is. So you can see that it is in the text format. PostgreSQL database dump, dumped from database version 12.5, started on this particular time, and it contains all the information for your database. Just to be remembering like this creates as soon as you fire it. So whatever the state of the database at that time, it is going to capture all that. So anything changing after that, it is not going to control. So pg underscore dump can create the files in other formats. You can increase the number of parallelism. You can have some more fine-grained control. If you wanted to see more, just say pg underscore dump hyphen hyphen help. It is going to show you all the details which you can do with this. The biggest part is what is the advantage when there are so many tools and technologies available for backing up the database, why pg underscore dump is still one of the best choice for backup and restoration. So the best part is it can be reloaded into newer version of PostgreSQL. Say for example, my current PostgreSQL is on 12.5, and the newer version, if you see it, it is on 13.51. And let us assume not really concerning to this environment, but what you can actually do is you can reload from a lower environment to the say for example lower version to the higher versions, or that is only possible using pg underscore dump. And while the file level backups, and there are two other, and which is the continuous archiving, they are specific to your server version specific. You cannot go beyond that. So This is the only choice when you have to transport your database across the version. You have to use pg underscore dump. And pg underscore dump is the only method which is going to work when you have to transfer a database from 32-bit to 64-bit operating systems. And the dumps which are created by pg dump are internally consistent. That means it is going to represent the snapshot at the data when the pg dump was started running. Anything which happened after that, it is not going to capture that. So you have to make sure that if you wanted a consistent snapshot, that means you have to stop the application interface facing it, so that nobody is able to access and modify it. There are pros and cons also. We are not going to discuss about that. But how to restore the dump which is being backed up using underscore, which is being backed up using pg underscore dump. The text files which are created by pg underscore dump, they can be only read by the program which is called as PSQL, and it is available in all the versions, and that is the way it is used for restoring the database in same host or different host. Say for example, we have uh, let's say we have taken a backup using like this, and if I wanted to restore it in our same host using some name, let's say if I say I wanted to restore dvd rental as dvd rental underscore restored one, what I should be doing is, and this is really related to the refreshes or the migrations. So you need to create that blank database and it is going to restore that. So it is going to give you the message that this database doesn't exist. So what you have to do is you just create this database. So you just say create a database and database name. Uh, If you just say /l, it is going to show you that database exists. And now you try importing using PSQL dvd rental underscore restored one, and it is going to be restored. So this is restored. So this is the simplest way of doing this. The pgdump and PSQL can be used to write or read from the pipes. That means in case I have two servers and if there is a connectivity, so that part is very, very important. If the two servers are connected, the ports are open for the connection, then in that case you can transfer the database from one host to another. That means you can restore the database from one host to another without transferring it using WinSCP or using the SCP command. So it will be done over the network. So you just say pg underscore dump. So this is a case. I have two servers. This is one which is PG11 EMS, and there is another server which is PG13 EMS. So if I wanted to transfer the data from one host to another, so what I will say is pg underscore dump hyphen h, the host name of the source server and the database name. Then you put it the pipe. Pgdump is this entire stuff is for backing up. Then there is a pipe that means redirect this output to PSQL-H. This is the target server and this is the target database. So once you do this, this is going to restore. We are not actually going to do it because the firewall ports are not open. The firewall is not open between source and the target. The moment you do this, this is going to be restored into the target environment. So this is going to be very, very easy and one of the convenient way of copying the database from one host to another. Or this is also used for refresh. You can put it in the cron job depending upon your requirement on the weekly basis. Whatever refresh requirement you have, you can use it using the pg underscore dump method. But this is only applicable when you have a single database or a specific database. In case you wanted to do it for the all the databases on the particular host on the cluster, so you will be using pg underscore dump all. So pg underscore dumps will be using for the one database. If you have to do it for all the database, you have to use pg underscore dump all. And one of the challenge with pg underscore dump is it is not going to dump the information about roles or table space because they are they are available on the cluster wise rather than the database. In case you have some roles and the table spaces for let's say for particular database, it is going, you have to use pg underscore dump all. So pg underscore dump all is used to back up all the databases. So if I simply say pg underscore dump all, and if I give the location and the name, it is going to dump all the information. So you can see all the cluster related information will be captured. So you can see that. So this is pg underscore dump all. It is going to dump all the informations which is related to. So it says PostgreSQL database cluster dump complete. It is not saying it is database dump only. It is whatever is there in the cluster wise, it is going to dump all of them. And to restore it, you have to use PSQL command. Program is used to read it and write it back to the database, so you can use it according to your requirement. The second in this case is the file system level backup, which is always considered to be one of the option when you talk about the relational database. So backup in this, what happens is you mention the location of the data directory. Let's say if my this is not going to be the practical one. If you say show data underscore directory, this is your data directory location. In case you wanted to do a file system backup, you can mention it like this: tar hyphen cvf. What we are saying, it is an impractical way of uh, doing the backup. This is not the practical way. It is never suggested, but this is one of the way. And in what scenario it can be tested, I'll tell you that as well. So the tar backup has been taken. What are the disadvantages of using it when you do this way, tar-cvf, or why it is supposed to be inferior as compared to pg underscore dump method? In this case, the database must be shut down in order to get a usable backup. Just if you say I have disconnected all the connections, it is not going to work, because in part because tar and the similar tools do not make an atomic snapshot of the state of the file system. So it also because of the internal buffering within the server. And you also cannot backup the restore only using certain individual tables or databases using the respective files or directory. So though it is going to happen in that way, but we cannot use it. An alternative file system backup approach is to make a consistent snapshot of the data directory. So this is not going to be practical, but this is a way available in case you can freeze your file system so that there are no changes, no buffering is available. In that case, you can try to use it. Make sure that you do the checksums so as to assure that it is a consistent cold sort of backup. You can use rsync as well in case you try this way. But this is not the suggested way, but this is an available option in case somehow you can freeze the file system for any type of read and write for the time being when you wanted to take a snapshot backup of that file system where the data is residing. The third one, which is the continuous archiving and point in time recovery, this is most famous one, and this is particularly for production environment. And back behind the scene, it is going to use your wall, which is write ahead logging, and it is the data will be available in the pg underscore wall, and this is available in your data directory. So this contains all the information which has changed in your database. So any insert, update, delete operations which is happening at the table level, they will be first stored in wall level, wall files. And in case your database has crashed, you can restore your database using that. So when you take a continuous archiving and point in time recovery strategy, you do a file system level backup. When we say file system backup, it is this 1 second, but it is actually not that. There is an inbuilt tool which is given to take the base backup, which is called as pg underscore base backup tool. So what it does, it is going to read your entire data directory, assuming you have the table spaces also available over there. It is going to take a backup of the entire data directory in a format that can be restored using the untar way. So in layman language, we will say it is a tar backup, and when you restore it, you you restore it using the untar way in your data directory, and on top of that, whatever wall files they are available, you have to put it back. And when you are doing the restoration, you have to make sure that you restore all the wall archives so that you can restore it to a particular point in time, or whatever archives of walls are available, they you will be used for restoring the database. This is not straightforward. There are some parameters which are involved which you need to follow just to make sure that you restore it. So there is a complete session on that. You can follow that, and it is going to be very simple. So when you do the restoration using pg underscore base backup, and you use the restoration using point in time recovery, you have to make sure the permissions on the restored data directory is correct, and then you try to restore it, and then it is going to work. So this is one of the best way of backup strategy when you talk about the production environment, where you don't want to perform the pg underscore dump backup or pg underscore dump all, because whatever transactions are there in the database, you wanted to capture all of them. So you should be following pg underscore dump. You should be following pg underscore base backup, which is actually the third way of backing up your entire cluster, and that is called as continuous archiving and point in time recovery. So if you talk about all the three, so just a quick recap. So we have seen the quickest way of backing up the database, individual database, you have pg underscore dump. If you have to back up the entire cluster, pg underscore dump all is there. There is a provision for file system level backup also, in case you are able to freeze the data blocks or the bufferings that do not change. And for the production environment, wherein every transaction matters, you have to make sure that you archive all the transactions. So you have continuous point in time recovery method, wherein back behind the scene, you have to take the pg underscore base backup, and whatever the archives are there, you have to back up all of them. And during restoration, you have to use the base backup plus all the wall files which are available, and you have to restore your database up to a point in time. And this is going to be very important for your production environment. There are open source tool and techniques available, wherein third method will be available that can be used. So if you talk about pg underscore uh, a backrash that can be used, you can use the barman. So they are really useful. So this is just about the basic concept of PostgreSQL backup strategy. I hope this is going to help, and thank you. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will see how to backup and restore in PostgreSQL. So for backup in PostgreSQL, we have pg underscore dump, which used to take the backup of individual databases or tables. If you wanted to take backup of all the databases, you should use pg underscore dump all. For restoration, you have two utilities provided. One is pg underscore restore, which is used to restore the backup which has not been in text format. For restoration of the dumps which are in text format, you use pSQL. So let's see what are the different backup formats. You have the backup format in plain text, so you can restore it using PSQL. You can take the pg underscore dump backup either in custom archive, or you can use the tar archive, which is Linux format, or you can put it in the directory format so that you have individual tables separated. These are the different connection options. When you say simply pg underscore dump hyphen hyphen help, it will show you all the options. Hyphen f stands for the file name. You can mention the file name or the directory location. Hyphen f stands for the format, so you can mention the custom format, directory format, you have tar format, you have plain text. You can mention the number of the jobs in case you wanted to parallelize your backup, and your tar backup, you can compress it using the hyphen z option or hyphen hyphen compress, 0 to 9, 0 being none, and 9 being the highest compression level. You can mention the lock, wait, timeout as well. Then you have some more backup options. You can take the backup of data only. You can include blobs in your backup. You can exclude the blobs backup. And when you are creating the dump, you can mention hyphen c, small c. What it does, it cleans database objects recreating. So it puts the drop command. So hyphen c capital key puts the create command in the dump option. And hyphen n schema, you can mention the schema names which has to be backed up. And if you mention capital hyphen n, you mention the schema names which has not to be backed up. Then hyphen o, or no ownership, so you can skip the restoration of the objects if in the plain text format. Hyphen s, you can mention the schema only, it takes the backup of the schema, no data. So hyphen a was just for the data, and it is for the schema only. Hyphen s, you can mention the super user username, which has to be used in plain text format. So you can dump the table name using the hyphen hyphen t table, and you can mention the table names or the pattern, whatever you like. And hyphen hyphen exclude also, if you wanted to uh, exclude the backup of some of the table or some of the table in particular pattern. Let's say they are starting with tab and something. You can exclude the privileges also when you backups. You just say hyphen x, it doesn't back up the grants and the revokes. There are different options. You mentioned hyphen d or hyphen db name. You mentioned the database name. Hyphen h, you mentioned the host name. You mentioned the IP address. Hyphen p is for the port name. If you have a non-default port, hyphen u stands for the username, which user is specified to take the backup. Hyphen w, when you mention, then your piece this backup command doesn't prompt for the password. Hyphen w, when you mention it, forcefully prompts for the password. Then hyphen hyphen role name, you mention the role name before the backup dump. Then you have the restoration command. What is pg underscore restore? It is used to restore the PostgreSQL database backup from the archive, which is created by the dump pg underscore dump. So pg underscore restore, these are the different options. Hyphen d, you mention the database name. Hyphen f, you mention the file name. Hyphen f in capital, you mention whether it is other than the text format, all will be picked up from here. So you have a custom format, you have D for directory format, T for tar format. Hyphen L, it mentioned the list. Hyphen V displays what is happening in the background when you take the backup or the restore. It is valid for both. If you wanted to restore just the data, you just say hyphen A. It restores the data and no schema. And hyphen clean, it creates the database objects. And if you mention hyphen index, hyphen hyphen index, it restores the named index which are mentioned. If you wanted to mention the number of parallel jobs, you can mention it. And hyphen L is either used to mention the file name, which is containing a number of tables. You can restore the database schema using -n command. If you want mention capital N, it skips the schema which has to be restored. Then you can restore the functions. You can, with small s, you can mention the schema only. With the capital S, you mention the super user name which has to be used. -t, you use it for the table name. Capital T, you mention for the trigger name. And let's see the demo. So I mentioned everything here on a notepad, and we are going to use it. So if you simply say pg underscore dump help, it will show you what are the different options available in pg dump. Or you simply say pg dump all help, it will show you all the options which are available. So let's quickly, it's very easy. So we are going with the first option, wherein we are going to create a PostgreSQL dump file, and we are saying pg underscore dump -v verbose, and the database which we are going to take backup is dvd rental, and this will be uh, dumped in this particular location. And we have mentioned -v verbose, so this will display what is happening in the background. So you can see that backup is getting created, and it is, if I go to cd slash postgre slash backup, you can see that backup file is created in this format. So let me remove everything. Okay, let me remove DVD stars, everything. Let me execute the backup once again. pg dump -v DVD rental. So this is going to take the backup of DVD rental database. And if you wanted to see the content, you can see either use some editor, or you just say view command. So you can see that it is a Postgre database dump. Database version is this one, and this will create the database in the format. Let's try out the second command, where everything remains safe. Say instead of giving this arrow mark, we just give the -f, and we mention the complete location of the file which has to be created. You can see that it is getting created. It's very, very easy. And if I say pg, if you wanted to take the backup in the tar format, so I'll say pg dump -v verbose. So this will print on a screen. And if I say -u, who's the user who is going to take the backup? It is Postgre. -w in caps, it will prompt for the password. -f, this is a format, and it is in text format, plain format. And sorry, -f, then I am saying T, this is going to take the backup in the tar format. And for which database? It is for the DVD rental database, and this will be the tar file which will be created. And let's mention the password. So this is going to create the backup in tar format. So this is the tar file which is created. If I have to restore the backup which we have taken for the DVD rental, and first you have to create a database which is blank. So create dv-t, from which template 0 and 1 are available, and the database which we are going to create, blank database, it is restored underscore DVD rental. It already exists, so let me create DVD rental 1, DVD rental underscore new. Let's say DVD rental underscore new. So I'll say the database name is DVD rental underscore new. DVD rental underscore new. It also exists. DVD rental now. So it is getting created. It is created. So DVD rental uh, we created DVD renter underscore now, and we are going to restore the backup in this particular database. So we'll simply say PSQL, new database name, inverts arrow, and the location of the dump file. And just mention the verbose if you wanted to see what's happening in the background. So this is happening. So it's very, very easy. If you wanted to take the backup of all the databases, we are going to use pgdump all. Pgdump all, and let's say verbose. I think it is going to work. So you can see in the verbose format in the screen, everything is getting displayed, and it is going to take the backup of all the database. And if you wanted to take a backup of a specific table, then also you can mention. So the format for that is pg underscore dump. I wanted to take a backup of payment table, which is there in uh, in DVD rental database. So pgdump hyphen f, which is the format. It is in custom format. Only we are taking the backup of data. Hyphen u is username. Hyphen w stands for it is going to prompt for the password. Then we have database name. Then hyphen t. Table name is payments. And just mention the password. DVD rental, I think, not rentals. Yes. Or let's remove it, and we will back it up using the verbose command. pgdump -v verbose, and enter the password. Then you can see that payment table has been backed up. If you have to restore the database of the particular table, what you have to do is you have to truncate the table, then restore the data only. It's very easy. Let's see some more example. To dump a database into a PL SQL script, we have seen that, and using the format also we have seen that. If you wanted to do it in a custom format, we can use this for the particular database. Let's try this one, although most of them has already been executed. So this is pgdump -v verbose -f format. C is -f is file, and C is the custom format, then the database name, and just execute it. To dump a database into a directory, we use -d command. So let's do that. And let's try this. Let's go to, I think it is executed. And you can see it has executed now. It's in the directory and subdirectory structure. To dump a database into a directory format in parallel with 5 worker jobs for worker jobs, let's try this one. pgdump -v -f is the format. Then we have the directory format, then this database name, and these are the number of workers. If it is more, then you can mention it, and you can compress it as well. So -f, it's executing. You just need to know what you are doing. Then to create an archive into a freshly created database, let's create a new database, restore database, DVD rental underscore new. Let's try this one, or let's say it as new one. I hope this doesn't exist. Yes, and then restore it from the backup which we have just taken. So it is pg underscore restore hyphen d database name and the dump name. This is done. I'm not going to check it because if it is not doing it, it will show you the error. To reload an archive file into the same database it was dumped from, then it is going to discard, it is going to clean and create it. A pg restore underscore hyphen d. Then let's try this one. We'll put the verbose. You can see that it is creating again. And if you have to dump a single table, which we have seen earlier as well, in the text format, we can use pg dump, and this is done. If you wanted to see the content, you can quickly see it. This is the text and readable format. So this is all about the different options available in Postgre backup and dump. And I hope this is going to help, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is PG underscore base backup and how to use it, and we will see some of the examples as well. So first of all, what is PG base backup? So we have a couple of backup utilities in Postgre. So we have PG underscore backup, then we have PG underscore backup all, and there is something called as PG underscore base backup as well. So when you wanted to take a backup of a running PostgreSQL cluster, you have to use PG base backup. If I wanted to take a backup of one database at one particular time, or n number of databases, or all the databases, I have to use PG underscore backup or PG underscore backup all. In case I wanted to take a backup which can be used for point in time recovery, that means I wanted to take a backup of the entire cluster of Postgre, then I have to use pg base underscore backup, so that all the files which are there in the cluster, they will be backed up. So this kind of backup is mainly useful for log shipping or streaming replication, or you have to create a standby database, or in case you wanted to restore your database at a one particular point of time. So when you take a PG underscore base backup, it is a binary backup of your database cluster files. This cannot be used for the single database. In fact, this is used for the entire cluster only. So who can take the PG base backup? So any user who is having the a super privilege, let's say the super user or the Postgre user who is having the super user privilege, can take the backup, or you have to create a user which have the permission to take the backup. And when you configure the PG base backup, you need to modify PG underscore HBA.conf as well, so that the replication connection can be allowed. Although there is, in case you just wanted to take a PG base backup, you don't need the replication, but this is required. And in the demo, we will see how to do that. So most of the time when you do it, you do it either for taking a point in time recovery purpose for the data entire cluster, or you have to create the standby databases. So what is the usage? The usage is PG underscore base backup, and then you have a number of options. So we'll see what are the different options. So you have something called as pg base backup underscore d. That means you define the directory or the location where the backup will be stored. So this receives base backup into the directory. Then you have -f, which says which format you want it to take. There is P and T. P stands for the plain text, that means you can read it, and T stands for the tar. The file will be tarred in the Unix format. So you have something called as -x, which means do you want the val files as well, which is required for your recovery. Val is so in one of the tutorial we have explained about it what is val. So this is required for your recovery and it has all the information. Val is nothing but it is write ahead log. So you have -x. -x small is whether you wanted to take a backup of val files, then in what mode you wanted to take it. Either you say fetch or the stream. When you say fetch, after the backup, all the files will be fetched of val and stream. When you wanted to take when you configure a standby database, that means continuously you wanted the val files to be shipped across. Uh, you can zip that as well. So -z is used to compress the tar output. So this will help you to save some storage. -z it tells to what extent you will be able to compress. So compression algorithm will be applied. The value lies between 0 to 9, 0 being not compressing and 9 is the highest. So most of the time when it is a big database, you want it to the database size is more, or the cluster overall cluster size is more, you wanted to use the compression level, but make sure that this compression is done during the off business hours, or it is going to take a lot of CPU from your system. Then you have -l, which will set the leveling for the database. Let's say I wanted to say daily uh, PG base backup or weekly or monthly. So you can level it and you can read it later. So -p stands for the progress. In case you wanted to see if it is a database size is more, you would like to see how it is progressing. So you can mention -p. So it will show how much it has been backed up and what is the way it is going. Then you have -verbose. So when you fire PG base backup and the backup, you don't see any kind of output. You just press enter and it will come out, and you don't know whether it has happened or what was the progress. So you can use -v, which is verbose. So on the screen it will show you how it is moving. Then you have -version that will show you the version information. Then if you wanted to take a BG base backup from remote server, then you have to mention where your instance is running. So you have to mention --host equal to the IP address or the host name of the PostgreSQL server. Then the port, if it is a default port, it is fine. If it is non-default, then you have to mention the port number as well. And in case you wanted to see the time interval status packet which is sent to the server, you can mention -s. And if you are using if you are using a user other than Postgre, which should be used because Postgre is not supposed to be used for such operations. Once in a while you can use that, but if you have to configure a backup, then you have to use a different user. So in our demo we will see that. -w, it will now not prompt for the password, which is not good. We will use the password, so we have to use -w, which will forcefully allow us to input the password. And I think this is more than enough about the introduction, and now we will see how the demo is going to work. So I have a Postgres server which is running on 192.168.1.61 Linux system, and I have a Postgre 12 running on it. So let me show you that. sudo systemctl status PostgreSQL 12, and I'm logged in as Postgre. We'll see what are the different steps. So in the prerequisite, what we will do is we will create a role which will take the backup of the entire cluster. Then using create username with the password, and in the encrypted format we'll give the password. Then what we have to do is we have to add that particular user in pg_hba.conf file to allow the backup. So that will give the host replication, because there is no database with the name replication, but this will be used either for the replication or taking backup of the entire cluster, and the username followed by the IP address from where you wanted to take backup, and then subnet. Then we wanted to enforce a password prompt, so this will do that. Then we have to we will check that whether it is entered properly or not. Then we will reload the configuration. Then we will fire the backup. So let's log into pSQL prompt. So you can see I'm already logged in as to the prompt. Okay, I have already created a user with the name replication user. So let me drop that. Drop role replication_user. Yes. The first step is we'll create a user. So we will say create user replication_user with replication. With replication means this will have the replication privileges associated with that, and then we will give a password. So this is a demo, that's why I have given the password as password only, but that should not be the case. And just say du, and it will show you the role which is created. So we have created the role replication_user, and as a prerequisite, this should have the privilege of replication. So it is having that. In the next step, what we will do is we will add this role to pg_hba.conf, so that backup it has the ability to take the backup. So let me go to pg data. So I'll exit of this prompt, and we'll say vi and pg data, which is the base directory, then pg_hba.conf. Scroll down to the bottom, and we have something called as replication privilege. So you have to add in this section. So it should be like this: host, then database. You can see it is under the section database, but there is nothing like replication database. This is required because this should have the replication privilege. Then the username. The username is replication_user. Then the IP address. IP address is localhost only, but if you wanted to have it from many other servers, then you have to give the range of the IP address, and then I'll give MD5. And I added this earlier as well, but just to show what are the different entries we put. So we'll have to give host, then replication. That means it has the privilege of replication. Then the username, then the IP address or the range of the IP address, subnet, then the what authentication method. So we will give MD5 over here. Now after that, you have to reload this. So we'll say okay, PSQL-C, select pg reload underscore conf. Just reload this. Yes, this is done. Now what we will do, we'll see a basic demo wherein we'll say pg base backup hyphen u replication user hyphen d, and let me show you the pg underscore base backup hyphen hyphen help. So you can see that pg base backup takes a backup of a running PostgreSQL server. And what is the usage pg underscore base backup hyphen options? Then we have hyphen d, which stands for you mention the directory location. Then hyphen f, you mention the format, whether it is plain or tar. Hyphen r, you mention the rate at which the transfer has to happen. Then you have table space mapping in case you wanted to map it. Then you have the location of the val directory. Then what kind of val method it has to extract, whether it has to fetch or it has to stream, whether you wanted to zip the backup file, or to what extent you wanted to compress it 0 to 9. Then you have, these are the basic stuff, like you do the checkpoint, otherwise it will do it automatically. You create the slot, it create slots when it starts. You set the label, and you set the if you say hyphen progress, this will show you the progress. Or the connections options are if you are doing it from a remote server, you just say the host name, the port number, then you mention the username, whether you wanted the password or no password, so everything will be mentioned. So let's perform the first demo. So we wanted to use this particular location as our destination for the backup. So let's go to this location and remove if there is any data. There's nothing. This should be owned by the current user. My current user is Postgre. And we'll say pg base backup hyphen u. The username is replication underscore user, and hyphen d, and the destination. So this is a very basic backup of pg base backup. Just press enter, and this will prompt for the password of replication user. So we mentioned password as password only, and it is happening in the background. If you go to this location, you will see that the files are backed up now. So these are the different files, and this is the same file which is there in pg data. So let me open one more session, and I'll just say sudo su space minus postgre, and I'll do cd dollar postgre data. This will take me to the default data directory location, and if I do cd to this location, you will see there are so many files. So if I say ls-ltr and count the number of files, you have 27 files. And when we took the pg base backup, you can see everything is here. So if I say ls-lrt wc-l, you can see almost equivalent number of files are there. So if you see pg underscore val is here, and if we go here, so you can see pg underscore val, pg underscore two phase, pg underscore two phase. So whatever was there in the data directory, everything, including the configuration file. So this location is my uh, uh, backup location where we have just taken the PostgreSQL backup in the text format, right? So everything is here as it is. It has taken the backup of pghb_conf. It has taken the backup of postgre.auto.conf. It has taken the backup of postgresql.conf, and everything, pg back underscore version, pg underscore table spaces. So everything it has taken. So that's the advantage of using pg underscore base backup. It takes backup of everything along with the val, which is write ahead log as well. So we saw that pg underscore val. If you include that, it will take that as well. So here it is. If you do cd here as well, it will show you it has taken the backup of that as well. Now let's do one more um backup, where in what we will do, we will tar it. We will take a tar backup. So let's go to cd and let's remove everything from here. The backup which we had taken rm minus rf, and we have deleted the backup now. Just say ls-ltr. There is nothing, and this is the backup location. What we will say now is pg base backup, the utility name, -u username, -d the destination, and then these. Okay, I was supposed to show you the progress as well. So let me execute the backup once again using the same command. So pg base backup -u username -d directory. So this was, if you don't mention anything, so this is going to be the default text base backup. If I say just -v verbose, so this will show you the backup status on a screen as well, like what's going on. So if you see that it is initiating base backup, writing for checkpoint to complete, checkpoint completed. So when you see this, I think it makes more sense instead of just you press enter and it gets completed. So let's remove the file over here. So I'll just remove everything from this directory. Now in the second mm, demo, what we will do, we will perform pg base backup -u username -d directory, then -f, that is the format. If you wanted to use text format, you can do that, or you can take the tar back. Sorry, it is tar backup only. The first one was hyphen plain formats. If you don't mention, that will be plain. So this one we are going to take tar backup -z. We are going to zip this -p. This will show us the progress as well. So just press enter and feed in the password. So you can see it is showing you the percentage as well. If you wanted to make it more, what do you see, the informative, let me remove it once again, rm minus rf. You can see that there is base dot. So it has taken the two backup. One is base backup, another is for the wall files, which is write ahead log file. So it has taken it in two different zip folders, zip. Yeah, a zip file. So let me remove everything from this location. Now what we will do, we'll fire everything same with the -verbose. Feed in the password, and you can see that along with the percentage, it is showing on what is going on. Although though it is a very small database, but in the bigger environment you will be able to see the difference, like what all is going on, and with what speed it is moving on. The -p is for the progress only. And if you wanted to do it from a remote server, you can do it. You mention the -h, the IP address or the host name, then you mention the port name also, so you can do that way. This is just a basic introduction and how to use the PG-based backup. So what we did is we created a user. So just a recap. First we created a role replication underscore user, and we given it the replication privilege. Then the second important step is you have to add that replication underscore code user in pg underscore hba uh, pg underscore hba.conf so that it can take the backup. So that will be in the last option where replication is mentioned. So host, this is not the database name, but this is the privilege. Then this is the username, which is replication underscore user, and then from which IP address. If you wanted to give take it from the other, you can mention the IP address of that, and then PG MD5. That is, it will prompt for the password. Then we reloaded the configuration. Then we took the backup, and there are different options which we have discussed. I hope this is going to help, and mostly this is helpful when you do restore the point in time restoration on the same server with the WAL files, or onto the different server when you create a standby database, a standby server, or a streaming replication. So in those scenarios, it is useful. I hope it is going to help, and thanks for watching. Hello and welcome. In this session, we are going to learn how to upgrade Postgre from lower version to higher version. This is not the demo, this is just the theoretical way, like what are the different strategies available to upgrade Postgre from lower version to higher version. So normally there are three types of strategies available for. In our case, we recently faced some issues with upgrading Postgre from lower version to higher version. That was Postgre 10 to Postgre 13. So in general, there are three ways to upgrade your Postgre. Say for this example, so the best way is when you are upgrading, you just go with pg underscore upgrade, which is the suggested way of upgrading Postgre 10 to Postgre 13, or it may be something else in your case. There is a second way wherein you can upgrade your Postgre from lower version to higher version using pg dump all. In this way, you will just take a backup from source and you will do it on the target. The third way of upgradation is via the replication way, wherein you will do the logical replication from one version to another version. So there's some basic about the database version detail in Postgre. So current Postgre version number consists of a major number and a minor number. Say for example, there is Postgre version 10.1 or 13.4. Let's say, then the first two digits represents the major number, and the last digits represents the minor number. So minor release never changes the internal storage format, and they are compatible with uh, earlier minor releases. Let's say I have 12.1, 12.2. In that case, the compatibility will not be changed because of the minor version change. So there will be a change when we go from one major version to another major version. Let's say 10.1 to 13.4. That's a change in the major version. So the storage, what do you say, the compatibility and other features are going to change. So that's about the major and the minor version. Let's talk about the upgrade speed and complexity associated with the upgrade. Since it is an open source database model which is available, so whenever a new version is available, and if it is a staple, then the community goes and try to upgrade and take the advantages of the newer version. The fastest way of upgradation is using the pg underscore upgrade out of the three upgrade facilities which are available. The traditional way, which is using the backup and restore, is always considered to be the safest way of upgrade. And recently we faced an issue wherein we have taken that approach and we have moved the data using the PG dump all method. So out of the three, when we say about PG underscore upgrade, wherein it is going to do the in-place upgrade, so whatever is available, it is going to upgrade that, and it is the fastest way of upgrading your Postgre from lower version to higher version. So how does PG underscore upgrade works? The PG underscore upgrade tool, which is available in the newer version as well as in the lower version also. So if you have to upgrade from lower version to higher version, this utility you have to execute from the higher version so that it can upgrade from lower version to higher version. So this is the way it works. So PG underscore utility will be available in the bin directory, which is, let's say I have an example. I'm trying to upgrade from 9.6 to 10, which is the change in the version, change in the major version. So when we say PG underscore upgrade, you mention the hyphen old data directory, you mention the location of old data directory, you mention the location of new data directory, you mention the location of old binary location, and you mention the location of new binary location. And when you do this, you always make sure that you specify user and port number so that it can connect to the proper database. What are the prerequisites when we are taking the upgrade strategy using the PG underscore upgrade? You should always take a snapshot of virtual machine, because most of the time we this is very frequent, and if you have the extensions available, then they will not directly allow you to upgrade using PG underscore upgrade utility. Let's say you have using a foreign data wrapper, and if it is there in your lower version, and if you use PG underscore upgrade, it is not going to allow unless or until you drop the foreign data wrapper extension in your source. And it is not just this extension. If you have, let's say, 100 of extensions in your source environment, then it may be difficult, because it will always ask for some of the conflicting extensions to be dropped. The second one is in terms of the prerequisites. It is when you are trying to upgrade, it always make sure that you take a complete backup using PG underscore dump all, or if you are using PG underscore base backup, if you are using that as a utility to backup your database environment, then ensure you have the proper backup in place. And you have two levels of rollback plan. One is at the virtual machine level, wherein you can restore within few minutes depending upon the size, and another is you have to take a backup using uh, the the PG underscore dump all. And let us see, I have already mentioned it on the notepad. So upgrade strategy, if you are going to use PG dump all, therein, let's say in this demo, when we do it next time, we are going to create two instances. One is for Postgre 10 and another is for Postgre 13. So once you do the installation, what you have to do is, for this particular demo, what I had done earlier is, in Postgre 10 or Postgre, let's say 11, whatever you wanted to install, insert some sample data. Insert some sample data, and then you on the same server, because you're going to do it on the same server for Postgre 13, you install the binary of Postgre 13, and the only thing which you have to take care is, because on both, whether it is this system or another system, the port has to be different. The older system would be running, let's say, on 5432. You make sure you give some other, otherwise it is not going to allow to execute your Postgre 13. So you run it on different port, let's say 5433, and when you are connecting, make sure you mention the port number. If my port Postgre 10 is running on 5433, 5432, you mention PSQL-P 5432. And if you wanted to connect to Postgre 13, then you mention 5433, whatever your port number you have mentioned. So for demo environment, what we had done is in our lower environment, we inserted some data. PSQL-P 5432, it is connecting to my Postgre 10 or 11. Then we have imported some DVD rental data inside that, and then we had taken a backup just to simulate it. And finally, what we had done is we stopped the Postgre 10 because we have extracted the data from there, and we connected to Postgre 13 using PSQL-P 5433. And then if you can check the version, you can check it over there. And when you are going to import it, use PSQL-P 5433, and then you import the data. The side by side upgrade is always supposed to be the safest way, because you are not going to change anything on the source environment. In our case, when we face this situation wherein we were supposed to drop the extensions, we did not do it. We, in spite of that, we went with the other way, wherein we wanted to keep the source intact in case there is some problem. Though we had a virtual machine snapshot, we did not go with that. And then we had gone with the side-by-side upgrade using the traditional way, which is backup and restore, so that at one particular point of time we have both the environments available for testing. In case the application team assumes the newer upgrade system is not valid, then we are always in a system to roll back it without restoring the snapshot of the virtual machine, or without restoring the backup, which is the logical backup which I had, pg underscore dump all. We didn't go with that, and we had this system up and running. This is the safest way, where in side by side upgrade you have it. And if you wanted to go with the PG upgrade, which is the fastest way of upgrading from lower version to higher version, and this is the command which you have to execute. PG upgrade, you have to mention the location of the old data directory, new data directory, the complete location, old binary directory location, and new binary directory location. So it will appear something like this. This is the location of newer version of upgrade utility, old data directory, new data directory, and when you say -c, it is going to check whether everything is uh, met, all the conditions are met for the upgrade, and then you start the upgrade without -c. It is going to upgrade your entire Postgre 10. And once it is done, what you have to do, it will allow you to start the Postgre on your newer system, and then it will ask you to stop the Postgre lower version. So the only problem with this way is most of the time when you have the extensions installed on it, it is going to show you that you drop it on the source environment. So sometimes it may not be advisable to do so, because we wanted to retain both the systems in case we have to roll back. And finally, when this PG upgrade utility goes successful, it will allow you to drop the older cluster. So there is another way also, which is called as the logical replication, where you can replicate your data from source to target environment. So that's all about the conceptual way of upgrading it. So you have the three ways. You have the safest way of upgradation using PG dump all. You can do it using PG upgrade, which is fastest. In case you wanted it to for the continuous replication because of the downtime constraint, then you have to go with the replication way. So PG dump all, when you are doing it, it is a complete downtime. PG upgrade also, you have to shut down your source cluster environment. And if you go with the replication way, then it is a continuous replication, and your downtime will be minimized. Though we did not do the demo has already been performed in previous sessions, so you can refer that. And in some other demo, we'll try how to upgrade uh, lower version to higher version, let's say from Postgre 12 to Postgre 13, using the replication. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to upgrade Postgre lower version to higher version using PG underscore upgrade utility. So first, let's understand what is PG underscore upgrade utility in PostgreSQL. So PG underscore upgrade utility is also known as PG underscore migrator in earlier version of PostgreSQL, and it is a utility which is used to upgrade the Postgre instance from lower version to higher version. Let's say if I have to upgrade my Postgre instance from 10 to 12, I can use PG underscore upgrade utility. So PG underscore upgrade utility supports upgrade from 8.4 dot star version to the latest version. The current version is 12 and 13th is the Vita version. So this particular utility, PG underscore upgrade, is not applicable for minor upgrade. That means if let's say if I'm on 10.1 and if I wanted to upgrade it to 10.2, this is not valid. So this is a utility which is used to upgrade from lower to higher version, and let's see how it is used. PG underscore upgrade. If you say PG underscore upgrade hyphen hyphen L, you will see the different options. The first option is hyphen small b, which represents to the uh, uh, older cluster having the executable location. If I say capital B, that means the new cluster executable location. If I simply say hyphen C, it means I can check the status whether this particular PG underscore upgrade can upgrade from one version to another version or not. Hyphen small d represents the data directory of older cluster. Hyphen capital D represents for the data directory of new cluster. And some other important parameters are hyphen small p, which represents the port number of older cluster. Hyphen p represents the port number of new cluster. You can mention the username if there is a some other user other than Postgres. You can mention that. Hyphen v is used to for verbose. You can see the proceedings on the screen as well. So how do we use the PG underscore upgrade utility? So what we have to do before running this utility, you have to create a new cluster, and you have to instantiate it using the initdb. And once you instantiate the new cluster, in our case, the demo which we are going to perform is from 10 to 12 upgrade. So there will be one instance of PostgreSQL 10 and another will be PostgreSQL 12. So we will upgrade from PostgreSQL 10 to PostgreSQL 12. So you have to shut down the older instance, and you have to shut down the new instance as well before we use this upgrade utility. So what happens in the background when you use this utility? So what it does, it copies the data from older data directory to the newer data directory. And since there will be two cluster, one will be on 10 and another will be on 12. So you have to make sure that you give the exact location of data directory of old location, new location, binary directory location of old environment and the new environment. So this is how do we use the PG upgrade hyphen D. A small d represents the older clustered data directory location. Capital D represents the new data directory location, and then a small b represents the bin location of older cluster, capital B represents the bin location of a new cluster. So let's see the demo now. And the demo which we are going to perform is like this. So in the demo, what we will do is we are going to upgrade PostgreSQL 10 to PostgreSQL 12 on RHEL 7.5, and we will be upgrading one database, which is DVD rental, or it is applicable for all the databases which are hosted on the older cluster. So let's perform it. So I have listed all the steps here in a notepad. So we are going to execute this. This is a step-by-step procedure to upgrade PostgreSQL 10 to PostgreSQL 12. So I have a Linux system. The IP address is 192.168.1.56. I have the root access and I'm logged in as Mova Extreme. So in this step, first I'll check whether I have the internet activated on my system or not. So I'll just say ping google.com. So this is working fine. In the step two, it is everything from the beginning. So I'm going to install um, the PostgreSQL 10 version. So yum install PostgreSQL 10 hyphen server PostgreSQL 10. So I'm going to install this. This entire demo is going to take at least 10 to 15 minutes. So once we install this, we have to instantiate it. Yes, the packages will be downloaded. It is very, very fast. The next step is we'll say PostgreSQL 10 hyphen setup space initDB. This is going to initialize the database, and your data directory will be created. This is done. Once it is done, you just switch to Postgre user sudo su space minus Postgre, just clearing the screen. Once it is done, you just try to start it using sudo systemctl start PostgreSQL 10. Once it is done, just check the status sudo systemctl status PostgreSQL 10. You can see that it is in running status. Now let's load sample data. So I have a database in copied here in all.sql. So I'm just going to import that. Once it is done, we'll log into Postgre prompt and we'll see what is the database hosted over there. So I have a number of databases. Mostly it is DVD rental. This just to showcase like how this database will be migrated from, upgraded from 10 to 12. Just say PSQL, and so I have DVD rental, uh, DVD rental underscore new, DVD rental underscore now, restore DVD rental, and there are so many DVD rental databases. So I'll just quit out of this, and then we will go to the step 3. Um, so we have performed 2 steps, and now we are going to install the newer version of PostgreSQL. So in this, we are going to install PostgreSQL 12. So this has to be done as the root user. So we'll say yum install PostgreSQL 12 hyphen server, and this all will be mentioned in the command section. It's very, very easy. And just say yes. So this will be downloaded. Once it is downloaded, you just have to go to the complete location of the binary location, and then you have to execute it, because you have 2 clusters now. One is on 10G and another is on 12. So usr slash pgsql 12 bin postgresql 12 hyphen setup initdb. So we are going to initialize it. Once it is initialized, what we have to do is we will switch as the Postgre user, and we have to start the new instance of Postgre, but this is not possible on the default port, so we have to change the default port of 54322 to some other value. So what we am going to do is, so we are going to add it the postgresql.conf of 12, postgresql 12, and we'll replace 5432, which is the default port, to the new port, because you cannot run two instances on the same port, so you have to change it to some other value. So I'm giving 5433, this is the newer port, and then we will restart the PostgreSQL. Just starting, and then check the status. So you can see we have it is running. Now we have two instances running as PostgreSQL. So check instances are running or not. So we will say ps-ef grab postgre postmaster, which is the main background process. So you can see one Postgre master is running out of psql 10 and another from 12, and the data directory are different. Now, using the pgctl, we have to check the status of both the cluster. So we'll say pgctl, and this has to be from the PostgreSQL 10 version, and then we will give the location of the data directory and then just say status. So you can say that pgctl server is running. Then similarly, we'll do it for 12. So you just make sure that you give the location of your 10 and 12 PostgreSQL respectively. So this is also running, server is running. Then what we are going to do is we have to stop both PostgreSQL instances. So using the pgctl only, we have to stop it. So pgctl-d data directory location, and I'll just say stop. So the PostgreSQL 10 instances is stopped. Now we are stopping the PostgreSQL 12 instance. So pgctl-d and data directory location, and then stop. It is done. Just check the status using the status command instead of a stop. We'll just say status, it is not running. We'll similarly check it for 12. You can see that it is not running, so both are not running. We can check it from the background process, which is ps-ef grab postmaster. Just execute it, and there you can see there is no output. This is just reflection of the command which we executed. Now we will check if the cluster is ready for the upgrade or not. So I'll explain the what is this all script is about. So this is PG upgrade, which is from the newer so /usr PGSQL 12 bin. The PG underscore upgrade is from PostgreSQL 12 hyphen old data directory. What is the location of old data directory? Or the location of old data directory is this one. Hyphen new data directory. This is the location of PostgreSQL 12. And then we will give the location of old binary location of PostgreSQL 10. So this is USR PGSQL 10 hyphen bin. Then we will give the location of bin directory of PostgreSQL 12. Hyphen C is just to check whether our cluster can be upgraded or not. So you can see that checking cluster version, then checking database user is install user or not, then it is checking the connections, whether it can connect to both the instances or not. Then it is checking whether clusters are compatible, whether it can be upgraded from lower version to higher version, that is PostgreSQL 10 to 12. So everything is fine. So now we will invoke the same command without the without hyphen C option. So that means it is PG upgrade. We have given the location of old data directory, new data directory. We have given the location of old binary directory, and we have given the location of new binary directory. So the first option will be for the existing environment, and the next will be for the new environment, and just press enter. So this is going to take a few minutes depending upon the size of the database. You can see that creating dump of the database schema. So it is taking all the databases one by one, and this will copy and paste from PostgreSQL 10 to 12. So behind the scenes, it is doing a number of things. It is analyzing, it is restoring the objects from from lower version to higher version. So it has created two scripts to analyze the new cluster if in case you wanted to analyze it, and the another script is used to delete the old cluster. What we will do now is we will start the new cluster. Let's stop it first. If it is started, we'll say pgctl-d and data directory location and stop. It is not running, so we can say either start it, or if it is not starting, what we will do is we will change the server status is running, and sometimes it creates the problem. And what we have to do is in postgresql.conf we have to change the port number. So the port number, let's make it 5432 as it was there in the older what do you say, the PostgreSQL 10. So let's start it, stop and start again, and we'll try to connect. It is stopped. Using the pgctl again, start it. It is started. Let's try to log in. PSQL, just say -l and you will see all the databases: DVD rental underscore new, then now, and there was a user also, which is user2 underscore remote. If something is not migrated, that it will show you like user run this script. So we are not going to analyze it now, and I just wanted to keep it for some more time, the older cluster, and if you don't need it, you just go and delete it. Quit and delete the older cluster. So we have a new cluster now. So I'll revisit what we have done is in our demo we installed PostgreSQL 10. We initialized the cluster. Then we imported some data which was having DVD rental database. Then we installed newer version of PostgreSQL 12. Then we changed the directory from 5432 to 5433 because we cannot run two instances on one port. Then we started the PostgreSQL 12. Then we stopped both the servers, PostgreSQL 10 and 12, using pgctl command, and it has to be from respective binary location. Then we, using the pg upgrade command, we mentioned the location of old directory of existing environment and new environment. Then we mentioned the bin directory location of older environment and newer environment, and we mentioned the -c to check whether the cluster can be upgraded or not. And finally we fired the same command without -c, and we upgraded the cluster within no time because the data was very less. Then we started the new cluster. We changed the port from 5432 to 5433 to 5432, and then we verified if the database is copied or not. So this was all about the PG upgrade utility to upgrade PostgreSQL 10 to PostgreSQL 12 on RHECL 7.5. I hope this is going to help, and all the commands will be there in the comment section. And thanks for watching. Hello and welcome. In this session, we are going to learn how to migrate Postgre database from one server to another using pg dump all. So I have two servers already with me, and the source server The IP address is 192.168.1.113 and the target server is 192.168.1.116. Both of them are already having the Postgre version 13 installed, and as a prerequisite, since this is a lab environment and we have already disabled the firewall and SE Linux is disabled, and the password of Postgre database user has been set to password, and the database can be accessed remotely. I will show you what is there and then we will start from there. So this is my source server having the IP address 192.168.113, and you can see on the listen address this is the IP address. On the target side also, this is the target server which is having the IP address 116, and if I just check the postgresql.conf file, the IP address is set to listen underscore address. That means they can be accessed remotely with one more setting. If you just check your hba.conf file, you will be able to see that. This is my pg. It should be pg underscore hba.conf. So I have mentioned that the IP address in this range, they should be accessible. So from my laptop also, which is having the IP address in this range, so I will be able to access it. And the same goes for the source as well. So I'll just show how it is. This is required in order to ensure that we are able to access it remotely. You can see that configuration is also over here. I think it's here. Yeah. Okay. Now what we are going to do is we are going to take a backup of all the database from the source and we will transfer it to the target and then we will restore it over there. It is very straightforward demo that we are going to perform. Okay, so let's begin with it. And the first thing, which there are a few prerequisites that you can check out, like finding the size of the database. What I have done in advance is I'm already connected to PG admin using to the both the source and the target server. So I'll show this is my source 192.168.113 and the target is 116. So if you go and just check this source database server, this is how it is. Okay, let me go and connect to the source database server in Postgre database, and what you can do is you can fire few commands to find out the size and other details. So what you will do is just replace the database name with the databases which are there on the source side. So I have several databases: demo, DVD rental underscore 2, 3, 4, 5. So just if you wanted to capture all these details, so I'll say DVD rental. So it is DVD rental. So I just check the name, DVD rental. Just checking the size, and we will cross verify this should not be available on the target environment. Okay, let's execute this. You can see there are 1, 2, 3, 4, 5, 6 databases. Just I'm trying to execute because this will be required. There's 15 MB in size, so they are replica of each other, these databases. So somewhere around 60, 70 or 80 MB of data is there on the source side. On the target side, which is my 116, you don't see any database, right? This is just the default Postgre database. So you can capture all the details from here. So you can list down the databases on the source. Using the command prompt, it is easy to do. You just say PSQL, list down the databases like this. You can see there are 9 rows. There are 2 template databases. One is default Postgre databases, and these are 6 databases which are user created. Or you can fire this select DAT name from PG underscore database. That will give you the details of the database on the source side. Also, you can find out all the schemas on the source side. You need to record all these when you're doing the migration, just to cross verify when you are already on the target, just to cross verify everything is fine or not. Or you can find all the details of the individual objects on the source side using this command, and this will show you how many uh, default, non-default, and count of the objects are there. Okay, so and you can list down the users. I believe I have not created any user other than the default one, but if you create, you will be able to capture that. So by default, it is just the Postgre on the source side, and you can find out if you have any extensions deployed on the source side, and the target I believe it is already not set up, so we just installed the binaries there only. And the first thing which we are going to do is we are going to backup of the databases on the source side. So we'll say, and the location of the file system where we are going to store on the source side is postgres/backup, and the same location we have on the target as well. This is not mandatory. There's just we have it. So I'm just going to take backup of all the databases on the source side. Just exit out of the Postgre command prompt and just say pg dump all, and this should be done any moment. So once this is done, you have to transfer. So if you see this ls-ltr, this backup file will be created, and you need to transfer this from source to target side using the SCP. Okay, so what I'm going to say is SCP it from the source side and transfer it to the target. So let's navigate to that location cd, and if you say ls-lrt, you can see all.sql, and we will SCP it from source to target side. Target is 116 IP address. This is the username, and this is the location where it is going to copy. I'm just saying yes, I want to continue. Give the password of Postgre on the target side. It is, I believe, password only, or Postgre. Yes, it is. Let's go to target side. First of all, let's try login using PSQL. Yes, we are able to log in. And now navigate to the location where you have copied the, we have copied it to this location, all.sql, you can see. And if you say psql/l, this is going to list down all the databases. So you have just 3 default databases, and we are going to import all the databases now. So we'll say PSQL, and the name of, and these are the databases which are required to be over here. But let's see if it throws any error when we say PSQL on the target side. Okay, there are few things which it has not done. We'll say POSQL and just say /l. You can see all the databases are restored. What is not done is the Extensions, so you need to create those extensions manually on the target side if they are not done, and you can cross check the other components which you have recorded when you are trying to record everything from the source side. So in a nutshell, we have transferred the dump from source to target, and we have imported. We haven't mentioned the database name, and the way it is there on the source side, the same databases will be created over here. So what you need to do more than this is you just go here, just refresh it, and you should be able to see all the databases which are restored. You need to confirm the users, the if you have schemas, they are coming over here or not. So you need to check out the table spaces as well, and those are the mandatory things which you need to check about. And since the database size was less, we could have used over the network also. So in another session, we are going to see how to do it over the network when the database size is very small. I hope this migration is going to help you, and thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn how to upgrade Postgre lower version to higher version using pg underscore upgrade utility. So first, let's understand what is pg underscore upgrade utility in PostgreSQL. So pg underscore upgrade utility is also known as pg underscore migrator in earlier version of PostgreSQL, and it is a utility which is used to upgrade the Postgre instance from lower version to higher version. Let's say if I have to upgrade my Postgre instance from 10 to 12, I can use pg underscore upgrade utility. So pg underscore upgrade utility supports upgrade from 8.4 dot star version to the latest version. The current version is 12 and 13th is the Vita version. So this particular utility, pg underscore upgrade, is not applicable for minor upgrade. That means if let's say if I'm on 10.1 and if I wanted to upgrade it to 10.2, this is not valid. So this is a utility which is used to upgrade from lower to higher version, and see let's see how it is used. Pg underscore upgrade. If you say pg underscore upgrade hyphen l, you will see the different options. The first option is hyphen small b, which represents to the uh, uh, older cluster having the executable location. If I say capital B, that means the new cluster executable location. If I simply say hyphen C, it means I can check the status whether this particular pg underscore upgrade can upgrade from one version to another version or not. Hyphen small d represents the data directory of older cluster. Hyphen capital D represents for the data directory of new cluster. And some other important parameters are hyphen small p, which represents the port number of older cluster. Hyphen p represents the port number of new cluster. You can mention the username. If there is a some other user other than Postgres, you can mention that. Hyphen v is used to for verbose. You can see the proceedings on the screen as well. So how do we use the pg underscore upgrade utility? So what we have to do before running this utility, you have to create a new cluster, and you have to instantiate it using the initdb. And once you instantiate the new cluster, in our case, the demo which we are going to perform is from 10 to 12 upgrade. So there will be one instance of PostgreSQL 10 and another will be PostgreSQL 12. So we will upgrade from PostgreSQL 10 to PostgreSQL 12. So you have to shut down the older instance, and you have to shut down the new instance as well before we use this upgrade utility. So what happens in the background when you use this utility? So what it does, it copies the data from older data directory to the newer data directory. And since there will be two cluster, one will be on 10 and another will be on 12. So you have to make sure that you give the exact location of data directory of old location, new location, binary directory location of old environment and the new environment. So this is how do we use the PG upgrade. PG upgrade -d. A small d represents the older clustered data directory location. Capital D represents the new data directory location, and then a small b represents the bin location of older cluster. Capital B represents the bin location of a new cluster. So let's see the demo now. And the demo which we are going to perform is like this. So in the demo, what we will do is we are going to upgrade PostgreSQL 10 to PostgreSQL 12 on RHEL 7.5, and we will be upgrading one database, which is DVD rental, or it is applicable for all the databases which are hosted on the older cluster. So let's perform it. So I have listed all the steps here in a notepad. So we are going to execute this. This is a step-by-step procedure to upgrade PostgreSQL 10 to PostgreSQL 12. So I have a Linux system. The IP address is 192.168.1.56. I have the root access and I'm logged in as Mova Extreme. So in this step, first I'll check whether I have the internet activated on my system or not. So I'll just say ping google.com. So this is working fine. In the step two, it is everything from the beginning. So I'm going to install um, the PostgreSQL 10 version. So yum install PostgreSQL 10 hyphen server PostgreSQL 10. So I'm going to install this. This entire demo is going to take at least 10 to 15 minutes. So once we install this, we have to instantiate it. Yes, the packages will be downloaded. It is very, very fast. The next step is we'll say PostgreSQL 10 hyphen setup space initDB. This is going to initialize the database, and your data directory will be created. This is done. Once it is done, you just switch to Postgre user sudo su space minus Postgre, just clearing the screen. Once it is done, you just try to start it using sudo systemctl start PostgreSQL 10. Once it is done, just check the status sudo systemctl status PostgreSQL 10. You can see that it is in running status. Now let's load sample data. So I have a database copied here in all.sql. So I'm just going to import that. Once it is done, we'll log into Postgre prompt and we'll see what is the database hosted over there. So I have a number of databases. Mostly it is DVD rental. This is just to showcase like how this database will be migrated from, upgraded from 10 to 12. Just say PSQL, and so I have DVD rental, uh, DVD rental underscore new, DVD rental underscore now, restore DVD rental, and there are so many DVD rental databases. So I'll just quit out of this, and then we will go to the step 3. Um, so we have performed 2 steps, and now we are going to install the newer version of PostgreSQL. So in this, we are going to install PostgreSQL 12. So yeah, this has to be done as the root user. So we'll say yum install PostgreSQL 12-server, and this all will be mentioned in the command section. It's very, very easy. And just say yes. So this will be downloaded. Once it is downloaded, you just have to go to the complete location of the binary location, and then you have to execute it because you have two clusters now. One is on 10G and another is on 12. So USR slash PGSQL 12 bin PostgreSQL 12 hyphen setup initdb. So we are going to initialize it. Once it is initialized, what we have to do is we will switch as the Postgre user. And we have to start the new instance of Postgre, but this is not possible on the default port. So we have to change the default port of 54322 to some other value. So what we am going to do is, so we are going to add it, the postgresql.conf of 12, PostgreSQL 12, and we'll replace 5432, which is the default port, to the new port because you cannot run two instances on the same port. So you have to change it to some other value. So I'm giving 5433. This is the newer port. And then we will restart the PostgreSQL. Just starting, and then check the status. So you can see we have it as running. Now we have two instances running as PostgreSQL. So check instances are running or not. So we will say ps-ef grab postgre postmaster, which is the main background process. So you can see one Postgre master is running out of pSQL 10 and another from 12, and the data directory are different. Now, using the pgctl, we have to check the status of both the cluster. So we'll say pgctl, and this has to be from the PostgreSQL 10 version, and then we will give the location of the data directory and then just say status. So you can say that pgctl servers is running. Then similarly, we'll do it for 12. So you just make sure that you give the location of your 10 and 12 PostgreSQL respectively. So this is also running, server is running. Then what we are going to do is we have to stop both PostgreSQL instances. So using the pgctl only, we have to stop it. So pgctl-d data directory location, and I'll just say stop. So the PostgreSQL 10 instances stopped. Now we are stopping the PostgreSQL 12 instance. So pgctl-d and data directory location, and then stop. It is done. Just check the status using the status command instead of a stop. We'll just say status. It is not running. We'll similarly check it for 12. You can see that it is not running. So both are not running. We can check it from the background process, which is ps-ef grab postmaster. Just execute it, and there you can see there is no output. This is just reflection of the command which we executed. Now we will check if the cluster is ready for the upgrade or not. So I'll explain what is this all script is about. So this is PG upgrade, which is from the newer, so /usr PGSQL 12 bin. The PG underscore upgrade is from PostgreSQL 12 hyphen old data directory. What is the location of old data directory? Or the location of old data directory is this one. Hyphen new data directory. This is the location of PostgreSQL 12. And then we will give the location of old binary location of PostgreSQL 10. So this is USR PGSQL 10 hyphen bin. Then we will give the location of bin directory of PostgreSQL 12. Hyphen C is just to check whether our cluster can be upgraded or not. So you can see that checking cluster version, then checking database user is install user or not, then it is checking the connections, whether it can connect to both the instances or not. Then it is checking whether clusters are compatible, whether it can be upgraded from lower version to higher version, that is PostgreSQL 10 to 12. So everything is fine. So now we will invoke the same command without the without -c option. So that means it is PG upgrade. We have given the location of old data directory, new data directory. We have given the location of old binary directory, and we have given the location of new binary directory. So the first option will be for the existing environment, and the next will be for the new environment, and just press enter. So this is going to take a few minutes depending upon the size of the database. You can see that creating dump of the database schema. So it is taking all the databases one by one, and this will copy and paste from PostgreSQL 10 to 12. So behind the scenes, it is doing a number of things. It is analyzing, it is restoring the objects from from lower version to higher version. So it has created two scripts to analyze the new cluster if in case you wanted to analyze it, and the another script is used to delete the old cluster. What we will do now is we will start the new cluster. Let's stop it first. If it is started, we'll say pgctl-d and data directory location and stop. It is not running, so we can say either start it, or if it is not starting, what we will do is we will change the okay, server status is running, and sometimes it creates the problem. And what we have to do is in postgresql.conf, we have to change the port number. So the port number, let's make it 5432 as it was there in the older what do you say, the PostgreSQL 10. So let's start it, stop and start again, and we'll try to connect. It has stopped. Using the pgctl again, start it. It has started. Let's try to login. PSQL, just says -l, and you will see all the databases: dvd rental underscore new, then now, and there was a user also, which is user2 underscore remote. If something is not migrated, that it will show you like user run this script. So we are not going to analyze it now, and I just wanted to keep it for some more time, the older cluster. And if you don't need it, you just go and delete it. Quit and delete the older cluster. So we have a new cluster now. So I'll revisit what we have done is in our demo, we installed PostgreSQL 10, we initialized the cluster, then we imported some data which was having DVD rental database. Then we installed newer version of PostgreSQL 12. Then we changed the directory from 5432 to 5433 because we cannot run two instances on one port. Then we started the PostgreSQL 12. Then we stopped both the servers, PostgreSQL 10 and 12, using pgctl command, and it has to be from respective binary location. Then we, using the pg upgrade command, we mentioned the location of old directory of existing environment and new environment. Then we mentioned the bin directory location of older environment and newer environment, and we mentioned -c to check whether the cluster can be upgraded or not. And finally, we fired the same command without -c, and we upgraded the cluster within no time because the data was very less. Then we started the new cluster. We changed the port from 5432 to 5433, 3325432, and then we verified if the database is copied or not. So this was all about the PG upgrade utility to upgrade PostgreSQL 10 to PostgreSQL 12 on RHECL 7.5. I hope this is going to help, and all the commands will be there in the comment section. And thanks for watching. Hello and welcome to E-MultiSkills video tutorial. In this video tutorial, we will learn what is logical replication in PostgreSQL, and following that, we will see a demo on logical replication. So what is a logical replication in PostgreSQL? So logical replication is one of the way of replicating the data and its associated change from one database to another database, or the databases may be on same host or different hosts. So we are talking about the tables wherein the individual row is actually identified using the primary key. So any changes which is happening on to the table will be replicated from one database to another database. So when we talk about logical replication, it is entirely different from what we call as the physical replication, wherein bit to bit the data is same on two different hosts. But when we say about logical replication, you can control what data has to be replicated from one database to another in PostgreSQL. So you have a control over, you have a fine grained control over the data which has to be replicated, and you have a good control. So in PostgreSQL, when we talk about the logical replication, we talk about two terms. One is the subscriber and another is the publisher. So the one where the application connects in the particular database, that particular node is known as the publisher node, and wherever the logical replication is replicating the data, that is known as the subscriber. So publisher is the one wherein the changes are actually happening, and subscriber is the one which is accepting those changes. So when we set up the logical replication, we set up two, let's say we set up two different hosts, and we have two different instances, we have two databases. So what happens initially, uh, we have to replicate the data from publisher to subscriber. So the initial data is same. Once the initial data is same, then using the Postgre logical replication, whatever changes are happening on the publisher will be automatically subscribed by the subscriber. So it is like changes are happening on the publisher, and the subscriber gets them onto the subscriber server or the host, and it is all happening in the real time. The way the changes are happened onto the to the publisher, the same way it is applied on the subscriber. So there is always a transactional consistency. Let's see some of the use cases of Postgre logical replication. So what we can do is we can send the incremental changes in a particular database or n number of databases from the publisher to the subscriber. Or what we can do is there may be some kind of data warehouse kind of thing wherein the consolidation from multiple databases go into a single database. Or what we can do is we can replicate the changes between different major versions. Or it is possible that I have a PostgreSQL instance which is running on Linux and another in Windows, so I can replicate the data from Linux to Windows, and whatever changes are happening, subsequent changes are happening, that one can be replicated on different hosts. Or there may be a case wherein we can share a subset of database between multiple databases. So let's say there is a table which is existing on a database A, and it can be sent to different database, like let's say database B, C, D, and E. It is not like you send the entire content of the database, let's say a few tables, can be subscribed by those databases. So that's a good use of logical replication. So a little bit more about the publication and the subscription. So as we discussed earlier as well, so the publisher node or the publication node is the one where in the application connects, the changes are happening over there, and from the publication node, the changes go to the subscriber, the one which accepts those changes in the downstream. So publisher is the one where an application is going to connect. There will be a table, there will be some primary key, and the changes from publication is replicated to the subscriber uh, the using the logical replication. So there are some kind of restrictions on also here when we use logical replication. So any kind of DDL changes which are happening on to the publisher, they will not be replicated to the subscriber. In that case, whatever DDLs are running on to the publisher, that has to be manually applied on to the subscriber, or using the PG dump structure only you can move the those commands to the subscriber. And the sequence data, this is, I think, applicable mostly in such kind of replication. So sequence data is not replicated from publisher to the subscriber. If you are running the truncate command, the truncate command is not actually replicated onto the subscriber. So instead, you can use the delete command if it is possible. Large objects replication is not allowed, or it is not possible. Maybe in the future uh, versions it will be possible. And replication is only possible from base table to base table. That means if you wanted to replicate the views, metallized views, or partition root tables, or the foreign tables, those are not possible. And let's see the demo on logical replication, which is hosted on 2Node. So let me close this, and we'll see the demo. So the demo is like this. I have two nodes, 192.168.1.51, another is 61. So PostgreSQL 12 is already installed, and the first node will be acting as the publisher, and the second node will be acting as the subscriber. So on to the first node, what we are going to do is we are going to configure it for the logical replication. So what we will do is in postgresql.conf, we will replace localhost with the IP address of that particular node, which is 192.168.1.51. Then wall level will be changed to the logical, and then we will allow the request from the second node 61. So we will in the publisher node, what will we do is pg_hba.conf, we will add the IP address of the subscriber server. So let's start that. This is my publisher server, so let's check the status. Sudo systemctl status PostgreSQL 12. Oh, it is starting. Let's say check the status. It is running. And the second step is what we will do is we will edit the postgresql.conf, and we will make the changes. The changes is localhost has to be replaced by the IP address of that server, and because we have to connect it from remotely as well. So I'll be changing the localhost to the IP address of the server. The IP address of this server is, let me copy and paste the IP address. IP address is 192.168.1.51. So localhost entry has been replaced by this. And then we will go further to well. So well level has to be changed to logical. So let's change it from replica to logical. So it is going to capture all the changes which are happening on to the publisher database. And these are the only two changes. We are doing a basic logical replication. This is done. Then what we will do is we will add it pg_hba.conf. So this will make sure that the connection from subscriber server is allowed. So we will go to the section IPv4 local connections, and we will add the entry. So the entry will be host all databases, all users from 192.168.1.61 using the password method can connect. So we have to tell the publisher that this is going to happen, and you need to allow if there is a connection request from the subscriber server. This done. Now the next step is you will have to restart it because we have made some changes. Let's restart. Let's create the database user and the table. So we'll create a database with the name create database wrap db onto the source, which is my publisher. So you can see that database is created. Next, switch to the database, and what we will do is we will create a table, wrap table, which will have the ID, name, and price. Let's create this. This is created. And then we will create a role wrap user with replication, and login password is secret underscore password. You can keep any other password. This is a demo, that's why we are doing this. We can see that wrap user is created. Then let's grant all privileges on database to that particular user. This is done. Next, on public schema also we are giving it, although this is not the right way, but this is a demo, so we are doing this. Okay, so once it is done, you go to the second node, and we have to create the structure of the database. We have to create the empty table, and then we will start the application. Okay, this is my subscriber server. So we'll say uh, create database wrap db. This is done. Then we will switch to wrap db database. RapDB database is created, then we have to create the table. The structure of the table has to be created first because DDLs are not allowed. They will not be replicated. Then what we will do is we will set up the replication. Okay, to set up the replication, we have to execute create replication on source database server. So this is my source database server. So we will say create replication, my replication. So this is done. Then you have to add the table to that particular publication. So we are saying alter publication name, and the table name. This is also done. Now we will have to create the subscription. To create the subscription, uh, we have to fire this complete command, and this has everything whatever we have done onto the source. I'll explain what is this. So we'll say create wrap the subscription, and subscription name, connection, host is 192.168.1.51 where my publisher is running. Then port is 5432. This is the default one. Password is secret underscore password, which we have given. User is wrap user. DB name is wrap DB, and publication name we are giving here is my publication that we had mentioned. Okay, it is not accepting, so let me restart this. Systemctl restart. Okay, let me restart it because I made some changes and I have not restarted it. Let me see the status. Yeah, it is back. And let me try the replication creating the my subscription again. Okay, you can see that create replication slot my subscription on this is done. Now we will test the replication. Okay, the table name is uh, wrap underscore table. So let's say select a star from wrap table. You can see there is no row on to the target. That is my subscriber. On the publisher also, we will check it and there shouldn't be anything because there is, okay, let's switch to wrapdb and then we will say select a star from, okay, there's nothing. Let's insert one row. We'll say insert into wrap table and the first one is ice cream. Let's insert this on the publisher. It is inserted. Let's check the status on here also in publisher because we have inserted it. Under the subscriber, fire the same command. That data should be replicated. You can see the data is replicated. Let's add one more row onto the publisher, and if you simply say select a star from wrap table, there are two rows onto a publisher, then there should be same on subscriber also. You can see that it is getting replicated. So just a recap of what we have done is we have two servers. One is publisher and the other is acting as the subscriber. So we have on the publisher, we have changed listen address to the IP address of that particular host. Wall level has been changed to the logical so that it can capture all the changes in wall. And pg_hba.conf, we have added the IP address of the subscriber so that incoming connections are allowed. Then we have created a database, a user, and the table. And then we created a publication. Then we added the table to that particular publication. And on the subscription side, what we did is we said create subscription, subscription name, and in connections, we have mentioned everything. The publisher host, publisher port number, password, user, database name, and then we tested the replication and it was working fine. So I hope it is going to help in setting up the replication, and see you soon in another video. Thanks for watching. Hello and welcome. In the session, we will see how to load the sample database in PostgreSQL. And the sample database which we are going to load in PostgreSQL, it is DVD rental. So what we are going to do is, as a prerequisite, we have an EC2 instance which is running with the RHEL 8. We are able to connect with the EC2 instance, and let me show how it is. So this is my EC2 instance. If I say sudo su space minus postgre, I'm able to connect with it. And if I say psql, I'm able to show you the databases, and there is no database with the name DVD rental. So what we will do is we will create the database and then we will load the database. So before that, what we will do is, so we will transfer it using the WinSCP. So I have the WinSCP tool available on my system, and what I'm going to do is, let me create a connection. So I'll say open connection, and where is that connection? New connection, and this is the host name. And you have to go to the advanced. In the advanced, you have to locate the location of your this is your authentication, and you just have to point the location of the private key which you are using, and you just say save and login. Okay, so this is your dvd rental.zip which you can download from the internet. It is easily available, And what I'm going to do is I'm going to put it in my backup directory, which is there in the temp. Not suggested, but just for this demo, I'm going to use it. So I'll go to cd/tmp slash backup, and I'll remove everything over here. And now this is the DVD rental, and this is my blank directory where I'm going to transfer this zip file. This is transferred, and now I'm on my putty session. You can see that I have the DVD rental.zip available over here. What I'll do is I'll try to unzip. Okay, this is unzipped. Now it is in the tar format, and what we will do now is we'll directly go ahead and import it. So to import, what you have to execute is you have to execute this particular command, which is pg underscore restore hyphen u postgre hyphen d, the database name which I'm going to create. The database name is createdb, and let's say the database which we are going to import, its name is dvd rental. So both these commands we are going to run from the shell only. So I'll say create dvd rental, and if I go to PSQL, you should be able to see that there is a blank database which we just created, and using pg underscore restore, we are going to restore the data in it. Pg underscore restore hyphen u, the user which is going to restore it, and the hyphen d, the database where it is getting restored, and the complete location of the tar file from where this restoration is going to happen. This is done. You go to PSQL, just say L plus. You will be able to see that earlier it was just the blank database, just few KB, and now it is 15 MB in size. If you just wanted to go inside, connect with this and just say dd plus, and you will be able to see there are 15 tables which are imported. So this is how we load a sample database. In our case, it is DVD rental, and this can be used for the testing. I hope this is going to help, and thank you. Hello and welcome. In this session, we are going to learn what is a streaming replication in PostgreSQL. This is just a diagrammatic representation of the streaming replication in PostgreSQL, though not much details have been mentioned. It is just like there will be a primary database which will be responsible for read and write operations, and from whatever changes are happening, there will be a wall file generated, and through the wall sender it will be sent on to the replica, wherein it will be received and it will be applied. So that's a kind of streaming replication which happens in Postgre. So let's coming back to the notepad where we have all the details noted. So we are going to talk about the streaming replication in Postgre. For this demo, we are not going to do the live demo. The steps are already executed. In the next demo, we are going to show it step by step. But here, this is a presentation how we are going to do it step by step. So Postgre replication is the process of copying the data from primary to the another host, which is known as the standby. So this particular feature was launched in Postgre version 9.0, and streaming replication was introduced. So how does the streaming replication works in PostgreSQL? So every transaction is in PostgreSQL is returned to a file which is known as wall, which is known as write ahead log to achieve the durability. And when a slave uses these wall segments to continuously replicate the data which is changing on the master, then it will be replicated onto the slave. So in streaming replication, there will be three kind of terminologies which will be used, and that actually works. So there is a wall sender process on the primary server which sends the wall data, which is like whatever transactions has happened, whatever has changed the data on the primary, that will be sent to the standby server. And then we have a wall receiver and a startup process which will be running on the standby server that receives and replay these data. and this wall sender and wall receiver that communicates using a TCP connection. And we know that PostgreSQL has both logical and physical replication, and those are the two important replication. In logical replication, it streams a high level change from the primary database to the replica database. So using logical replication, you can change the streams to whatever is happening on a single database or in a table. So in physical replication, changes to the wall log files are streamed and replicated to the replica cluster. So you can't replicate a specific area of a primary database cluster, but all the changes will be replicated. So streaming replication allows the standby server to stay more up to date than it is possible with file-based logs shipping. So that's the general terms about the logical and the streaming replication. Now we will see how to do these step by step. So I have two EC2 instance which I have launched. So these are the two EC2 instance which I have launched, and these are the public IP address which will be immediately destroyed after this demo. So this is the public IP of my primary server, and this is the secondary server. So these are the two EC2 instances which are launched having the Linux as the operating system. So on the primary, these are the steps which you would have done at least uh, I believe some 30 or 40 times in this entire way through me. So what is the first thing which we are going to do is sudo dnf install -y and the complete location of the RPM, which is your latest RPM for Postgre 13. Then we are going to disable the Postgre, which is the default module available, and then we are going to install the Postgre 13. These are the three steps, and then we are going to initialize the database using PostgreSQL 13 setup init db, and then we are going to enable and start the Postgre 13 on primary server. So I'm already, so let me exit out of this, and if I say sudo okay, so let me show you. So you can see Postgre 13 is already active and running, and if you see it further on the, instead of I'll say it replica. On the replica, what we have done is we have executed these three steps. One is sudo dnf install -y and the repo RPMs for latest Postgre 13. Then we have disabled the default Postgre 13 on Linux. Then we are going to install the Postgre 13 server on replica server. The two steps which we are not doing is we are not initializing the database, and we are not starting and enabling the Postgre 13. Since there is no initialization, so there is no concept of enabling and starting it. So it is just the software is available on Postgre 13. The second thing which we will do is on the primary server, we will just ensure that our postmaster is running. That means PostgreSQL is running. So you can see that postmaster is running, and there are different background processes which are mandatory, and the something which is of very interest for this streaming replication is wall writer. And one of the things which you have to do is you have to ensure that SES status, because you are doing it on EC2 instance, you have to ensure that SES status, this should be disabled. So in case you have and you are not sure how to do it, just go and make it to disable. So you can see C Linux, this should be disabled for this. Or if you have a firewall, make sure that the firewall is stopped so that the 5432 port where your PostgreSQL is communicating, that should be able to communicate between the two nodes. Then what we are going to do is, this is a very, very important part wherein we are going to enable primary for the replication as below. So what we will do is, let's log into PSQL, switch the service account, Postgre, and then this is going to be very, very important. You just say show config underscore file. So by default, you just graph for listen underscore address, cat, and graph for listen underscore address. So there is something called as listen underscore address on your postgresql.conf in your source and target. In your source, you have to ensure that listen underscore address has to be changed, because by default it will be local. And if you see it, uh, mm, local underscore address, that you have to change it from localhost to the IP address of the server. So in our case, we have just changes to star or the IP address of the server so that it allows the remote connection. Then the second thing which we have to do is we have on the source server. So everything we are doing it on the primary. So we are going to create a user, which we are saying as create user replication. So what this is going to do is this is going to create a replication user which will be used to replicate the data from primary to the replica. So this user is already been created. So if you say psql and /du, you will be able to see that a replication user, which is called the rep user, has been created with the replication capability. Then the next thing which you have to do is you have to tell your hba.conf file that allow the connection from the replica. So what you will do is, this is going to be very, very, very important. Cat pg data hba.conf. So you have to ensure that host replication rep user, and this is the IP address from where your replica will be coming. You have to say that whenever the replica is coming from this, ensure that the connection is allowed. So you have to ensure this, otherwise it is not going to work. Then finally, on the primary server, you have to restart your PostgreSQL. So far we have uh, installed the PostgreSQL binary on the source environment. The database is up and running. On the console PSQL, we have changed the listen address either to the IP address of the primary host, or ensure that star is mentioned so as to allow it. Then the next thing which we have done on the primary side is we have created a user called rep user with the replication capability. And then in the hba.conf, we have allowed the IP address of the replica so that it can connect. And finally, we have restarted the primary server. Now on the replica side, let's open the replica. This is our replica. Here also you have to ensure that SAS status, it must be disabled so as this demo to work. And we have to create a base backup. So far in replica, you just have the binary and nothing else. So these things are not going to work over here. So initially, when there is nothing, you go and check it over here. This will be blank. As of now, there will be data because the command has already been executed. And the next thing which you have to do on logging onto the the replica is, you have to execute this command. PG base backup, I'm not going to execute it. I'm just going to show how it is going to work when you put it onto the replica side. You just say PG underscore base backup hyphen H. You have to mention the IP address of the source. Then you have to mention the username. This is the username. Then you have to say checkpoint. It is equal to fast. Then you have to mention the data directory. The data directory where the data will be replicated. Then hyphen R and then the slot, and you can give some name. In this case, we have just given the same name only. So what this will do, this PG base backup, this will connect to the primary IP and copy all the data files from the primary, right? And the connection happens through Postgre database user, which is named as wrap user. So initially this directory on the replica was empty. Now it has been filled up. So now if you go over here and just check it out, and if you just check it out, the data has been filled up like this. That means the data using the pg underscore base backup command has been copied from primary to the replica. And how to verify that everything is working fine or not? So initially this was blank, and when you executed this has been filled up. And apart from that, there is one more important file which comes over here, which is called as, I'll show you that. Um, the one which is copied over here, it is called as postgresql.auto.conf. So it has the listen address of equal to star, then primary connection info. It is saying that when it is going connecting to the primary, it is using the wrap user, it is using a password file which is used for this purpose. Then there is a channel binding, and this is the host where it has connected. This is the port number. This is the SSL mode, and these are the basic details. Okay, and finally, we have to start the replica. So there is a extra file which comes, which will not be visible on the source, is this file, standby.signal. So I think it is already lost because I have I believe I restarted it. Standby.signal. Okay, sorry. This is empty by default. So this is created, which signals that it is a standby environment of your primary. And finally, you have to start your replica. So how do you start your replica? Initially, you were not able to start your replica because there was no database on it. It was just binary. Using the PG base backup, you have brought the data from your primary to the replica environment, and you have to just using this command, you just have to uh, start it up the normal way. And if you say sudo systemctl start PostgreSQL, this will be started. So in our case, we are just going to check the status. It's running. So I have just completed it a couple of hours back. And then finally, if you say PSAXF grep postmaster or post, this will, okay, let me switch to su space minus postgre, sudo su space minus postgre, and you say just postmaster. You will be able to see the background processes, and there is important background process which you need to check, that Postgre wall receiver streaming, that should be working, because that is something. So there are two things. One is wall sender, which will be there on the source side, and there is something called as wall receiver on the target side that must be running. That ensures that this is a replica and it is in the standby mode, and it is replicating the data from the primary using the wall receiver process. Now, how to ensure that Postgre application is successful? What you have to do is on the source side, you will just say, so these are the two important commands, so which confirms that it is in the replica mode. Expanded display you must set on, and then you have to simply say select star from pg underscore stat underscore replication. So this view tells that replication is running. This is the process ID, this is the user SysID. Who used this replication? This is rep user. This is replication name is rep receiver. The client address is this one. This is your target side, and status is streaming. It is in the asynchronous mode. And then finally, when you check it on the replica side, you set the extended mode on, and then you simply say select star from pg underscore stat underscore val underscore receivers. And if you see the detail like status is streaming, and slot name we have not given anything, and you can see the details who has caused this replication to initiate. So we used rep user to initiate the replication. And if you, in case you wanted to check whether replication is working fine or not, you can create a table. That's the basic thing on the primary side, and the same will be replicated on the target side. But in our case, we have just seen that the status is working, so everything is fine. So just to recap, like what all has been done so far. Streaming replication is very important in PostgreSQL, because this is going to be the base for wrap MGR, which is going to be used for failover and other stuff. So before that, we should know like how the streaming replication works in Postgre. In our case, we use two EC2 instance. We have launched two EC2 instance which were running on Linux, and then we have carried out few steps. The few steps were just we executed 6 steps in primary, wherein we installed the binary, we initialized the database, we enabled and started the database. On the target side, we just installed the binary, and on the primary side, we checked what is the status of postmaster. We disabled the SC Linux on both source and target, and on the primary side, we have changed the listen address from localhost to star, or the IP address of the source. Then we created a replication user, which is going to cause the replication data to move from source to target. And then we have allowed the remote connection in pg underscore hba.conf in our source, and we have mentioned the IP address of the target. Then we have restarted the Postgres server on source, and then on the target side, we created a PG base backup using this command, -h. This is the primary host IP. Then we have used the replication user, which we created on source side. So using this is connected to primary side, and it is doing the continuous checkpoint, and this is the current location of the data directory wherein it will be dumped, and we have given a slot name for this to happen. So these are the details which are mentioned. -d, it is the for the destination directory. -r is for replica for the replication, and then finally the val comes into the picture. So once it is done, it gets executed within few seconds only, because there was no data at all. And on the replica side, there will be one important file which will be created. That's an empty file, which is standby.signal, which represents that it is a standby environment only, and it is going to receive the data in continuous mode from the master, and that's the way it is going to work. And if you see the postgresql.auto.conf, this will have the commands which are being used. And then we have started the replica. To start the replica, there should have been the data directory, which has been brought by pg underscore base backup, And then when finally we checked using the two commands, one is select star from pg underscore stat underscore replication, and other is pg underscore stat underscore val underscore replication. So using this command on source and the replica side, we verified everything is fine and working. So this is on our source side, and this is on our target side, our replica side. So I hope this is going to help. Hello and welcome. In this session, we will see how to optimize the backup and restore speed of PostgreSQL. So as usual, everything is mentioned in a notepad, and we will follow through this, and we will see how we can improve the speed of PostgreSQL when we are going to take the backup and we are going to restore using pg underscore dump and pg underscore restore. So we have a scenario. We have 500 gigs of PostgreSQL database, and there will be two sub scenarios wherein there will be very small size tables, and there will be few large size tables. For this particular scenario, just say if I have a database which is of 100 GB, or let's say it is of several hundred GB, and we need to take the backup using pg underscore dump because we need to migrate it to the cloud. Maybe it any sort of cloud. It may be your Google cloud, it may be your Azure cloud, or it may be your AWS cloud. And for this particular demo, not this is going to be very specific, but I have just an EC2 instance which is of very small in size in terms of the CPU and memory. This is just the demonstration purpose. For this we have done it, but we'll go through the theoretical part wherein we will try to understand what are the different factors which are going to impact the speed of the backup and restore using pg underscore dump and pg underscore restore. So to speed up the backup of your large database, when I say large database in Postgre, anything above 100 GB, we say it is a large database. That doesn't mean that it is some sort of restriction. It is just that this is common terminology used when you have to take the backup using pg underscore dump. So for the large database, which can be 100 GB and more than that, pg underscore dump, which is a command line utility, or which is a utility which can be used to take the backup in parallel mode. So if you wanted to take the parallel mode backup using pg underscore dump, then you have to use the -j flag of pg underscore dump, and that's only possible when you are using the directory of or archive format. So you can say pg underscore dump -j. This denotes the number of parallelism, and uh, how many parallel threads you can invoke. It entirely depends upon the number of CPUs you have. So if you say ls CPU, that will show you how many CPUs you have on your system and how many can be used for parallel purpose. So let's say if I say ls CPU, it will show you how many CPU and how many cores you have. So you can see the core sockets, and you can see the cores. Let us say, for example, if this is 2 and this is 4, in that case, what is going to happen? This is just for the demo only. We'll say pg underscore dump -j. You have to mention the number of parallelism. If it is 2, mention 2. If it is 4, the number of cores, you can mention 4 over here, whatever suits your requirement, or whatever is the strength of your server, you can mention hyphen that. So then you can mention the format. This is directory format, and this is the name of the this is the location where you are going to put the zipped directory structure. And I have mentioned the database name as DVD rental. So if I simply I need to first remove, I think it is already existing. There's a very small size database, so probably you will not see any sort of impact also, but when it is a large sized database, you will be able to see the impact. So if I say rm -rf, I have just removed it, and what you can do is you can simply fire this command. So what this will do is this is going to parallel put your backup in parallel mode. So pg dump will be parallelized in hyphen j, which is equal to 4. So there will be 4 parallel threads which will execute, and this will execute your backup in parallel mode. So this is going to be highly effective, and this is going to speed up the way of your pg underscore dump. And this largely helps when you have to restore, or when you have to back up your large size database. You have enough CPU on your system, and it is not going to impact the number of cores which you are going to utilize for the backup purpose. In a similar way, you can use it for the restoration. You simply say pg underscore restore hyphen hyphen no owner. You mention where is the location of your backup, which is in the zipped, or which is in the in particular format. Then you mention the number of restore operation, I mean the number of threads. If I say 4 cores are there, I'll just mention 4. I this The important part of this is you should have enough CPU on your system so that it is not overburdened, and it should not impact your normal database operation. And hyphen d, I have mentioned the database where it is going to restore. So using pg underscore restore with the hyphen j flag, you can restore a dump in parallel. So it works with the archive or the custom or the directory format. So one of the other important thing is, so I'll just mention in note. So whatever it is, if you have not taken the backup, which is already there in the archive or the custom format, so that's the important. If you have not taken in parallel mode also, you can restore it using this. I'll just save it. And the deciding factor when you start your migration to the cloud, whether it is online or offline. In offline, when you take the backup, you have to ensure your application is down. And when you put pg underscore dump command, which you have executed in the parallel mode, it is assumed that it is a downtime has started. So anything after that is not going to be captured. So what we will do is, we need to check the number of free CPUs on your system and the number of cores. Based on that, you can perform the parallel backup and restore using pg underscore dump and pg underscore restore. You have to make sure that it is in the proper directory format, and when you use the zip format, it is going to reduce the size, so that when you are restoring, the size will be very small in size. So it always matters. So the number of free CPUs or the number of available CPUs on your server, the storage, because when you are going to compress it, it is going to take the CPUs, so for the compression purpose. So this is a generic scenario. Now, if the migration has to be done for small size tables, but some of them are large size table, then what is that we have to do? So it is just few large size tables. Let's say it is 50 GB, and remaining tables are just of 1 GB, 2 GB, or 5 GB in size, and we have to perform the migration. So you can adopt the mix of backup and restore activity. That means when you say pg underscore dump, you can put in parallel mode, and you can use another utility, which is pg underscore loader. If these database size or table size are very small in size, so instead of dumping it on the operating system then shipping it to the target, or what you can do is, you can perform this way: pg dump hyphen d. Let's say this is my database name, and this is custom format, and this is the restore. So this is, you take the backup, and the output is simultaneously redirected for the restoration purpose. In that case, you are not supposed to store in the on the host at particular file system. In this case, you have a restriction. You cannot use the parallel mode because that's the only restriction. If you have large size database with very small tables, you don't want to take the backup on the operating system. You want to take a backup and restore simultaneously. You can use the redirect option. So pg underscore dump hyphen d DVD rental. This is the database name, and this is the format. So and you can redirect the output so that PG restore will pick up the backup from here. If you use hyphen J option also, it is not going to helpful. So you can ignore that. Not you can ignore that. It will be ignored during the restoration. There is another good utility which is available, which is PG Loader. So PG Loader, a combination of PG Loader, PG Dump, and PG Restore can be used for varying table size in Postgre. So if you have to compare the performance and the speed of PG underscore dump with PG underscore restore and the uh, PG loader, then you can do that. So there are some of the test scenarios wherein some 500 gigs of Postgre database, when it was used with the PG underscore dump and PG underscore restore, and when it was used with PG loader, it has been entirely different. If it is a single large sized table, you can use PG loader. It is going to increase the speed of migration to a large extent, and in some of the lab scenarios it has been observed with PG loader, the speed of backup and restore is almost 3 times as compared to PG underscore dump and PG underscore restore. And this is largely applicable or only applicable to the tables where the single table size is large. So you have to ensure that. So a database with multiple tables, uh, some of them are large, some of them are very small. So you can use the PG dump and PG restore for the small tables, and for the large table, you can use your PG loader, which is going to speed up the migration speed. So it is up to you how you wanted to use, but in some of the scenarios, mix of both PG underscore dump, restore, and the PG loader, it really helps. And the most important part is the CPU. If you do not have the enough CPU on your system based on the number of cores, so you have to check this particular parameter, which we just saw. It was the number of cores, and where is that? Okay, let me execute it once again. ls CPU, and you have to check this. So ensure and make sure you have enough of the CPU capacity free on your system, because it is going to entirely bring your system at the knee, because it is going to consume all of your CPUs, because you are going to use the pg underscore dump in the parallel mode. And if you are executing the same command from here also, you are going to use the pg underscore restore utility as well. And if you are using pg loader also, you can do it from here. So we just saw like a combination of pg underscore dump with the parallel mode, pg underscore restore with parallel mode, and pg loader for the last size table. It helps in migration from on-premises to cloud, or maybe from one system to another if you have enough CPUs which are. This session we will see if the Postgre releases the space when a user related database is dropped. So in short, when you drop a database, is Postgre going to release the storage at the operating system or not? So as usual, we will go through the steps which are mentioned in the document. So the question for today is, does PostgreSQL release a space when the database is dropped? So to destroy or drop a database, you should have the drop database privilege. Either the owner of the database can do it, or the super user who is having such super privileges, he should be able to do it. So to drop the database, it is very, very simple. You just log into PSQL. I'll quickly log in. PSQL, just list down the databases, and whatever database you wanted to drop, let's say I wanted to drop testdb, I can do it. Drop database and the database name. The important part of this is not how do we drop it, how easy it is to drop. Like some of the important things, if the user application is already connected, and if you are connected to the test DB like this one, you would not be able to drop the database. Let's say this is the last database in your PostgreSQL. In that case, better you get connected to some of the template database which is available, and you should drop the last user database. The command will be either you use the drop database name, or you can use the drop db at the operating system which is available. The important fact about this is uh, in some of the cases, it has been seen the database size is has gone beyond our imagination because of the fragmentation and because of the number of tuples which get increased in your table. So basically, the table size goes beyond imagination. The number of rows which is actually is there is and the size, they are not corresponding to each other. That means there are some unused space which cannot be used, but they are actually occupying the space because of the dead tuples. And to best of our auto vacuum services, which is launched on the regular basis, somehow we were not able to reclaim the storage. And the last thing which we thought, like, why don't we drop the entire cluster with the content and rebuild it from beginning? So what we need to do is, I'll basically go through it. We will take a pg underscore back, dump all backup of the PostgreSQL databases, and in case you have since we are doing everything on the same operating system, I'm not going to zip it. In case you wanted to do it on other server, better you go for the zip, compress it so that you can save some storage. But when you zip it with the maximum number, that means it is going to exhaust all the CPU and IO subsystem on your system. So what I'm going to do is, I'll show you what we have at this point of time. I'm running everything on an EC2 instance, and I have Postgre 12 running, and you can see this is my postmaster, and these are the different background processes available over here. And what we are going to do is, we are going to take a backup. This is the location, this is the default location where backup is residing. So let me go here and remove some of this stuff. So I'll say rm minus rf star dot zip. Okay. So what I will do now is, I'll just take a compressed, uncompressed backup using pg dump all, because we are going to remove everything and we are going to rebuild so as to release the storage at the operating system, though it is not being visible over here because the database size which is there in the Postgre as of now, it is DVD rental. So let me show you PSQL/L plus. You will be able to see there are some DVD rental databases which are 15 MB in size. We are going to drop everything and we will see how to rebuild it from the beginning using the backup and restore feature. So the second thing which we are going to do is perform the backup of PostgreSQL configuration file. So we'll just say show config underscore file or show data underscore directory. So what we will do over here is there are n number of configuration files available over here. So if you just say ls-ltr start.conf, you will be able to see at least 5 files should be visible. It is ident hba postgresql.auto.conf and postgresql.conf. So we are going to take a backup. How we are going to take a backup? Using the cp command, we are going to take a backup of all of these in your backup directory where you wanted to create a fresh backup for everything which you are going to destroy. So we have taken a backup of all the configuration file. And the next thing which we'll be doing is there are a lot of information which you can see using these commands. You can see show all or table pg underscore file underscore settings. That will show you all the details in case you wanted to see. You can see the different options in your postgresql.conf in case in case you have to modify some of the parameters since you are going to restore it from the backup which you have just taken. And what we will do now is we are going to stop the cluster. So one of the things which you should be doing is you should create a profile for PostgreSQL so that in case if it is not able to export the binary location, it should automatically do when you export the profile. So I have exported the location of bin location of Postgre where all my installed binaries are available. Now what we will do is we will go ahead and check if the OS processes is running. Yes, it should be running as of now. What we will do is, okay, I'll put couple more commands over here. We'll check the status, then stop, then check the status again to avoid any kind of inconsistency. Let me save this. Now we will go ahead and check the status using pg underscore ctl hyphen d, location of the data directory, and then the status. So status is running. Let us stop it. Then we will check the status again. It is stopped. Now let us check the status again and check because it has stopped, so nothing should be running. And at the operating system also the background processes should go off. The next thing which we will do is we'll go to the data directory location where all my data directory files are available. You can see there are a number of data files, and what we need to do is, since we have already um, stopped the cluster, we are going to remove all the files from here. We removed all the files. Now what we will do, just say ls-ltr just to check if everything is removed or not. Since there is no error, so there should not be any problem. ls-ltr, everything is done. Now what we will do is again check the location of your bin. So bin is here in /usr pg sql-bin. So for 13 it will be something else. For 11 this will be something else. For 10 this will be something else. So what I'm going to do, I'm going to initialize my data directory because I have deleted everything. So all the directories, subdirectories which are required to build your PostgreSQL, they will be initialized over here. Okay, you can see that it has been initialized, and if you go to this location, because we are in the same location, just say ls and you will be able to see all the files are reconstructed or reinstalled. Now what we will do is we will restore all the configuration files that has been picked up prior to the deletion of the cluster, because by default these are the default configuration files, and we might have made a number of changes in your postgresql.conf or in your pg underscore hba.conf. So just go ahead and restore it from the settings or from the backup which you had taken. Okay, this is wrong. Okay, this is restored. You can cross verify every time you do such things, because if they're not properly copied, it might create a problem. Next thing what we will do is, so we will, since the cluster is in the stopped status, we will go ahead and start it. Just say psux. You'll see everything is stopped. Just check the status. It is not running. Start and then check the status. It has been started. Check the status. It is running. You can see the background process is also running successfully. Now, if you have compressed your backup and transferred to some other server, you have to uncompress it so that you can utilize it. Since we have not done it, we are simply going and restoring it using PSQL. So restore the backup of PostgreSQL using, so new pages will be written and there will not be any what do you say, the extra space between the rows in the form of dead tuples which has been removed or deleted. It is restored. All the databases, they have been restored. Now the next thing which we will do is we can check if everything is fine or not. PSQL/L plus. This will show you. So what happens is, in this case, when you have restored it again, it is entirely a new cluster which has been rebuilt, and it surely releases your storage. What you should have done earlier is you could have checked what is the size of the files which are occupying. If you go to this location where my actual files reside for the databases, cd pg data in base location, and if you say lswc-l, this will show you there are 8 folders over here. And if you see over here, 1 2 3 4 5 6 7 8, they are 8 over here. That means, and if you wanted to see the individual file, what do you say, the sizes, you can see it once you have before deletion and after deletion. You should be able to see the difference. Since our database size is very less, which is just 15 MB at the database level, the operating system level, that would be lesser. But when you do such activity, this is going to release the storage. And one of the other thing, if you have fired the delete command, or if you have removed and still it is not, if you have fired the drop command and still if it has not released any storage, what you need to do is you can, there might be a possibility like archiving has been enabled on your database. This is just some of the thing which may be possible. If your archive mode is enabled, and if you have mentioned some other location, non-default location, or what I will say, the archiving location, and if you have not removed the archive from there, it may be possible like those it is getting stored over there, and you have to manually delete if it is not already deleted. So this may be one of the case. After deletion of the database also, this might not have been removed from non-default location if it is. So you have to verify, or before deletion also you can check what are the different locations where it is keeping the archives if you have enabled the archiving. And when you rebuild it using the pg dump all backup and restore, it is going to release the storage. And sometimes it also happens like when you have executed such a script for the deletion at the operating system, it might be deleting slowly depending upon the size of the database, and you have to check what are the different activities which are happening inside the database. If you say simply select star from pg underscore stat underscore activity, this is going to show you the query, and if the database which you have deleted or going to delete, if there you are facing any problem, you will be able to see the details from here. Select star from pg underscore stat underscore activity. This gives you good information, and if the deletion is already in progress, you should be able to see it using lsof grep deleted. So this will show if there are any open file descriptors which are still in progress. In some of the cases, you might have to reboot your operating system in the worst case scenario. Not very usual, but sometimes this has been seen to release the storage because the file descriptor might have been in used space, in used state. I hope this is going to help, and mostly it's a very simple and straightforward stuff. Drop the database, it is going to release the storage. If it is not, that means you have to make sure your auto vacuum process, whether it is releasing the storage back to the table or as applicable in vacuum full, it is giving the storage back to the operating system. And this one, this has been done in the lab environment. You can check it out, and this is going to help you. I hope this is going to help, and thank you. Hello and welcome. In this session, we are going to see how to backup and restore using the PG-based backup on the same host. So as usual, everything is there on the notepad. So we are going to discuss about the backup and restore using the PG-based backup on the same host. And what we are going to do is we are going to restore by taking a backup using PG-based backup. So as a prerequisite, we have an EC2 instance having RHEL 8 installed on it. We have a sample database which is called as DVD rental, which is already loaded on that. So let me log in. So I'm in PSQL, and if you simply say, I'll just copy and paste for quick reference. Show data underscore directory. This is my data directory, and if you say /l, this will list down all the sorry, I have two /l. It will show you there are 100 DVD rental databases that we are going to backup using pg underscore base backup. And if you see more details, you will be able to see like this. This is the detail of the table spaces which we have. We have only default table space. We do not have any non-default table space in this environment. And what we are going to do is, if you see L plus, that is the detailed view of the databases, this is what it is. So everything is there in the default table space. We do not have any non-default table space. So if it is non-default table space, you have a couple of extra steps involved, but since we do not have it, we are going to skip that. And before doing anything, what you need to do is you need to make sure that the details related to the archive. So if you say select name, comma settings, comma unit from pg underscore settings, where name like archive percentage, it will show you all the settings related to the archive. So if you see, if you say archive underscore mode, it should be on. Archive timeout, it should be 5 minute. If you say archive command, uh, this should be enabled so that the archives go to a particular location. And archive cleanup, we are not going to do it. It's not required for this one. And we already changed it from a default to the non-default value. So earlier it was disabled. We made it to 305 minutes. Archive mode, earlier it was off. We made it on. And let's go to the next step. The first step which we need to do is just go to show config underscore file. That will show you the location of postgresql.conf. And what you need to do is you need to change 4 parameters. One is archive mode, which we have turned on from off. Archive timeout, we have made it from disabled to 300 seconds, which is 5 minutes. And archive command, we have made it to the particular location. Then once these changes are made, because I'm not going to do it again because it's already done. So you simply say sudo systemctl restart PostgreSQL 13 so that these changes are in place. So the next thing which we will do is, since we have 100 approx 100 databases and we have already checked like archive mode is on, archive default timeout is 5 minutes, archive command is we have given something, and then we are going to forcefully switch the pg underscore the wall files. So let's quickly do it a few times. Let me log into PSQL, and we have done it. Let's change the password of Postgre database user. We have made it to password. And then what you do is let's create a directory wherein we are going to initiate a compressed PG based backup to a particular destination. Let's quit from here and just say mkdir-p. So there should be something already over there. We are going to remove it, rm-rf star. So there is nothing inside that. So we created a destination where we are going to take the backup. And now what we are going to do is we are going to execute the pg underscore base backup. The prerequisite is the archive mode should be on, and there should be an archive command. So these two are the minimum values which are required. So now we are going to execute pg underscore base backup. It is being done from the local host. If it is from a remote host, you have to mention the IP address or the host name. Then the port is 5432. We need a super user, either the replication user who can have that privilege, or the super user. In our case, we are doing it from the Postgre super user. -d is the destination where we are going to do the base backup. And there are few options which we are doing. -f, which is the format, we are doing it in the text format. -z is the zip we are doing. -access is for the wall method, and we are doing it for streaming. And that's it about it. So let's execute it from here. Feed in the password. So once this is done, what we will do is we can initiate an uncompressed backup as well if you want. But in our case, since we have to save some storage, we are doing this. If you wanted to do without the compression, you just have to remove -z. Okay. You can see that backup is already done. So we have a base backup, we have a backup of wall, and we have the manifest. So during the restoration, we need just these two files. And if you wanted to have an uncompressed backup, you can do that. Now we are going to perform the disaster recovery by cleaning all the data files. So before doing that, let's do something. So we just wanted to verify what is our data directory location. And then what you are going to do is just go to this location and see the contents. The contents are here. And the next thing which you have to do is you stop the PostgreSQL services. Let's stop the PostgreSQL services. Stop. And then we will check the status. And then we are going to delete the data directory where all the files are there. So just delete everything which is there in the data directory. Okay, so if you just say ls-ld and this particular data directory location, you won't be able to see that because it has been deleted. And the next step, since we do not have any table space other than the default one which we have already seen, we are going to continue with the below untar command. So let's go to this location. If you say ls-ltr, you will be able to see there are the zipped file, zipped tar file for base and wall backup. What you need to do is, let's create the data directory where we are going to restore all this. So it is just we removed it here and then we are going to create it again. The next thing which we will do is we are going to unzip the base backup and the wall backup, pg underscore wall, from zipped to unzipped. And the second thing which we will do is we will unzip the wall file as well. That will be required. This is done. And the next thing which we are going to do is we have to untar the base backup to the location where it is required. So there is no special command for the restoration. It is just OS level, what do you say, the untar command which we are using. So it is going to untar. Ensure that you have the data directory created and we are going to restore it over there. It is done. If you see pwd, and if you go to this location, you should be able to see that. Okay, one more thing we are going to do is we need to restore the wall backup as well. So we have already unzipped it, and whatever wall we have which is restored from the backup, let's remove that as well. And what we are going to do is we are going to create that directory and we are going to restore it from the backup which we had taken. And finally, what we are going to do is we are going to untar the wall backup which we have taken during the backup into the location, wall backup location. Okay, this is done. If you do cd over here, you will be able to see it. Okay. The next thing which we will do is we do not have any default table, non-default table spaces, so we have to move to the next step. And one more thing we have to do is we have to inform postgresql.conf about the restore command. So in the restore command, you will have to mention the location where your wall files are there. So you just search for restore and restore, you have to mention it's already mentioned over here. Since I'm doing it again, so it has retained the previous value. Now once we have restored the base backup, wall backup, we need to try starting the Postgre, and we need to verify what's happening in the environment. So what we will do is we will check the status and try starting it. So any issue which is related to the PostgreSQL startup will be recorded in var log messages, which is at the system level. Since PostgreSQL might not come up, and any problem writing into the PostgreSQL log will not be written over here, that will be written into your var log messages. So if you simply say sudo systemctl start PostgreSQL, it is showing us there is some problem and it might have returned some information. So this is the latest. So I have just done tail 100f and it will show you data directory has invalid permission. So it is saying permission should be this one 0750, but let's give it to 700. So we will pick up the information from here itself and we will give it to chmod 700 and this one. If we try restarting now, it should work. It is working, and if you see here, it started PostgreSQL 13 server, and if you check the status, it's up and running. So just a recap, what all we okay. Let us cross verify. Uh, let's log into PSQL and just say /l. You will be able to see there are 100 PostgreSQL databases. Sorry, the dividend databases, and they are available. And that's all about how do we restore PostgreSQL using the PG underscore base underscore backup. So this comes by default, and if you know how to use it, is sometimes going to be really, really helpful. I hope this is going to help. Hello and welcome. In this session, we are going to learn how to obtain the continuous archiving and how to perform a point-in-time recovery using PostgreSQL 13. So we are directly going to start with the demo, and as usual, everything is going to be placed on a notepad. And before we start, what is continuous archiving and how to perform point-in-time recovery with PostgreSQL, we need to understand one of the thing. Like before we discuss about this, we need to understand what is WAL, which is known as write-ahead logging. So what is WAL in Postgre? So WAL is a standard method of ensuring data integrity. So before the changes which are committed in the Postgre database, before they are returned to the data files, they are returned onto the WAL logs as well. So these are some of the questions which comes up very frequently, like does Postgre have a transaction log? Yes, Postgre has a transaction log which is known as WAL, and WAL has a record of all the events or changes that has changed the WAL data, and it is just a description of the changes which is made to the actual data. Using the Postgre WAL entries, you can restore the database back to the state at its previous state. And where are the Postgre WAL files located? So WAL files are located in their default location under your data directory in pg underscore WAL. And the size of each WAL segment is 16 MB in size. You can modify it according to your requirement. So another popular question for this is what are the WAL files used for? The WAL files, they are used for roll forward journal, and they record the transaction that has been committed against your database. And that's all the basics about your WAL and why we are discussing about it. So we are going to set up our environment in such a way that we will take a backup and we can restore it using those transaction logs to a point in time to a consistent state. We already know that there is a pg underscore dump and pg underscore dump all utility which can take a backup of or the snapshot or the database at a particular point of time, but anything which has happened after that, that will not be recorded. So to perform all this continuous replication, a continuous archiving and point in recovery in PostgreSQL, we are going to set an EC2 instance. So I'll directly go to the console and launch an EC2 instance, and then we will discuss about it. So I'm going to use RHEL 8, the free tier, add storage, So all defaults only, nothing special. So we just wanted to make sure that only I should be able to and PostgreSQL port I'm enabling so that I can access it from my system in case it is required. Though this is just for this demo purpose, and then we will say review and launch. I have the private keys already created and located on my system. So once it is available, we are going to work on this. So this is going to take at least a minute or so. In that time, we will try to navigate through the steps. So we are going to launch an EC2 instance. It's just one instance, it is not two. Then we are going to connect with the putty session, and then we will disable the Linux, SC Linux, and we will start from there. Though these steps are not important because we have seen it earlier as well, but I wanted to show it from the beginning. So let me see if the instance, I'll copy the public host name, and I will locate where my uh, keys are, so that once the system is up and ready, we'll directly go over there and start from there. Okay, so I'm waiting for this to get in 2 by 2 checks available. So what we are going to do it, let's navigate through the step. In the first step, we are going to download and configure the PostgreSQL 13 on the Linux EC2 instance. Once the installation is done, now we will set the listen address equal to star or the IP address of the system so that we can connect remotely. We will change the Postgre database user password as well, and then we will enable sudo access to Postgre so that whenever we restart our Postgre instance, it should not ask for us as the root user or the sudo user. So we'll give the sudo access to Postgre. Let us see the status so that we can directly start the steps, because it is going to take at least 25 to 30 minutes. Still it is an initialization phase. Still going over there. So let me, sometimes it is very irritating. Okay, so, and then we are going to add our Postgre user to the sudoers, and then we will reboot it, because initially we disabled the fire SE Linux. So to just make it effective, we have to do that. Then in our pg_hba.conf, we are going to add the IP addresses, which I am going to access it, and then we are going to restart the Postgre. Then the second step onwards is the step which is required for this demo. So it is already configured, the system is up and running. Let's connect, accept, and we'll go to EC2 hyphen user. Okay, I'm connected. Now let's follow the steps. So we are going to execute the first step. Let's do the SC status. We are going to uh, disable the SC Linux. So what I'm going to do is I'll say vi. It creates a problem. So instead of enforcing, let's and make it disabled. Save it, and then move on to the next step. Let's see the um, let's start downloading and configuring the PostgreSQL 13 on EC2 instance. So I'm just going to copy and paste all the 6 commands. I'm not going to discuss because we have already seen these commands earlier as well. This is going to take a minute or so, and after that we are going to configure the remote access. In remote access, we will just say alter system set listen address equal to the IP address of the system. This shouldn't take less than 30 seconds, I believe so. And back behind the scene, when this continuous archiving and this thing is configured, back behind the scene, it is going to use your PG underscore base backup. So we'll see some more details about PG underscore base backup, which somebody has asked me earlier how to restore it. So the restoration step will be over here. So we will be using the restore command, how to use the restore. So we have seen in one of the session how to take the backup, but we will see how to restore using the backup which has been taken from PG underscore base backup. This is almost done. Just yes, 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 yes. Come out. Yes, this is done. And now what we are going to do is let's switch to the Postgre user. This is done. Now let's say PSQL. We say PSQL, and then we will execute two commands. One is alter system set local listen underscore address equal to star or the IP address. We'll cross check it once it is rebooted, and we are going to change the password of Postgre uh, database user. This is also done. Just quit out of this. And one of the things which we should do is we will add the Postgre OS user to the sudoers. If you do it, the advantage which happens is um, every time you use Postgre OS user for rebooting the starting the Postgre service, it is not going to ask for the password. So we are enable. It's a good practice to have it to the restricted mode. So put the details over here. Postgre all and yes, save it, and then we will say reboot. Let's reboot the instance. It will take at least 30 seconds or so because we have changed some of the settings which require the reboot. So once it is done, we are going to change the hba underscore pg underscore hba dot conf file. We are going to add our IP address so that we those IP address will connect to this. It's just a demo, but this is something which you need to make sure that in your organization, if you have to ensure connectivity, you mention this thing in pg underscore hba dot conf file. So we'll say restart session. If it is up, it will allow me to connect. If not, we will wait for another few more seconds. Okay, it is allowing me. So it hardly takes 30 seconds. Now what we are going to do is we will switch to the Postgre user. Sudo su space. We are logged in. Now just update your hba.conf file and add the IP addresses which requires the access to your system with proper the authentication way. So I've just added. So what next we are going to do is let's go to PSQL and just to verify show listen underscore addresses. So we wanted to see this. We will say show listen underscore addresses. Yes, this is fine. Now what we are going to do is we are going to restart our instance and we are going to restart and check the status. It is restarted. Check the status. This is up and running. And then what we are doing is now from here, this is the important step, configuring the continuous archiving on Postgre cluster. So what we are going to do is we are going to configure PostgreSQL cluster to archive the files in a directory which is different from the default data directory. So this is my default data directory, and I'll show you where is the wall going as of now. So there is something called as pg underscore wall. If you see over here, the the walls are here. So you can see this is just created. What we have to do is we have to make a mechanism, and we will have to move these walls from this particular location to somewhere else. This is not the correct way to put it over there, but since I don't have any other file system, so what I will do is I'll create a directory under the data directory, which is pg13 underscore archive. So I have created it. So everything will be done through the service user, which is Postgre. This is the first step. Then what we will do is we will add our postgresql.conf file. So the first thing which we will do is you just have to make sure the location of your configuration file. So if you say show config underscore file, you will be able to see the location of postgresql.conf. The next thing which you will do is you will add it, and you will add three important parameters which is mandatory for your this demo. So first thing is archive mode on. You have to make sure that archive mode is on. So in postgresql.conf, search for this. By default, this will be off. You need to make it on. So this is on. This is first parameter. The second parameter is the archive command, where you wanted to move your archive. So by default, these will be in the default mode, and they will be appearing as commented. So uncomment, and you need to make the changes over there. In our case, we wanted to move the archive to this location, so you have to put this command over here. This is just a location which I have mentioned, and ensure that it is put in the same format. And an example is already mentioned over here. So we are just following it. There's nothing great about it. It is just like you maintain the proper what do you say, spacing between them. Okay, this is the second part, and the third part is wall level. By default, wall level will be in replica mode. This is the minimum which is required. Ensure that you have the information captured uh, to your so these are the three parameters which you need to put it, and then we will restart the. Now what we are going to do is three parameters which are there, and they need the recycle of your system. So we will say sudo, and we will recycle the sudo systemctl restart PostgreSQL 13. It is done. Just check the status. This is done. Go to psql command prompt and verify all the three uh, status of all the three. One is the archive mode, which is on. Another is archive underscore command, which we have just created. A third is the wall level. And then what we are going to do is just see some information. By default, wall level is 16 MB, and Postgre will archive wall file once it is full. In case you wanted to forcefully switch it, you need to use this command. So let's say if I wanted to switch it forcefully, I should do this. So this is going to forcefully switch it. And then third step, which we are going to do is we are going to initiate a physical backup of the PostgreSQL 13. So what we are going to do is for PostgreSQL point in time recovery, we need to take a physical backup of Postgre cluster. And what we will do is we have to take a copy of all the data files in Postgre 13 data directory, assuming everything is in the default location. So what we will do is we will execute PSQL and we will just check what is our data directory. The data directory is that current one. In your case, it may be something else. So what we will do is we wanted to take a backup of our cluster using the PG base backup. So we will create a directory. For my case, it is just one file system I have. This is not the best way, but you need to have it somewhere separately. I just created a PG underscore PG13 underscore backup. And what I'm going to do is I'm going to take a backup. It's very, very straightforward. PG backup hyphen capital D, and I just mentioned the complete location of the backup. So this is going to copy and paste the entire content of data directory to this location. And now we are going to test the PostgreSQL point in time recovery. What is the prerequisite? The prerequisite is latest physical backup of the Postgres cluster should be have been taken using PG base backup. We have done that. We should have enabled archiving and wall files to some non-default location. We have done that. And now we will try to perform the point in time recovery. So what we will do is let's stop the cluster because we wanted to do everything on this cluster itself. What I'm going to do is just clear the screen and stop the cluster. Just check the status, everything is down. Now what we will do is we are going to rename the data directory of Postgre cluster. We are just simulating like we have lost the data. So what we will do is I'm going to rename the data directory so that we cannot start our system. So instead of deleting all the contents of the data directory, I'm just going to remove it. So if you go to this particular location and try to find data, you will not be able to see it. And what you need to do is you need to create it. Let's create the data directory again, and you will be able to see that there is no content inside that. And if you see this, there it is empty. Now what you have to do is we are going to restore using the cp command. So what has been done so far? We have lost the environment. There is nothing inside that. You cannot restart your system. And what we are going to do is we are going to restore the database or the entire cluster, which we have taken the backup using PG underscore base backup. Now what we are going to do is all the contents, it is available over here because we have put the backup in this location. If you see ls, you will be able to see everything is it is same the way it was there in data directory. This is just a kind of cp which has been done by pg underscore base backup. Now what we are doing is using cp-a command, we are trying to copy everything to the data directory which you had earlier. So just copy and paste using this cp command. If you go to your new the data directory location, now you will be able to see everything has been copied using cp command. What next we are going to do is this is going to be very, very important, otherwise your cluster will never come up. Ensure honor is postgre slash postgre for this particular data directory, and the permission is 700. So what we will do is uh, you need to make sure the permission is 700. Otherwise, during the startup of the cluster, it will not come up. So you can verify you have made the changes. Now what next we are going to do is the wall files in the pg underscore wall directory are restored from pg base backup. They are old. Let's say I have restored it from the older environment. Then if you see this, let's say I have restored it from a backup which I had taken yesterday. So pg underscore wall will have the older wall files, but I wanted the latest one. So what I will do is remove everything from here just to simulate it. Rm minus rf star. And then what we will do is now we are going to restore the wall files which were available to this particular location. So just control C to the location, because you remember we renamed our data directory to data underscore old, and this pg underscore val will have that data. So if you say ls, you can see the data over there. So what I will do is I just wanted to copy this from all from here to the to the wall directory. Is it copied? Cp hyphen a star to this. So if I go to pg val location, I should be able to see everything. And one more thing we have to do is, since we have started the archiving, whatever is there in the archive location, in the backup archive location, we have to restore it from there. You can see there are some files available over here. So you have to copy it from there as well. Copy everything from here as well to the pg wall location, because these will be required when it is being restored. There's also, so if you go to pg underscore val, you will be able to see there are a lot of val files. So the only thing is we restored the data files into data underscore directory, which is this particular location where lib psql 13 data, and we have restored back the the wall files to pg underscore val. And one more thing which we have to do is, since we have restored it from the backup, we need to there is something called as okay, let me do this. Just go to pg postgresql.conf file and for restore command. You wanted to restore back the files. Just mention the location your where you archived your works. Once this is done, what you have to do is you have a number of options for the recovery. You can recover the target to a particular timestamp, to a particular transaction ID, to a particular log sequence number, or the name of the restore point if you have created something before doing some activity, and if you wanted to restore that, you can do it. And there are some of the things which are available. There is something called as recovery underscore target. If you do not mention it, so it will try to apply all the available wall files and try to bring it up to a consistent state. This is the default one. So before starting the Postgre, you make sure that you start the PostgreSQL in recovery mode. How can you do that? You create an empty file in PostgreSQL data directory, which is called as recovery.signal. So it is going to look for that. So what you have to do is you have to ensure that you mention this. So this should be available, recovery dot, yes. And now try to restart it. Just check the status. It is down. It is expected to be down because we have removed everything, and this is the first time we are trying to start. Oh, wow, this is started. Normally there will be the issues with the um, status. You can see it is up and running. So what you need to do is you can check the log files to make sure what it has done. Just say ls-ltr and do a view what it has done. So, okay, it is trying to find out some of the history files which we have already restored to the actual location. You have already copied it in the wall location, and where from where it is starting the disk system. Okay, consistent recovery state reached at this particular point. So during the restoration, it has applied whatever wall files it was available for it to start the database. These are not available because we have moved it to the pg underscore wall location. Otherwise, you have the option to put it at a particular point in time, and you can, and this is a great thing, and all the environment should have this kind of this thing, setting, so that you can restore and recover your wall according to your requirement. So just a recap of what we have done is we have set up the continuous archiving and perform the point in time recovery. What we everything behind this is wall. You need to ensure your wall is properly configured. The first thing, we initiated a Postgre 13 instance on EC2, and then what we have done in the second stage, which is the most important stage, is we have configured continuous archiving. To configure the continuous archiving, there are three parameters which are enabled: archive mode on, archive command, where do you want to keep the archive. So we have created a directory outside the data directory, it should have been, but in my case it is, I have made it over there. Then we have enabled the wall level, like what kind of information, the changes you wanted to capture. This is the minimum requirement, this is what we want for our environment. Then we restarted, so we made the changes in the postgresql.conf file. Then we restarted and we cross-checked if everything is as per our requirement. And then we tried switching some of the wall files just to make sure they are archived and they are not in the default location. Then we initiated a physical backup of the PostgreSQL 13 using pg underscore base backup. What we created it, we created just a backup location, and using pg underscore base backup, we mentioned the location, and all the data files are copied over there. And during the just to test the point in time recovery, we stopped the cluster. We excuse me, we renamed the data directory to data underscore old, and then we created the data directory again so that it is empty. We cross-checked it. Then using the cp command, using operating system cp command, everything which was available in pg base backup excuse me, they have been restored back to data directory. And the important part is you need to make sure the permission is 700 for the data directory. Once it is done, you make sure the walls are restored. Else you mention the information in your postgresql.conf file for the restore command, like they are available at this particular location. And you have to create a and what you have to do is, there is an important parameter recovery underscore target. It it has a lot of options available according to your requirement, but in our case we wanted to take consistent state. Whatever archives are available, we wanted to apply all of them. And there is important parameter which we need to create in our data directory, which is recovery dot signal. We need to create a blank file. And then finally we started the PostgreSQL 13, and it started uh, uh, actually. I hope this is going to help, and try to test it out a couple of times, and probably in some other session we will see how to use different options. Maybe restore point is a good idea to test it out. We will test it out and we will see how it is going to behave. I hope this is going to help, and thank you. Welcome. In this session, we are going to learn about what is PostgreSQL log underscore statement. So we are going to start with the introduction to PostgreSQL underscore PostgreLog underscore statement. So log underscore statement is a parameter in Postgre which will allow you to log the SQL statement which you run in PostgreSQL database. So um, log underscore statement it is available in the postgresql.conf file, and the way you wanted to log your SQL queries in that, it can be controlled from here. So this particular parameter log underscore statement has four parameters which are allowed. The options are none, DDL, mode, and all. So by default, log underscore uh, a statement parameter, it will be turned off. So it is set to none in your postgresql.conf file, right? So when you say none, this option of log underscore statement is defined, and it doesn't log any query in error log file. So when we say any SQL statement which you fire is not going to log that. DDL, so any DDL statement, create, alter, and drop, they will be logged. All, any statement which you fire, it will be logged. Mod, mod is for all the DDLs along with the DMLs and some more parameters they will be allowed in mod. Sorry, in mod kind of this thing. So we are going to log into this. The first thing which we are going to do is, okay, let me go to PSQL. So I'm logged in as Postgre. Just go to PSQL and just say show config underscore file. Sorry, it's we have already fired it. So this is our postgresql.conf, and if you wanted to see this parameter using this, you can just vi this and just say log underscore statement, statement, log underscore statement, and this will take you to log underscore statement parameter. So let us see where it is. uh, Log underscore statement, yeah. So log underscore statement by default it is none, and you have other parameters DDL, mod, and all which are allowed. So what we are going to do is we'll go to the command prompt. Let us come out of this and just cd to the data directory, and then you have log. Then you will see some file with the PostgreSQL hyphen date hyphen um, today's today is Saturday, so it is going to show you that. So what we are going to do is now we will start with the first option. What we are going to do is we are going to change our log underscore statement. So first of all, let's check what is the log underscore statement, because I have already tried earlier, so our default configuration may not be available over there. Okay, none parameter is already set. So what we are going to do is we are going to change it to let's change it to DDL. So we'll say alter system set log underscore statement equal to DDL. We wanted to capture the DDL statement which we are going to log. The system is altered. Just show. Okay, let's restart it. Sudo systemctl restart PostgreSQL hyphen 13. There is some spelling mistake. POSTGRE SQL-13. So it has restarted it. Just check the status. This should be running. So you can see it is running. So now we will fire PSQL statement again just to check what is our current logging status. All right, you can see it as DDL. So any DDL statement should be logged over here now. So we will say trail minus 1F and the log file. Database system is ready to accept connections. Now let us fire the first statement. Okay, let's create the table. Table is created. You can see the table is, this statement is logged. And let's fire the select star. There is nothing inside this table, but if you check out here, this statement is not logged. Let's insert some data in this. We are going to insert 3 rows inside this table. Okay, 3 rows inserted. If you say select star from course, it will show you 3 row, but these 3 statements are also not captured in PostgreSQL .log file, which is log underscore statement, which we have set to we set it to DDL. So it is going to capture all the DDL statement. Now let's do some DML. So DML will be captured in your all option. So anything which you fire it is going to be captured in all. So let's check the status of log underscore statement. It is set to DDL. Let's change it to all. Then any statement which we fire, it should be logged over here. So we have already done it. Just say show log underscore statement. Okay. Just to let's restart it. We are going to restart the now PSQL, and this should show you what is your current status of log underscore statement. It is also any command which we fire, it will be logged from hereafter. So just say select star from courses. So your select star from courses is logged. Now just do one thing, just drop and create the table. Drop table course. So this should be also captured. This is captured. So just say again select star from course. Course doesn't exist. Course doesn't exist. So it is capturing everything. So it is very disastrous to have all statement logged in your Postgre database in log file. So the next one is mod. So what it is going to include, it is going to include your DDL and DML statement. So let's change it to mod and restart Postgre, and then you just say select star from course. Check out what is the log statement which is set. It is set to mod. So let's say select star from courses. It is logged over here. Sorry, this is okay. We haven't fired any DDL and DML statement. Let's first create the table. So we are going to create the table first. So let's create table. So it should be logged over here. This is logged in the log file. Then again, you insert few rows. This should also be logged because this is DML. This is logged, right? So just a recap. And when we say none, it is not going to log any of these things, which is default one. So what is log underscore statement? It is a way to log your DDL, DML statement and any other statement in PostgreSQL database in terms of the file. And where this file will be stored, this file will be stored under your log directory. This is my data directory, and inside the log you will see this file generated. So you can view, and if you wanted to capture some of these things which is happening, so you will have to turn on the log underscore statement parameter in postgresql.conf, and using the alter system set command you can do it, and it will be very useful if you are doing it for a short period of time, and then make it turn back to parameter none, which is default, which is not going to log anything. I hope this parameter is going to help you, and thanks for watching. How to monitor the PostgreSQL streaming replication on a setup which has one primary and one slave. So that's one master and one slave. So I have already the setup done, which is there on EC2 instance, and it's Postgre 13, which is running on the primary and the slave. So all the details are over here. So one of the thing is whenever we have the PostgreSQL replication and we are involved in the monitoring, there are few commonly known issues which makes your streaming replication go out of sync. Everything is recorded there in the WAL files, and if there is a problem in sending the WAL files from your master to slave or from your primary to the replica, then there is a problem. And the problem exists in the form of a replica which is going out of sync. If there is a problem in accepting the write ahead log files on the standby side or the replica side, it might go out of sync. If there is a high load on the primary, it may lead the replica to go out of sync. If there is a high load on the replica, it may also cause the replica to go out of sync. And one of the major contributing issue for the replica to go out of sync is if the network outage is there between the primary and the replica, then it also results. Or there may be a scenario wherein your replica has been down for several hours and the WAL files which has been generated on the primary, they are not available. And there are some commonly known things about the replica which is going out of the sync is if my primary, which is accepting the transaction from the application, it is highly active. In that case, also, it may be possible that those changes they are not replicated or propagated to the replica. It may also cause the standby to or your replica to go out of sync. There may be a network outage between your primary and the replica. It also may cause the replica to go out of sync. Or there may be some unknown issues apart from these known issues, which may also cause the replica to go out of sync. So what are the different important parameters which contributes to the valid state of the replication? So you need to have a quick watch on those. One of the parameter on the primary is your WAL keep segment. So this is the minimum number of WAL files that you keep on the primary. If it is a higher value, then the replica going out of sync is minimized. But if you keep the higher value, that means you have the high requirement for the storage on the primary. The second parameter is max wall size. So this is the maximum size of all the log files which is available on your disk. And then we use the term replication lag. So it is how do we find it? So let's say if I execute a query on the master and it returns 10 rows, and if I execute the same query on my replica, which is in the read mode, and if it doesn't produces the same result as it was on the primary, then there may be two things. One is replica is already in the recovery mode, or it may be it is lacking so much behind in terms of the wall files that those changes are not replicated on the replica side. So we'll see what are the different basic queries which can be used on the primary and the replica side. So I have a Postgres 13 streaming replication already set up. This is my primary, this is my replica. So I'll go to the primary and I'll just say PSQL. And if I say select star from pg underscore stat underscore replication, okay, let me put it in the extended view. And if I say select star from pg underscore stat underscore replication, it will show the status of the application. This is the PID, and this is the username. Then this is the IP address of the receiver where my streaming replication is happening. And this is the backend start time. The status is streaming, and this is the sent LSN, write LSN, and replay LSN. So you can see it is consistent. And if there is some lag on the standby, you will be able to see the status over here. Write lag, flush lag, and replay lag. Write lag, like what is the delay in writing, what is the flushing of those files on the disk, and then applying those files on the standby environment. Sync status is in asynchronous, and the replay time is the current time. As of now, my primary and the replica, they are connected. It is in running mode. What I'm doing is I'm just going to stop my replica, and we will see uh, what happens to this select star from pg underscore stat underscore replication. You will not see anything. So it's like the connection is not established because it is down. The standby is down, or it might be a scenario your network is not there, so it's not able to communicate, so it is not going to see. So this is one of the basic thing which you can check from the primary side. The other thing is, if you have a streaming replication and if you have used replication slot, let me start the instance on the replica side. Okay, so let me simply say start. It is started, and the same command pg underscore stat underscore replication, you will be able to see now the connection is established. Write lag, there is a slight lag which is very less, and if you see it now, that write lag has gone away, though there is no activity on the primary side. And the second command which you can fire is select star from pg underscore replication underscore slots. So it is like I have given some slot name, the slot type is physical. This is active. Active is true. That means it is doing its work and it is transferring the connection is established, and the wall files are getting applied. What I will do is, again, I'm going to switch off the replica, and then let's see this command. You can see that active is false. That means there is no streaming replication happening at this point. So you have to check this active. it will remain in the false state unless or until you establish the connection. So to establish the connection, this is a pseudo status which we have created. I'll start it, and then this should go and become active again. So this active is true, so this is fine now. And another thing which we can check on the primary side is we can check the current wall LSN status. I'll go to the primary and I'll fire this. Select pg underscore current underscore wall underscore LSN. So this is the current wall log sequence number, and then the final command which you can fire on the primary side. So it depends upon your scenario what suits best for you, but most of the information you will be able to see. Using this command, you will be able to see the application name as you would have seen in the first step, then sending lag, receiving lag, replaying lag, and total lag. So this information might help you when there is a large gap between your primary and the replica. On the replica side, you can check what is the current status of your replica. Let's go to the command prompt and say select PG is in recovery. So this will show you PG is in recovery. It is in the true state. So recovery is happening without any problem. We can check the status of wall log files, how it is getting received over here. So I'll say select PG last wall receive, and this is the last wall which is received. Then what is the last wall file which is getting replayed on the, or it is getting reapplied on the replica? So you can see it has given that information as well. And I can check the replay timestamp as well on the replica side as well. So going back to the last one in this also shows some important information. So these most of these values are valid for Postgre 10 and onwards. If you have to check the prior versions, then there is a slight change. Probably I'll put that as well. There is no replication log delay, so everything is fine. And the final thing, if there is an out of sync replica and there is no way to correct it, then you need to check the archive command on your primary, the restore command on the standby. And what you need to do is on the replica side, you need to export the data directory, remove everything, and then you do a PG based backup on replica to bring the data from the primary. So you can use the data directory location, then you can use the -r, which is going to create your recovery file. Then you can use a -access file, which is going to send all the log files, which is written on the primary to the replica. You can use the -v, which is the verbose. It will show you the display on the screen, and the -p that will display the progress of the restore. And then you have to check your log files if everything is fine or not, and then it should work properly. So it's always good to give importance of the how can we monitor the different things. So everything is available over here. So I hope this is going to help, and thank you. Hello and welcome. In this session, we are going to see some basics about the PostgreSQL log. So I have the notepad. I'll quickly show how it is going to look like. And okay, here it is. So we have everything recorded in a notepad, and we are going to see some of the basics about the PostgreSQL log. So like any other relational database or any other or operating system or anywhere wherein you wanted to check the issue with your environment, the logs are very, very important. So in our case also, we have the PostgreSQL log available, which will be used for troubleshooting and doing some analysis on your environment. So Postgre has an amazing log management facility. If you what do you say, if you maintain the proper configuration of your PostgreSQL according to the requirement, then it is going to be really helpful for you. So starting with the overview of PostgreSQL log management. So PostgreSQL supports three types of logging your server messages. So you can have a standard error log message, which is known as stderr, or you can put it in CSV log mode or sys log. So if you're working on Windows, obviously it is going to event log. So everything can be put into the SQL PostgreSQL.conf file, and it is going to pick up the information from there. If you wanted to keep the logging in CSV format, then you have it will be coming into comma separated value. And if you wanted to feed this into some tools wherein it is going to read the information from there, then it is going to be really useful. But by default, your logging mechanism is going to be stderr. So if you wanted to see like what is happening and what is the current location, if you haven't made any change, so by default in your data directory, if you go to log directory, you will see something like postgresql.log or postgresql.csv if you have put it in the CSV format. What is most important before you go to the log format, the stderr format or CSV format, that logging collector must be enabled, which is a background process which is going to pick up the information and put it over there. There are different severity level which are as usual in any other environment. So you have informational messages, you have panic, fatal, log, and info. We are not going to discuss about those, like what are those. We are directly jumping to the different parameters which are of utmost importance when we are talking about the PostgreSQL logs. The first parameter is logging collector. So if you see this parameter helps in enabling the logging character. What it is, so it is a background process which is going to capture the log message, and either it will redirect it to the stder or comma separated value, whatever format you have defined. So I have an EC2 instance running with the PostgreSQL installed on it. So I'm going to just execute this. I haven't made any change. So if I say show logging underscore collector, by default, this value will be on. That means the messages will be logged into your standard error log file. The second important thing is where it is going to log it. So when logging character is collector is enabled, which is the first step, which is by default enabled, then in that case it will go to write to some particular location. By default, this is in your log, which is in your Postgre uh, data directory. So if you simply say show log underscore directory, this will point to the log directory which is in your data directory. So let me show you show data underscore directory. If you go here and just say ls, you will be able to see a directory called log. So it is pointing to this. So you can see these are the log files which are available, and it is rotating on daily basis. So we'll talk about that. But before that, let's go to further different points. So the next PostgreSQL conf parameter is log file name. What should be the file name for this particular log file? So when logging character is enabled, when the collector is enabled, then it is going to put it into a log file. So if you simply say show log file, so we know that it is going to, okay, let me log into PSQL again and fire show log. So You can see the format, the file name is PostgreSQL hyphen percentage a dot log. So it is going to put uh, the uh, the uh, the format of the weekday. So whether it is Sunday, Monday, Tuesday, Wednesday. So those things it is going to put over here. So this is the default format, and the next parameter in this is the log file mode. So on Linux system, this parameter sets the permission for log file. What should be the permission on this? So by default, this will be 0600. So if you see show log file mode, it is going to show you. So these are the default parameters. So you can see this is the default parameter. But so by default, only the owner should be able to read and write this. So this is a special parameter. If you talk about the log rotation age, in case your database is very active, and if you wanted to rotate your log file onto a particular time period, then you can do it. So if you say show log rotation age, it will show you what it is. So by default, it is 1 day. You can change it according to your requirement. Log rotation size, if by default it is 10 MB, so after 10 MB, if you specify, it will auto rotate it. Auto rotate means it's going to create the new one. So by default, it is set to 0. Set to 0, that means it has been disabled for size based. But it is a good idea in case you have it for the specific date, let's say after 1 week or something like that, or in between, if you wanted to put the size like after 100 MB or something, like this should create a new, then you can do that. There is another one parameter which is called as log truncate on rotation. So it is something like you wanted to truncate rather than appending it, so you can rely on this parameter. So log truncate on rotation, so it is showing on. So this is the default value. And if you're using the syslog facility, so you can simply say like where it is going to log your syslog value. So show syslog underscore facility. So there are different parameters, local 0 to local 7. So you can, by default, it is going to local 0. These are very important, which is log min messages. So it is going to control which message level. So there are different message levels which are available in a server. It may be a panic level, it may be a warning level, it may be a fatal level. So which one you wanted to log. So this is very important. So one of the most important parameter for log. So if I say show minimum log messages, so warning. So you can see this series, warning is coming over here. So anything above the warning, they will be returned into your log file. So what it is doing, it is going to control which message are returned to the server log. And by default, the value is warning. The next important parameter is number 10. If you see log min error statement, it is going to control which SQL statement is going to be logged. The previous one, number 9, it is showing which level. So it is warning level by default. And number 10 is which statement caused this warning, error, log, fatal, or panic. So if I say show log min error statement, and if you execute this, this is error. So by default, anything related to error, it is going to pick up. So error is here, so you will be able to see these messages will be logged. So anything after that, they will be logged. Next one is log minimum duration statement. So here you are going to control the timing, at what time. If it is running in the database at a specific time, then they should be logged or not. So if you simply say show, okay, let me type this. I think I have not. If I simply say show log min duration statement. So this is set to -1. What does it mean? So it means that it is disabled by default. If you set it to 0, that means any statement which is executing in database, that is going to be logged into the log file. So what it is doing, if you set it to, let's say, some particular value, 250 milliseconds, then anything which is running up to 250 and greater than that, 250 and greater than that, they will be logged in. So you have to be sure what SQL statement which is residing in your database at a particular time, they should be logged. Next one is if you wanted to log the application name, not the name which is reflected by the application, but it is something which is going to be read by the PostgreSQL. If you wanted to capture that, so that will be enabled. So next one is log checkpoint. Why we are discussing about these? Because these will be used in next topic, which is about the PG Badger. So we are going to talk about PG Badger after this, but let's see what is there in show log underscore checkpoint. What it is going to see is, what is going to do, it is going to cause checkpoints and restart points to be logged in your server log. So if you say show log underscore checkpoints, by default this is off, and for your troubleshooting and analysis purpose, if you put it here, so that will show like what is the checkpoints and restart being done, and it will be logged. The next one is log connections. If you enable this, then every attempted connection to the PostgreSQL will be logged. So by default, this is off. If for troubleshooting period you wanted to do that, this will be good, but you have to turn it off immediately after the troubleshooting is done. The next is log disconnection. If it will capture what sessions are terminated, and they will be logged, and it also captures the time for which they were connected. So if I say show log underscore connections, let's capture this. If you say show log underscore connections, oops, what happened? Okay, it is log disconnections. Log connections we have already seen. So let's see log disconnection. So by default it is off. If you turn it on, it is going to show what all has got disconnected just for the troubleshooting period. And the next one is the log duration. It is going to log the duration of every completed statement in your database. So if you say show, let me fire this. It's good to know about these parameters, like there are these many parameters existing, and in case if you have to use them, it is going to be helpful. So it is by default it is off. What it means is it is going to track the duration of every completed statement in your log file. That is going to be helpful. These parameters we are going to learn in the next topic, which is all about the PG Badger. I hope this is going to help. Thank you. Hello and welcome. In this session, we are going to learn what is the usage of Python in PostgreSQL, or how do we integrate Python for the PostgreSQL. So you already might be aware that Python is one of the most powerful programming language nowadays, and this has been everywhere. So we will try to see for PostgreSQL database how can we use it to a minimum extent. So we will see the module which is being used for Postgre, and we will see a basic thing in PostgreSQL, like how do we make a connection to the database, and then how do we create a table, how do we insert one or two row, and then how do we display the data from the table. So this is all about what we are going to see in this demo. So the first thing, the PostgreSQL database can be integrated with Python using this module, which is PSYCOPG2 module. So what I'm going to do is I already have an internet connectivity with my Postgres server. So I'll just say sudo yum install Python and the module. Since it is already installed, so it will show it's already installed and with the latest version, so nothing to do. But in your system, it is a Linux environment. You have to install this module for your database. So the next thing which we are going to do is we are directly going to create a Python script and we are going to log into the database. So I'll show you the script which is there. So the script name is login postgre.py. So we are just saying the location of the Python executable, and then we are importing the module which we have just installed. So this is very important. Then we are going to say uh, connection equal to the module name, and then we are connecting, and then we are saying database, which database I want to connect. I want to connect with the DVD rental. User is Postgre, password is password, this is the host IP, and this is the port number where Postgre is running. And then it is going to display the database login successful. We are not going to mention if any of the parameter is wrong, how to handle that. We are not doing that. It's just a straightforward, basic, very basic Postgre uh, Python script. So we'll just say Python, and the script will try to execute, and we'll see if it displays the success or not. So it is displaying database login successful. Since it has met all this criteria, so it has printed the login successful. Now what we are going to do in the second step, we are going to create a table. To create the table, this is the script which we are going to use. So we just mention the Python, and then we are going to import the module. So we are just saying import and the module names. Then in the connection, we are just saying the module dot connect and the connection string. This is the detail of the connection string. Database name, username, password, host IP, and the port name. Then it is going to print whether login is successful or not. Once it is successful, then we are mentioning the cursor, and then we are going to execute the create table statement for a table called as films, and that has one column with the code, and it is going to store char 5, and then it will display the table creation completed successfully. So let me first connect to Postgre and drop that table. Okay, it is not there, I believe. So let us go and execute create table, and then we will say Python and the create table. So table creation is successful. Now what we will do next is we will insert a row. For inserting a row, we have the script. So it is just insert data dot py. What we are doing over here is the same thing. We are going to import the module. Then in the connect, we are just saying we are giving the dot connect, and then we are showing we are mentioning all the details which are required for the connection. So once it is connected, then we are going to execute the, so you need to understand what is this the connect module, and then you have the in the cursor you have execute. Okay, so in the execute we are just saying insert into films, and then the column name, and here is the data. Then we are going to commit it, and then it is going to print the message, and then it is finally going to close the connection. So let's execute it. Python and insert data. PYTH1. Okay, the records are inserted, and the final one where since there is no index created and there is no constraint, so if I insert the same record n number of times, it is going to be getting inserted over here. The last one in this one is the selecting the data. So we are just going to select the data. What we are doing again is we are going to import the module, then we are going to connect it. This is the connect string, and I believe I have created some more table. So here, okay, this is going to display. So once I have mentioned the connection details, it is going to, since my table films has one column only, so I'll just say when you are displaying the rows, just display all the rows. Okay, so this is going to display, since it has only one row, so it is going to display only one uh, column details. So let's execute it, Python, and select data.py. So you can see this is the data which is available as of now. There are many rows so with the same uh, output because I have inserted this many times during the creation of this demo. So this is just the basic. There are a lot of things which can be done depending upon what do you want. So it is just like just what we have done is we tried how to connect to the database. Then we had created a table. Then we created we inserted some row, and then finally we fetched the data. If you know the basics of this will be useful, and you can implement many more things as you move further. I hope this the basic thing is going to help you, and thanks for watching. In this session, we are going to learn what is IaaS and PaaS, which stands for Infrastructure as a Service, and the second one stands for Platform as a Service. So our requirement is we need to have the Postgre deployed on a machine in the cloud, and there is a decision making which has to happen, and mostly there is a lot of discussion which happens whether you wanted to install the Postgre on a virtual machine in a cloud, or you wanted to have a pre-installed managed instance of PostgreSQL. So there are two terms which are very oftenly used. One is IaaS, which is known as the virtual machine deployed in the cloud, and the other word which comes is PaaS. There is a spell mistake over here, which is PaaS. It should be platform as a service. So it is simply like if you wanted to have the full control over a machine and you wanted to deploy Postgre on top of that in the cloud, maybe in AWS, Azure, or Google Cloud, you need to have the virtual machine spin up in any of these preferred cloud or any other cloud service provider which you have. The other way is you can choose with the pre-installed managed instance of Postgre in any of these three major cloud service provider. So that's the basic difference between the infrastructure as a service and platform as a service. So basically, a virtual machine which is there in the cloud is called as IaaS. And if there is a pre-installed instance of Postgre in cloud and you do not have access to the operating system, it is termed as the PaaS, platform as a service. So What is the decision making factor, like what shall I choose? So it depends upon how much control do you want over the machine. If I wanted to have the full control in terms of the Postgre instance which I wanted to install, let's say I wanted to install a Postgre which is quite legacy that's quite old, let's say 9.5 or 9.6, just because of my application dependency and something like that. This is just an assumption. And most of your Postgre managed instance, which is available in either of these three service providers, cloud service providers, they may not have the oldest version. And if somehow you have those binaries you wanted to get installed on a virtual machine, you have to select a virtual machine in any of these cloud, and there you can go with that. So when you choose between infrastructure as a service or platform as a service, you need to have some decision making, like how do you want to manage the database? How do you want to apply the patches? How do you want to manage the backups? And how do you want the operation related what do you say, the operational things of Postgre managed? Right, so you need to consider all of these. If you are running your Postgre on a virtual machine in the cloud, and then you have to take care of everything, starting from the deployment. Then you have to manage the high availability, you have to manage the disaster recovery, you have to manage the monitoring, you have to manage the backups, you have to manage the replication if it is there. So it is, everything is customer managed. But when it is about a platform as a service, in that case there are a lot of overheads which you, or there are a lot of work which wherein an administrator work. Those are already taken away from the administrator, and they are already automated in cloud. So there is an easy manageability when you work in a managed instance, be it any of these three: Azure, AWS, or Google Cloud Services. So we will see some of the attributes. So availability SLA. If let's say my virtual machine or infrastructure as a service, it is in the AWS cloud, then the SLA depends upon the virtual machine which you have selected. If I talk about Postgre as a managed instance, or as platform as a service, in that case, it will depend upon the managed instance SLA. What about the operating system and PostgreSQL patching? If you are running it on a virtual machine as infrastructure as service, then it is your responsibility. It's customer managed, and you have to manage everything. If it is with platform as a service, then it is optional, and you can manage it in the managed window. But most of these things are automated by the cloud. High availability, you have to architect how you wanted to maintain the high availability of Postgre when you install Postgre in a virtual machine in cloud. And when you go with the managed instance, it is available built in. So you just have to find out what kind of high availability which is available in the particular cloud you wanted to go with. Hybrid scenario, if you wanted to have the what do you say, the multiple instances of the Postgre, say for example, for high availability, you can have you have to manage it yourself. But there are some in case of the cloud, it is termed as the read replica, and there is a consistent replication happening between the primary and the read replica, so they are in continuous replication with each other. So that's easily managed. But when you have to do it yourself, you have to manage all the challenges. The backup and restore, which is one of the most critical part in Postgre, If it is on a virtual machine, you have to manage everything yourself, whether you wanted to do either of the three, the way like you wanted to use the PG dump all, or you wanted to have using the PG based backup, or you wanted to use some third party tool to manage the backup and recovery, you have to do it yourself. But when you go with the platform as a service, so everything is automated, the point in time recovery, the backups, and everything is managed by the cloud service provider. Then the important part is about the monitoring of the database. So if you are doing it yourself, then you have to make sure what individual components you wanted to monitor. But when you are in managed instance, everything is pre-managed, and you just have to trigger what alerts you wanted to see. Let's say for the storage, for the CPU, for the memory, for the maximum number of sessions, about some performance threshold. So everything you can set in the managed instance. Threat protection in case of a virtual machine, you have to manage it yourself, not at the cloud service provider, but something where you wanted to protect the data internally. But when you talk about the Postgre as a managed instance or platform as a service, so you have a lot of things which are available that you can enable. Disaster recovery in case of managed instance, it is we call it as replica, and in case of virtual machine, you have to manage it yourself. With infrastructure as a service, what do we get? It is if you are trying to do, if you have the shortage of the manpower or the skilled worker, and you do not have any dependency on the operating system, then probably managed instance is one of the good thing to go with. But if you have some dependency, and those dependency cannot be ruled out with the managed instance, then you have to go with the infrastructure as a service. So full control, you can have it over the virtual machine, but not over the managed instance. With platform as a service, what do we get? So you are not supposed to bother about the underlying infrastructure, the operating system, the hardware, and the internal software. Everything will be taken care by the cloud service provider. But other than that, let's say the managing of the high availability of the databases, the read replicas, encryption, those things will be taken care by the cloud service provider. So everything has its own pros and cons. So it depends upon what kind of scenario you have. And if you wanted more flexibility, you have to go with infrastructure as a service. If you are fine with the less, what do you say, less flexibility, and you wanted to give away all the management part to the cloud service provider, you can go with the managed instance. So it depends upon what you are looking for. So it's all about the virtual machine and the managed instance. So sometimes there is some kind of confusion, like what is this IaaS or PaaS? So it's very simple. If it is a virtual machine, it is infrastructure as a service. And the way you work on the on-premises environment, you will have to work it in the cloud as well. If it is platform as a service, that means everything is pre-decided, and there is just few clicks, and your the way you wanted to enable the high availability backups and other things, they will be created. I hope it is going to help, and thank you. Welcome. In this session, we will see what is AWS database services, though we were supposed to talk about the RDS in AWS, but we will start with AWS database services. So in AWS, which is Amazon Web Services, there are 15 types of database engines which are offered by AWS. And these are the different types which are offered. So you have relational database, you have key value database, you have document based database, in-memory database, graph database, time series database, wide column database, and ledger based databases. So what are the general features of these databases which are offered by the cloud service provider, which is AWS, and in wide terms for any cloud service provider. So these database services which are offered by AWS, they are fully managed. That means most of the administration part, the critical time consuming part, that will be taken care by the cloud service provider, which is AWS. The performance which is seen in terms of the managed instance or the databases in AWS which is being offered, they have the performance at a scale because of the intelligent hardware which is being used. And in some of the scenarios, let's say the MySQL which is being used in on premises and the MySQL which is being used in AWS, there is uh, a lot of difference in terms of the performance. So what it says is there is alternative 3 to 5 times of millisecond response time. The databases which are offered in AWS cloud, they're highly secure and highly available because of the kind of security algorithm which is being offered, and because of the infrastructure and the management, they are highly available. This is the first type of database, which is relational database service. So, relational database is the one where in your data will be stored in a table in terms of columns and row, which is the normal way of storing the data in a table. The example is Amazon Aurora database, Amazon RDS database, which has 7 different types of engine. You have Amazon Redshift. So maybe when we talk about the RDS for Postgre, we will talk about these three databases which is available for Postgre as Amazon Aurora, Amazon RDS, and Amazon Redshift data warehousing solution. In case of relational database, you have a predefined schema. That means the table structure. If I talk in the technical terms, the table structure will be predefined, or unless or until you modify the structure of the table. Your relational databases are asset compliant. That means there will be atomicity, consistency, and the data will be durable. You have the referential integrity for the transaction, and the data is consistent. This is mainly used for ERP and e-commerce. There are n numbers, but these are just too few. Another very popular NoSQL database is document database in AWS. So it is called as Amazon Document DB, which is MongoDB compatible. That means the MongoDB which you have been using on premises, the same thing can be used here in AWS cloud. It is highly, very, very fast. It is scalable and it is highly available. So what you can do is you can store the data in the form of JSON format, and the updates happen very, very fast. What are the use cases? You can use it for content management, for catalogs, and for storing the user profiles. The third type of database is key value pair database. And the example for key value database is Amazon DynamoDB, which is really a very successful database in AWS. So key value databases are optimized for common access pattern. It stores and retrieves large volume of data, and these databases deliver very quick responses. That means if you have a huge volume of the data and you wanted the concurrent request, then Amazon DynamoDB is one of the fastest way of retrieving the data. It is used for high traffic web apps and e-commerce system, and it can be used for the gaming application, wherein you will have the large data set and there are high requirement for concurrent requests. The fourth type of database is wide column database. It is in AWS, it is called as Amazon Key Space, and this is compatible or equivalent to your Apache Cassandra. So what happens? A wide column stores it is a kind of NoSQL database. It uses tables, rows, and columns, but unlike a relational database, the name and format of the column can vary from row to row in the same table. So there is no, it is not as equal to your relational database. So it can be used for fleet management or route optimization. So in that case, your wide column database called as Amazon Key Space can be used. The fifth type of database is in-memory database. So normally outside of AWS, it is known as Redis. So here you have two types of offerings from AWS. So one is known as Elastic Cache for Memcached, and another is Elastic Cache for Redis. So it is in-memory database which is used for application that require real-time access to the data, and another is by storing the data directly in the memory. These databases deliver the microsecond latency and high throughput. It can be used for caching purpose, for session management, and for gaming leaderboards. The sixth type of database which is being offered by AWS, it is graph database. The example is Amazon Neptune database. It is mainly used for the application that need to navigate and query millions of requests, millions of relationships, which is not possible in any other sort of database. So the graph database, it is for multiple what do you say, the relationships, then you have to use it. It is good for large data sets with the millisecond latency. It is mainly used for the fraud detection and social networking recommendations, wherein you have to go deep into the relationships. Uh, the last one in this, I believe, is time series database, which is called as Amazon Time Stream. And Time Stream database collects the information and derive the insight from the data that changes over the time. And it is used mainly for IoT application, DevOps, and industrial telemetry. And that's all about the databases to move the wall files to a new location in PostgreSQL. So I have everything noted over here, and we will go through these steps, and we will follow it step by step. So high level steps are uh, the current situation is I have the wall files configured at the default location, which is your pg data slash pg underscore val location. Due to some requirement, I need to change this location to some other file system where it is high performing, and the best practices also says that your wall files and database files should not reside on the same file system. So to achieve that, we are performing all these steps. What we will do, we will stop the Postgre cluster. We will move the wall files to a new location. Then we are going to create a symbolic link from existing location to the new location. Then we will restart the cluster, and that's it. So I have Postgre installed on an EC2 instance. So I'm already logged in over there through the MOVA Xterm, and we are going to follow the rest of the steps. What is the default location of the wall files? The default location of the wall files is in your PG data, PG underscore well. So what we will do is, if you go inside this, or if you navigate to this, you will be able to see the wall files which are available. So what we will do is, we will create a new location where we wanted to migrate our wall files. So I'm just going to create it since I do not have a separate file system. So I'll create it over here. Let me see, because I used this earlier as well. Okay, it's empty. The next thing which we will do is we will check the status of Postgre, and we have to stop it. If you do not stop it, then the things are going to be messed up and nothing will work after that. Stop it so that your Postgre is not in use. Check the status again. We will check the status now. It is checked. And now what we will do is we will copy the files from our wall locations to the new location. So my wall location is this one. So in my pg underscore wall, I have one is wall file, another is archive underscore status. So what I will do is either you use the rsync, since I have a very small environment, and if you wanted to move it at the high speed and you wanted to retain the permission and other things, you can use the rsync. But for this demo, it is a very small file which is available. So we will navigate to that and we will simply use the cp command. Cp from existing location to the new location. So let's navigate to the new file system and see, yes, you have the both things copied over here. Now what we will do is we will rename the existing wall location so that by mistake also it's not passed up. So I already have this one, so let me delete this. So what I will do is rm minus rf, this is the remains from the previous demo, and we will now rename it. This is renamed. And now what we will do is we'll just cross verify that nothing exists in the default wall location, or that directory itself should not exist. So it doesn't exist now. What we will do now is we will navigate to pg data and we will create the soft link. So ln-s, and this will point to the new location. And if you do ls-ltr, you will be able to see that pg underscore val is redirected to a new location. And now, if everything has been perfectly fine, so what I can do as a cross check is navigate to the new file system and see the one file and another directory, which is archive underscore status, is available or not. That's available. So on the top side, everything looks fine. So if I say sudo systemctl start PostgreSQL 13, it should work. It's working. And if I do ls-ltr, you can see that pg wall, this is a soft link. This is a soft link. This is not the directory. This is pointing to this location. So it seems the things are working fine. If you wanted to cross verify, just go to cd log, just in case you wanted to check, and you can check the log. This is everything is fine, everything is clean and good. So our system is perfectly fine. Now there are just few things. I can log into PSQL just to check if everything is fine or not. I'm able to log in. So the other thing which we should do is, if you have already taken a backup of the location where we renamed it, you can take a backup and you can remove it permanently. Okay, some of the things about the val is automatically enabled. You do not need to manually enable it, and what you need is only the file system storage, which is required to store it properly. And while files, the wall records are appended to the wall logs as a new record is written, and the insert position is in the form of LSN, which is log sequence number. And where it is stored by default, it is by default stored in pg underscore val location. And if you have to create a new location, you have to tell that the default location, which is pg underscore val, that by default it will come to here, but using the soft link, you should go to the new location. And that's only possible when you create a soft link. And that's all about it. I hope this is going to help. Hello and welcome. In this session, we are going to learn what is RDS, or which is also known as Amazon Relational Database Services. So we have all the details over here, and we will go through with what is RDS and an overview. So Amazon has released Amazon Relational Database Services as a web-based solution for the relational databases. They are 7 in number with different engines. So one of the reason to be accepted by the organization for AWS RDS is it is cost efficient, and you do not have to worry about the capacity, and most of the operational database activities, they are automated in AWS RDS. So one other question, why shall I run my database in RDS when we have two more options? One is running the database, let's say Postgre, either in on-premises, which is not cost effective, or running the database like PostgreSQL in EC2 instance. So when you run your database in RDS, most of the database activities are automated, starting from the provisioning till the different phases of the RDS activity, like backup and recovery, setting up the high availability, the disaster recovery. Those things, they are just a click away. You can just click some of the options, and the required environment will be set up for you. So this is just one more point wherein we will discuss about why should we not be on EC2 or on premises. What are the different things which needs to be considered when you are on premises or when you run your database on EC2. Starting from the data center which you own, where you are going to have your servers and the entire infrastructure related to your organization for the IT services. You need the hardware for the server, you need the power, you need the network and the cooling. If you are doing it in on premises, you are going to pay for everything. The total cost of ownership is going to be very high. But if you do the same thing, let's say you wanted to run the database on EC2 instance, you don't have to pay for the hardware, you don't have to pay for the power which runs those servers, the network and the cooling. That's you are not going to bother about that. Everything will be managed by AWS, and you have to pay as you use. The server maintenance, in case of on-premises, it is customer managed. Any issue with the server, you have to manage it. But in case of EC2, uh, if your database is running on EC2, it will be managed by the AWS. Operating system installation, it will be done by you, whether you do it on premises or EC2. If you talk about the patching of the operating system, installation of the database software patching, everything will be done by the customer, whether you do it on premises or in EC2. Scheduling the database backup, or making a strategy how to back up the database. Whatever you have been doing in on premises, the same way you will keep on doing when you run your database in EC2 instance. Setting up the high availability for the relational database like PostgreSQL, you have to manage yourself, and whether it is on EC2 instance or on premises. So it is just a virtual machine which is not running in your environment. It is being given to you by AWS. The scaling of your database when you run it in on premises or when you run it in EC2, everything you have to manage. Setting up the disaster recovery for your database, you have to do it yourself, whether you do it in on premises or EC2. So other than the two factors, one is related to the server maintenance and the hardware. In EC2, you don't have to bother about, but other than that, there is almost 90% of the similarity when you run it on premises or DB2 in terms of the task, not related to the total cost of ownership when you run it on premises and the database on EC2 instance. We will see the comparison when you run your database in RDS as a managed instance or when you run the database in EC2 instance. The hardware part or the server maintenance will be taken care by AWS, whether you run it on EC2 or the RDS. When you run the database on EC2, you have to perform the operating system installation. You have to do the operating system patching. That means you are the owner of the operating system. In case of RDS, you don't have the access to the operating system, and that is entirely taken care by AWS. When you run your database in EC2 instance, whether you install the database software or the patching, it will be taken care by the customer. But installation of the database software and the patching and everything that will be taken care by AWS. Setting of the database backup in EC2 instance will be taken care by customer, but when it runs in RDS, it will be taken care by AWS. High availability and the scaling, that part will be taken care by the customer when you run the database in EC2 instance. And when you do the same in Amazon RDS, it will be taken care by AWS. What are the distinguished features when you talk about the RDS? So most of the time consuming and the difficult part will be taken care by the AWS. The backups are automated. You can do the snapshot backup, and when you do the restoration from such backup, they are highly reliable as compared to those backups which you create when you run your database on EC2 instance or on premises. When you set up the high availability in case of EC2 instance or on premises, you have to manage it very well, and it's really time consuming to make the high availability setup. But when you do this thing in case of RDS, it is going to be very simple, and failover to such high availability solution is reliable, and it is very easy. You can use the read replica to scale up your read actions in case of RDS. You can use the IAM for identity and access management. This is one of the most secure features which is available in RDS. You can put your database in virtual private cloud, so it is safer. It is as good as like you're running your databases in your own environment. So there are a few terminologies which are used in AWS for RDS. One of them is we say it DB instance or managed instance. It is like an isolated database which you run in AWS, or wherein in one instance you can have one or more database. If you are talking about Postgre, you will have one managed instance that will be running as an isolated database instance, and that can have many user databases. What are the different database engines supported in RDS? You have seven databases. One of them is Postgre, which is either available as the relational database in database services, or it is also available as Aurora as the relational database service. There are six more other different engines like Oracle, MySQL, you have MariaDB, and there are MS SQL databases also there. So, and Oracle is as well there. So there are total several types of relational databases which are available in RDS. You might heard this, you might hear this term very oftenly in any cloud, or in our case, it is VPC. So it is like the predefined range of IP address. You can create your own subnet, you can create your own routing, you can have the ACL access control list. So your environment will be highly secure and safe. You might hear about the AWS regions and the availability zones. So the data center facilities which are being offered by AWS, they are known as the AWS region. So it is available in almost all the continents. You talk about the America region, you talk about Europe, Asia. It's available almost everywhere. If you talk about the availability zone, so one region can have multiple availability zones, and one availability zone is quite away from another availability zone. So we say it is multi-AZ. One region may have many availability zone. If you talk about uh, the security, one of the recommended way is you create your own VPC, and you should launch your databases inside the virtual private cloud. And how do we monitor the relational databases when you do not have the access to the operating system? Because normally what we do, we install the monitoring software on top of the operating system where database is running. Generally, in general, if you are using some other way, it fetches the information from the databases which are running on a particular host. But in case of RDS, you have CloudWatch, which can monitor the state, performance, and health of the database, and you can be notified depending upon what kind of matrices and threshold you select. How can we work with the Amazon RDS? So direct access you do not have to the operating system. So what you have to do, you have to use some third-party tool or some of the tools which are being offered by AWS so that you can connect with the RDS. Say, for example, if I have a managed instance of PostgreSQL, which is running in RDS, so I can use pgadmin to connect with the Postgre, which is running as RDS, or I can use PSQL, which is a command line tool which I can install in some other system, and from some remote system I can access my Postgre RDS instance. That's the way. There's all general details about the RDS in AWS. There's all the basics. I hope this is going to help, and thank you.
Welcome. In this session, we will see how to launch a PostgreSQL managed instance in AWS as RDS instance and then connect to it using pgadmin and EC2 instance. So let's get started. I'm in the AWS console. I'm on RDS. So I'll just say the dashboard and you can see the dashboard. Now we are going to just create a PostgreSQL managed instance. So I'll just click the create database. We are here in standard create. You can go with the easy create, whatever you want. So on the RDS page, you will see there are several options. We have to go with the PostgreSQL. With respect to the version, there are different versions which are supported and are available. You can see Postgre 9.6.20 till 13.4 is the latest release. I'll go with the 13.4, which is available. For this demo, we are just going to use the dev and test setup. In the settings, by default, the DB instance identifier is coming as database one. If you want to change, you can change it according to your requirement. The master username or the admin username over here, it is by default Postgre. If you have worked on on-premises or EC2 instance where you have installed Postgre, so the the Postgre which is available over there, and this admin user, it's different. We can generate the password later on as well, or we can set the password right now also. I'll just say auto generate a password. DB instance class, you have to mention what is the amount of CPU, RAM, and the storage you wanted for it. For this demo, we'll go with the bus table classes. We'll go with we will include previous version classes so that we can just have a very light machine for our demo purpose. From the storage perspective, you have three options available. You have SSD, GP2, and then IO1 is available. You have the magnetic, so we'll go with the SSD GP2, which is high performing disk. And DB instance class, which we already discussed, it depends upon which DB instances you want for your environment. So you can select what is the virtual CPU and the RAM which is required, along with the network throughput. And we'll go with the minimum server configuration over here. Storage type, you have selected SSD. Storage size, we have given initially just 20 GB. Postgre RDS has a limitation between minimum 20 GB to 16 terabyte. We are not going to enable the storage auto scaling. This can be done later on as well. Availability and durability, this is not a production environment. Even if the availability zone where my Postgre is running, even if it goes down, I'm not bothered about it. If it is production environment, I need to have the multi-AZ configuration so that a standby of the Postgre must be available in another availability zone. So if one of the AZ goes down, then your workload can be available in another available zone. For this demo, we are not going to create it. We will just say do not create a standby instance, but this can be done. We'll go with the VPC, the default one. But in real environment, you should have a new VPC, and it is always preferred to keep your RDS instance in a created VPC. Public access, there is no reason that you should have the public access for your managed RDS instance for PostgreSQL. We will go with the public access because we wanted to access it from our system and from other resources. But if you wanted to say no, you can just say no, and it will not be available publicly. We will go with the default security group. We are not going to choose any availability zone, so it is going to take any of these three availability zones. So by default, I have taken these are the different options which are available for your region. So I have selected the Asia Pacific, and according to your requirement, you can go with that. Additional configuration. In additional configuration, you have the port number. If you wanted to change the port, you can change it over here. We'll go with the default password authentication, the way it works in normal Postgres standalone environment. If you wanted to go with the additional configuration, you can set some initial database name, but later on this also it can be created, so it is up to you. DB parameter option, we will discuss about the DB, what is DB parameter, and the option group. We're not going to enable the automated backup. This can be enabled later on also. This is a good thing in managed instance in RDS. So you can enable the automated backup, so you can do point in time recovery. So this is one of the overhead which has been taken away from the administrator. So I'll just unselect it. The data at rest and the data in transit, they both are encrypted. So we will so you can enable this for the encryption. If you wanted to have the performance inside available, so you can just retain the duration. If you wanted, for the default one, it is just 7 days. If you wanted to retain for a longer period, you can have that as well. So we'll go with the default one. And in case you wanted to have the enable enhanced monitoring, so you can go with the enhanced monitoring. So you can see what are the different processes or threads of the CPU which are using the resources, and you can export your logs to your CloudWatch. CloudWatch is the default way of monitoring solution in RDS and in AWS. So we will select log export so that we can see what is happening back behind the scene. Maintenance, so minor upgrade in Postgre in RDS or any other relational database, it is automatically taken care by AWS. So if you enable it by default, so it will be upgraded, and you can select the maintenance window where it is going to be upgraded. This is the estimated monthly charge which is going to be incurred on this particular instance. We'll just say create database, and this will be created. And then we will understand what are the different components which are. This is going to take at least a couple of minutes or so. It is still in the creation step. You can see the different options which are available over here, but there is much more than this which can be done. Once it is ready, it will be available with the endpoint and the port number. Port number will be 5432, and the availability zone, the VPC, and the security group. So we have to be careful with the security group, because this is how we make sure that the remote instances get connected to your Postgre RDS instance. Still being spin up, so we will have to wait for some time. On the monitoring part, so who is going to take care of the monitoring? It is being taken care by the CloudWatch, which is the default way of monitoring your AWS resources. So it is going to show you the CPU utilization, the DB connections, the free storage, the freeable memory, and this way by default there are some 24 parameters. So you can go to the next page, and you should be able to see the queue length, read throughput, swap usage, write latency. So on each page I believe there are 6 parameters. It's all related to the network over here, and then it is related to the replication in case you have enabled the replication, uh, and that's it. Or you can put everything over here on the same page as well. So all the parameters which are being monitored, they are available over here. Let's see what is the status. It is still creating. Let's go to the logs and the events. In the logs and the events, it will show you when they in the event section, it will show you when the DB instance was created, when the CloudWatch logs exported, which logs. So we are talking about the PostgreSQL log and the upgrade log, and it will show you the master password when it was reset, DB instance when it was shut down or it was started. So those information you will be able to see. If you wanted to see the Postgre error log, then you can just click over here and just see, just do the watch, and it is going to show you what all information is written over here. Let's go back again. Let's check the status, what it is. It is active. I think it is available and ready. So we should be able to see the status. Okay. And if you just click database one, which we have created, monitoring, log and events we have seen, and then we go with the configuration. It is going to show you the DB instance ID, which we have created is with the default name, which is database one. Database version is 13.4, and this is the security group. This is the ARN name. Availability, so what we need for the connection is the master username and the password. We see only the username is there. We can reset the password now. And storage level, it is encrypted. The default storage which is available is 20 GB, and that's it, the basic information. And then maintenance and backup, it will show you if the maintenance, so it is showing that minor upgrade is disabled, and automated backup is already disabled. We didn't do it because it was a demo and the development box, but this can be checked or enabled anytime later as well. So we will click it, and for connection what we need is we need the endpoint. So we will take this, and what we are going to do is we are going to connect it with pgadmin. For connection with the pgadmin, I would need the host name, user id, and the password, and the port name is default one, which is 5432. We will go with this. This may take a little bit of time, maybe a minute or so. I'll put the host name over here. The username is this one, and let's, okay. I'll go to the servers. I'll just say create server. Mention the host name over here. The host name is this one. Just copy and put it over here. And in the connections, you just have to mention the port name, which is 5432, which we have taken by default. The admin user is Postgre. Sorry, the database name is Postgre. The username is Postgre, and we will find the password and put it over here. So what we need to do is we need to go back over here, and we'll just have to say, just click this one, and under the modify, what we are going to do is we are going to reset the password of Postgre admin user. So you can see all the details are there. DB identifier is there. New master password. We will just copy and paste this one. I want to keep password as this one. I'll confirm the password, and rest of the things I don't want to change anything, so I'll keep everything the way it was, and I'll just say continue. Modify DB instance. So we'll see what is the status as of now. Let's put this password in pgadmin so that we should be able to connect. Okay. Password authentication failed. Let us see if it is already modified or not. We will modify once again. This is the password which we wanted to key for the Postgre admin user. Okay, I think the changes are still not done, so we will wait for some more time. It is still resetting, that's why we are not able to do it. I thought it's already done. We'll check the status again. Well, this is still doing its task. And in the meantime, once we are able to connect with this, let's save the password. We'll say save the password, and okay, we are able to connect now. You can see that we are able to connect with the RDS instance. We have the Postgre database and RDS admin database, which is provided by the RDS for the management purpose, and we do not have access to it. The other thing which we have to do is using an EC2 instance, we will try to connect with this. So I have the EC2 instance already available and running. We'll go to that, and this is the host name. EC2-user sudo su space minus postgre, and we will say PSQL and let me see. Okay, what we are going to do is we are going to connect with the, so what we have to fire the command psql-u-h and the host name of or the endpoints of your RDS instance. And I'll explain what are the different challenges that you may face. This is the endpoint. I'll just copy and paste. So I'm just saying psql-u, username is postgre, which is admin user -h. This is the remote RDS instance, and just press enter. And we will feed in the password. This is the password. We are able to connect with the RDS instance from an EC2 instance, and the different challenges which you will face when you try to do it yourself is regarding the security group. So what you need to do is when you click on the security group, you need to go and check your inbound rules. Since I had already done this step for you, what you have to do it when I'm trying to connect with my local system, which is my system. So what I have to do, I have to just say add rule, and here I have to give PostgreSQL, and then I have to feed in my IP address in case I'm just trying to log in with my IP address on port number 5432. This is already done, and this IP keeps on changing. This is dynamic in nature. So you just save, and you will be able to connect from your system, because that's the way how you control the security group. The other thing is when you have to connect your RDS instance, when you try to connect your RDS instance, this is the security group of my RDS instance. And if I just say add rule, I wanted to connect from the EC2 instance. So I need to just mention the IP address. Let's say I am just giving the public IP address and private IP address of my EC2 instance. So what I have to do is I again have to go to PostgreSQL port, and I have to mention the IP address, and then save it. And that's how what we do when we try to connect RDS instance remotely. So everything revolves around the incoming connections to your RDS. So you need to make sure that your security group allows incoming connection from your EC2 instance or from your local instance or any IP address which you are trying to connect. In RDS, you do not have access to pg_hba.conf, so you cannot do anything. And one of the difference over here will be when you try to connect to your RDS instance, by default you will be able to see there is a Postgre database, and you will be able to see there is something called as RDS admin. So this is the management database which is not accessible from outside the world. And if you see, it is going to show you some of the error messages over here, so you cannot access this. Also, RDS cannot be accessed on port number 22. So the only way you have to log in is the database port, which is 5432. In another session, we will see more topics about this. I hope this is going to help. And
Hello and welcome. In this session, we are going to learn some basics about how do we analyze a query with explain and try to understand what can be done further from there. So we are just going to see what are the some basic details about the explain. So I just tell you a basic situation wherein I have a table with let's say hundreds of thousands of rows, and when I'm trying to find when I'm trying to execute a select query on the table, it is going to take a huge amount of time. The time which it is taking to execute the query, it is not the optimal time. So it is not taking the optimal time. So what is that we can do in that situation? So in that situation, we are going to analyze the query with the explain. So before we understand what is explain, we need to understand what is a planner or the optimizer. The planner or an optimizer in PostgreSQL, it creates an optimal execution plan. So when a SQL query executes, then there will be different execution path, and the task of the planner or the optimizer is to choose the optimal plan so that the amount of time spent on the execution is less and the amount of the cost which is incurred on execution of the query should also be lesser. So this is what the planner or the optimizer do. So it creates an optimal execution plan. So if we see what is an explain do in PostgreSQL, so the explain it returns the execution plan which PostgreSQL generates for a given statement, right? So when you execute an SQL statement using the explain, so what it will do is it will show you how the SQL statement has been executed. Say for an example, I have a table with the name actor and it has hundreds of thousands of rows, and if I just say select a star from the actor where some particular actor ID is equal to this. So in that case, how the SQL statement is going to be executed. It is going for the index scan, or is it going to scan the entire table, which is the sequential scan. So this is just one of the basic example. And in case it is a complex query, which is obvious in a production environment, and if multiple tables are involved, then what kind of join algorithm will be used? That is mentioned all there in the SQL query, and when you try to generate and explain, that will show you some more details, and you can try to find out what is the SQL statement which is taking more time, which you assume it is an unusual time, which can be tuned. So explain will give you just the cost and the estimation of the amount of time which is going to be incurred on that. So basically we'll say explain, it shows the execution plan of the statement, and if there are multiple tables involved, then it will show you what is the best algorithm which is going to be executed by the execution plan, and from there you can try to find some meaningful information. And the most critical part of the display is the cost. If you think the cost, but this is not also the thumb rule, if the cost is less, that doesn't necessarily means the your SQL query is doing great, but sometimes it is misleading as well. So it is all hit and trial. Sometimes the thumb rule works, sometimes it doesn't work. So it works in that way. Okay, so there is one more thing when we try to execute an SQL statement with with explain. You can use the keyword analyze also. So what analyze will do is it will actually execute the SQL statement. So you have to be very cautious when you are trying to explain an SQL query along with the analyze, because analyze is going to actually execute the SQL statement. And this is the format. We can say begin if you wanted to put in a blocks, and explain, and you put analyze, and let's say select a star from actor. So you can do it like this. So let me show you. I have a table with the name actor, and if you try to execute the SQL statement like this, so you will be seeing something like this. So I have executed explain, analyze, verbose, buffers, select star from actor. So what it is doing the sequential scan on the table actor. It is there in the public schema, and it is showing you the cost. It is showing you the row. It is showing you the width. It is showing you the actual time. It is showing you how many number of rows will be uh, returned, and it is showing you how many times the iteration will be there. It is just one. And output, what will be there? It will be 1, 2, 3, and 4 columns are there. And in buffers, because I have given the option of buffers also, it has given the shared hit is equal to 2. So we will see what are the different options available when you execute the explain. So this is the command which we have executed. The first option which you can see, it is analyze. So what it will do is it is going to be actually executing the SQL statement. So if it is just a select, it makes sense to some extent. But if it is insert, update, delete, so you have to be cautious, because just for testing purpose, wherein you are trying to find out what is the cost and the execution time, this may be disastrous if it is just for the testing purpose. Verbose, it is something which you would have seen earlier also. This is going to display the additional information on the screen when the execution output is there. So this will sometimes help you. Cost, this is something which is always meaningful, but not the thumb rule, wherein a small cost is the best optimized query. So we'll say cost, it gives the information related to the startup and the total cost of each plan node, right? By default, this parameter is set to true. Even if you don't mention this cost, it is going to show you the details. Verbose, it is false by default. Analyze is also false by default. This is important information which is related to the buffer. By default, it is false, and it specifies the number of shared block hit. You can say the read, dirtied, and the return, right? And for this, you should have the track IO timing enabled in your postgresql.conf. If you see there is a hit, that means the read was avoided because the block was there in the cache. And shared block contains data from the tables and the indexes. So that's how it actually buffer helps in you in some sort of identification. Wall and these things, I believe they are available from version 12, and they are available in 13. Timing also gives you some information. By default, it is set to true, because this is something which will be always available. Wall, it is set to false, so it includes the number of the wall records which will be generated. Summary, it will show you the summarized output. And format, by default, is set to text. And let us go back to the statement. So we just executed explain, analyze, select star from actor where actor ID is greater than 10. So table is something like this. We are not doing any tuning on this. This is just like, so we have some 200 rows in this, and we said explain, analyze, select a star from actor where actor ID is greater than 10. So it is going to do a sequential scan on the table actor. The cost is the startup, and this is 4.50. The number of rows which will be returned is 190. The width of this is 25. Actual time, which is a spent, is between 0.014 milliseconds to 0.133 milliseconds, and the rows returned will be 190. There will be just one iteration, one loop. And rows which are removed by the filter, since we have put a filter which is greater than 10, so 10 rows will be removed. Other than that, all our rows are getting displayed. So if we say planning time, it is 0.06, and the actual execution time is 0.28. So this is the time which is spent on planning, like how this SQL statement is going to be executed. So once the planning is done, then the execution happens. So this is how basically explain can be used. This is just the basic. This doesn't talk about the details, but this is just like how can you use the explain in your SQL statement to find out if there are some issues with the SQL statement, which can be rectified either by creating the index or removing the index or using some kind of hint or partitioning. So the two important factors in this will be the execution time and the cost. I hope this basic is going to help you. Thank you. Hello and welcome. In this session, we will see how to recover Postgre RDS admin username and password. I'm on the RDS console. I'm already logged in AWS RDS console, and I have in front of me the dashboard. And if I just click the DB instance, I should be able to see the DB instances which are running. So as of now, I can see there is one DB identifier which is available is database one. I wanted to connect with this Postgre which is running in RDS. So what are the informations which are required to get connected with the database? So I need the endpoint and the ports. I need the master username. And if I don't have the password, I need to reset the password. The first thing which is required is endpoint and port. So let's go to RDS console. I have already clicked the database one, which is the only database available in RDS, which is having the Postgre. So you can see the details over here. The engine is Postgre. In the connectivity and security, you will be able to see the endpoint. So this is the endpoint which I need to just copy. And since RDS, we cannot directly control to the operating system and we cannot connect to that. So what we need to do is, so we need to use the information endpoint and port, and we have to connect with some tool which can talk on these parameters. So we have PG admin, wherein if you just say create server, you will be able to establish the connection. So this is the name of the host through which we are trying to connect. So host name I have mentioned over here. The port name, if you see on the RDS, it is 5432. So we will go here and by default it is 5432. The next two information which is required is the maintenance database. So we have the Postgre maintenance database by default over here, and we will see there is a username which is mentioned over there. So what we need to find out from the RDS, like what is the username? The endpoint and the port, we have already seen it from the connectivity and security. You have to go to the configuration, and over the configuration, you will be able to see in the availability region, you will be able to see master username. Your master username is Postgre. So it's by default is coming Postgre over here as well. If there is some other user, so you have to put in that particular user over here. The next thing which we have to do is we have to enter the password. So how to enter the password if I do not know? So normally this happens when the service is transitioned from one customer to another. So what we will do is instead of working on the existing password, if it is nowhere used, let's go ahead and modify the RDS admin user's password. So we'll go and perform the modify action, and here you will be able to see what all actions can be done to modify the instance details. So this is specific to this particular RDS instance, which is having the RDS version 13.3 for PostgreSQL, and you will see it has prompted for new master password. So let's put in some alphanumeric password, something complex one. Put in from here, and I'll enter over here. I'll put the same details over here as well, and rest of the things will remain same because we just wanted to change or we wanted to reset the password for the admin user. The admin user name was uh, Postgre. If it is something else, then you have to use that particular user ID when you are trying to connect, and then you have to put it into the, and I'll just say modify DB instance. This might take some time to get refreshed, and we will see. Let's see the configuration. Okay, connectivity and successfully modified database 1. I hope we should be able to log in. Let's see the events, logs and the events. These are the different events which has happened, and let's see what has happened in the. Okay, we'll try to connect. It is still showing a resetting master credential, so we will wait at least for 45 seconds. Anytime you do some changes to the RDS, you make sure that you see the status. It should be available. If it is not available, you will not be able to connect. Though we have changed the password, we have given this as the password, but we will not be able to connect using the PG admin tool. If let me put the password over here. I've already clicked the save. If it is, it is still showing resetting master credential. Once it is available, okay, it is available, so we should be able to log in now. It should allow to log in us now. If the password is correct, if you have the ports open for from your local system to RDS, then it will allow. Okay, let us see what other issues may be when you are trying to connect. You just have to go ahead and check the security group. The security group should allow the connectivity from your local system. So what I have done is I'm trying to connect to the Postgre using my local system, and on my local system I have the PG admin tool installed. So what I will do, I'll go to the inbound rules, and I'll added the inbound rules, and I'll add my IP address of the system. So I'll just say PostgreSQL, and it has already taken port number 5432, and I'll add my IP, and I'll just say save to. Now let's try to log in. Now you are able to log in. So to connect RDS remotely from any system, in my case it was my local system. What I did is I had a tool, PG admin tool, which is a GUI tool to connect with the Postgre. So it requires your host name, which is your I'll show you over here. It needs the endpoint. So we picked up the endpoint information from the RDS. We picked up the port from there. We picked up the master username, and we have resetted the password. So just see it once again. So the first thing which you need to do is just go to the RDS. Locate the RDS instance wherein you want to get the information. So I just clicked the DB identifier. I just have one DB identifier, which is database one. The first thing which you have to pick up is the endpoint. So this is my endpoint, which is required to connect. And this is the port number. Then you have to go to the configuration. Under the configuration, you have availability. Under availability, you have master username, and master username is this one wherein you are going to connect. And after that, you have, if you do not know the admin user master user password, then you have to go here and just say modify. Under the modify, you have to give your new password, and then you have to just say save. Once you saved it, you once you save it, then the status will change from whatever action you have done. Let's say you are resetting the master user password, so it will show you master user password resetting. Unless it comes to the available state, it will not allow you to log in. And when I try to connect from remote system, in my case it is my local system, I need to make sure the security group of RDS should allow incoming connection from this. So that's the way you control the incoming connection from a remote host. And if you have any other information required, you can reach out. So here are the details on the screen. I hope this is going to help, and thanks for watching.
Welcome. In this session, we are going to do a migration of Postgre from one server to another by taking a backup using pg underscore dump all. But we are not going to transfer the file from source server to the target server since we do not have the facility of doing so. And we do have the dump size whose size is not very much. So I'll show you the server which we have, or probably I should show you the things on the notepad. So as a prerequisite, both the source and the target side, we have disabled the firewall and the SE Linux. We are able to connect the PostgreSQL from source to target and target to source. That means remote access is enabled on both the servers. And in the pre-migration phase, we have the source server whose IP is 192.168.113 and the target server is 116. The Postgre is already installed with the version 13 on both of them. So I'm going to log into the source. So this is the source. Let's quit, and I'm already logged in as Postgre OS user. Just say PSQL, list down the databases. You will see I have created 100 databases with the DVD rental 1 to 100. This is our source side. And on the target side, I'm able to connect using PSQL-U, that is capital U, the user is Postgre-H is the host name of the target, that is the IP address, and then -W. I'm just entering the password of the remote Postgre, and you can see there are 3 databases, and on the source side I have 105. So we have 102 databases which has to be transferred to the target side. So what we are going to do in the first phase is, there are few things which you can check it. So the first thing is you can check the size just to estimate how much of the storage might be required to take the backup. So one of the database size is 15 MB and we have 100, so it is 1500 MB, close to 1.5 gigabyte of storage for storing the backup. That's an approximate size. I'm not saying that this dump will be of that size, but this is the approximate requirement. And what we are going to do is you can list down all the users as well, the table spaces, the schemas, and other things. So the details are mentioned, you can use them and find. So there is another video also which is talking all about how we are doing it by transferring the dump from one server to another. In this case, we are not going to transfer, but from the source side, we are going to take a backup. So now what we are going to do in the migration phase is we are going to take a backup of all the databases. So on the source server, we are logged in, and we'll say pg dump all, direct it to postgre/backup/all.sql. So everything will be captured inside all.sql. So this may take a couple of minutes, and once this is done, we will see the next step which we have to do. So we are saying do not transfer the dump from source to the target. Okay, we are not going to do it. So do not transfer. So this is not going to be done. So what we will do is, this is the command through which we have created the databases and we have restored the DVD rental database inside the source server, and there are a few users which are also created. We are going to use this command just to be very sure what you are doing. So we are going to use this command on. Okay, let me see. Okay, this is done. So the backup is completed. What we are going to do is, let us go to my source, just refresh it, and you will see there are 100 databases with the name DVD rental underscore 1 to DVD rental underscore 100. Just I'm going to, okay, I just clicked this arrow and this is minimized. Now I'm just clicking 192.168.1.116. And if you refresh it, you will see the list of databases. And if you see the list of databases, it is just one database, which is the default database. So there are no other databases. So we have to transfer 102 databases from source to target. And we are going to use this command. Only the problem will be 100 times I have to enter the password. Okay, so let me, okay, I'm going to fire this command on the source server. In any way, we are not going to log into the target server at the operating system level. So we are just saying psql-u is the username. Where it has to log in, it has to log into the remote server, which is 192.168.1.1.6, and -w, you have to give the password. The only problem will be I will have to enter the password 100 times. This might be annoying. I should have done something else, but that's fine. Apology for this. I should have done something else. All right. Might be 10 or 11 databases have been restored already. Not a good way. I have already executed it. So I wanted this to go away. And very soon this will be done. This might be annoying. Apology for that. Okay. So not on all the 100 databases are restored because I have canceled in between. But if you see, you go to target server and just refresh, you will see we have restored the 40 databases, and after that just canceled. And let's, okay, we'll stop here. We will not do it because it's going to take some more time. But what we are going to check is, if I say /l on the target side, it will show you the databases which are restored. Oh, I think there are a lot which are restored. It is just 41 databases because I canceled in between because it has asked for the password and I didn't supply it. And you can see the databases are restored, and if you see the users, there are users also which are restored on the target. So it is quite possible to do the restoration on the target side without transferring the dump. If you feel the dump size is not very large, if it is a small, then it will be restored over the network. And if you have a good link and the speed of restoration is also fast, which depends on a number of factors, then this is doable for a small restoration. And you can compare the individual components, like on the source side and the target side. If everything is matching, that means now everything is fine from the migration point of view. I hope this is going to help, and thanks for watching.
In this session, we are going to learn how to launch an AWS EC2 instance and how to deploy a PostgreSQL instance on top of that. So what we are going to do is, since PostgreSQL is one of the most world's famous open source relational database, and the way it is growing up, it has taken the attention of all the cloud service providers. So if you are already there in PostgreSQL in your on-premises environment, there may be two options. Either you go for the managed service like AWS RDS, or if your applications are logged in due to some reasons, then in that case it is good to lift and shift. In that case, whatever databases you have in Postgre in your on-premises environment, you wanted to let the database run in same way in the cloud also. So you have the possibility of using the left and shift. So what we are going to do is we are going to launch an EC2 instance, and on top of that we will deploy uh, the binaries of PostgreSQL 13, and then we will enable the remote connectivity, and then finally we will try to connect it using some GUI tool. So just the basics of like why we wanted to be on the unmanaged service like infrastructure as a service or EC2 instance, so wherein we have to manage all the infrastructure which is related to the management of backups, patching, the patching of the operating system, and the databases and everything we have to taken care. Where in the managed service we have everything covered up, but because of the n number of reasons, the way it works is in RDS the SSH control has been taken away, and there is a lot of restrictions which has been imposed. And if you wanted to continue with the way you are working in your on-premises environment, you just go and use the database in EC2. So whether we are going to use the EC2 instance or the relational database service, it entirely depends upon the way the application works, and it is all the ask of application only. So what we are going to do is it is a 5-step process. We are going to launch an EC2 instance using the AWS console, and then we will try to log in it through the putty, and then we are going to configure the remote connection from the local system. Then we will try to connect it using the pgadmin and the command line interface. So let's quickly start up. So I'm already logged into AWS console. I'll say just launch instances. Okay, let me create an instance. So we are going to use the free tier instance. So the best way of learning and practicing the open source relational databases or the NoSQL databases is just go ahead and quickly launch some of the free tier EC2 instance or from some other cloud service provider, the lightweight virtual machines, and then you can log into that. Or if you have already some local virtual machines, you can use that as well. So I'm going to launch RHEL 8 system, which is in free tier, and that's more than enough. One virtual CPU and 1 GB of RAM. I'll just say next, configure instance details. We are going with all default settings. We are not going to get anything which is non-default. So everything will be default only. And we'll say next, add storage. We are going to use 10 GB of the storage, which is more than sufficient for our testing purpose. And then we will say add tags. We are not going to tag anything. Then we will say configure security settings. So this is very, very important if you talk about any relational database or any other database. You need to ensure that from where you wanted to access your system and what port. So one of the things we will be doing is we will be accessing the putty session using port number 22, and I'll be using my IP address. So, or you can mention the IP address of your system, so it will pick up that as well. So let us say my IP, and I'll add one more rule. This is for PostgreSQL. Once we install that, I wanted to allow the port of PostgreSQL as well, so that we can access it remotely. Let's go with I will try with those and we'll see how it works. and then we will say review and launch. I have already created a key pair. I'm going to use that. So I do have an access, and we'll say launch instances. It is not going to take more than 1 minute or so. Once it is available, then we will see how to connect with that. Still it is in pending state. It is still initializing. So once it is done, it is still initializing. So okay, we have all the details over here. We will go to the networking, or simply we can say action or connect. Still it is getting initialized. We'll try to access it using the putty session, and okay, this is the public DNS which we have to use. And let's go to the putty session. There's the public DNS, and we have to go to authority, and we have to give the location of the key. So it is ec2-user. Those details are already over here. So we are logged in. Now what we are going to do is we have completed the first two steps wherein we have logged in. Now one of the things which we should do is we should disable the firewall. So just say, I think I have mentioned the commands over here. Okay. SC status. So as of now it is enabled only. So we are going to disable it. So vi config, and instead of enforcing we will say disabled. I should have used sudo and just mention disabled. We might have to reboot the instance. Okay, this is done. The next step which we have to do is we have to download and configure the PostgreSQL 13 on Linux EC2 instance. So what you need to do is you need to go to this site, and there you have to select the Linux and the version. If you simply select that, it will show you what all steps you have to do. So these are the steps which you have to follow. I have already copied it on the notepad, so we are going to just run it off. So we have to use sudo to install the requirements of Postgre. It is just 5 steps. We are getting the repository for Postgre. and there are some default modules which are available, so we have to disable those. Just disable them, and then you have to install the Postgre 13 server. It's very fast. Within 5 to 10 minutes your EC2 instance having PostgreSQL will be up and running. You will be able to access it from your local system either through the command line or through the GUI tool. Whatever you feel is better, it will be ready. You need an internet connection to perform all these steps. This is done. Go to the next step, initialize the database. This is initialization of Postgre 13 server. Then we have to enable it so that after reboot it should come up. And finally we have to start the PostgreSQL server. What we will do is, so when you install the Postgre on your system, by default it creates a Postgre operating system user, and it creates a database also which is Postgre, and there will be a user also whose name will be Postgre. So let's switch to Postgre OS user, who is going to be the owner, and this is the command line psql, and there is a user also with the name Postgre. We have to change the password, so let's change the password of the user. We have changed it. Now the next step which we are going to do is we are going to verify if we are able to do the remote login on the same server. So it doesn't make sense when you have to say you have to log in on the same server with the IP address. So what we are going to do is so I'm logged in as PSQL. We'll say show config underscore file. So this is your postgresql.conf file. So we have to add the IP address of the system where this is running. So this is running on this, so we are going to add this. So we'll say vi. Okay, I'll show you from here. So by default, Postgre do not allow the remote connection. So anything which is on the local host, it will be allowed. So what we need to do is we need to change this. So we will say vi, and listen address we have to change. A listen address we are going to change, and we are going to make it the IP address of the system. And the IP address or the host name, we'll try with both, which one works fine. Where is the IP? Okay, here it is. There is a caveat using it, but just for testing we are doing this. We have added it, and the next thing which we have to do is we have to add the IP address from where you are going to access this. So there is a file which is called as hpa underscore pg underscore hba.conf, which is Postgre host based authentication. We are going to add that as well, and at the bottom of that we are going to say who all are going to access the system. So these are the virtual IPs of the system from where I'm going to use it. So you need to check out on which system you are going to log in. So it should include those. Okay, so I have added IP address. In your case, you have to add the IP address of your local system. This is done. So once this is done, you need to restart the Postgre server. I'll exit from Postgre operating system user, and then I'll say sudo systemctl restart. I haven't given the permission so that Postgre can restart it. So it is done. Now let's check the status. We'll check the status. I need to reboot the server because C Linux might create some problem. And we will try to log in through the host name from the local system. And I need the host name. So the host name is, where's the public host name? This is the public host name. We'll mention it over here. So if I simply say psql-u postgre and the password, which we have just set, you will be able to log in. But what if we have to mention the IP address or the host name of the system? It is saying this IP address, it should have been added in postgre hba.conf. So let me check if this is the IP address which is added or not. Okay, I think we need to reboot the system as well, and then it may work. Okay. Or we will try rebooting the system from here, and we will say reboot instance 194. Okay, let us reboot the instance. It is getting rebooted, and within a minute this should come up. I should have mentioned the IP address, sorry, the host name. Let us check the status. This is the public host name. We'll say restart the session. ec2-user. We'll say sudo su space -postgre. And let's log in. PSQL, it is not accepting, so that means it is still down. We'll restart it. Sudo systemctl restart, and then we will check the status. I need to use it from this user. So okay, this is done. Let's check the status. This is running. Now let's try to connect it remotely. So it will show us, this is my PG admin which is running on local system. So I'll say connect I'll go to create, and from here I'll mention the IP address. Let's see, public IP address is this one. The only problem will be if the ports are not opened, and in inbound rules that should be opened, or hba.conf that should have that entry. Okay, this is saying 122.80. This is not there in the hba.conf, so we are going to add that entry over here. So it should be in this format. So what we will do is sudo su space minus postgre, and we will add the postgre.hba.conf file. Go to the bottom and add this line. Let's restart the Postgre services. Check the status. Okay, this is working fine. And now try to connect remotely. Okay, we already have the connection. Just say OK. Um, 122. Okay, let me check. If config okay. One 122.80.200.23. So let me check. Oh, I missed one over here. So let's switch to Postgre user and added the file. This should work now. The IP address which I mentioned for host base access authentication, it was wrong. Restart the service, check the status, and retry the connection. It shouldn't work now. You are connected. So you are connected remotely. Your database is installed on EC2, and this is what we have done. So just a recap of what we have done is we have launched an EC2 instance, and we are trying to replicate a scenario wherein we have to migrate our application or the workload to EC2 cloud. In our case, this is just an open source relational database which is Postgre, which is still running on the older versions. The newer versions of the RDS support 9.6 onwards till 13, and 14.0 it's in the preview version. And this is what we have done. As a prerequisite, we should have then access to the AWS console. We should have putty and puttygen downloaded on our system. We should have a GUI client. In my case, it is PG admin. Then we logged into AWS console. We created an EC2 instance with RHEL 8 image, and then we connected it to using the putty. Then we downloaded the PostgreSQL 13 and started it. We enabled the remote connection. And the two important things which were here is postgresql.conf file, wherein you have to remove the local host with the IP address of the server. And then we have a postgre.hba.conf file, wherein we have to add the IP address of the destination from where you wanted to connect. So those IPs we have mentioned, then we have checked the status. And one of the thing in PostgreSQL is when we install Postgre or download Postgre using yum, it creates your Postgre OS user, and by default there is a Postgre database also, and Postgre um, uh, database user. Postgre database is also there. Sorry, so there are three Postgre, and Postgre OS user is the owner. And this is how we have done it. If you wanted to transfer the workload from here, it is the things will be almost same the way you work on premises environment. I hope it is going to help. Hello and welcome. In this session we are going to learn how to migrate PostgreSQL, which is running on premises, to AWS RDS. So these are the steps which we are going to follow. So we are going to do the migration of on-premises PostgreSQL server to AWS RDS to the PostgreSQL. So I have a setup already established, wherein I have a source setup wherein we will log in through the pgadmin tool, and it is already running on Linux server. On the target side, we are going to create an RDS and we will try to connect it using the pgadmin tool. So there are a few things which I have already performed for PostgreSQL on the source side. So what I have done is, on the source side, I have installed PostgreSQL 12. So using yum install, and this is the link. Then I have followed yum install PostgreSQL 12, then Postgres server, and then finally I have initialized the database, enabled PostgreSQL 12, started it, and now we are going to follow from here. So for the source environment, I'm already logged in using the MOBA Xterm. So let me show you that. So this is systemctl status postgre 12. So you can see that it is running. And on the source side, since this is our demo environment, we need to ensure that firewall and SE Linux, they should be in an appropriate way. So our firewall should be in the state of stopped. So I have stopped the firewall. You can see it is in the stopped status, and we will check the status of SE Linux as well. So this should be disabled, otherwise we will go into issues. So this is disabled. This is my source setup, and you and the default PostgreSQL user, we will give some password. So I have already changed the password of default Postgre user on the source side. So I have mentioned alter user Postgre password and given the password. And before we do anything, let's go and create the target environment, and then we will start from this step which says enable remote access of PostgreSQL 12, because by default Postgre doesn't allow the remote connection. So we need to make some changes which are already made. So I'll just explain what has been done so as your Postgre can enable the remote connection. So we'll go to the AWS RDS. I have already connected to AWS console, and we are going to create a database. So we'll say create database. You need to have the login details so that you can create it. So I'm going to create a Postgre database. So this session will also show you how you can connect to your Postgre RDS remotely. So there are few things which we are going to perform. So here is the version. So my requirement is, if you see the versions which are available, it is starting from 9.6 and it is ending at Postgre 13, which is the last available public release version. So you can see that it is available, and we wanted to take a lightweight machine, so we'll say just dev and test environment. In the settings side, we have to mention the database name. So we'll say RDS Postgre demo, and this is the master username, which is Postgre So we'll give the password, feed in the password again. I have kept the password simple, and we will choose the lightest weight machine. I have chosen 2 virtual CPUs and 8 GB of RAM, and 20 GB maximum storage, which I'm going to use. I'm not going to enable storage auto scaling. We are not going to create a standby instance. And from the connectivity side, we'll go with the default VPC, which is not recommended in production environment. Since this is a demo, so we are going with the default VPC, and we will try to access it publicly. The endpoints will be accessible from outside. So that's not a good thing, but just for this demo we are doing it. And in the additional information we don't have anything, so we are taking the default port, which is 5432. We have different types of database authentication, but we are going with the password authentication. But if you want, you can have one more layer of authentication, and you can enable the IAM authentication as well. If you have Kerberos, you can go with that also. In additional configuration, we are not going to give anything else that can be changed later on. So we are saying create database. So this is going to create the database. So once it is created, this is going to take 2 to 3 minutes. So once it is done, we have to check the remote connectivity. Since this is a RDS environment, so SSH is by default disabled. So you can connect through uh, the endpoint and the port with the relevant tool. In this our case, we will try to log in through PSQL or pgadmin tool. So this is going to take few minutes. In the meantime, we will come back to our step-by-step migration. And on the source side, we were discussing like we have changed the Postgre user uh, password to some password which we have given. Then we are going on the source side. It's all about the source side. On the source side, we have to enable remote connection so that other than localhost, somebody else can also connect. It is all about the application also. So on the source side, we will check the postgresql.conf file. So I'm logged in as Postgre user. Postgre is the database. Postgre is the OS user, and Postgre is a database also, and Postgre is the database also. So just be sure that you know all the three. So what we are going to do is we are going to check the postgresql.conf file, and we are going to check what is the listen address. So if you see the listen address, by default it will be localhost. So you need to mention the IP address of the host where your server is running, PostgreSQL server is running. Otherwise, it is not going to be accessed from outside. The next thing which we need to do is we have something called as pg_hba.conf, which is Postgre host based authentication. In this file, we need to add one line which will allow the application IPs or the set of IP address to connect to your source database using the password algorithm. So this is required, otherwise it is not going to be accessed. So these two changes are mandatory. You need to make it out. The next thing, and which IP address has to be feed in here. So it is the range of the IP address of your organization or your environment wherein you are working. And once these are done, you have to restart your PostgreSQL server just to ensure that all the changes are effective. So we are going to restart it, and we will check the status. So you can see that it is running, and these are the background processes which are running. Now we will try, if everything is fine, we should be able to connect. So what is the default way of connecting? You say PSQL, and you will be able to log in. But in case you wanted to get password authentication used, you have to mention this. So it is psql-u, which is the username, -h is the host name, and just press enter and feed in the password. So this is how you log in. The next thing which we are going to do is we are going to take a backup of all the databases on the source side. So we have a directory which is already created. So we are going to take a backup of all the databases over here. So before we go from here, we talk about the migration strategy in a relational databases system, or let's say PostgreSQL. So there are two type of migration strategy. One is online and other is offline. In online migration process, what happens? Your source database will keep on running and you have to transfer the data to your target environment, which is RDS, and your changes will keep on happening in the source environment because the application is still live on source, and whatever changes are happening, you have to capture that and you have to keep transferring them to the target side. This is one of the most difficult situation because your application do not afford to have downtime. So what you need to do is you need to have a mechanism in place so that your you can take you can create a replica on the target side in RDS, and your changes whatever are happening on the source side, they will keep on replicating. So there is something called as DMS, database migration services, which is provided by AWS. So you can use that service. So what that service will do, it will get the connection from your source database. You will have an admin user, you will have the source IP of the server, the user, which will be the admin user, and using the credential, it will connect to the source environment, and it will connect to the target environment as well, which is your RDS, which is getting created. Once the connection is made, what it will do is it takes a backup of your source environment in one shot and it will restore it over there. So there are a couple of types of migrations which are inbuilt in DMS. One is what it will say is one time. So we just take a backup and restore it over there. And another is keep replicating. That means whatever changes are happening. So that is known as change data capture. So whatever changes are happening, keep on transferring those changes from your source to the RDS. So that's also available. And the third one is both. Take one time and whatever changes are happening, keep on doing all those. So that is only that is good when you have an online application and they cannot afford to have downtime for this migration purpose. But in our case, since it is a small database, we are going to take a backup. So what this cloud provider suggests is if you can afford a downtime, you go with your native tool like PG dump or PG dump all. So you can take a backup and you restore it using the relevant tools in the target side. So the APIs are already exposed, so you can directly import into your target environment. The only challenge in the target environment is you cannot access the operating system. So either you have to use an intermediate operating system on your AWS side, you create an EC2 instance, and from there you dump all the backups and you execute PSQL from there, and you can do everything from there. And what is the most time consuming task will be when you take a backup, you transfer it to the EC2 instance, and from there when you restore it to the target side. Those are the time consuming activities. So you have to plan it in a such a way that whatever downtime is approved after the POC, you can perform it in that duration. So that's all about the migration strategies. In our case, we are going to take a backup and we are going to restore it. So we are going to find the size of the database. So what I have done is I have created, okay, it's all gone, or okay, you can see I have almost 100 database, and this is DVD rental database, and the size of each database is 15 MB. That means almost 1500 gigabytes megabyte of data is there. So it is just 1.5 GB. So it is roughly 1.6 GB. And there are 100 tables, so I assume this will be closer to 1.5 gigabyte. What you can do, you can list down the database name using like this, also using the catalog table. Or additionally, if you wanted to see the list of the schemas or the namespaces, you can do this. These are the things which you need to do in advance just to capture the informations. And you can list down the different types of objects which are available that will help when you perform the migration. This is the post migration things which you validate. And you can list down the users which are on the source side just to ensure that those users should be available on the target once the migration is completed. In our case, this is just one user, but you can create many and then you can see whether it is working or not. You can check out the list of the extensions which are installed, and you have to verify whether everything is available over there or not. So there is a lot of restriction in RDS for PostgreSQL, so you need to ensure that your application continue to work when you migrate to RDS. Now in the migration phase, we are going with the offline migration. We are not going with the online migration, which is DMS. So what I'm going to do is we are going to take a backup of all the databases on the source side. Let me see if the target is created or not. It is created. Okay, let's initiate a backup. So this is started, and what we will do is we will check the security just to ensure that it has proper security group for incoming and outgoing rules. So it is getting opened. We'll see the details. I have enabled the public connection just for this demo purpose. Inbound rule. Just added the inbound rule just to see what's there. I'm not going to save anything. So it is just we have selected PostgreSQL and 5432, and this should be the public IP from where I will be connecting temporarily. Okay, the backup is done. We will see it. It's very small backup, roughly some 350 MB or something like that. So what we are going to do now is we will try to connect to the target environment. So how we are going to connect to the target environment? Let's pick out the details of the RDS. We need the endpoint just to ensure that we have the correct endpoint, user ID, and the password, because we just enabled the password authentication. There are 3 types, but we are going with one only. Sometimes it is very slow. Just go to the dashboard and pick out the database. So this is the DB identifier, and we will see what is the um, where is it? This is the endpoint. So we are going to connect it through this. I will note it down over here so that we can test how it works. On the source side, I have a connectivity with the AWS RDS, or it has an internet connectivity as well. So we are going to test whether from the source side we are able to connect to the RDS or not. You can see we are able to connect to the target side from the source. And how do we identify? You can see the Postgre user, the RDS admin, which is the database available only on the RDS. So we are connected to the target side. Now what we will do is we will connect using the PG admin as well. So we'll create the server. We'll have to mention the um, endpoint. So this is the endpoint. In the connection, we will mention the endpoint. Just feed in the password. And if everything is fine, it should be able to connect. So you can see we are able to connect. So let me delete unnecessary connection. So I have deleted it, and this is my new RDS instance which is created. This is my Postgre default database which is created, and this is the RDS admin which is created by the RDS, and you can see you cannot access it. These are the restrictions which are imposed. So what we will do is the next step which we are going to, so we have everything done. Now we are going to import all the databases. So let's create the blank databases in case if it is required. Or let's go and fire the import. How we are going to fire the import? This is the commands. The only challenge will be, so I have mentioned PSQL-U username, which is the admin user -h. This is the target username, target database, which is RDS, then -w, which is the prompt for the password, and then press enter. And I have to find out a way wherein I don't need to give the password. So the first one it gave error is for the Postgre database, which already exists. So it is not going to recreate that, and it has started the import. I'm just feeding in the password because for every database it is prompting, but I'll find out a way. Okay, I'm not going to do it for the entire 100 databases. We are just, so every time I have to supply the password, otherwise I can put it in the password file. But let's quickly check out how many databases are imported. So you can see DVD rental is imported DVD rental _1, DVD rental _10. So this way it is going to import all the databases one by one. And what we need to check finally is the list of the things which we have done earlier, like what are the namespaces that are required, what is the database size which is imported, and the list of the users on the source side and the target side. You need to compare all of them. So just in a nutshell, what we have done is we have an on-premises source database which is on Linux. It is installed with Postgre 12, and we have a target which we created RDS Postgre 13, and we enabled the public access, otherwise that was not required in real environment. And then we had taken a backup of the source databases using pg dump all, and once we have the connectivity established, we imported it. I can continue the backup, but it is going to take a lot of time. So this will skip So I'll feed the password with copy and paste. I should have dropped the databases which I'm going to import it again. Otherwise, it is going to give me this kind of error wherein it is going to check each row one by one. Not a good way. So you have similar feature in DMS also when your replication breaks. So what you can do is you can drop all the databases and then you can uh, initiate it once again. This might be slower because the data is going over the internet. If I would have used an EC2 instance in the same zone, then the import would have been faster because it will be in the same environment. Here we have a connectivity between source to target over the internet. We'll try to import some 10 or 12 databases and then we will stop. The main challenge during such kind of migration is the downtime. What is the downtime which is approved? What is the size of the database? And whether the application is so critical that it cannot assume or it cannot go for the downtime. So everything has to be considered before you migrate the database to the cloud. So that's one of the limitation when we go to the cloud. The size of the database always play a big role, and you have to make your strategies accordingly so as to make sure that your database is migrated within an established time. So DVD rental 20 database is migrated. There's DVD rental 22, 23, 24, and at the 25, I'll close it. Okay, let us cross check how many databases we have imported so far. You can see there are 25 databases which are imported. Not all the databases are user databases. There are few which are system databases. The system database, these are the two templates, template 1, template 0. This is the database of RDS, and this is the Postgre default database which is created during the installation of Postgre. And by default here it is also available in RDS. And rest of the things which you need to check whether the users are imported or not. If the users are not imported, then you have to take a script from the source side and you have to import it on the target side. I hope this is going to helpful because we have done so. What AWS also suggesting is you use your native tools for Postgre. You have pgdump and pgdump, all which are good utility. You can use it according to your environment, and the migration should be successful. Hello and welcome. In this session, we are going to learn one of the most important topic in AWS, which is migration of database from on-premises to AWS RDS using a tool called as DMS. DMS is called as the Database Migration Services, and if you talk about AWS or any other cloud service provider, all of the service provider, whether it is AWS in this particular demo case, or if you talk about Azure, you talk about Google, most of the cloud service provider or almost all the cloud service provider, they do provide some sort of database migration tools which helps in migrating the homogeneous or heterogeneous database to the cloud. This is for the easiness of the migration so that the customer can easily migrate their own premises or other databases to the cloud. This particular scenario is related to migration of an on-premises PostgreSQL 13 database to Amazon RDS. Though there are, so if you talk about what is the preferred way of migration to the cloud, in this case, so if the downtime is affordable, you go with the native tool like pgdump or pgdump-all, wherein you can take a backup of your source database and you can restore it to the target environment. But we are not going to discuss about that. We are going to discuss about the DMS, which is database migration services tool, which has a lot of capability that can do homogeneous migration. That means I can migrate my PostgreSQL to the same version on RDS. That means the Postgre which is running on the source, and there will be the Postgre on the RDS. So I can do the migration. So in this tool, we will have a lot of features. One is one-time load. It is something like when we do a pg dump all and then we restore to the target database, we say we are restoring it at one time only. So we take a backup, we restore it, and we then the application is serviced to the new database which is on RDS. There are other cases as well. If you want your source database to be fully functional and operational, and you want the connectivity of the source database with the application, and whatever changes are happening, that should continuously replicate to the target database. In our case, it is RDS. In that case, the continuous replication will keep on happening in the background using DMS, which will take the changes from the source database and it will keep on replicating the target environment. So this is the main usage in our case, where in my source database, which is PostgreSQL, that is running and there is very little downtime which is provided by the application, so that we can switch over during the actual cutover, and rest of the things. So the initial load, the continuous change, data capture, so those things we have to take care using this particular tool. So as usual, we will shift to the notepad. So that talks about a lot about this AWS database migration services. So this is a tool which is available in AWS only. So it stands for database migration services. So the short form is DMS. What it is used for? It is used to migrate your on-premises or cloud database, which is in AWS, to the target in cloud. It can migrate your database in a secure manner, wherein encryption will be available, and it can do the transfer in a fastest way. Why are we using AWS DMS? The source database, this is very important. The source database remains fully operational. That means whatever changes are happening onto the source database, they will keep on happening. So you don't need to restrict your application to connect to your source database. It will keep on happening. So for the end user or the application, there is no change. The source database will remain operational, and we can minimize the downtime so that during the actual cutover, the database will be shut down once the replication is completed onto the target RDS, and then the switchover will happen. Which are the databases, or what are all databases does it support on the source side? So DMS can migrate almost all of the enterprise or open source database. If you talk about Oracle, you talk about MS SQL, you talk about the other relational database, you talk about MySQL, you say it is Postgre, MariaDB, and on the target side, so you have so many lists. So it mainly supports two things. One is the homogeneous migration. Let's say I wanted to migrate Postgre to Postgre. That is known as the homogeneous migration. It also supports, and that is the main usage of DMS. It supports the heterogeneous migration, where you can migrate from the different engine. Let's say I wanted to migrate from Oracle to Postgre. In that case, this is going to be extremely useful, and this is the main usage of DMS. DMS can do heterogeneous migration, so that is the most important feature, and that's why it is widely used, and that's used as a catching point to bring the customer to AWS cloud for the databases. So whatever databases, source databases they have, it can be used, DMS can be used. Only not the DMS will be used. There is another component which will also come into the picture, which is known as a schema change. So there is something called as a city. So that is used to schema conversion tool that will change from source to target side. Let's say I wanted to convert from Oracle to Postgre. In that case, that additional tool will be used. We are not going to talk about that. It is just a background like what all DMS can do. Apart from that, you can do a lot of things. You can replicate your multiple databases to the Amazon simple storage services, which is S3. You can put everything over there, and that's an scalable service which is available. One of the important feature of this DMS can be if you have multiple databases and you wanted to consolidate it, you wanted to put it into a data warehouse solution, something like Redshift. In that case, DMS is going to be extremely useful. So that is widely used. So this is one of the landing point for the AWS. So DMS is extremely used when you have to migrate your enterprise level databases to the open source database, and the backend it is just either MySQL or Postgre. If you talk about Aurora has two compatibility. One is MySQL, another is PostgreSQL. In case you wanted to migrate your Oracle database to the target environment, which is Amazon Aurora, then DMS is going to be extremely useful. Redshift, that is another example. If you wanted to migrate your terabyte of database which is running on Oracle to Redshift, then in that case also it is going to be extremely useful. So those things are available. So there are a lot of other things also available in case you have to do some heterogeneous migration. So that was just an introduction how about the DMS. When we talk about the simplicity, it is extremely simple. You are not going to change anything on the source database unless or until if it is a prerequisite. Let's say I wanted to continuously replicate the changes from source to target, be it any open source database, be it any enterprise database. So there are some prerequisites that has to be changed because you need to capture the transaction from the source database. I'm not talking about those, but other than that, there is no major change which is affecting your source database. You are not supposed to, or there is no scope for downloading of any driver or installing any application for migration. You don't need to download it. So everything will be there through the AWS management console. So once the migration is initiated, DMS will manage all the complexity of the migrations process which is included. So it is going to replicate the data automatically from source to the target environment. So there is something called as CDC, which is continuous data change. So that is something which is very, very important when you have to replicate the continuous data change from source to target. How DMS is going to reduce the downtime. So when you migrate your database using AWS, therein the downtime will be minimized. Why it is so? Because your source database will continuously running, and whatever changes are happening onto the source database, that will continuously replicate to the target database using the DMS tool, because it is going to do two things. One is it is going to do one time load, which is known as full load, and then it will connect to the source database, which is Postgre in our case. It will take all the changes and it will continuously replicate to the target environment, which is our RDS. And it has the capability of showing you the report as well, like in your source environment, these are the structures which are available, and the target, this is what has been replicated. What are the supported database for AWS migration? So AWS database supports almost all category of enterprise and open source database. You can do a lot of homogeneous migration, let's say Postgre to Postgre. You can do heterogeneous migration, which is from your Oracle to Postgre. Just giving an example. Or you, if you wanted to go to some Postgre compatible databases like Amazon Aurora cluster, or if you wanted to go to data warehouse solution like AWS Redshift, in that case also it is going to be useful. Or if there is something which is running on EC2 environment, so that also can be done. So the requisite is the landing has to be there in your uh, Amazon database services. So if you talk about any open source database, enterprise database, or NoSQL database, it is going to support almost all the flavors and the engines. What is the migration cost? The AWS database migration cost is very low because it is a migration service. If you do it manually, let's say if I wanted to migrate from Oracle to Postgre, though our this thing is not related to this, but I'm just saying in that case you have to use Aura 2 PG, which is sometimes difficult to set up, but not that. But in this case you don't have to do anything. There will be, you just have to spin up an instance which is called as DMS according to your requirement, according to how much of CPU and RAM you want. That instance will be initiated, and you can easily connect it to your source and target environment. The only prerequisite is there should be the connectivity between source and target. So what you have to pay for, you don't have to pay for the DMS, you have to pay for the DMS instance, which is back behind the scene. It is an EC2 instance which is a spin up. So whatever CPU, memory, or the storage you are consuming, that you have to pay. So you have the flexibility of doing one time or continuous replication of DMS. Let's say in our case Postgre, though it is not recommended, but in our case we are supposed to use the PG dump all, which is a native tool. So all the cloud service providers say if you have to migrate to the cloud, your first thing is, if you can afford the downtime, you can go for your native tool, and you can migrate your data from on-premises to cloud. But in case there is a requirement of continuous replication of the database from source to target, in that case it is going to be useful. And this is why it is meant for. You can do the data validation once the data is migrated from the source to target, and in any ways your source will remain untouched. When we talk about the reliability of the DMS, the two most important capabilities of the tool is the resiliency and the self-healing. So it will continuously keep on monitoring the source and target connectivity. So if there is some kind of failure, then it is going to report you that as well. It monitors the network connectivity between your DMS instance, source, and the target. And it is going to monitor the replication instance, which is going to perform on the replication. So in case there is an interruption in network, or in case there is some problem with your source or the target database, in that case it is going to stop over there, and there is a possibility to resume the task from there onward. So these are some of the greatest features of the DMS, why it is used for. So these are some of the use cases which we have already discussed about the homogeneous database migration. When we say about homogeneous, that means your source and target engines are same, or they may be compatible. So if you talk about when I have to migrate from Postgre to Aurora cluster, in that case both Aurora cluster, which is Postgre compatible as well. So that is a kind of homogeneous migration. In case if I wanted to migrate from Postgre to Redshift cluster, though Redshift is mainly used as a data warehousing solution, wherein you have to bring the data from large source of data, let's say in an Oracle, then you can use it. So homogeneous means it is the same engine, and they are very easy to set up. You don't have to do any schema changes because everything will remain same. The data types will remain same. The codes and other things, they are not going to change. So it is easier to do the migration when it is homogeneous database migration. The second type is heterogeneous migration, and that is the special use of the DMS wherein source and target database engines are going to change. For example, Oracle to PostgreSQL, and there is something else as well. So why we are talking about the heterogeneous migration, and not in this demo, in another demo we will see how to migrate Oracle to PostgreSQL. So why it is so important? Like DMS is one of the solution, because DMS is going to convert the schema, it is going to convert the data types, also it is going to convert the database codes of the source and target, and the main task will be the conversion part. So in case there are heterogeneous migration, which is the main usage of DMS, along with the CDC of homogeneous environment, there will be one more tool which will be added to this, which is known as SCT, schema conversion tool. That is the first tool which will come into the picture, that will do all the code changes, so that source Oracle to target PostgreSQL schema changes will be done. And then using the migration service, which is DMS, we will load the data from source to target. That may be one time, and there may be the continuous data change capture as well. So that will also keep on replicating. What is the prerequisite? The source database may be on premises, which is actual requirement, or it may be in the AWS as well. But your landing position should always be the AWS. Otherwise, it is not going to identify it. The database consolidation is one of the most important use case in case you have multiple small databases and you wanted to land into AWS, one of the database, let's say in Postgre. Then in that case also it can be used. So either you can go for the homogeneous migration. Let's say I have around 100 small databases ranging from 1 GB to 10 GB. Then DMS can be used, and you can land all your 1 GB to 10 GB of database from source to target. So you have consolidated everything into the AWS PostgreSQL. And or there may be heterogeneous migration wherein you can consolidate your small databases or big databases as well, big size databases from your on premises or your AWS cloud database, or which is running on EC to the landing position in AWS RDS. So those cases also it can be hugely used. One of the greatest feature when we talk about the continuous data replication, because nowadays business is running 24 by 7, and it's very difficult to get the downtime, because business always wants the continuous access to their application. That means your database at the back end will keep on having the data changes, and there will be very difficult to get the downtime for a bigger migration. In that case, when we talk about the DMS, so there are two things. One is the initial load, which is a full load, followed by a continuous data replication, wherein data will keep on replicating from my source to the target. And DMS is going to be extremely useful when we are migrating and using this feature from source to the target. So how we are going to migrate on premises PostgreSQL database to Amazon RDS for Postgre. So the point of discussion is on premises Postgres source database to RDS for PostgreSQL. There are two options which are available. One is AWS, which is the point of this discussion. Second is the PostgreSQL native tool. You can use your PG dump, you can use PG restore or PSQL, or some third-party tools are also available. You can use them. So what do we need is to perform this migration using the DMS. I should have an active AWS subscription. I should have an access to the source database. I should have created a target RDS instance where in my database is going to be migrated. When you are going to use the RDS, you have the limitation of a maximum of 64 terabyte of database. So you need to consider this. And one of the biggest drawback is you don't have the access to the operating system. So you need to consider in case your application is picking some of the data or dumping some of the data on the operating system of the on-premises source database. What are the products versions which are supported? It is supporting from 9.5 to 13th, which is the current working Postgre version, and 14 is in preview state. Source database, it can be on-premises PostgreSQL. For our demo, we have created it on EC2 instance, and we are going to see it. The target environment also we have created it on RDS, which is PostgreSQL. And what we are going to use the tool which we are going to use is AWS DMS. We are not going to use pgdump, pgrestore and PESQL because our requirement is this is something which I have taken from AWS site, which talks about what are the prerequisites that we should do. So you should validate your source and target database version and the engine. So in our case, it is PostgreSQL 13. I have created it on source. You need to identify the hardware requirement for the target. That depends upon what is your source database usage for CPU, RAM, and the memory. You have to identify the capacity management as well. You have to properly manage the network requirement. You have to identify the security requirement for your source and target database. And you have two things. One is your native tool. We are not going to use that. We are going to use the AWS DMS. I'm repeating everything so that we understand what we are going to do and what are the different options available. AWS migration we are going to do it's using the AWS DMS for what is the best usage of this. So we are going to use it for the minimum downtime. It can support many database engines, and finally you have to migrate your applications once your database is migrated. And now we'll see the demo. So most of the part I have already done it, because if I do it right now, it is going to create a lot of problem. And what I mean, it is going to have let me put it over here. Okay, this is really time consuming. The first thing which we are going to do is we have created an on-premises equivalent source database. So I have already created an EC2 instance PostgreSQL 13, which I have already installed, and here what I'm connected to. So if you go to ESQL, and you simply say /l, which show you the databases. So I have DVD rental underscore 1 to 100 databases. We are not going to migrate all of them. So there is a separate, we can see it how to do this and migrate to EC2 instance. This is my source database, and I have made a connectivity with pgadmin as well. So this is my EC2 instance. If I just simply refresh it, you will be able to see I have 102 databases available over here, and we are going to migrate one of the schema of a particular database to the RDS using DMS. And if I show you the details of the EC2, this is something which is really very important. DMS, anybody can launch and do this stuff. The only challenge will be how do you control the security. If you are not able to configure and control the proper security, you will always face the problem in terms of the connectivity, and that's sometimes really time consuming when you talk about those things. So what I have done is I have launched an EC2 instance on an EC2 instance of RHEL 8, and I have installed Postgre 13 on top of that. And then to connect it with my local system, what I done is you have to go to the security wizard and there you have to do. I'll tell you what are the things which is supposed to be taken care. So you always see the inbound rule. In the inbound rule, you have to say, I want access of this EC2 instance using port number 22. So you have to enable SSH, and you have to mention the IP address, to which IP address you want to give the access. These IP addresses are dynamic IP address. They will keep on changing. So if you try to access that, they will never be accessible. So on port number 22, from this particular IP address, I'm trying to access this EC2 instance, so I'll be able to do. The second thing which I should be doing is, I need to access PostgreSQL port, which is 5432 from my local system. And once you add these two to inbound rule, you should be able to access it from your local system, whose IP may be something like this. And one of the other thing which you have to do in over here is, you need to go to pghb_conf. Here also you need to mention the IP address from where you wanted to access your EC2 instance or your on-premises environment. These are the some of the basic things which you need to take care, otherwise you will not be able to access it. So this is all about the source environment. Let's go to the second step. So this is very important. On premises or EC2 instance where your Postgre 13 is running, make sure the security group inbound rule allows the IP address of your system from where you are going to access it, and pg_hba.conf, that should have the IP address of your from where you wanted to connect. When you talk about the RDS PostgreSQL 13, it's the launching is very easy. There are just few clicks wherein you have to click it, and it will allow the launching. What is the most important part? The most important part of the RDS is as well. Once I'll show you where is our RDS. Let's go back to the RDS. Sometimes it is very slow. This should be coming up any moment. Okay. So this is an DB instance which I have launched in RDS. So if you see the details, it is PostgreSQL engine. I have used a DBT3 micro, and 5432, which is the default port. This is the host name, and the security group. This is of utmost important. You need to make sure that the security groups are properly handled. Otherwise, rest of the things are just few clicks and the instance will be launched. So I'll show you what is that important part in your inbound rules. So always control your inbound rule and outbound rule based upon your requirement. So inbound rule, I wanted to access my RDS instance from my local system. So I have mentioned the port number, the PostgreSQL port, which is 5432, and the IP address of my local system, so that using PG admin I should be able to connect. So I'm already connected to the RDS instance. If you see here, if I just say refresh, there is a system database which is called as RDS admin. So you can see that I have already connected it through the RDS instance. The only requirement is you need to control your security group. In our demo case, it is publicly accessible, but that's not the requirement in actual. Then the third thing which you need to do is you have to connect both the instance using pgadmin, which we have already done. Now you have to spin up DMS instance for the replication purpose. So what you have to do is you go to the AWS DMS dashboard, and Here you will say create database migration. Sorry, where is DMS instance? So this is what you have to do. This is the first thing. After you have created two instances, one is my EC2 instance, which is my source environment, assuming it is synonymous to my on-premises PostgreSQL server. Then I have created the RDS environment, and I have connected my source and target using the PG admin. Then we have to create a replication instance. You just give some name and you give some class as well. Maybe we'll do a small demo after this, wherein we will try out those steps in a very fast way so that you can follow it step by step. So you just have to mention the details and then it is done. Once you have launched your DMS instance, just note down the public IP and private IP. Once it is done, you have to create the endpoints. When you create the endpoint, the first one will be your source endpoint. In the source endpoint, you will have to give the name of your source environment. So let me show you. So you have to mention, so if you go here, probably I'll do one so that it will be easy to um, validate it. Let me show the modify page. Then you have to, so once you say create endpoint, it will show you two options, source endpoint and target endpoint. The first thing we wanted to connect to our source database, which I'm assuming it is on my on-premises environment, but for our case it is EC2 instance. So I have given some identifier like it is EC2-Postgre 13, or otherwise in normal case it will be on-premises Postgre 13, or you mention the server name, something like that. The source engine, what is my source engine? My source engine is PostgreSQL, so I have given the name. Provide access information manually. What is the server IP address? So this is the server IP address or the host name. So you manually give the IP address over here. Mention the port name. If you wanted to use SSL mode, which you should, but in our demo we are not doing it, just say none. And mention the admin user. For our case we have said Postgre. Password will give to the Postgre, and which database you want to connect to. We are going to connect to DVD rental because we have some 15 tables and we want to migrate DVD rental sample database from source to target environment. Endpoint settings, we are not going to do anything, and just save it, and your this thing will be created. Once it is created, you can test the connection. This is something which is time consuming, and this mostly fails because of some kind of security guidelines if you are not following. So you just have to do the run test because it is going to check whether your source endpoint, that means an endpoint, can connect to your source environment or not. If it is not successful, that means your migration task will not start. This is a prerequisite. And what is the guideline which you have to follow? The security group of your on-premises environment, or in our case EC2 instance, that should allow the incoming request from DMS. So if we go to EC2 instance, we have to mention the IP address. So this is the IP address of my DMS environment. I am saying on 5432 allow the IP address of my DMS so that it can connect. So in the inbound rule of your EC2 instance, you should have the incoming request of your DMS IP, because DMS is going to connect to your PostgreSQL source database. So this is mandatory, otherwise it will show you a number of errors. So our connection is successful, that is fine. That means our source stuff is fine. Now let's go back to the other. uh, if you check this, we are going to create the another endpoint, which is our target endpoint. So there are two bullets, so you just select target endpoint, and then you mention the name, some usable name, sorry, some meaningful name, so that you can identify. You have to mention the target engine. You have a lot of target engine, but in our case it is homogeneous migration, Postgre to Postgre, so you have used Postgre. Then we are going to provide the access information manually. This is the host name, or public host name of my RDS instance. This is the port number. We are not using the SSL mode. This is the username, which is admin username Postgre. You have to feed in the password, and this is the Postgre. Endpoint settings, we are not doing anything, and just you say save, and it is done. Once it is done, you have to do the connection. You have to do the test connection. You have to run the test, otherwise it is going to fail. Why it is going to fail? You have to have the security group of RDS, ensuring that it is. So let me show you the RDS security group. If you go to the RDS and you check the security group of your RDS instance, you will be able to see the details. And this is going to be very important, very critical. Otherwise it is going to take away a lot of your time just in troubleshooting. Just go to the DB instance which is of your interest. In our case we have just one. Just click this. On the right hand side you will be able to see the security group. So this is my default security group. Just click this, and I forgot the name. What was the name? Okay, this is already selected. Just check the inbound rule. What is the important part in RDS security group details? So you have to add when you say add rule, in the add rule you have to say PostgreSQL, and you have to uh, add the IP address of your DMS. You have to add the IP address of your DMS, otherwise it is not going to work. This is very important. The IP address of DMS has to be added on both the places, on source and the target side, because DMS is the one which is going to talk to both source and target. So inbound rule should allow the IP address of DMS on both EC2 and RDS. So that IP address should be available over there. And here also in RDS, you need to make sure the IP address is added with the port number. And if you are trying to connect from your source, from your system, the IP address will also be mentioned over here. So that's very important. And one of the most important thing is, if you see some kind of issue, then you need to check the IP security group of your replication instance. So let me go to the replication instance and show you how the security group looks like. This is the security group. You have to just check the inbound rule. Where it is gone. I think this is the one, DMS security group. And now This is the replication instance, and in the replication instance, just click the replication instance. This is just what do you say, the EC2 instance only. And this is your sorry, this is your security group. So this should come automatically. You can see the outbound is like this. I'm not sure if I'm checking the correct one. So the endpoint public IP and the private IP, you need to make sure you have it. And when you are connecting to the RDS, they have to be properly taken care of. Otherwise, it is going to fail out. The final thing, we have created the replication endpoints. We have tested it, and then we will go ahead and initiate the migration task. I have done this earlier, so let me go to, this is my target environment, and let me drop, where is the schemas? Let me drop this. This is dropped on the target side, so we'll go ahead and initiate one migration task. I'll show you step by step so that it will be easy to follow, since this will be becoming very large. So I thought using it whatever I have it. This is my replication task. So let me show you how it looks like. So you simply say create migration task. You have to give the task name. So I'm just saying task 2 EC2 to RDS PostgreSQL 13 migration, something like that. You can say start task on modify. So once it is modified, uh, you just say save, and it is going to execute. So what are the different things which are going to happen when your migration starts? So it is going to target table preparation mode. Is that if the tables already exist, don't do anything. If it exists, drop tables on target. So it is going to drop and then recreate it. Otherwise, if data is already there, you wanted to truncate it, it can do that as well. If you have the LOBs, then if you say I don't want to include the LOB, or if you say I want to load the full LOB, that is also possible, or you wanted to limited the LOB, that is also possible. You can do the enable validation part, wherein if you wanted to say uh, choose the setting, if you wanted to DMS to compare the data at the source and the target immediately once it is performed. After the full load, it can be done. It will show the report in your S3 bucket, like this is what has happened, and this is matching, this is missing. You can create the AWS migration logs as well, and you will see the different kinds of the alarms which will be created. Once it will show you the error warning, default debug, or detailed debug, these things. In our case, it is just a demo, so depending upon your requirement, if you have a number of objects which needs to be validated, you make sure that you enable the validation. If you wanted to do some kind of table mapping, let's say on my source it is A, on target it wanted to be something else, then you can do that. Now this is the first thing which starts. Enter a schema. If you have multiple schemas, if you wanted to migrate all of them, you just mention percentage. That means it is going to pick up all the schema. So other than a schema, you don't have anything. In particular schema, if you have the all the tables, you just include percentage, or if you say include, it will allow you to do those things. It has the transformation rule as well. If you wanted to modify something on the target side also, that's possible. So you just simply say save, and the moment you do it, it is going to start your migration. So in our case, we have done the full load, but we will be doing the full load plus CDC as well, and only CDC is also possible. So it is going to, it is running. So this is mainly 5 steps only. If you are able to control your what do you say, the just the security groups, and most of the things will be working fine. This should not take more time. It depends upon the amount of the data. For our case, it is very less, so it is not going to take more time. Any moment this will show that it has let's say load complete. I think initiated again. So I have initiated again, and I have clicked the drop and recreate, so it is going to drop and recreate. And if you connect to this, we have only one schema because it has already dropped it, I believe. So you will not be able to see second one, but the moment it comes up again, it will come up. So let's wait for couple more, maybe another 1 minute or so. This is starting. So just a recap, there are 5 steps available in this demo. Maybe we'll do all the steps by launching. Maybe that is going to take 2 hours or something like that. In the first step, we created an on-premises equivalent EC2 instance with Postgre 13 running. We imported one sample database, which is DVD rental. Then we connected to PG admin, and we ensured pg_hba.conf as the IP address of the system where you want to connect with, so that you can easily visualize your database. So that is one thing. In the second part, in the second step, we initialized one RDS instance of Postgre 13. We noted down the endpoint, and in the inbound rule, we have added the IP address of the system from where we are connecting to, and the DMS IP address as well, so that it is easier for us to make sure that we are connected. Then in the third step, we connected with PG admin, and in the fourth step, we launched a DMS instance, which is a EC2 instance having the conversion tools, the DMS tools. And in the fourth step, we launched the source endpoint, target endpoint, and we finally launched a DMS instance task. The task has the details of the source endpoint and the target endpoint, and finally it replicated the data in one shot, which is just one time load only. So I think it should have come back now. Still, I think it is running. Okay, this is done. We'll see the details. Table statistics, you can see what all tables were migrated. So it is customer, payment, film actor, store, city, and these were there in your public schema. And let us see, we should have dropped it there as well. Okay. There are some validation failures as well. Refresh. I think I have dropped that table. If you go to the source environment, you should be able to see the tables. In my DVD rental, you have the public schema. In your public schema, you will be able to see the tables. So these are the tables which have been loaded from source to target. There is no end of this thing. Maybe in second demo we will see step by step launching everything. That will be of 2 hours or something like that, and I think hopefully that will be helpful. And thank you. Welcome. In this session, we will see what is DB parameter group in Postgre, which is deployed in an RDS instance. So we'll say it is a managed instance which is running in RDS for PostgreSQL. So we'll talk about what is DB parameters group in Postgre, which is running in RDS. So when you talk about the parameters group, we talk about the different types of configuration file. By default, when you create a Postgre in an EC2 instance or on premises, you have configuration files. So by default, they will be available in your data directory. And if you try to navigate to that location and just search with anything ending with the word .conf, you will be able to see that. But the same is not true when you work in RDS instance. You do not have the access to the operating system. So basically, you cannot modify the different parameters which are there in PostgreSQL.conf. So what happens in that case when you do not have the access to the file onto the operating system? AWS RDS has made a very good way to tackle that. So they have called it as a parameter group in Postgre or any other RDS instance. So what you can do is you can go and change the settings in the parameter group. Basically, it is set of the configuration files which you will normally see it in your PostgreSQL.conf. So by default, they have defined it for Postgre 10, 11, 12, and 13. So whatever Postgre instances they are available in RDS, a predefined, pre-configured parameter group is available for all the PostgreSQL instances. And the different parameters which are mentioned, they are dependent upon the engines which is there, the compute class, the CPU, and the RAM which is available. So these configuration parameter files, which is called as the parameter group, may not better fit into in your setup. So what you can do is you can create your own parameter group. So basically, it is saying like instead of changing the parameters in PostgreSQL.conf, you create a new file wherein you can replicate the data from uh, the uh, the parameter group, and you can modify according to your requirement. So basically there will be a template which is available for each version instance, and you can take the data from there. There will be some of the parameters which are static in nature. There are some of the parameters they are dynamic in nature. It is like your PostgreSQL.conf parameter file, wherein some of them will be dynamic, some of them will be static. And when you associate a new parameter group to a DB instance, the whatever the modified and the dynamic parameters, they will be applied only when you reboot your instance. So if you see any abnormal behavior, you must check what are the different parameters which you have changed in your new configuration file. So in a demo, we will see how to create a new parameter group for PostgreSQL. Before that, let's go to the RDS. So this is my RDS screen on AWS console. Let's go to DB instances. I have PostgreSQL RDS instance, which is with this identifier database -2. I'll just click it. And in the configuration, you will have to navigate over there and you will be able to see there are two things. One is the option group, which is not valid for your Postgre, but there is another term which is used over here is parameter group. Parameter group over here, basically, it is your PostgreSQL.conf. So instead of giving you the access to the operating system, which is already taken away from you, so what they have done is they have created a parameter group, and you can create your own parameter group based on the template which is provided for the each instance, and you can modify the value according to your requirement. So this is another way of tackling the parameters which is there in RDS instance. So what we will do is, if you just click this, it will take you to the to over there. So before doing this, what we will do is, on the RDS screen, you will be on the left hand side, you will see there are several tabs. So one of them is parameters group. So if you just click it, it will take you the list of the different parameters group which are available. So anything which is started with the default, this is the default parameter group which is available, and this will be assigned to the particular Postgre instance which you are going to create. So the one which is of our interest is this one, uh, default Postgre 13. So when you create or when you launch a Postgre RDS instance, by default this will be assigned if it is Postgre 13. So what we will do is, in the first demo, we are going to create a new parameter group for Postgre 13 RDS instance. By default, there is a default parameter which is given, but we don't want to take that because we wanted to modify some of the parameters. So, and we cannot do it for the default one, so we are going to create a new one. So I'll select Postgre 13. This is the parameter group family. This is type is DB parameter group, and I will say this is my uh, Postgre 13. So I will name it PG13 for dev environment. Basically, it is like you are copying the contents from the existing PostgreSQL.conf parameter. Not synonymous, but just to understand, you can do it like this. So we are going to create it. You can see that it is created. So what we can do now is, you have different actions which are available. So uh, you can uh, delete it, you can reset it to the default value, you can compare it with the existing one, you can copy it, and you can edit it. So what we will do is, we will go to the dashboard now, and we wanted to assign the newly created, let's go here to the DB instances, click this one, and basically what we wanted to do is the default parameter group which is available, we wanted to replace it with the new value. So we'll say modify, and let's see what all options are over here. It takes some time because it has to load, it has to pick up the new values, and for all the static and dynamic parameter, when it is you are updating it, your instance has to be rebooted. So you need to continuously check the status of your instance. And we are connected to this particular instance 13.4. This is database identifier. We don't want to change the password. You can see the storage details and other things are available over here. And subnet group, database authentication, additional configuration, you have the DB parameter group. Instead of using the default one, I wanted to change it with a new parameter group. which we just created. So it is just like a copy of your parameter group, existing parameter groups. We'll say continue. And if you scroll down, you will be able to see it when to apply these modifications. That means the new postgresql.conf file. It is just to understand how, if you have already worked on the on-premises environment or virtual machine which is running in a cloud. So either you say apply during the next scheduled maintenance window, or you say apply immediately. So the modification in this request and the pending modification will be asynchronously applied as soon as possible, regardless of the maintenance window. So we'll say modify DB instance. It is getting modified, and you'll be able to see some of the things over here. Okay, let me refresh it. Let it come to a point wherein we can refresh it. So you can see the status over here. If you see the cursor, you can see the status is still modifying. This is a very lightweight machine, which is T3 micro. It is still in the modifying phase. And once it is available, we will see. Okay, it is still modifying. And then we will see some of the scenarios where we are trying to attach it, and we will see how to modify the parameters in DB parameter group. This is still modifying. So one of the thing is, does PostgreSQL in RDS has a postgresql.conf? Yes, it is. That's the basic thing. And if you check the status, it will show you some status as well, like where it is available. But the only thing is you will not be able to access the operating system. So there is a separate way which is given to attach. That is basically to create a new configuration file, modify it, and then to make it happen, to make it applied, you will have to reboot your instance. Let's click over here. This is still applying. So status is available now. And now this should open a new window. Okay, you can go to the configuration page now. And in the options group, you will be able to see the default one. In the parameter group, you are able to change it to the new parameter group which you have created, which is PG13 development environment. It is clearly showing it is pending the reboot. That means to make it effective, you go ahead and reboot your instance. So we are rebooting our instance. It is getting rebooted. So you can see the status over here. It is rebooting. It is something like wherein you have made some changes to your postgresql.conf, and if you are on a Linux environment on RHEL, you will simply say sudo systemctl restart and the instance. Let's say if it is PostgreSQL-13, you will do that. It is synonymous to that. So it is easier to understand if you would have worked in on-premises or a virtual machine which is running in cloud. It is rebooting. Okay. The status hasn't changed. It is still okay. It is done now. And if we click it now over here, we will be able to see What's happening behind the scene? The status must show ready for the configuration file, which is our parameter group. Let's go to the configuration and see what is the status now. Your parameter group is in sync now. Let's go to the next demo, what we are going to try to do. We have modified, okay, we haven't modified the parameters in parameter group. So what we will do now is, let's click this parameter group. So it is something like you are trying to edit the parameter group. So let's uh, uh, mm, okay, edit parameters. Which one? Okay, let's change the analyze scale factor from 5.05 to 0.10, and just save the changes. It is saved. Let's see the preview changes. The current value is 0.10, which we have already saved it. That's why it is showing it like this. And let's go back to the RDS instance. It is still modifying. If I say in a very basic layman language, like you are trying to edit the, you have made the VI editor command, and you are just replacing some of the values, you saved it, and now you are trying to come out of this. Still it is showing modifying. Let's wait a couple more, not minutes, maybe in another few seconds, this should come out. Okay, still it is modifying. While it is doing its job, we'll go to the parameter group and we will see what is the status mentioned over there. Though we see the status over here is available now. Let's go to the configuration and see what is over there. You can see it is in sync with this, and it seems to be working fine now. Let's see what is the next thing we can do. We'll check the status. It should be available. All right. We modified as well, and then how can we reset the parameters group to their default values? So let's again go to the RDS, and on the left hand side you will be able to see the parameter groups. In the parameter groups you will be able to see the group which we have created. We created this group, and if we just say edit parameter, and if we say reset, Are you sure you wanted to reset below parameters DB group? So it is like 0.05. Do we change it to its double of the value? Let's say 0.05 to 0.10. We wanted to revert, so we'll say revert parameters. This is just for some temporary testing. We did all this, and then we are just saying, okay, we already saved it. We can go back to our RDS dashboard and we can see what's happening onto the parameter group which is applied and wherein we have reverted the value. You can see it is modifying. So back behind the scene, it is just doing some updates, making the changes, and wherever after making the changes, reboot is required, you have to do it. And we can copy a parameter group also instead of starting from the scratch, and we can list down the parameter groups values as well. Still, it is modifying. I'm connected to this Postgre RDS instance. We just wanted to see how the configuration file looks like in Postgre RDS. Still, it is modifying. It is sometimes very annoying, but that's how it works. It is available now. What we will do now is the configuration file. You just will see show continue. You can see that when I executed show config underscore file on an RDS instance, which I am connected through pgadmin GUI tool, it is showing me that the configuration parameter file, which is postgresql.conf, is being stored at, or it is located as RDS dbdata slash config slash postgresql.conf. Let us see how your HBA file is located. So again, it is located in RDS DB data. You do not have the access, but through the query you can see it. And what are the different values of the configuration file? You can see it through the PG, select star from PG underscore settings, and you can see all the parameter files. What are the different values which are available? And so we have close to 353 parameters in your RDS Postgre 13. The same command I'm going to run in an Postgre instance which is running on a virtual machine. So 353 values were there in RDS. Let's see over here. And if you scroll it down, you have 329. That means the configuration file which is there in your default installation or local installation, it is different than what you have, at least in the number of counts. And the different parameters are tuned according to the managed instance requirement. Let's say the CPU which is available on a particular managed instance, the RAM, and the storage. I hope this is going to help. And in case you need any clarification, you can. Hello and welcome. In this session, we will see what is an option and parameter group in PostgreSQL, which is deployed in RDS. So when we talk about the PostgreSQL, let us assume it is on premises or EC2 instance. The way it behaves is the configuration is mentioned in postgresql.conf. But in case of managed instance like RDS, wherein Postgre is available as a managed instance, in that case, you do not have access to postgresql.conf file. So the parameter will be available as parameter groups. So we have two terminologies which come into place. So when you talk about Postgre as a managed instance in RDS, one is the parameter group and another is option group. Parameter group contains the postgresql.conf parameters, wherein you can create a new configuration parameter file from the existing sample of uh, each instance which is related to your particular instance version. Let's say Postgre 13, you have a different template available for parameter group, and so is available for the others. But what if I need something else apart from the parameter group? So RDS has provided an option for the options group. So any additional feature which you want, and if it is offered by the RDS as a managed instance for PostgreSQL, then you need to use the options group. And this is available for all the managed instances. But in case of Postgre, this value is not available. So if you go to the RDS instance, you have two things. One is the parameters group, and let's say if I wanted to see the value of the default Postgre 13 parameters, I will be able to see it the way we have seen it in the previous demo. So we have the options available. But if I wanted to see what all is there in the options group, you will not be able to see it for the Postgre 13. Let's say if I just select the default Postgre 13. So you can see it is just the ARN name is mentioned, the option group name is there, the description is there, but there is nothing inside that, right? We do not have anything over here. So what you can add is just the tags in case of the options. So basically, there is no concept of options when you talk about the Postgre in RDS. Then why we are talking about it? We are talking about it because we have something else other than this. If you go to the PostgreSQL, and let's say I am already connected to one of the RDS instance, here it is. If I wanted to see the parameter options, I will be just saying select star from pg underscore settings, and this will show me. So there are two windows. Let me see where it has gone. Okay, these are the values which are available in your postgresql.conf, or in case of Postgre RDS, we say this is the parameter group. The another is option groups. So option group is not available in case of Postgre at RDS. So any additional feature or the new feature in case of Postgre we call is as extension. So if you wanted to see what all extensions are available in your Postgre, so you will simply say pg underscore available underscore extension. These are the extensions which are already available in case of Postgre, which is deployed in RDS. If it is your on-premises or EC2 instance, you have to deploy these additional extensions yourself. But in case of RDS, they are available. So if I say options group in Postgre at RDS, there is nothing like that. It is just blank. It is a blank template only. Since it is being offered for all the RDS instances, that's why a blank instance is given, but a blank options group is given. But if you wanted to see more about the extra features which you can avail in case of Postgres, so they are available as extensions. So you will simply say select start from pg underscore available underscore extensions, and this will show you how many extensions are available on your particular Postgres instance. So we have RDS Postgre 13. So these are the different, if you can see over here, HStore is there, FDW is there. So you have almost all the major extensions available in case of RDS. So instead of, so just to summarize, there is nothing like options group in Postgre, which is deployed in RDS, and we have the parameter groups, which is nothing, just the components of PostgreSQL.conf. And in case of Postgre at RDS, the options they are blank, but they are available as extension in Postgre, and RDS is already deployed with those famous extensions, and you just have to say pg underscore available underscore extensions, and that will show you what all extensions are already available, and you can go ahead and use them. I hope this is going to help, and thank you. Welcome. In this session, we will see what is wall archiving in PostgreSQL and how to enable it, and some of the most important topics which happen in space of wall archiving. So first of the thing, why do we need a wall file? A wall file is the fundamental file which is available in PostgreSQL. We will talk about that. But before that, wall files all and the archive files which are there in PostgreSQL, if you enable it, they are required mainly for point in time recovery for your Postgre. And if you have the PG base backup available along with the wall files, and if there are any archives which you have enabled, then that will help you in roll forward for your Postgre backup, and you can restore it to a particular point in time. So how can we see the wall segments in PostgreSQL? You can simply do ls-lrt of pg data and pg underscore wall. So what I will do is, if you simply say ls-ltr, I'm already logged into an EC2 instance that has Postgre already installed. So if you do this, this is the default location of PG wall when you create a new cluster. So this is how it looks initially. And once you have enabled the archiving, you will see something very, very interesting in a directory which is available like this. So if you say ls-ld, and then if you go to pg data, pg wall slash archive underscore status, you will see a directory something like this. As of now, since we have not enabled the archiving, you will not be able to see anything inside this directory. So when a new cluster is created, you will see just a PG wall and maybe a couple of the wall files available and a blank data directory which is called as archive underscore status. Now the question is, what is wall archiving and how to configure it in PostgreSQL? So we need to understand what is wall. Wall file is required for the data integrity. So when the wall file that results in reduced number of disk write, and because they are only the log file that needs to be flushed to the disk. So in general, these are the files which are required for every transaction that changes the data in your database. It is stored over there. It records all the transaction which has happened inside your database. In case you have to restore your database, what you need is you need a hot backup of the database. In Postgre world, we say pg underscore base backup, and on top of that, if you have the walls, then if you can apply all of them, then you can restore it up to a particular point in time. But what is wall archiving? The generic meaning of archiving is to copy to a different location. The same holds for Postgre wall as well. If you are able to copy the wall from the default location for our newly created cluster, it will be in pg data slash pg underscore wall. If you are able to copy this wall file to a non-default location, then you will be able to save it and it will not be recycled or deleted due to the Postgres setting, which are there by default or which you enable according to your environment. The recycling can be delayed by setting some of the parameters to a higher limit, but there will be a limit when it is going to be recycled. So we'll see what is the default location of the Postgre wall file. So if you go to this location ls-ltr, which you have already seen, $pg data slash pg wall, you will be able to see the current location of the wall files. If you wanted to give to a different location to the wall, you need to create a soft link and then you need to redirect it to a new location. And how to enable the wall archiving? So let's see these two parameters, show wall level and show wall keep size. So if I just go to PSQL command prompt and if I say the wall level, by default it is replica, so it is going to generate enough, or you can have it the logical as well. So wall keep size, as of now it is mentioned to 0 because it is a new cluster and there has been no modification in that. But for our purpose, we are going to save it, or we are going to change it. To make the archiving, you have to set a parameter which is called as archive underscore mode. It has to be set to on. These three are the parameters value which are available, but we have to set it on to enable it. Second important configuration in archive command is in archiving is archive underscore command. Actually, this is the command which actually invokes inside your postgresql.conf file, and it actually does the archiving to a location which you mention over there. And we have something called as archive timeout also. By default this is 0, but when you set it to some value, let's say 1 hour, so after 1 hour, even if there is no activity in the database, the wall segment will get generated. Let us see the current settings in our PostgreSQL. These are the default which are available during the creation of the instance. You can see that archive command is disabled, archive mode is off, that we need to set to on. Archive timeout is 0, that means automatically no switching of the log file is going to happen. Wall keep size, there is nothing like this, so we can set it to some value. Wall level, by default it is replica, so this is fine. Wall segment size, it is 16 MB, and that's okay for us. So let's go ahead and make the required. So how do we configure the wall archiving? This is the important step. First of all, you need to have a file system where you can store it. So for our case, we are going to keep it at this location in our home directory. Let's see if there is something over there. These were old files. We will remove all of them. Okay, the first step which you need to do is you need to create a location where you are going to store the file. So I'm going to say mkdir-p $home. This is my home directory, and inside that I'm going to keep the wall archive. So this is a small demo environment. So this much of space is enough for me. df-h. You can see we have 8.4 GB, but that's more than sufficient. And what we need to make changes is we have to change the archive mode to on. We have to set the archive command wherein we have to mention what location it is going to copy. We have to set the higher limit of the max wall size. Let's say if we say 1 GB, we have to set that. Either you can put these value manually into postgresql.conf using vi command or the editor which you are using, and you can mention wall keep segments, that is the minimum number of 10 wall log files will be retained on the file system. Wall level, by default it is replica, and then we have the commands which you can fire. So I can directly use the let us do it one by one. I'll go to PSQL prompt. So instead of doing vi this time, I'm just going to fire it on the PSQL prompt. Alter system set archive command. We are going to mention the location. So we are saying alter system set archive command. We are saying put it in this particular location. This is where live PGSQL, and there is a directory wall underscore archive we have created. It is going to use that location. And there seems something missing over here. It's not fully copied. Let's copy it again. Okay, let me copy it from the notepad, which we have prepared for this. So what we will use is this command. Okay, let's go back and say order system archive timeout equal to 1 hour. We wanted after 1 hour, there should be a forceful generation. It is done. Let me check. Let us fire all the commands in one shot. Alter system set archive mode equal to on, archive command, archive timeout, and wall keep size, we are keeping it to 100 MB. Okay. All right. So also let's mention the wall keep segment. Let's say 10 we will keep. Okay, that's fine for this demo. Let's restart the PostgreSQL instance. This is restarted. Now we are going to verify the changes which have been performed for enabling the archiving, whether they are whether they came up or not. Okay, this seems okay. Archive mode should be set to on. This is on. Archive command, this is very important because this is the command which is going to copy the archive from your default location, which is pgdata/val, to this particular location it is going to copy. Archive timeout after 60 minutes, there will be a forceful switch. So this is mentioned. Wall keep size we have mentioned is 100 MB. Wall level it is default replica. Wall segment size it was 16 MB. So that's everything is perfect. Okay, let's do some switch and see what happens. Let's go to the new location where the archives will be copied. As of now, there's nothing in this. And if we go to ls-lrt $pg data /pg underscore wall, you will see there is just one file, one log of wall. And let's do some switches. Okay, 2, 3, 4. Now let's see what is getting generated in PG data, PG wall. Okay. Okay, this is a reload config I have fired. I should have fired the, where is that? Okay, okay, let me, I think I have not copied it over here. Let's go to PSQL and execute this. Yes. And now, first of all, we will see what is there in the wall file. pgdata/pgwall, you will see there are two wall files generated. And if we go to the archives, the location which we had created, you will see the two files came over, copied over here as well. But what is there inside the archive status? Let us go there. Navigate to pgdata/pgwall, and we have the third file also generated. Go to archive status. You can see there are two files with the extension .done. So this is wall number 1 .done, wall number 2 .done. It means that when this archiving command was executed, these two files are successfully copied to the archive location, which is this location. $home/archive wall archive, that was the name. And if you see, these are copied over here. Let's do some more force switchings and we'll see what happens. Let us see what is there in the wall archives. 1, 2, 3, 4, 5. 5 files are copied to the archiving location. Now let's go back to the wall files. We'll go to the actual wall location, which is pgdata/pgwall. And if you see here, there are 6 files which are generated. 1, 2, 3, 4, 5, 6. And if we go to archive status, it shows that 5 files have been copied. And you can see here the 5 files of wall, 5 wall files that are generated in the default location, they are copied or they have been archived to a location which you have mentioned in archive underscore command location. So this is working fine. Now let's do the next step. What we are going to do is we are going to stop the archiving to see what happens. So we are saying alter system set archive command. We are setting it to false. It is done. And then let's reload the configuration file. It is reloaded. And then let's switch the wall files a couple of times. Okay. All right. Then let's check what happens in archive status. In the archive status, it is saying that 5 files which are ready, which are in the .done state, they have been already archived, but there are 2 files. Since we have set the archiving to off, they are now ready to be archived. So what we did is we have turned off the archiving. So we just set like archive command equal to off to false. So the archiving is paused or the stopped as of now. Let us go to this location because 1, 2, 3, 4, 5. These 5 files, they are in archive underscore status with .done. That means they have already been archived. Number 6 and number 7, they are showing ready. That means they are ready to be archived. But in default pg underscore wall directory, we can see there are 8 wall files. 7, they have been moved to archive underscore status. With the status, there are 5 with the done. That means they have already archived. 6 and 7, they are ready to be archived. And number 8 is still available in pg underscore wall. If you again turn it to on, they will be moved over to pg underscore to the non-default location where you have mentioned. So if you now it will not move automatically unless or until you again switch on the archiving. So cd $home, and here you see the wall archive. The 5 files which are with the done status, they are available over here. The ready, they are not yet available over here. Just to simulate, we turned it off, but there may be many reasons why they have not came up over here in the real scenario. So some of the scenario may be archiving is not working because of XYZ reason, or there may be too much of load on your operating system, or archiving may be failing due to some XYZ reason. And how can we monitor the archiving? You just simply say select star from pg underscore stat underscore archiver. As of now, this is turned off, but when it was on, you can mention it over here. You can see. Oops. Last archived wall, it is showing that till number 5, it has been archived, and at the operating system also, we are seeing it perfectly fine. Last archive time, you can see it over here. There has been 15 failed counts. Last failed wall, that means number 6, which is showing ready. It has not been archived because of some problem with the archiving, and it is showing dot ready status, so that is also good. It's not going to show you in the next one because it is showing you the last one. Last fail time, it is also going to show if you wanted to do some troubleshooting, and that is how it is going to work. Let us see if there is some information mentioned in your log file. cd $pg data. There are some informations which are mentioned over here. So if you're able to find something from different factors, you will be able to do it. Otherwise, you will be able to see some of the information mentioned over here. But most of them is the command which we have fired but you might find some information over here. So just a recap of what we have done is we have seen how to enable the archiving in PostgreSQL and what is there in the archive underscore status command. So to enable the archiving, what you need to do is you need to work on a few parameters, and some of them are like your archive mode equal to on. You have to set the archive command. You have to fire the command. When a new wall file is generated, it will copy it to the wall location, wall archive location, which you have mentioned. And if you mention the archive timeout, then forcefully it is going to switch the wall. So that will also help in making sure that in the quiet period there will be switches happening, and it is also archived. And you can mention the wall keep size, wall keep segments, and you have to restart to make sure that it works properly. And when you turn it on, you will be able to see that archive underscore status. This is going to be very, very interesting. Okay, let me scroll up, and we are talking about archive underscore status. That clearly shows what is the status of the archive as of now. So we saw 5 files which are already archived there in the .done status, and those which are not archived, they are in the dot. So these are just the pointer which tells what is the status as of now. And if you wanted to see through the command prompt, you can fire pg underscore stat underscore archive. I hope this is going to help. Welcome. In this session, we will see how to perform reindex in PostgreSQL. We need to understand one thing very clearly. In case of PostgreSQL, the maintenance activities are very, very important, and not performing them regularly on time can lead to drastic performance degradation. So the first thing is why the index rebuild is required. So the first thing is that happens in all the environments. If there is some software bug or there is some kind of hardware failure, so your indexes may get corrupted, and in that case you have to rebuild your index. This is the generic scenario. There may be a case in case of PostgreSQL that the bloating has bloated your index, and in that case it has many empty or near to empty pages. So just to remove those bloating from there, the unused spaces, you need to clear those spaces, so that can increase the performance of the index. The third reason why we should reindex is just because if you have modified the fill factor in case of index which you are using in PostgreSQL. The fourth one is an index which is built with the concurrently option that has failed. In that case also you have to rebuild your index. And over a period of time when the index gets bloated, in that case also you are supposed to rebuild it again. So the utility is already provided in Postgre, which is called as reindex. Using the reindex, you can reindex your indexes, particular index, or all the indexes on the tables, or all the indexes on a particular schema or a database. So those things can be done. So what you need to do is you need to create some of the test scenario to generate some of the load. I have already done it. So let's see what is being done. So I have created the demo table 1, 2, 3, 4, and 5. Let me create one more demo table. Just to make sure that your wall files are not filled, because you are going to write at least 6 tables with at least 500,000 rows in each table. So I'm just going to create one more. Just now I have created 5 tables, each with the 5,000 rows. 500,000 rows, the using the function which is called as generate underscore series. So it is very easy to use. So, you must use it. The next thing is how can I use the indexes or the tables which are already available. So you simply say dt plus, so that will show you the table. So demo table underscore 1 to 5 already was there. So just I created one more table which is demo underscore table 6. And if you have to check the indexes, what you have to do is just say di plus, so you will be able to see there is an index which we just created, and it is uh, on the okay, I think I haven't given the table name. All right, so demo table 6. All right, so there may be such case over here as well. So this is my demo table underscore 5. This is on demo table underscore 4, 3, 2. Okay. So rest of the things, everything is fine. So that's how you have to generate some load. And one of the thing which you can do is you can use sysbench to load some of the data. I have already done it. So you just create a user database and you grant all privileges on sysbench to the sysbench. Then I added the sysbench in pg_hba.conf. Then using this particular command, it is available over here in this tutorial. You can just copy and paste and see how it works. Also, what you need to do is you need to generate some load using the PG bench. So let me drop the database, drop db PG bench. It is hopefully dropped. So what I'm going to do is, okay, I created a blank table and then using the PG bench -i PG bench, I have initialized it. Now let me using 50 connections and 1000 transactions, let us pump some data. Once it is done, you can load the DVD rental database. The software is already attached in the tutorial. Using that, you can uh, uh, what do you say? You can import the database, and then we will see how to perform the indexing. So one of the things which you need to remember is we are going to load a lot of data. So make sure that your wall location is not filled up. df-h dollar pg data. Okay, we have a lot of space available now also. So the important part is you perform a lot of operation just to create a lot of tables in your case. So what I'm going to do is using PSQL, first of all, let's go to, I'm logged into Postgre database, and let's see what all indexes we have over here. You can see a lot of indexes are there. There are 10 indexes. I just wanted to reindex one of the index. So what I will do is reindex, index, and the index name. This is done. This way you can do it one by one if that is the case. Otherwise, what you can do is on a particular table, let's say there are indexes, and if you wanted to reindex all the indexes which are there on a particular table, you can do it. So let's say uh, if I say dt plus, there is a table called as demo table 2. So what we wanted to do is we wanted to reindex all the indexes which are there on this particular table. So let's do the reindex table and table name. So this is done. If you wanted to reindex all the indexes in a particular schema, you can do that. Let's say if I wanted to reindex the all the indexes in particular schema, I'll be able to do that. This is how to done. We will see in another scenario how to actually speed up this entire stuff. And the final command which you can use is reindexing all the indexes in a particular database. Let's go to DVD rental. This is reindexed. Okay, we have completed it. Then there is an assignment. Make sure that you let me save this because there was an error. And make sure that you try out this reindexing assignment. So what you need to have, the PG13 installed on an EC2 instance. Then you need to generate some load on it. So you generate at least 5 or 6 tables or 10 tables. I have used 500,000 rows for inserting the rows in those 5 tables and created the relevant indexes on those. And then I used sysbench to generate some load and indexes, then pgbench, and then I imported the DVD rental database. And then using the multiple available indexes, you can perform the reindexing of individual index, you can perform the reindexing of the table, schema, and database. The help steps are available over here, demo on the reindex, and this is all a step. So just look at it once you are not able to perform it yourself. So this is all available over here. I hope this is going to help, and thank you. In this session, we will learn what is partitioning in PostgreSQL and how it is going to be beneficial. The same detail is available over here in courses.emultiskills.com, and you can see the slide presentation which is being used as of now. This will be followed by a demo. All the details are mentioned over here, so you can just copy and paste the details from courses.emultiskills.com. So let's continue. What is partitioning? So when there is a large table in PostgreSQL and you wanted to make it into small pieces so that it improves your performance of the SQL statement as well as management of the data. So partitioning is nothing but just dividing the bigger table into smaller pieces. What are the benefits of partitioning? The first one which we talk about is query performance. When heavily accessed rows of the tables are in a single partition or a small number of partition, then it is easier to access those rows. And heavy used part of the indexes, they fit in the memory when the table is partitioned. So in simple terms, when you access the data from a small piece of the table, your accessibility of the data is faster because you are going to access the relevant data only. We continue with the benefits. So when queries are of dates access a large percentage of a single partition, performance can be improved by using a sequential scan of that particular partition instead of using an index. And this is going to be really beneficial when the table is very, very large. And this is going to require random access read scattered across the whole table. So instead of a big table, you are going to read the data in a sequential scan from the n number of partitions which are based on that particular table. Some of the other important benefits of using the partition table is about the loads and deletes that can be accomplished by adding or removing the partitions. So instead of working on the entire table, you can work on the individual partition. You can drop the individual partition using alter table, detach statement, or alter table add partition. In this way, the bulk operations will be faster. And one of the challenge with the big tables in case of Postgre is if it is a big table and in case you have to do the vacuum, it is going to be very, very problematic. In some cases, it has been observed that those vacuum processes will never be able to complete. If you try to log them, then it has other overhead. When should we partition a table? So rule of thumb is the size of the table should exceed the physical memory of the database server. Let's say I have a 32 GB table and some of my application tables, if they have exceeded 32 GB of the size, in that case, you need to partition your table. And if it is smaller partition table, they are good to fit into the memory, the indexes, and their accessibility will be faster. What are the different types of partition? We have range partition. The table is partitioned into ranges, which is defined by a key column or the set of column with no overlap between the ranges of the value assigned to different partition. Let's say if I do a range partition of some number between 1 to 10, they will fit into one partition. The other one ranges from 10 to 20, and the last one, let's say from 30 to onwards or something like that. The one which conflicts everywhere, that is going to belong in the next partition or the last partition. We have other partition as well, list partition and hash partitioning as well. In list partition, the table is partitioned by explicitly listing some key values which appear in each partition. The last but in this series is hash partition. Partitions are then defined by the two values. Let's say if you wanted to partition a table with 100 rows, wherein one of the column is having the column name as ID, the values are 1 to 100, and if you wanted to create 10 partitions for 1 to 10, in that case they will go into one partition, 10 to 20 in another. This way they go into 10 different partition. If you do it the list partition, then you will find the list of some of the values, and you will put the relevant data in one partition and different relevant data in other partition. In case the part excuse me, in case neither excuse me, in case your neither your list partition nor your uh, other partition is good for your partitioning strategy, in that way you go for the hash partitioning, and in this you will see two terms. One is the modulus, other is the reminder. Modulus is the number of partition, and reminder is the it is going to be less than the number of the partitions. So what are we going to do? We are going to perform a demo. We have everything listed over here, and we are going to use that. This is lesson number 117. Okay, let's go ahead and we'll start with the range partition. What we will do is everything is there over here in MOBA Extreme. And what we are going to do is we are going to have it, we are already logged into the PSQL prompt, and now we will drop the table if it already exists. So I'll say drop table sales. We are going to use it for this demo. And here we go. We are going to go with the range partition. We are going to create a table sales where we have the sales ID as the serial, total sales count as integer, sales date as sales, and we are going to partition by range. That means for every month we are going to create one partition, and this way for 1 year we will have 12 partition. The very popular, what do we say, the example for the partitioned tables. And I'm going to create 12 partitions for 12 months of last year, which is 2021. Let me create one more partition for 2022. Okay, let me quit. We'll say clear PSQL, and we are just going to copy and paste. So what we did is we are going to create the create table sales 2021. Okay, let me show you it over here. It is create table sales 2021-01. That is the partition number 1, and it is going to store the data where the date will be between 1/1/2021 to 1/2/2021. That means the first day of January and first day of February. So including these two, it is going to create the partition. Excuse me. So we have created a 12 partition, and then what we will do is we will see the relevant data over here, and the tables are created. You can see create table, that is the partitions are created. Now we will see what are those partitions. So there are 12 rows. You can see it is created in the public schema. The table name is sales. The schema name is public, and the child table 01, 02 till 12. So 12 partitions are created. And now we will try to insert some data. It is all in the range only. That means it lies between 1st January 2021 through 31st December 2021. Yes, you can see the data is inserted. Now what we are going to do is, okay, let me insert some more data. Hopefully this is fine. So you can use all of them if you have taken the subscription. Yes, this is done. And now we will see the details. It's good demo to practice. You can see we have these many row counts for different partitions. Excuse me. Now the next thing which we are going to do is let's do an explain of the data between 1st January to 31st January on 2021, the first partition. If we do it, you can see that we have done a sequential scan, and this is going to be useful in that case. Now we are going to go with the list partitioning. List partitioning, what we will do is we are going to create a sample data table wherein we are going to partition by the city. Let's create it. I hope the table has already been dropped. Okay, let me drop table, table name. So what we are going to do is we are going to create a table sample data where we have age. Okay, let me see. Okay, I think, okay. All right, let's go with this. This is going to be very simple and straightforward. We have some age, the the people with some specific age in particular city, and not very relevant, but this is just a demo, so let's quickly do it. And we are going to create three partitions, and what we are going to do, if the value is DL or BLR, it is going to be in the first partition, second partition, and the third partition if the value is something else. So let's quickly create this. So that means in this case, we are saying if the range is DL or BLR, they will go into different partition, excuse me. Let's insert the data. The data is inserted. Now let's go and see the status of the sample data. You can see we have the values available over here with the age. That means it is going to different partition. And in case if you wanted to see some more detail, you will be able to see this. You can see if sample data, if the value is DL, it is going to go into sample data 1. If the value is BLR, it will go into sample data 2. If there is something else, it is going to go in the default partition. The next one, if your list partition or range partition, none of those work for your example, in that case, you should go with the hash partition. That means the data will be gone to the different partitions, and they will be it will be tried to be equalized. So let me drop this table because we are going to use the same name, which is sample data. Paste. Okay. And the next thing which we are going to do is we are going to create the table sample data. Age is not null, city, varchar, partition by hash city. Okay, the table is created. Now let's create some partition 0, 1, 2, 3, 4. So we have already discussed what is modulus and remainder in this. Excuse me. If the modulus is 4, remainder it is going to be always less than 4. And let's insert some data. We have inserted some data now, and finally let's see the detail of sample data. We have partition 1, 2, 3, 4. These are the details, modulus and the remainder, and finally the let's describe one of the partition. And this is how your hash partitioning is going to work. So just a recap, we saw what is partitioning in Postgre, bigger table into smaller pieces. Is there any thumb rule? Yes, the thumb rule is if the size of the table is more than your memory, so it is good to try to fit it in the memory, though memory will be used by something else as well, but we will try to put it using the partitioning. It is big table into small tables. You have the query performance because you have to scan a smaller number of a portion of the table, and the heavily used part of the indexes is going to fit into the memory, and you get the performance benefit using this sequential scan instead of the index scan on that particular partition when it is created. And the table management is good when you have to add, drop, or alter any partition, the vacuuming process is going to be faster onto the individual partition instead of the large, bigger table type of the partition. You have range partition, we have list partition, we have hash partition. Range partition, wherein you mention the range. Let's say we have seen the demo of range partition, wherein we have created 12 different partition for each month, and the sales data has gone into individual partitions. Very popular example for the sales, and it goes into their uh, relevant partition. The management is good, the data accessibility is fast, and management of the table is faster, query performance is good. So you go with the range partition in that case. If you have some key like the list partition, if you know the list on what basis, if you have some keywords, like if this is the keyword of the particular column, and the name, if it matches that, it will move your data into that particular partition. Hash partition, if range and list partition excuse me, does not qualify, in that case hash partitioning is going to be useful for you. We saw the demo for the list partitioning, hash partitioning as well, and that's all. So you can see all the details are over here. So once you it is lesson number 117, and I hope this is going to be helpful for you. Welcome. In this session, we will see what is password authentication in PostgreSQL. This is lesson number 118, which is on courses.emultiskills.com. So the topic is password authentication in PostgreSQL, and this is considered one of the most important security related topics. So if we go with the overview, so password authentication is considered as one of the most trusted way for the authentication method, wherein you have a user ID and the password. But the question over here is, how is that password stored onto the server, and how is that password sent across the connection or over the network? So if you see, there are just three types of password authentication in PostgreSQL. The first one, which is available in the latest version of PostgreSQL, is a SCRAM SHA 256. And when we talk about the SCRAM SHA 256, this is considered as one of the strongest way of authentication, and this is available in all the recent available PostgreSQL versions. And one of the good thing about it is it is a challenge response scheme. So in case you are facing password sniffing related issues on the untrusted connection, if you are not there in the VPN, and if your connection is coming from the outside world, which is out of your control, and that's very much possible in case of open source databases like PostgreSQL. And when you have to take care of the security, it is assumed that you use SCRAM SHA 256. And what happens, it is going to store the password on your Postgre in a cryptographic hashed form. That's very secure. So if you say what is the most secure way of password authentication, then we will say it is a SCRAM SHA 256. What is the good part? This is the strongest way. What is the weakest part, or why it is not considered as one of the good thing? It is because if you talk about the legacy old systems, in that case it is because of the older libraries, it is not going to work over there. But in the recent ones, it is available, and this is suggested, and by default this comes up. The second password-based authentication in PostgreSQL is MD5. As compared to SCRAM SHA 256, it is less secure. It is also a challenge response mechanism. It helps in preventing the password sniffing in case you are coming from the public network, and it and one of the good thing about it is it helps in avoiding the password sniffing, and it avoids storing password on the server in the plain text. So if you talk about SHA 256 and MD5, so the storing of the password on the server is not in a plain text. What is the cons of MD5? So it provides no protection in case your attacker is able to steal the password hash from the server. So it's not considered as secure as your MD5. Where do we put, whether it is MD5 or Scram 256, you put it in the pg_hba.conf. So if you just go ahead and see show config underscore file or show pg_hba dot, okay, let me go over there, and if we go over here, pg_hba.conf, you should be able to see that um, this is Postgre 13, and if you see the default ones which are coming are Scram SHA 256. So coming back to the topic again, MD5, it provides no protection if the password is stolen in the hash format from the server. Where do we give Scram 256 or MD5? You put it in the pg_hba.conf. What about the third way, which is the oldest way in Postgre? It is password-based authentication. So it sends the password in the clear text over the network, and it is always vulnerable for password sniffing. If you are using the older versions, you will not be able to use the strongest way of password authentication, which is Scram SHA 256. Wherever possible, do not use the password-based authentication. If you have upgraded your Postgre from lower version to a higher version, so in most of the cases, what we ideally do is all the configuration parameters we try to carry over from the legacy versions. So we should avoid, wherever it is possible, just go for Scram 256. In case you do not have the SSL encryption enabled, then it's really a bad way from a bad perspective from the security. There are some of the questionnaires like where is the password for each database user is stored. So if you see the pg_auth ID, here you store the password in the hashed format. So I'll just copy and paste it on the PSQL. If I just execute it, you will be able to see that. Let me take you to one of the example, which is Postgre role. Here it is. So the role name is Postgre. Role super user, it is true. Role inheritance, true. Role create role, it is able to create the role, true. That's everything is true. And if you, okay, I should, where is it? Okay. Let me select star from pg_auth ID. It seems, okay. Role password, it's not, I think I haven't kept the password for the user Postgre, but in case if it is available, it will show you the role password in the hashed format. The next thing is how can you set the password? Either you use the altered user or alter role in case of Postgre, or you can create the role with the login password, whatever you wanted to key. Let me try with this. Okay, if you see this role name, which is FOO, and if you see the role password, it is in the Scram SHA-256, so you will not know what is the password I have given it over here. And in case if you wanted to change the password, if you are logged in with that user, you simply say /password and you will be able to do that. But in case there is no password set, in that case it is not going to work for you. Excuse me. Enter new password for user Postgre. If you enter, you have to give it. I haven't given anything, so it is saying empty string is not a valid password, clearing password. So that's fine for me. How can we see that what is set at the instance level? So simply I have to go to the PSQL prompt and I have to say show password underscore encryption. So if I simply say this, so at the instance level, we have this set to Scram SHA 256. So who controls it? It is controlled by the password underscore configuration parameter, which is in postgresql.conf. Okay, some of the things now is if a password was encrypted using the MD5 setting, then it can only be used for the MD5 and password authentication method specifications. In case you have the password encryption using the Scram 256, then in that case, either you can use Scram SHA 256 and the password. The password transmission will be in the plain text in that case. And how can we upgrade to Scram SHA 256? I missed 6 from MD5. So if I say what is the most strongest way of password authentication, so I will say Scram SHA 256 instead of using the MD5. So the only challenge is Scram SHA 256 may not be available on the older system. So you need to make sure your all clients comply with this and all the client libraries are using the system to support Scram SHA 256. Then you have to set the password encryption, which is equal to Scram SHA 256 in postgresql.conf. And you set the new password, restart your instance in case it doesn't work, then you should be able to use this. So it's very straightforward. So you have 3 ways of password-based authentication. Scram SHA 256, which is the strongest way, MD5 less secure, and the password-based, which is available on the older system. This is the least secure, and password sniffing happens. So what 2 ways are most strongest for avoiding the password sniffing? It is Scram SHA 256, and on the second point, it is MD5. And the least secure is password based. If it is an open network, then it should not be used. Where is the password stored? The password is stored in the encrypted format in your PG underscore auth ID. So you can check that. And where do we set the password encryption at the cluster level in Postgre? We do it in the postgresql.conf and the parameter name is password underscore encryption. So if you have not taken the subscription, you can go to courses.E-MultiSkills.com and take the subscription. This is one-time paid subscription, and I hope this is going to help. And thank you. Welcome. In this session, we will see what is PG collector and how it can be useful for the data collection and analysis for running PostgreSQL instance. So what you need to do is the Postgre data, the PG underscore collector tool is already attached in this tutorial, and you can download it from here. Please remember that you need to have a subscription in case you wanted to use courses.emultiskills.com. And what you need to do is I have a running PostgreSQL instance. I'll log into PSQL, and once you log into that, the way to execute this script is I have already transferred pg underscore collector dot SQL script in in /tmp, and this is the way you have to execute it. The way you execute the SQL statement in Postgre, the SQL file, the same way you have to execute it as well. It has n number of SQL commands inside it, and once you execute it, it is going to uh, let me see where it is as of now. Okay, this is the file, and what I will do is psql /i/tmp, and you need to give the location, and once you execute it, it is going to be executed like this. And you will see a generated file in this format, pg underscore collector postgre, and the output is .html. So what I have done is I have already transferred it from the Postgre instance, which is on an EC2 instance, to my local system, and it looks like this. So on the top, you can see that it is PG host name. It is going to display, and it is the data directory where it is going to where the base location. Then you have the version, and I have this is the primary instance of my streaming replication. So it is showing it as DB, which is in the read-write mode. If you have it for replica, it is going to show you that it is read only. The date it is going to show when it was started, uptime, to which DB you have connected and executed the script. So I have connected it to Postgre database, so it is going to show me that database version. It is going to show you the database version as well as the operating system details as well. In the next section, it is going to show you the list of the databases. By default, these are available over here. Other than PG Bench, these are the three default ones you will be able to see. And one good thing is it is going to show you for the size as well, the table spaces where it is located. So, and apart from that, it is going to show you the database name, the template, and the frozen XID as well, in case you are touching that. If I click to the database size, it is going to show you what is the different database size available. It is going to show you the index size. So in terms of the information, huge information is available over here. So if I go back and check the PGS state underscore statement extension, it will show you whether it is installed or not, and what are the different parameters which are enabled. So it is going to show you as that as well. PG audit extension, if you have enabled it, it is going to show. In my case, it is not. If I click this, it is going to show me that PG underscore audit extension is not enabled. The only enabled this one is PG underscore stat underscore statements. And if you see the background process is not very important for us as of now, but it is going to show you that as well. Wall sender in this case is important. This is just to show that replication, streaming replication is working on it, and the basic information. If you wanted to know the partition tables exist or not, it is going to show you over here. In my case, there is no partition table, so it is not going to show. Then you have pg underscore hpa.conf. If you see this, it is going to show you something like this. So these are the default entries which are available, and just a couple of entries I have used for the replication purpose. So it is going to show you that as well. So it is a good information which is available. Triggers you can see, and it is not going to show me anything because there is nothing enabled for my case. DV parameters, this is another important information. You can see the information related to auto vacuum, and there are several others. So whatever you are interested, instead of finding it to postgresql.conf, you will be able to see all the details over here. Vacuum and statistics, which is very, very important for performance tuning. So these are uh, displayed over here. So a very good HTML format, and it is good to have. Then some of the important information which is related to the replication. So you can see that the replication detail is available over here. Excuse me. So the replication slot information, what type of replication it is, and how much it is lagging behind, that information is also available over here. Public schema, it is also going to show you that duplicate indexes, PG config. In terms of the extensions, if you wanted to see, by default, it is going to show me the PL PGSQL, which is by default, but this is the one which we have installed, so it is going to show you that as well. So if you go to some of the important information, it is related to the session and connection info. So it is going to show you. So by default, it has 100 connections allowed. As of now, there is just one connection, so you will be able to see that active and inactive connection. It is going to show you. It is just one active connection, which is related to the replication user. So it is going to show you that as well. If you see the public schema details, it is going to show you the public schema, how many indexes, tables, or views are available in that. It is going to show you that as well. It is going to show you the invalid indexes, access, privileges, stamp tables, foreign key without indexes, table size. These are important parameters. Memory settings. This is good to have it over here. These are the effective cache size, which is twice of the, which is 50% of the RAM. In my case, it is the size is 4 GB, and you can see it is available over here. Shared buffer information is also available over here. It is just uh, uh, default value, which is 128 MB. Maintenance work memory, it is also 64 MB. Work memory 4 MB by default, which is available. So it is going to show you the huge page. By default, it is set to try if it is available, and it is giving you good information. So it is going to be present over here as well. And SSL, it is going to show you if it is enabled. Table space info, fragmentation, which is again very much related to your performance tuning. So you can see those details are available over here. These are the default schema related information which are there in the Postgres. So these you can see over here. I don't have the user data too much over here, but it is going to show you the bloating and other information and what all needs the vacuuming. So it looks like there is a lot of information which can be used. So it's also suggestive to have it put it in the cron tab, and you can use it as on a required basis. In case you find it very useful, it is good to apply in your environment. So the script is already attached over here. You can see that pg underscore collector.sql. In case you wanted to go, just look for the original the GitHub repository, and you will be able to download the updated version in case it comes. Uh, for now, I believe this is more than enough, and just go and put it in your environment. Try to execute and see the important information. And a lot of useful information is available, which is good for your environment. I hope it is going to help, and thanks for watching it. Welcome. In this session, we will see what is PG metric tool and how it can be beneficial for the collection of the data, and further how it can be used for the analysis. So PG metric is an open source tool, though there are others also which can be used for the collection of the data, and then it can be further used for the analysis. You have PostgreSQL tuner, then you have some other tool as well. You have PG underscore collector. Then you have some other open source tools available which can be used for such purposes. So one of the famous tool is PG Badger, but pgmetric is also an important tool which can be used for the data analysis and further troubleshooting. As of now, it can collect more than 300 plus 50 plus matrices. And for this particular demo, what we have used is we have a master and we have a replica which we have created. So let me restart this session. Okay. So the replication is already established using the streaming replication and using these commands like sudo yum install -y wget. We installed the wget, then we downloaded this particular tar file having the pgmetric binary. We untarred it, and then we have it available over here on the master. So you can see we downloaded the dump file over here, untarred it, and so once you do it like this, you will be able to see something like this. This is the binary which is available as of now. And how to invoke it? It works the same way your PSQL works. You can invoke it. So if it is already not in the path, you can include this particular location in your path so that you don't have to go this location and do rest of the stuff. So if you see -help, it will show you what all it can do. So you can see over here -t timeout. You can mention the versions. You can mention if you don't want to collect the table spaces and the relations size, you can skip. And collection only from schema, which is matching something, you can do that. You can exclude some schema, or you can collect it for some particular tables or types of tables, or if you want to exclude that, you can exclude that as well. Excuse me. You can limit the SQL length as well. You can limit the SQL limit as well. So default is 500 SQL length, and statement length is 100. You can have it for all DBs, or collects info from all user database, or you can have it for the you can give the location of the log file and it will be able to fetch information from there, or you can mention the location of the log directory as well. It is going to pick the, and the output format, you can have the output format in human readable JSON format or CSV. So whatever format you wanted to, like, you can go with the different options which are available as of now. So for this setup, the step-by-step configuration is given. Like when so you can see over here, what we have done is, for the demo, we created two EC2 instance. One is master and another is slave. We installed the database binary database on the source, and on the replica we installed the binary only. Disable the SC Linux. All the steps are there from beginning till the end for step-by-step configuration of the primary and the replica. Apart from that, there has been the important step which is related to loading sample data. uh, for the demo, we created some 5 tables with 500,000 rows, and relevant indexes are there, uh, and we used pgbench to load some data, then sysbench. So and you can import some sample DVD rental database as well, just to generate some load, and you can fire some query. The most important part of this is you have to ensure that Where is that I have mentioned? I have mentioned is pg underscore stat underscore statements that must be enabled so that it can find all the statements which are available. So let us see what all it can find for all the databases. As of now, this has been available only on the primary. If you want, you can put it on the replica as well. So I'm just going to run a pg metric -- all dbs. This has prompted for the Postgre database role. So I have entered that. So you can see the server version is 13.5. Server started date is the date when it was started. It is 2 days ago. The timelines, last checkpoint details it has, checkpoint log sequence number it has, and the important part is active backend is that means there is just one active connection which is available, the one which I am logged in. Recovery mode is no. That means you are connected to the primary one. And host name it has given CPU. Load average, there is no load average. So memory, what is the used memory, what is the free memory, what is there in the buffer, what is there in the cache. So all the information is there. Apart from that, you have swap related information. Then you have the some of the important parameters: shared buffer, work memory, maintenance work memory, and temp buffers. And since there is a replication which is already going on, so you can see that destination number one, the username is wrap user. The application is wall receiver. Client addresses, this is the client, that means that is the replica. The status is streaming, started at what time it started? It started 2 days ago. How many sent LSN last one it is showing. Return until there is no write lag, there is no flush lag, there is no replay lag. That means both are in sync with each other. Sync status is async. So in terms of the information, it is good that instead of using the pg underscore stat underscore application wall sender wall receiver, everything you can see over here, and it is able to show you the physical replication slot as well. There is a physical replication slot which is being used, which is active at this point of time, and this is the restart log sequence number. You can see above here as well. So it is not temporary. Wall files, the wall files are in archiving status. Wall files are 35, ready files are 0, and archive rate it is showing it 0.01 per minute. Last archived it is also showing. Any last failure for the archiving? No. So all the files which are generated, they are replicated. For the replica management, you can see that there is detail available over here. The wall compression has been set to off. Wall max size and min size, it is already mentioned over here. Checkpoint timeout and other details are here. Related to the background writer, you have the important information. So we can find the important info over here. Since this is a quite demo database, you will not be able to find most of the information. But when you run it in a busy database, you will be able to see a lot of information which will be of great use for you. And if you see the backend, total backends, there is just one connection which is connected, and you will be able to see the lockings and waitings and other things available over here. Locks relations, there are just four, and virtual XID, this is just one. Vacuum progress, this is important, like what no manual or auto vacuum job is in progress. When this is run, just a minute back or so, maintenance work memory it is showing. Auto vacuum it is on. The auto vacuum analyze threshold it is showing, and all the important details are over here. Roles it is showing, like how many excuse me, what all roles are available by. So you can see all the default roles are there. There is the default table spaces as well, and you will be able to see the database details. This is the default one. Then I created a PG bench database with some data that is also there. You can see the installed extension in that particular database. There is no such non-default extension. How many rows have changed, that information is also there. There is no connection, there's just one connection. And the other table information you can see over here. If there is any manual vacuum or analyze happen, nothing happen like so. And post analyze rows modified over 6.9%. So these are the important details. Likewise, there are 5 to 6 tables that is created as part of PG bench initialization and loading, so they are available over here. If you fire some SQL statement also, you will be able to, let's say I fire some statement, then that will also be captured over there. So when you do the demo, you should, let's say if I so if you run the PG metric, it captures all the information which is of great use for us. You need to make sure that PG underscore stat underscore statements that is enabled. And you can run it for that particular database as well, so that it is going to capture. So it's a lot of information which is available, and that can be of great use for your further. Hello and welcome. In this session, we will see how to find out the slow running queries in PostgreSQL. So this is a very obvious kind of situation wherein you have to find like what all statements which is running in PostgreSQL, and if there is a benchmark which says that a particular SQL statement was running in 10 seconds earlier, but now it is taking 15 or 20 seconds. So just in case you have to create some benchmark and you have to find out a particular statement, how much time it is going to take, then you wanted to log it, the information somewhere. So we have some of the methods available due to which we can find out like what all is happening in my database. So this is my PostgreSQL 13, which is running on an EC2 instance. And all the steps are here mentioned in courses.e-multiskills.com. If you wanted some subscription, you can apply for that. Excuse me. So this is one of the I believe if you have some temporary problem, or once in a while if you wanted to log your information in a written format somewhere into the log file, then you have to do something differently. So using this way, which we are going to discuss, wherein what we are going to do is we are going to log the SQL statement which takes let's say more than 5 seconds in the database. So what I will do is I'll log into PSQL and I'll show you a parameter which is going to help you in this case. So there is something called as log underscore min underscore duration. So I'll say show log min duration underscore statements. If you see this, okay, let me show you it using the postgresql.conf file. And the parameter which we wanted to see is I wanted to show the default parameter, though I have already changed it. So log underscore state underscore log underscore min underscore duration underscore statement, what it says is this particular parameter by default is -1. That means it is disabled. If you put this parameter to 0, then any action or statement which is executing in your database PostgreSQL cluster, this is going to be logged. That means all the information will be logged into your PostgreSQL log file. And if you wanted to mention a particular timeline, then you can mention the parameter greater than 0. The time which you mention over here, it is mentioned in milliseconds. So just ensure that you put the duration in milliseconds, then it will be automatically converted into seconds and whatever way you wanted to see. So I have already changed it from log underscore minimum duration underscore statements from -1 to 500 milliseconds. The next thing which you have to do is you have to generate some data. So what I will do is I have already created a PG bench, or what you can do is you can create some table. Let's say if I say, and if you mention this parameter into postgresql.conf file, this is for all the databases which are there in the cluster. So that may not be efficient for you, but you can do it for the individual database as well. Let's say if I wanted to make it 1000 or let's say 100 milliseconds, then if I say, so this is going to be done for the entire cluster, all the databases inside this cluster, and you do not need to reload, you do not need to recycle the instance, just reload it and it is going to work. Another thing is, which is very, very important, is from where can I get the data? So this is going to be very, very important. So you have some inbuilt tool which is called as PG bench. Using the PG bench, you can generate some data. So I'm just exporting the path of the binary location of PostgreSQL. And then what I will do is I already have a PG bench database which I have already created. I'm going to drop it and I'm going to recreate it. Excuse me. It is already in use, so I think the way, so I'll just say remove connection. I've already made some connection through the, yes. So this should allow me to drop the database now. I think still there is some connection over here. I believe this is, okay, let me, though we can find out, but let's delete this. It's gone. Now what we will do is we are going to create the database and then we are going to populate it. This is one of the fastest way to generate some data, or we will see other way as well. Let's initialize the PG bench and then we are going to execute this. So this is going to create 50 connections and 1000 transactions. This may take a minute or so. In the meantime, what we can do is we can generate some random data in some particular table. So let me create a duplicate session. EC2-user. So I'll say sudo su space minus postgre PSQL, and then what we will do is, okay, this is going to take a minute or so. What we will do is, let's create a table. I'm connected to PSQL, and I'll say create table slow underscore demo as select star from generate underscore series. This is a good function to generate the numbers. So it is going to generate, I believe, 50 million rows. It already exists. So I'll say instead of slow demo, okay, let me drop this drop table, and we will see slow underscore demo. Okay, this is dropped. Let's create table slow underscore demo as select star from generate underscore series. So this is going to insert 50 million rows, and once it is done, we will do some operation on this just to see how it is being captured. Let's create an index on the slow underscore demo table. So anything greater than 1 millisecond, we are going to capture in our PostgreSQL log file. That will be used later on for the analysis. For as of now, it is just like we wanted to capture the data. I'll say just display the number. That doesn't make any sense, but this is just, I wanted to display the number, and I wanted to see uh, how long it is going to take and how to capture that information in some recorded format. Okay, so I think everything is done from our side, and even the PG bench data is already generated. So we will go to cd $pg data / log. In the log file, you will be able to see the log. You can see the log is here with the today's escape shift G. Go to the bottom and you can see all the statements. This is 14 uh, um, 14,000 milliseconds, 11,000 milliseconds, 1,334 milliseconds. So what we did is anything greater than 100 millisecond, it is being captured. So it is like updating the PG bench table, PG bench underscore tellers. You can see that all these update statements are captured. So 131 milliseconds, 110 milliseconds, 140, and 11,000 milliseconds. So this is the statement which has taken the highest amount of the time, that is 14,000 milliseconds. So using this way, we can find out and it can be logged, but not for the entire cluster. For particular database, if you wanted to set, you can set it using this way. So I have mentioned this statement over here. So you can simply say alter database name, set log minimum duration statement instead of 10,000 seconds, milliseconds, whatever is, you wanted to find out, you can check out. So we have the SQL statement find out now. You can start the next set of analysis from here. Let's say if you wanted to check out the explain plan, and if you wanted to find out like how is the execution of the statements going on at a particular time of the day, then this actually helps sometimes. But there is not a replacement of pg underscore stat underscore statement in case, because that's a great utility. So what you can do is, so I have mentioned some more steps. Those who are having the subscription, they will be able to use all the steps. What else you can do is the another way is using the pg underscore stat underscore statement. So you can put this parameter in shared preload library, and before that you have to make sure that you have the contrib file downloaded on your system so that you don't fall into some problem. So once it is installed, you will be able to capture what all is happening into the database. But that will be printed over the screen. Just in case if you wanted to log it into some file, so that will be there into PostgreSQL log file. So both the methods, this is more prominent, this pg underscore stat underscore statement, but logging into your log file is also available. So whatever you are finding convenient and useful, you can use both of them. So, but don't forget to come out, just disable the log underscore stat underscore statements so that those are not unnecessarily captured. So once your analysis is done, like this particular statement has been taking this much of time, then you can put it to the default one or whatever you have set it in your environment. I hope this is going to help, and thanks. Welcome. This is lesson number 102. This is regarding the benchmarking for PostgreSQL performance testing. So what is Sysbench? Sysbench is an open source tool that can be used for performing the benchmarking for the operating system, as well as some of the databases like PostgreSQL and MySQL. In this case, we are going to perform the performance benchmarking for PostgreSQL using some dummy data that we'll be creating during course of this. So I have Postgre 13 already installed on EC2 instance. Now I'm just going to switch to user Postgre operating system user. Then I'm going to use the curl. Once this is done, just install the sysbench and check the version. Install sysbench. Check the version. And then what we are going to do is we are going to initialize and populate data. So let's create a role with the name sysbench, a database with the name sysbench, and then we will give the full permission on the database to the role. So this is done. The next step which we are going to do is you have to edit your pg underscore hba.conf file and just cross. I have done it in advance, but what you have to do is just make sure that you have the proper permission for the sysbench user. I've already added it, but this is what you have to do it. Just reload the configuration. That should be more than sufficient. Then let's try the connection with the sysbench. You're able to connect. Just try connecting to sysbench. There is no table available as of now. That's what we are going to do using the sysbench. We are saying the database driver is PostgreSQL OLTP size. Let's make it 500,000 rows. 10 tables. There will be just one thread. The host name mentioned. port, the role, the password, the database where it is going to be created, and just run it. Though in the real scenario, when you do it, you have to increase the number of threads so that you can see how it is behaving. But this is just a demo environment. And what it is going to do is using just one thread, you have to just increase the number of thread, number of rows just to see how it behaves. That's how you are going to test the concurrency and the performance benchmarking. Though this is not the real data, but it at least gives you some kind of information how your system might behave when there are heavy load on your system. So concurrently, there are 10 tables wherein some 500,000 rows are getting inserted. Just make sure that you have enough storage, because this is going to create a lot of wall files, and you need to clear them up if it is filled up. You can see that 8 tables with the 8 indexes created on them, they are being generated. 9, and this is the 10th one. The tables which are being created, they are with the name SB-test1 to SB-test10. There are no reads. It is just the write. You can see there is some other value also. The total, it is going to do 1890. The transactions, there's just happening under the one transaction. It is 0.1 per second. And the queries which are being populated, it was 21.86 queries per second. There has been no errors which are ignored. The statistics has gone for 86 seconds. The number of events is just one. This is the important metrics which you need to understand. The latency in milliseconds. This is the minimum. The average is 86,000 milliseconds. The maximum is also that 95%. So on an average, the latency it remains same. It is just one thread we have used. If you have more than one, then it is going to really help. Thread fairness, so it is just one thread which is just going to take average execution time of 86 milliseconds, but you need to increase the number of threads just to see how it behaves. In our case, it is just one virtual CPU, and it is just so it is very lightweight free tier machine, but you can check it for higher configuration system. You need to increase that. And what else you can do is you can see that the same has been captured over here. You can check the data verification, like the data is populated or not. So if you need some data for some other testing, this is one of the good way to populate the data, and this is done. And what you need to check it now is if you have to do some read-only bombardment, you can do that. Let's do this just to see how it is going to behave. I have initiated it with 10 threads, though in reality there will not be that much of CPU available over here. So thread, it is not going to be actually applicable over here, but we will see how it is going to behave. So transaction per second and others. Threads started, transaction per seconds, you can see. Let us go a little bit up and initializing worker threads. For the 10 seconds, it is 10 transaction per seconds. It is query per seconds, you can see. read and write, you can see how it is happening. There's the reads which are happening over here. The number of the reads which are over here, it is this much. The transaction rate now is 240,850 transaction per second. It is over here. So this will help you to analyze how the system is going to behave when you have enabled your query in multi-thread mode. So it is good to find out the um, latency, the total statistics, and you have a lot of information over here. What are the reads which are happening? What are the writes and other information? With different settings, you can find out how it is going to behave. So this was done with running the test with the number of threads 10. Report intermediate results every 10 seconds. It is going to display the result, and initializing random number generated from the current time. The last one, you can check it like this. With threads, we have given 30. Let's now give it 20 and how it behaves. It's just like you have to see what are the transaction rate, what are the read rate, and transaction per second. Those informations are really helpful. So you can see query per seconds which are running at this point of time with the with number of threads um, 10. So you need to compare the data with respect to um, the information which you captured earlier and now. So you can see the read operations, the write operations, how it is happening, what is the transaction rate, and the TPS. This is important. The latency information, you can find it out. So with different numbers of thread, different amount of the data which has to be inserted, you can find results and you can compare them. So you can see the execution time. Earlier it was 29 seconds. Now the execution time is 30 seconds. So there is a slight change because the overall uh, capacity of the system remains same, and we just decreased it from 30 to 20. So a lot of informations to check the transaction, the queries, the reconnects if it is happening. So you can see the information is over here. There's a number of the thread, 20 threads, transaction per second, queries per second, and read, write, and other operations which are happening. The latency in terms of the percentage, it is 95%. And the earlier also it has been 95%. It is just we change the thread from 10 to 20. Since it is a lightweight machine, you will not be able to see much of this. Is just kind of simulation. This is not the real data, but you should be able to do when you find the real data. To some extent, PG bench and sys bench really helps. A combination of both. When you have to do some kind of rough testing in your environment, like how the environment is going to behave, then it is really going to helpful. And all the information is mentioned over here. You can find out over here. I hope this is going to help, and thank you. Welcome. In this session, we will see why PostgreSQL is not able to use the indexes, and we are going to have the first scenario. In the first scenario, we will see that the index is not available. So this is very generic. If the index is not available, then it is not going to use. So for this demo, what we are going to do is we have the Postgre already installed on EC2 Linux, And for the demo, we are going to use the generate underscore series function, and we are going to insert some 500,000 rows in our table. So uh, okay, let me clear the screen, and I'm logged into PSQL prompt now. And what I will do is I'm going to create a table. So I'll say create table, table name. I select star from generate underscore series 1 to 500,000 as ID. Okay, let's drop it, drop table, or table is dropped. Now let's create the table. The table is created with 500,000 uh, rows. The next thing which we will do is when you do this kind of operation, the large number of wall files will be generated. So in case you have to remove them, I have given the procedure to remove them, so you can utilize that, and you can clean up those wall files as well. So what we will do now is we will just do an explain, and we'll see how it is able to. So I'll just say explain select ID from the table name where ID equal to 5,000. You can see that we have the parallel sequential scan on the table for one particular row. So what we are going to do now is, since there was no index created on this, and this should be a candidate, what we are going to do now is we are going to create an index on this particular table, and then we will see how it is going to impact. It's very generic scenario, nothing great about it. So it is create index, index name on the table, and the column name. The index is created. Now instead of 5,000, I'll pick up, okay, let's do it for 6,000, just to see how the explain plan is going to show the details. You can see that index only scan using the index name on the particular table name. And now what this is first of the scenario. Let's say you have large number of queries which in general scenario will be running, and in that case you have to find out if you, so index only scan if it is a large table and it suffice the condition, then it is going to be useful in most of the scenario. The second scenario is when you are going to use the limit in the query. So let's say if I say select ID from no index where ID is greater than 100,000, and I wanted to limit it to, let's say, 10 values or some of the values, where in the number of display you wanted to shorten that. In that case also your Postgre is not be able to use the indexes. So this is another scenario when you have to limit the output. So you can try this out. It is very straightforward. The way we have seen is, let's create uh, let's create another table, and we will see how it is going to work. We'll see explain select ID from no index underscore ID where ID is greater than this, and you can see it is going for the sequential scan, though there is an index already available, but it is not able to use that. So it is not like that being an index available, it is going to use it. So there are some scenarios wherein though the index is available, but it is not able to use that. So you can see the first case wherein there was no index. So it was going for parallel sequential scan. Then over here, it is going for the scenarios doesn't advocate that using the index always be beneficial, but this is just to showcase what are the cases wherein the index, though it is available, but it is not able to be utilized in the SQL query. Let's go on to the next one. The scenario 3, which says mismatch between query data type and column data type. So you have something called SPG underscore cast in PostgreSQL, which can do some kind of data type conversion in PostgreSQL. These can be the predefined one or something which you have defined yourself, just in case they do not suffice the condition. In that case, it might be possible that though there is an index available, but it is not going to be utilized. What happens in PostgreSQL? Though the data uh, matching is not possible because of wrong data type given on the query side, or something else is mentioned on the PG underscore cast. So it will go through without giving any sort of error. So if there is a mismatch between query data type and the column data type, which is one of the use case of PostgreSQL, in that case also it is not going to use the indexes, though it is available on the table. This is the fourth scenario, which says that query is executing and it is displaying almost the complete content of the table. So for our case, wherein we have the entire what do you say, the entire content of the table being displayed. Let's see this scenario. I just wanted to display one data. That's select ID from for table name where ID equal to 2. So it is going to use the indexes, and I'm using another case wherein I'm saying you display everything which is greater than ID 10, and this is the scenario wherein I have 500,000 rows in the table, and the ID greater than 10 display everything. Though there is an index available, but it is going for the sequential scan. That means it is going to scan all the blocks of the table. So this is much cheaper and this is beneficial. And you can see the number of rows which are displayed is 499,990. So it is going for the sequential scan. In the previous case, only one row was being displayed where we have set ID equal to 2. So this is another scenario if you have to display the larger data set. In that case also, though the index is available, but it is not going to utilize it. The next very much popular scenario, we wanted the output of the table for those columns where the index is not being created. It may be one of the index, or it may be many indexes, or it may be the sequence of a display. In that case also, let's say this is a very generic scenario. We are saying select x and y from table where x equal to some value. If there is an index created on the column x and y, then it is going to use the index only scan. Otherwise, it is not going to use it. The second scenario we are saying, the two columns where indexes are already available, and we wanted to have some different scenario. In that case also, it is going to display, it is going to use the index only scan. The third scenario, we are using three columns. Two columns are indexed. The third column is being used in the SQL query, is not indexed, and we are trying to use that. In that case also, it is not going to utilize that. So that is what we have to understand. And this is very obvious in case of Postgre. So whatever columns you wanted to utilize in SQL query, it is good to have the indexes on them. The last scenario, it says the table size is very small, and if you create um, an index on top of that, and if you try to mm, to utilize the index, it will be not be able to do so. Let's say let's create a very small table which is just 5,000 rows. These are the very generic scenario, and very frequently used. So we have just 5,000 rows available, and if I say I wanted to display the one of the ID, and from a very small table, and if you create an index also, in that case also it is going to use the sequential scan. And to go more detail about how to find the indexes, if I simply say /di, I'll be able to find what all indexes are available. And the other case, you can use it /dis. You will be able to see more details. And the final one, this is a good one. You can see there is an index on the table, a no index table. That is the name of the table. The index name is given, and the column name is also given. So being indexes on the table is good if it is a large data set and if it suffice the requirement of the PostgreSQL query. But though it is available, it is not being used. These are some of the use cases wherein the index is being available, but they are not being used. So this is going to, I hope this is going to help, and just do a practice, because large number of scenarios are available. 5 to 6 scenarios are available, though all cannot be tested, but 4 or 5 scenarios you can test it yourself. And just remember, it is going to generate huge amount of wall files. So you need to make sure that you have enough storage for the walls, or just clean up them regularly during this demo. So that step is already mentioned uh, in the document, so you can refer that as well. And just in case you have some more questions, so the paid subscription is available, and here is the detail, and I'll be posting it in the Hello and welcome. In this session, we will see how to find out the slow running queries in PostgreSQL. So this is a very obvious kind of situation wherein you have to find like what all statements which is running in PostgreSQL, and if there is a benchmark which says that a particular SQL statement was running in 10 seconds earlier, but now it is taking 15 or 20 seconds. So just in case, you have to create some benchmark and you have to find out a particular statement, how much time it is going to take. Then you wanted to log it, the information somewhere. So we have some of the methods available due to which we can find out like what all is happening in my database. So this is my PostgreSQL 13, which is running on an EC2 instance. And all the steps are here mentioned in courses.e-multiskills.com. If you wanted some subscription, you can apply for that. Excuse me. So this is one of the I believe if you have some temporary problem, or once in a while if you wanted to log your information in a written format somewhere into the log file, then you have to do something differently. So using this way, which we are going to discuss, wherein what we are going to do is we are going to log the SQL statement, which takes let's say more than 5 seconds in the database. So what I will do is I'll log into PSQL and I'll show you a parameter which is going to help you in this case. So there is something called as log underscore min underscore duration. So I'll say show log min duration underscore statements. If you see this, okay, let me show you it using the postgresql.conf file. And the parameter which we wanted to see is I wanted to show the default parameter, though I have already changed it. So log underscore state underscore log underscore min underscore duration underscore statement, what it says is this particular parameter by default is -1. That means it is disabled. If you put this parameter to 0, then any action or statement which is executing in your database PostgreSQL cluster, this is going to be logged. That means all the information will be logged into your PostgreSQL log file. And if you wanted to mention a particular timeline, then you can mention the parameter greater than 0. The time which you mention over here, it is mentioned in milliseconds. So just ensure that you put the duration in milliseconds, then it will be automatically converted into seconds and whatever way you wanted to see. So I have already changed it from log underscore minimum duration underscore statements from -1 to 500 milliseconds. The next thing which you have to do is you have to generate some data. So what I will do is I have already created a PG bench, or what you can do is you can create some table. Let's say if I say, and if you mention this parameter into postgresql.conf file, this is for all the databases which are there in the cluster. So that may not be efficient for you, but you can do it for the individual database as well. Let's say if I wanted to make it 1000 or let's say 100 milliseconds, then if I say, so this is going to be done for the entire cluster, all the databases inside this cluster, and you do not need to reload, you do not need to recycle the instance, just reload it and it is going to work. Another thing is, which is very, very important, is from where can I get the data? So this is going to be very, very important. So you have some inbuilt tool which is called as PG bench. Using the PG bench, you can generate some data. So I'm just exporting the path of the binary location of PostgreSQL. And then what I will do is I already have a PG bench database which I have already created. I'm going to drop it and I'm going to recreate it. Excuse me. It is already in use, so I think the way, so I'll just say remove connection. I've already made some connection through the, yes. This should allow me to drop the database now. I think still there is some connection over here. I believe this is, okay, let me, though we can find out, but let's delete this. It's gone. Now what we will do is we are going to create the database and then we are going to populate it. This is one of the fastest way to generate some data, or we will see other way as well. Let's initialize the PG bench and then we are going to execute this. So this is going to create 50 connections and 1000 transactions. This may take a minute or so. In the meantime, what we can do is uh, we can generate some random data in some particular table. So let me create a duplicate session. EC2-user. So I'll say sudo su space minus postgre PSQL, and then what we will do is, okay, this is going to take a minute or so. What we will do is let's create a table. I'm connected to PSQL and I'll say create table slow underscore demo as select star from generate underscore series. This is a good function to generate the numbers. So it is going to generate, I believe, 50 million rows. It already exists. So I'll say instead of slow demo, let me drop this drop table and we will see slow underscore demo. Okay, this is dropped. Let's create table slow underscore demo as select star from generate underscore series. So this is going to insert 50 million rows, and once it is done, we will do some operation on this just to see how it is being captured. Let's create an index on the slow underscore demo table. So anything greater than 1 millisecond, we are going to capture in our PostgreSQL log file. That will be used later on for the analysis. For as of now, it is just like we wanted to capture the data. I'll say just display the number. That doesn't make any sense, but this is just I wanted to display the number and I wanted to see uh, how long it is going to take and how to capture that information in some recorded format. Okay, so I think everything is done from our side, and even the PG bench data is already generated. So we will go to cd $pg data / log. In the log file, you will be able to see the log. You can see the log is here with the today's escape shift G. Go to the bottom and you can see all the statements. This is 14 uh, um, 14,000 milliseconds, 11,000 milliseconds, 1,334 milliseconds. So what we did is anything greater than 100 millisecond, it is being captured. So it is like updating the PG bench table, PG bench underscore tellers. You can see that all these update statements are captured. So 131 milliseconds, 110 milliseconds, 140, and 11,000 milliseconds. So this is the statement which has taken the highest amount of the time, that is 14,000 milliseconds. So using this way, we can find out and it can be logged, but not for the entire cluster. For particular database, if you wanted to set, you can set it using this way. So I have mentioned this statement over here. So you can simply say alter database name, set log minimum duration statement instead of 10,000 seconds, milliseconds, whatever is, you wanted to find out, you can check out. So we have the SQL statement find out now. You can start the next set of analysis from here. Let's say if you wanted to check out the explain plan, and if you wanted to find out like how is the execution of the statements going on at a particular time of the day, then this actually helps sometimes. But there is not a replacement of pg underscore stat underscore statement in case. Yeah, that's a great utility. So what you can do is, so I have mentioned some more steps. Those who are having the subscription, they will be able to use all the steps. What else you can do is the another way is using the pg underscore stat underscore statement. So you can put this parameter in shared preload library, and before that you have to make sure that you have the contrib file downloaded on your system so that you don't fall into some problem. So once it is installed, you will be able to capture what all is happening into the database, but that will be printed over the screen. Just in case if you wanted to log it into some file, so that will be there into PostgreSQL log file. So both the methods, this is more prominent, this pg underscore stat underscore statement, but logging into your log file is also available. So whatever you are finding convenient and useful, you can use both of them. So, but don't forget to come out, just disable the log underscore stat underscore statements so that those are not unnecessarily captured. So once your analysis is done, like this particular statement has been taking this much of time, then you can put it to the default one or whatever you have set it in your environment. I hope this is going to help, and thanks. And we will see how to create a Aurora PostgreSQL DB cluster and how to connect it remotely. It's a very straightforward demo, and all the steps, high level steps are mentioned. We are going to create an Aurora PostgreSQL DB cluster. Please remember that the resources which you are going to select for this demo, that should be minimum to ease the charge on your pocket. And the second thing which we are going to do is, we have an EC2 instance running where Postgre 13 is running. We will try to connect Aurora Postgre cluster from EC2 instance, which is having the Postgre running over there. The command remains same. psql-host, this will be the host name of the Aurora DB cluster, the port, the username, password, it will prompt, and the database name. So let's get started with the first. So I'll open two. Let me go and find RDS. That's the first thing which we are going to do. We are in the RDS console. Not yet. I should have logged in, and I'll open another console for EC2 as well, just to save some time. Okay, so I have already an Aurora Postgre cluster running. I'm not going to take care of that. We are going to do it from the beginning. So this is my RDS console. It is looking like this, the default page. What you need to do is you need to go scroll down and you will see something like create database. So you will see create database icon over there, and it will take you over here. Sometimes the loading is very slow. All right, there are two things. One is the standard create, another is easy create, wherein you don't have to feed most of the thing, but we will go with the standard create, wherein we are going to mention most of the items manually. So I'll go with the Amazon Aurora, and we are going to launch Amazon Aurora for PostgreSQL compatible edition. That means it is a kind of engineered system, and it is having both the things, MySQL and PostgreSQL. Whatever you want to choose, you can go with that. For our case, it is PostgreSQL, so we are going with that. We are going with the provisioned one. We are not going with the serverless. And here in the version, you have the control. You can take the version whatever it fits for your case. For us, we are going to go with the latest one, which is Postgre 13.6, and we'll just select it. We're not going to do it for the production environment since this is a demo, so we will take the lightest machine. So we'll go with dev and test. The settings here, the DB identifier, this should be unique across your account. So I have database -1 DB cluster already running, so it will not allow me. By default, it is going to take database -1. Database -2 it has taken. The master username over here, it is Postgre. So you can change it, the admin or whatever you want it to do. I'll say auto generate a password, and it will take, let's say, this previous version generation classes we are going to take. It is just two virtual CPUs, 4 GB of RAM, and we are not going to create an Aurora replica that we will see later, like what it is. From the connectivity point of view, we will go with the public access. We have if you are inside the VPC, let's make it no, so that you can't connect it from outside, which is safer, suggested, and as per recommendation. But for our demo, we wanted to take the access from the outside or from the public network, so we have selected yes. And VPC security group, we are going to consider the default one. In the additional settings, you will be able to see the port number. We will go with the default one. In case you wanted to go with the non-default, you can choose that. Babelfish setting, in case you wanted to bring the data from MS SQL, in that case you need to turn this on, so that if I just turn it on, it is going to make sure that your migration and other parts would be incorporated into this. Database authentication is password based. That means user ID and password I have to mention. In the additional configuration, we are not going to do anything and just say create database. Now the next part is I have to access this particular Aurora cluster from EC2 instance. So what I need to do is I need to go inside the database 2-instance 1 while it is getting created. It is creating. So let's see if we have something. We'll go with view credential details. So if you lose the password for the one time, you need to reset it. So I'll just say copy. The username is Postgre. The password, it is available over here. So this is my password and username is Postgre. And now back to here. Once it is created, you will see this is the endpoint of the regional cluster, and this is read only. So let's select this one. VPC setting, this is okay. It is still getting created. It may take some time. Monitoring, logs and events, configuration. So let it create first. So just to save some time, what I'm going to do is in the security group, I'm going to feed in the IP address. Okay, it is still getting created. Connectivity and security. We'll go with the default security group, which is assigned. And this is the important part over here. Since I'm using the default one wherein I have added my local IP address already, so it should already be available over there. So I'll just say edit inbound rules, and what you need to do over here is you need to add two IP address. Uh, one IP address you will be selecting, we are just going to access everything on 5432. So what you will do is you just have to select your IP address and the EC2 instance through which you are going to access this. So I'll just select the EC2 instance. This is my private IP. I'll select this one and I will add it over here. So I think I already have added it over there. 172, this 172.31.42.128, this already exists, so I don't need to do anything, which is going to be the most important part. So everything looks fine so far. Let's go back to the RDS console, and we'll see what is the status of the instance of the Postgre Aurora cluster, which is getting created. Sometimes when you click these icons, it takes its own time. You see this sign, that means it's getting processed. All right, so it is available. This is getting created. So let's do some preparation now while it is getting created. The first thing is we are going to connect with pgadmin from the local system or any host where pgadmin is running. You need to make sure that incoming should be allowed from the Aurora cluster, which you are trying to access. So still the endpoint is not created. Creating. This should be available at any time now. Once you see the status available, then only try to access it. Endpoint is available now. So what I will do is just I'll copy this and I'll go to the PG admin. I'll go to the servers, create server, enter the name. In the connection string, mention the endpoint. Postgre is the uh, maintenance database. Username is also Postgre. And the password, you copy the password which you had taken up. And you just enter it over here. Try to see if the instance is created. No. It is still configuring enhanced monitoring. Go to databases part and see the status. No, still it is not available. You can see the error once you do it over here. Wow. We are able to connect now because the endpoint was available and we are able to connect to the Aurora PostgreSQL cluster. So you can see the way your vanilla Postgre looks, it is slightly different. The RDS admin, which is the admin database offered by AWS, where it is going to store most of the information. It is available and not accessible to the end user like us. Now the next thing which we wanted to do is we will go to the EC2 instance, and from here we will connect. So I need to take out this information. I'll put it on a notepad. I need to replace the host name, which I'll pick it up from here. Take the endpoint, make the replacement over here. This is the endpoint for the previous one which I created. And from the EC2 instance where I have Postgre available, I'll copy this and I'll paste this password. If I say /l plus, I'm able to see this. You can see I have the Postgre RDS admin template 1, template 0. We are connected with the database. So everything remains same. The only thing is we need to properly maintain the security group and from where we are trying to connect. Rest, the way you connect to any managed instance, it works the same way. You can see we are connected. So there's nothing very difficult in this, all very straightforward. And in the next session, we will see the next step related to the cluster. I hope this is going to help and thank you. Welcome. In this session, we are going to learn what is PostgreSQL in Google Cloud. So this is going to be the first session on Postgre in Google Cloud. So here we go. So Postgre is one of the most popular open source relational database, and at this point of time it stands at number one in terms of the capability it has. Because of this, all the cloud service providers, whether it is AWS, Azure, or Google Cloud, they have provided it a very good place in their repository. So when we are talking about the Postgre in Google Cloud, so it is called as Cloud SQL. So under Cloud SQL, it has its place as PostgreSQL. So if I say what is Postgre in Cloud SQL, or what is Postgre in Google Cloud. So we'll say that Google Cloud, it is called as Cloud SQL, which provides a cloud-based alternative to your PostgreSQL, which you install in your local environment in your uh, data center. So if you want to spend lesser time on spending and management of PostgreSQL, then you have to go with the managed instance, which is called as the Cloud SQL in Google Cloud. And because of the very strong and robust infrastructure which Google has, so you can rely on the infrastructure. And due to this, it comes in two variety for the PostgreSQL. One is infrastructure as a service. That means you can deploy PostgreSQL on a virtual machine in Google Cloud. Second, Google Cloud provides you the managed instance of PostgreSQL. So in short, Google offers you two options. One is you deploy the PostgreSQL in the virtual machine as infrastructure as a service, or you have a pre-configured PostgreSQL instance, which is running on a virtual machine that is called as the managed instance, wherein you will not have the access to the operating system. So these are the two options which are available in Google Cloud. So the next thing is, what does Cloud SQL for PostgreSQL offers? So in short, this is your PaaS or platform as a service. Though you have a pre-configured, pre-installed PostgreSQL instance available when you spin up an instance in Google Cloud, which is called as the Cloud SQL. So you don't have to bother about the backups. They just on the click, if you say I wanted to configure the backup, enable it for so many days, so that feature will be available. You don't need to bother about the high availability and the failover. Let's say you wanted to have multiple instances running in multiple regions, and in case one of the instance in a particular region is down, you wanted to have the availability in another region, so you have the failover capability inbuilt available. Your data will be encrypted in the form, which is data at the rest, data at the transition. You have the network connectivity available with the high speed network which Google is having. This is already proven over the years. The storage which is available, you can have the storage in terms of the auto increment. In case your storage is lesser, it will auto increment the storage. You have the flexibility of taking the export and the import of the data. You can configure the replication, which are the inbuilt. The maintenance and the updates, wherein you spend a lot of time, that part will be taken away from you in managed instance. The monitoring is very robust in case of PostgreSQL, and whatever you are doing in the PostgreSQL instance in Google Cloud, which is called as Cloud SQL, those activities will be logged. So you have almost everything whatever you are looking for in PostgreSQL as a managed instance in Google Cloud. So this is something which we have seen in the previous slide as well. So you have when we say the Cloud SQL instance of PostgreSQL, that means it is a managed instance of PostgreSQL in Google Cloud. So back behind the scene, there is a virtual machine which is running on a Google virtual machine. And this is having the PostgreSQL instance or the cluster which is pre-installed the way you work in on-premises environment. And this particular virtual machine, when we say as a managed instance, will have these standby virtual machine configured in another zone, and it is going to be identical to your primary instance. Your PostgreSQL instance, it is scalable, it is durable. You have the storage attached, which can be auto incremented according to your requirement. You have an option for the static IP, which is attached to the virtual machine, and using that you can connect to the PostgreSQL instance. So almost all the features which should be available with the guarantee of Google. This is an image from PostgreSQL managed instance. You can see this is a virtual machine wherein you have a persistent disk. Inside the disk, you have the operating system installed. You have the database cluster running, which is PostgreSQL. You have an static IP using that your application is going to talk to the PostgreSQL instance. So this is the basic architecture which you can see in Google Cloud for PostgreSQL, and it's almost the same if you talk about any Google any cloud service provider. What are the database admin tools? So the way you work in your normal environment, same way you can have it for Google Cloud PostgreSQL as well. So if you are working on PG admin, you can continue to use PG admin. You can have the dbeaver, so you can continue to use that. So database administration tools for PostgreSQL, the way it works in your on-premises environment or other cloud providers, the same way it is going to work in Google Cloud as well. So this is general definition of Cloud SQL. So when we say what is Cloud SQL, so this is a fully managed service that offers you three uh, databases. Two are open source database. One is PostgreSQL. MySQL is also coming up in open source as well as enterprise database, and SQL Server. This is the enterprise database which is offered by Microsoft. So these are the three databases which are available under the umbrella of Cloud SQL. Again, the same thing. What are the advantages of using Cloud SQL? So your time consuming management tasks, they are taken away from you, and you can continue to work on your application development. Whether it is about the managing backups, high availability, replication, failover, or applying the patches, taking care of the operating system, and so and so forth. So everything is being taken care by the cloud service provider, which is Google in our case. It uses the wire protocols so that you can connect from any application from anywhere. What are the PostgreSQL versions available? So this is very important. So the still we see a lot of organizations still use 9.6. That is one of the most stable Postgre which was ever released. But the current version is 14, so you can see we have the variety available 9.6 through 13. So these are the PostgreSQL versions available. When we talk about the minor versions are automatically update as part of the schedule maintenance, and based on your preference, you can modify it. So next important thing is, does Cloud SQL support all database features? So there is a list of features which are available. In general, we say the extensions. If you see the list which is available on Google Cloud for PostgreSQL, you will be able to see what all it supports. So there is always a restriction, like what is available and what is not available. So almost all the features which are available in PostgreSQL generally outside Google Cloud, they will be available over here. Features. The most important feature is this is fully managed, and if we talk about in terms of the restriction, you can go maximum to 624 GB of RAM, 96 CPUs. You cannot go beyond 64 terabyte of storage. So that means there is a restriction when we talk about PostgreSQL as a managed instance in Google Cloud, and that's with all the cloud service provider, right? And it is almost available in all the continents across the globe. When you talk about the security, Google stands at number one in terms of the security. You talk about its internal network, you talk about the data which is available, and almost anything and everything. And as usual, it is going to support your SSL and TLS protocols. The data which is replicated between the multiple zones, they are really secure, and you can perform the failover according to your requirement. You can perform import export of your PostgreSQL the way you do it on other cloud service provider. Same is available over here as well, and it supports your standard PostgreSQL connectors. You can have the backups automated or on demand. It supports the point-in-time recovery. You can do the instance cloning in case you wanted to do some testing. It is available, and whatever Google Cloud services are there, you can integrate it with the PostgreSQL. And it supports a wide range of the versions starting from 9.6 through 13. Are there any limits on the storage? Yes, if it is a managed instance, you cannot go beyond 64 terabyte, 96 CPUs, and 624 GB of RAM. How is the PostgreSQL data replicated? So you have two ways. So when you talk about the high availability, you have the managed instance replication from one region to another, which is based on the disk-based replication. So in case there is any problem, the instance failovers to the available instance which is there in another region. You have the flexibility of creating the read replicas in case you wanted your application to be redirected to a PostgreSQL, which is there in the read mode available. You can do that. So those features are available in managed instance in PostgreSQL for Google Cloud. And that's all the basics about the PostgreSQL in Google Cloud. I hope this is going to help, and thank you. Welcome. In this session, we are going to launch PostgreSQL in cloud, which is the Google Cloud, and it is known as the Cloud SQL in GCP. So you can say this is the logo of Cloud SQL, and under the Cloud SQL, we have three relational database. One is PostgreSQL itself, another is MySQL, and the last one in this series is SQL Server. So these three are the managed instances which are available as Cloud SQL, and we are going to directly launch an instance from the Google Cloud Console. So you can see I'm already logged into the Google Console, and let me go to the home dashboard. I don't need to go to that. So let's go ahead, and I'm going to scroll down, and you will be able to see something called as the databases. And oops, let me press escape, and you can see I'm scrolling down the sidebar, and under the databases, just scroll down further and you will be able to see something called as SQL. You need to have an access to the console so that you can create the required resources. In our case, we are going to launch PostgreSQL instance. So this is the first screen which will appear under the Cloud SQL instance. So you can read it over here. Cloud SQL instances are fully managed relational MySQL, PostgreSQL, and SQL Server databases. So for us, the area of concern is PostgreSQL, and we are going to launch the instance. So the launching is not a big stuff. You just have to click few things, and this instance will be up and running. The important thing over here is the instances which are supported are just four major version. It is 9.6, 10, 11, 12, and 13. I think it's five major versions which are available. And if you say choose PostgreSQL, you need to choose the category of the machine and the version. So this is the first. So I'll write the instance ID. So I'll say GCP PG13. This is the instance ID. And the second one is the password. And set a password for the default admin user, which is Postgre. This is not the super user the way it happens in your on-premises environment or when you install Postgre as infrastructure as a service. So this is going to be part of the admin group, and it is going to perform a lot of the administrative tasks, but this is not actual Postgre. So if you just say generate, it is going to generate some alphanumerical password. I'm going to copy and keep it for reference when we have to use it for accessing this cloud SQL. The database version, for our interest, we are going to launch the latest one, which is Postgre 13 in our case, but Postgre 14 is also available, but this is not available as of yet over here. Choose region and journal availabilities. Though you will be seeing a lot of uh, Jones over here. These are the different regions which are available. So according to your company requirement, organization requirement, you will be keeping the data into the particular region according to the law and the governances. The next one is zone availability. Do you want the multiple copy of the data to be replicated across multiple zones? Then you choose this multiple zone, which is highly available. Just in case one of the zone is not available, the data will be available in the next available zone, and the it can be filled over to there, and it will be available for your application. But in this demo, we are just saying, I just wanted a single zone. Customize instance. So you can customize your instance as well. Machine type. For our demo, a very small, lightweight machine is more than enough. So if I say standard, just one virtual CPU, 3.75 gigabytes of RAM, this is more than enough. The storage SSD, which is recommended, is required. I'm going to have just 10 GB of the storage, which is more than sufficient for this demo. In case you had, if you wanted to have enable automatic storage increase, you can do it in your production environment or in the environment when your application is going to access it. But in our case, this 10 GB is more than enough. So I'm not going to auto increment the storage because it is going to be more than sufficient. Encryption, you have two options over here. One is the Google managed key. Otherwise, you have the other option available as well, which is customer managed key. You can choose any one of them. So you have the advanced connect encryption options also available. For the connections, I'm going to have the public IP enabled in case you wanted to have the connection from inside. In a virtual private network, you can have the private IP. But for our case, public IP is more than enough because I'm going to access this particular Cloud SQL Postgre instance through my local system. Backups, you can enable the backups so that you can perform point in recovery. So if you are not aware, there is something called as wall, which is write ahead loggy. So before writing the data permanently into the data files, it is returned to a log file and it is available for recovery. For our case, we are not going to perform backup and point in recovery for this demo, so we are just going to disable it. Maintenance, this is very, very important. So any kind of maintenance which is related to the instance, if you don't choose a window, there will be a particular window which will be applicable across all the customers. In case you wanted to have a particular um, uh, maintenance window, you can choose it. Otherwise, Google is going to enforce its own recommended maintenance window. You have the flag insight and levels. We are not going to discuss more about that. Just go and create the instance. So once the instance is created, we'll see what is going to happen. This is creating and it is going to be available in, let's say, another 45 seconds or so. And what will be most important after this is how we are going to access the PostgreSQL instance. In general, when we try to access the PostgreSQL from a remote location, which is also known as how to enable the remote connectivity, you need to add the IP address of the client to pg_hba.conf. In that case, in managed instance, you do not have the access to the operating system. So there should be some way wherein the firewall will be allowed to access your PostgreSQL instance. So internally, it is going to update your pg underscore hba dot conf file only, so that remotely the client connections can be established. So this should be available anytime now. And what will be of our concern is the connection point, wherein we will be having the public IP available. So this is coming up, and what we need to do is there is something called as add network. So this is coming, this is like the incoming connections. So this is telling like pg underscore hba.conf, wherein you say which IP or range of the IP address and which username or the database, if they are coming from this IP address, they should be allowed connection or not. So it is something like that, but internally it is pg underscore hba.conf updation only. So when you say add network, you are going to add the IP address from which you are going to access this instance. So in our case, this is my client which I'm going to access through it. So I'll just say, okay, it is still creating. Once it is created, we will be able to do that. We will be able to mention the range of the IP address over here, and it will be allowed to connect. So in general, when you try to connect from remote, let's say if I'm trying to connect through a PG admin client tool, I will be mentioning the IP address over here, and under the connection I will be mentioning the port. The default port is 5432. Maintenance database is default one, which is Postgre. The username is also Postgre, and we will enter the password which we have generated. So this is the password. Let me try to do some of the things ahead of the time, but this is not going to actually work, because the host name is still getting populated. Oh my God, this is showing 3 minutes. Okay, created. Oh, great. So public IP, yes. I'm going to mention the name of the, I'll say this is client connection to my Postgre instance. And there's just a client IP, temporary IP. Oops. Okay, and I'll say done. I'll just say save. So anything coming from this IP will be allowed the connection. This is updating it. And if you see the users in your managed instance, you have one default user, which is Postgre, which is also available, for which we have the password. And let me show you the connections. Let's go ahead and fill up the details once everything is visible over here. Okay, let's go to the overview part. And this is my public IP, so I'm going to connect through the public IP. I'll fill in the information in the host name or the IP address. This is where my managed instance of Postgre is running. And if I say save, if everything is fine, it should allow me the connection. You can see a connection has been established. And these are the default databases which are available. We have Postgre database available over here, and the another one is Cloud SQL Admin. If you try to connect this is not going to allow you the connection. Okay, this is how we create a managed instance in Google Cloud for PostgreSQL. which is really very easy. The main part to understand over here is once the instance is created, how do you connect? So we are going to connect it from the outside. So we have the public IP address available, and under the connections, this is very important. You have to allow the incoming connections from outside. So you need to mention the IP address or the range of the IP address, which is going to connect to your Postgre managed instance in Google Cloud. So I just mentioned one of the dynamic IP of the client, which dynamically changes. So any connection coming from this IP address or the range of IP address will be allowed to connect. And just to verify that it is allowing the connection from the range of the IP address, I launched a pgadmin 4. I mentioned the public IP address of managed instance. User is Postgre, and the database is also Postgre, and the password was feed in, and then it has given us the connection. So you can see we have the connection established to the PostgreSQL managed instance. Under the users, you can see that by default there is a user which is created in PostgreSQL managed instance in Google, which is Postgre. And under the databases also, you would be able to see that the default Postgre database is available. We are not going to touch backup, replicas, and the operations part. We are going to see this in upcoming demos. So this is just a basic like how to create an instance. And the important part is how to allow the remote connections, which is the connections part. I hope this is going to help, and thank you. We're going to learn about the Google Cloud PostgreSQL user. So let's start with the demo. As usual, everything is mentioned on a notepad, and we are going to follow through it. So for this demo, what we have is managed instance of PostgreSQL, that is Cloud SQL for PostgreSQL, and we will see how the admin user, which is Postgre, which is available by default, how it is different from the infrastructure as a service virtual machine wherein Postgre is installed. So the access to PostgreSQL managed instance in Cloud SQL is being managed by the PostgreSQL role, which is at the Postgre level, and that decides how the roles can access a PostgreSQL instance. So there are two terms which are interchangeably used. One is role and another is user. But in reality is role is equal to user plus login. So if a user has the login facility, it is known as the role. So let me show you the instance which is created. So this is a managed instance of Cloud SQL for PostgreSQL, and I have initiated it, or I have created a very lightweight machine. By default, there will be a Postgre database available, and let it you can see that Postgre database is there, and by default there is an admin database user which is Postgre. Let me drop the other one which I had created. Okay, I'll leave it like this. And I have another one which is a Postgre which is running on a virtual machine. Now we wanted to see how the Postgre uh, user or the role which is available on managed instance, how it is different from the Postgre user, which is created when you install Postgre on a virtual machine. So here we go. So this is the managed instance wherein I'm logged in. So you can see if you see the list of the databases which is available over here in managed instance is Cloud SQL Admin. You have Postgre and you have template 0 and template 1. In terms of the role, you have Cloud SQL Admin, Cloud SQL Agent, Cloud IAM Service Account, Cloud IAM User, Cloud Import Export, Cloud SQL Replica, cloud super user and Postgre. So we are concerned about the Postgre because this is the default admin user which prompts for entry of the password. So we'll see how this is different from the normal. So if you simply see over here, the Postgre, okay, let me show it this way. So if I say du in, this is the managed instance. So this Postgre role, it is having the create role, create DB. These are the attributes available. But if you see a normal virtual machine wherein you have the Postgre installed, so if I just say du, so by default this is the admin user of Postgre. So Postgre is super user. It has create role, create DB, replication, bypass, RLS. But in case of managed instance, that is different. So Cloud SQL admin, which is super user, create role, create DB, replication, and bypass RLS. So this is the role which is having the super privilege, but you are having the access on this. So I'll go through the notepad now, which has some details. Like when you create a PostgreSQL role in managed instance, by default it comes up with the with login attribute. But if the same role you created through the PLSQL prompt, it is not going to have that. So as of now, I'm connected through the PLSQL client. If I say create role, demo role, if I created something like this and I say du, I created the demo role, says the demo role, and it is not having the uh, it cannot log in, right? And if the same thing you try to create it through here, so I created one which is called as test through console, and when I did it, if I see you the details over here, test through console, it is having the create role, create DB, and it is like your Postgre, which is having the create role and create DB privileges, and it comes under the Cloud SQL super user. So anything which is any role which is created through the console will be part of Cloud super user. It will have the create role and create DB attributes. If you want, that can be changed later on, but that's the reality with the role which is created uh, through the Google console. It will be having the create role, create DB, and login privileges. But apart from this, you have the IAM facility available as in the cloud. So in case of Google Cloud as well, you have the facility of IAM, identity and access management, wherein you can create the roles according to the requirement of the user. And the best part is you can put it into a particular group wherein the management of such roles are easy. So instead of having the database role, you can have it the IAM role, which is easier to manage at the infrastructure level. If you have several users that needs to be managed, roles to be managed, in that case, it is going to be beneficial. So in general, if any role is created in managed instance in Google Postgre Cloud SQL, in that case, it is going to have create role privilege, create DB privilege, and login privilege. And if I show you it through the PG admin, you will be able to see this is my cloud uh, PostgreSQL. And these are the rules which are available. Cloud SQL, Cloud SQL admin, Cloud SQL agent, and there are so many over here which are related to cloud. And The one which is of our concern is Postgre. This is not having the same privilege the way it looks like in normal installation of Postgre on a virtual machine. So it is quite different. And when you create it, when you create the roles in Google PostgreSQL, it has different privileges. Like it is having almost the super user kind of privilege. That this is something which you can modify later on. So this is all the basics about the default Postgre admin role, which is available in Postgre SQL managed instance in Google Cloud. I hope this is going to help, and thank you. Welcome. In this session, we are going to learn what is replication in PostgreSQL in Google Cloud, and that is known as the Cloud SQL. And under the hood, it is PostgreSQL. So it's all about the theoretical concepts we are going to learn, but we are not going to do some sort of demo that will be performed in coming sessions. So first thing, what is replication in Cloud SQL for PostgreSQL? So replication, as the word says, it's a process wherein a copy of the data is created on some other machine or by some mechanism, and that data can be used as and for some backup purpose. So in this case, when we say replication in PostgreSQL, that means another copy of PostgreSQL instance will be created, and that is used to offload the work on the primary instance. So replication is just another copy of PostgreSQL instance wherein we can perform some type of operation. For example, we have to be very specific in this. In this case, we are saying it is a read-only operation on the replicated instance of PostgreSQL in Google Cloud. So some basic question over here. Why do we need a replication? So by replication, you can scale the data for PostgreSQL without compromising the performance or the availability of your PostgreSQL instance. So in that case, there will be another copy of that data, and that can be used to offload the work. So when we say offload the work to the replica, that means it is just the read operations which can be performed onto the replica, not the write application, sorry, not the write on the primary instance of PostgreSQL. So we will be talking about two terms. One is primary SQL instance, and the another is the replica copy, which is replication instance in this case, and that is known as the read-only copy and also known as replica. So the one wherein read and write operations both can happen, that is known as the primary PostgreSQL instance, and the another where read-only operations can happen, or the analytical read operations can happen, that is known as the replica. So primary instance and replica instance. So this replica instance can be used in many scenarios. It can be like you are migrating your data between different regions which are geographically apart, and you can have the migration of PostgreSQL data across the platform. You can migrate data between on-premises and to the Cloud SQL. And and one of the important fact about the PostgreSQL replica is it can be promoted the way your original PostgreSQL instance, right? In case there is an availability of primary instance, just assume this case there is a primary PostgreSQL managed instance in Google Cloud, and you create a replica of that, and due to some reason your primary PostgreSQL becomes unavailable. In that case, your replica can be promoted and it will work like your primary instance. So that is one of the good thing about the read replicas. When required, it can be promoted as the primary instance. Okay, the instance. So we already talked about the primary instance, the read-only or replica instance. So the primary is the one which caters the all requirement of the application read and write, and replicas are just the ones wherein only read operations can happen. So what are the criteria? Your source can be on-premises PostgreSQL instance, and your read-only replicas, or your replica can be there in the cloud SQL for PostgreSQL. So this way it can work. And to perform this kind of operation, wherein you wanted to continuously replicate the data from on-premises to the PostgreSQL instance, which is there in the Google Cloud, known as Cloud SQL, you can rely on a service which is provided by Google Cloud, which is known as DMS, Database Migration Services. So using Database Migration Services, you can perform one-time load, and continuous replication can happen. So it's just some more detail about what is a read replica. So read replica is just an exact copy of your primary instance, which is catering the need of read and write for your application. And your read replica will be used for offloading the work. For example, the application can connect to it so to perform the read only operations, nothing else apart from this. So read replicas are read only, and you cannot write to them. So you can have the read replica process the queries, you can perform the read request, you can have the analytical traffics over there. So this is going to reduce the load on the primary instance, right? And one of the important facts about the hardware requirement of your PostgreSQL, which is your read replica, we have to ensure that read only the replicas, which is there for the read only operations, the CPU and the memory, it should never be lesser than your primary instance. Either it will be equal or it should be more than that. In case you are trying to use the read replica, you have to use the connection string of the read replica. That means the IP address, which is referring to the PostgreSQL instance of read replica. And there is something called as cross-region read replica. So that's another feature which is available in PostgreSQL, wherein you can create a cross-region. That means a region which is geographically completely apart from your base location. So wherever your primary instance is residing, you can create a read-only replica in a geographically different region, which is called as the cross-region read replica. So using the cross-region read replica, in case your application uses that particular region, so instead of crossing several regions to access your primary instance for read-only operation, you can keep one copy of the replica over there, one replica near to the user's base location. So when the user's base location and the region is in the same location, your throughput and your throughput will be better, and it is going to help a lot. So cross-region replicas are really doing great, because you can have n number of read replicas depending upon your requirement. So there is one more replication which is there in PostgreSQL, which is called as the logical replication. So Cloud SQL, it enables you to configure your own replication solution, which is using the PostgreSQL logical replication feature. So in case you wanted to rely on particular tables, you wanted to replicate it, in that case, you can use the logical replication. So uh, we will see there is a detail which is mentioned over here as well. So if you talk about the read replicas, your primary will be in your cloud SQL instance, and the replica will be there in the cloud SQL instance. That means both will be there in the cloud SQL managed instance for PostgreSQL. What is the benefit? It is going to increase your read efficiency, so that the read will happen on an additional replica, and this is going to give you better readout. outputs. It can be used for the analytical targets also for your the read replica. If in case you are going to use the cross-region read replicas, so in this case also your primary and the read replica both has to be part of your Cloud SQL. That means both of them will be managed instance, and like your read replicas, it is going to help you in additional read capacity. It can be used for, as a analytical target. It can be used as the additional DR capability in case your primary PostgreSQL managed instance is not available. Your read replica can be promoted as the primary, and this is going to help you in your DR capability. And this also helps in migrating the data between regions if it is already available, so you can use it for the migration purpose. So the last in this series is the logical replication. So you can have any PostgreSQL instance, you can have any version. You can have the replication from outside the Cloud SQL. That means you don't need to be there in PostgreSQL instance in Cloud SQL. You can have it outside as well. In case you wanted to replicate data at the granular level, let's say you wanted to replicate the table data or some subset of the table, then you can use the logical replication. So this is just the concept about the replication in Postgre in Google Cloud. So just a recap, you can use, I believe there are 10 read replicas that can be created in PostgreSQL in Google Cloud, and you have the cross-region read replicas also available. On top of that, you can use the logical replication in case you wanted to replicate particular tables or subset of the data in a table, then you can use that as well. So I hope the basics about the replication in Cloud SQL will help you. And welcome in the session. We are going to learn about the high availability configuration in Cloud SQL for PostgreSQL instance. As usual, everything is being mentioned in this document, so you can see that it is about the high availability of Cloud SQL for PostgreSQL. So the basic thing is why do we need the high availability? The high availability is required for an instance in because if that is particular instance goes down and if there is no alternative for that PostgreSQL instance, in that case it is going to be called as the complete disaster. So availability of the high configuration, it causes the minimization of the downtime which has occurred during the outage of that PostgreSQL, or it may be possible that the zone where your PostgreSQL instance is running, if that particular entire zone is down, that means if there is an alternate region wherein you have created your PostgreSQL instance, which is for high availability, then uh, doing the failover, which will be actually automated and will be taken care by the Cloud SQL, it will fail over the instance to the other zone where it is available. So that's the reason why we need high availability. So high availability of the instance will be there in one particular region with multiple zones. So zones are physically apart, distant apart, several miles, so that the disaster or some kind of calamities on one particular location could be avoided to reach to the other. There may be other alternatives as well, but for this session, this is all about the high availability, wherein the multiple zones of that particular region, they will be configured for high availability. So when the failover happens, the data will be served from the alternate location, which is the high available location in alternate zone. So what are the terminologies which are used in case of high availability? So you have something called as primary instance, which is used for serving the data to the application. And if the high availability configuration is configured, in that case, there will be an standby instance, which will be having the persistent disk through the synchronization process, which is on the disk basis. The sync happens between the disk on the primary and the instant and the standby instance, and they will be in sync with each other. So this is known as the synchronous replication. So synchronous replication is on disk to disk basis that happens between two zones in a region, and once there is a commit which is fired by the client or the end user, it comes to the PostgreSQL primary instance, and simultaneously it goes to the standby instance that is having the persistent disk. So that's a background how the primary instance will be there, what a standby instance will be there, and you cannot access the standby instance because that will be continuously replicated from the primary using the synchronous replication. And in case the entire zone, so let me show you the option when you create your PostgreSQL instance. At that time, you mention choose region and zonal activity. So if you select a particular zone or region, that is, let's say in US, I select some particular region. So inside that region, there will be multiple zones which are physically distant apart data centers, and they are being named as, let's say, if I select the primary zone as so in this particular region there are one, two, three, four zones are available. So if I select one of them as primary zone, then other than that primary zone, I cannot select the primary zone as the secondary. So other than the primary zone, you can select any of the available zone, and that will be used for the replication purpose. So the data will be synchronously copied from primary to the standby instance, which you cannot use it. So when are we going to use it? When there is a failover happens. Let's say the entire zone, let's say this is my primary zone, US Central 1A, and my standby zone is this one, US Central 1B. If primary zone completely goes down, then a failover happens, and in the failover, what happens? The primary goes down and the standby instance becomes primary. In that case, the application will connect to the primary instance, and what happens back behind the scene? There will be persistent disk which is used to copy the data from primary to standby instance using the synchronous replication. Synchronous replication. So there are two kind of replication. One is synchronous, another is asynchronous. In is synchronous, when a commit happens from the application end, the data will be simultaneously going to both the instances, primary instance and the standby instance. If there is any problem, it is not going to write anywhere. So in this way, using the disk-based replication, the data gets copied to the primary and the standby uh, instance. In case there is a failover happens, then the primary goes down. If primary is a problem, then it is failed over to the standby instance, and now your standby instance becomes primary, but the vice versa is not possible. So once the standby becomes primary and primary goes down, and after some hours, if primary comes back, then it will not be treated as the standby or the primary, whatsoever it was. Then you have to recreate that standby once again. You have to create the standby again. Then that will be part of the high availability. And if you have to fail back again, then you can do the failback so that you can come back to your original node. There is a slight difference if you talk about the read replicas. Read replicas, they cannot be made highly available like the primary instances. So when there is a zonal outage, traffic to the read replicas in that zone, it stops. It is not going to work. Once the zone becomes available again, then the read replica in the zone will resume replication from the primary instance. And if the read replicas in the zone that is not in an outage, then they are connected to the standby instance and it becomes the primary instance. So that's how your read replicas are going to work. So they are not highly available. So the common configuration, maybe there are three zones. Let's say there is zone A, zone B, and zone C. So you can configure high availability for zone A and B, and you can create a read replica in zone C that can you use for the read-only application. So about the failover overview, so Cloud SQL will automatically switch to the standby instance in case there is some problem with the primary instance or the zone is having any issues. And the operation is such a fast operation that you will not be able to detect it, and there may be a fluctuation in your application and if the way they are configured. And for the basic requirement for the failover is your the primary will keep on pinging the standby instance which are there in the high availability, and if there in case there is a heartbeat problem, then primary declares the standby unresponsive, and in case there is a disaster with the primary, then that is not going to happen. So for the failover to happen successfully, it is mandatory that your standby should be healthy and the zone must be available. And that's all basic about the high availability in PostgreSQL in case of cloud SQL for PostgreSQL. And if you want it in one session, we will see how to configure it and how to perform the failover. So we can expect it hopefully in the next session. I hope this is going to help, and thank you. Hello and welcome. In this session, we are going to learn about the backups in Cloud SQL for PostgreSQL. So one of the question which arises like in Cloud SQL for PostgreSQL, everything is automated, right? So even the backups also, you just do few clicks and everything works fine. So what is the reason we are going to learn about the backups in PostgreSQL for Cloud SQL? The thing is the kind of the concepts which are mentioned in the clouds, be it Google Cloud, AWS Cloud, or Azure Cloud. Before you have, in case you are learning the PostgreSQL, so if you wanted to understand the concepts, the best way is to start with the clouds. Therein the things are mentioned in very detailed way, and if after that if you wanted to work on the infrastructure as a service, or if you wanted to work on a Postgre which is running on a virtual machine, it is good to have those kind of experiences. The first thing is why we should have a backup. Backup prevents you to be in a situation where you have lost your data or your data is corrupted, and if you have a backup, you can restore from the backup. Right? In Cloud SQL for PostgreSQL, you have the automated backup, which is enabled by default. And in case you wanted to disable, there is an option for that also. But there is no reason that why should you disable the backups in PostgreSQL in Cloud SQL. So you can have two types of backup. One is default automated backup, which you can enable, which will take the backup according to the preferred time, which you mentioned in the backup window. And another is the online on-demand backup. So you say, I wanted to take a backup, you just do few clicks and your backup will be initiated and it will be stored. Is there a reason between or let's talk about something. What is the difference between the backups versus the exports? Let's say the PG underscore backup or PG underscore backup all versus the backup which is enabled by default and initiated by PostgreSQL in Google Cloud. So when we say the backups, when I'm saying backup, I mean to say the backups which are enabled by default in Google Cloud for PostgreSQL. So these backups are managed by the Google Cloud itself, Cloud SQL, which is according to the retention policy. Say, for example, if I'm saying the retention period has to be 7 days, after 7 days, those will be unusable and they will be removed. Right. And when we talk about the other types of backup, which is export backup, and when you upload it to the Google Cloud storage, then you have to manage the life cycle unless or until you say, I don't want the exports backup to be usable after 7 days or something like that. If not, then these will keep on accumulating. And if you have a policy mentioned for your cloud storage, then it is going to follow that. Unless or until you have some retention policy mentioned, it is not going to be deleted. So in short, your storage utilization will be higher in case your database size is big. So backups in PostgreSQL for Cloud SQL, it takes the backup of the entire database. But when we say the export backup, you can select specific contents. So that's the main difference when you are going to select the automated backups, which you enable by default, versus the export backups. And some of the important point is you use backup and restore operation to upgrade your database from lower version to higher version. But in case of automated backups, which are there in the Google Cloud for PostgreSQL, they cannot be used to upgrade your PostgreSQL instance. Say, for example, I have a PostgreSQL instance of version 12 and I wanted to upgrade it to Postgre 13. Then using the default backup, which you execute, you just say tick, you enable that backup, you execute it. And if you wanted to restore it to a higher version, it is not possible. If you are using the automated backup, then only the same version of the instance you can restore it. It cannot be changed. So that you need to understand. What about the backup size? Let's say my database, Postgre database size is 100 gig in size. Then is it something like if I have uh, given a backup window of 7 days, so is it going to take the backup on of 100 GB on the daily basis, assuming that on daily basis it is going to generate, let's say 5 GB or 6 GB of the transaction logs. So in case of Cloud SQL for PostgreSQL, these backups are incremental in nature. When you execute the backup for the first time, it takes a full backup of the PostgreSQL, and subsequent backup from thereafter, it is going to pick up the changes, and those incremental blocks, they are applied to the last full backup. So it means the backup size which is available for you, it keeps on incrementing. It is not like on daily basis it is going to take the full backup. It just increments the amount of the data which changes. So say for example there is a transaction log which is going to change your database every day 1 gig in size. So there might be a change of just 1 GB in the backup size. So that's the important part. Let's say you have deleted the last backup. In that case, when you execute the backup again, it is going to take a fresh full backup, and after that it is going to, from the next day onwards or from next window onwards, it is going to take the subsequent incremental backup. So there are two types of backup in PostgreSQL for Cloud SQL. You have on-demand backup and the automated backup. So on-demand backups are those which you can execute at any time, and if I have already the uh, automated backup, why should I go for the on-demand backup? Let's say you don't want to wait for the automated backup window to get executed and then start your backup. In between, you have some maintenance activity, or there is some application code which is drastically going to change the database behavior, and there is a chance that database will be corrupted or unusable. In that case, you have to take an on-demand backup, so that in case of some failure, you should be able to restore from the on-demand backup. And one of the important thing about the automated backup and the on-demand backup is on-demand backups do not follow the retention policy. Say, for example, you have taken 100 on-demand backups on daily basis and you have a retention period of 7 days. So anything which is falling in the 7 days for the automated, only they will be deleted, not your not your on-demand backups. They are going to stay unless or until you are going to delete it. So it's going to be heavy on your pocket. So if I talk about the automated backup, when you are scheduling your automatic backup, wherein you just have to select the bullet and you say I wanted to enable it, and you have to mention the window. So it's obvious you will be selecting the window when when the activity on your database is least, so that it can consume most of the resources of your Postgre instance, and backup can be. So by default, it takes a window of 4 hours. So it is assumed that within the window of 4 hours, it is going to complete the entire backup related activity. Okay, so when the backup is one of the most important operation, and sometimes it creates a server performance issue also. So, but in case of PostgreSQL, it is most of the time it is like that. It is not going to create the problem because it is going to be off business hours, and it is not going to create any performance impact on your system. So during the scheduled backup window, the automated backups will enable, and that will keep your backup up and running. So this is possible when your system is up and running. Let's say you have stopped your instance for some reason, then an extra backup is also taken, so that whatever the state of the database of Postgre was before shutting down, so an extra backup is taken by default, just to make sure that when your system comes up, and if you try to restore it, you should be able to restore post reboot. And if you have stopped your Postgre instance for more than 36 hours, in that case, automated backups will be halted. They will not be automatically started. So you have to make sure that you check what is the automated backup status. You are not going to get any warnings or alerts like your backup, unless or until you have some mechanism wherein you track that your backup has not been initiated from last 36 hours or something like that, because your system has been down for that period. So one of the thing where these backups are stored, these backups are stored on the locations which you mentioned during the backup. So mostly it is in the same region where your instance is located, or if you mention the multi-region, so the regions which are close to your locations regions, there it will be spread across. So that's the way the backup locations is decided. In case you have some regulations in terms of the data where it should be stored, so make sure that you be there in the territory, or you mentioned very specifically like that I wanted to store my data in this particular region only. So you have to be very sure. There is some kind of conflict between the transaction logs and automated backup retention. So when we say transaction log retention period, let's say if it is 7 days, then it is going to be counted in terms of the exact days. When we talk about the automated backups retention, it actually go beyond the day boundary. It may be lesser than that, or it may be more than that. So if you try to put it in that way, then it is going to be difficult, because it is designed in this way only. If you talk about the transaction logs or the wall logs, they will be parsed according to the policy on the daily basis, right? There are a few of the question, can I export backup? You cannot export a backup because they are automated way of doing the entire PostgreSQL instance. What about the backup user? So there is a default cloud SQL admin user, database user, which is used for taking the backup. So this is transparent. You cannot see what is happening, but if you see the status of running backup and something like that, you will be able to see the user which is doing this particular operation. So is there a way that backups are impacting the PostgreSQL operation? In most of the scenario, it is not going to do it. It is not going to create any problem. And one of the thing is it will be in the off business hours, and it doesn't take that much of resource. But there is always a chance that something can happen. And one of the thing is, um I'm not able to see the current backup operations for my instance. So Google Console doesn't show you anything other than the success or the failure. In case you wanted to see more, you have to go to the Operations tab in your Google Cloud Console in your PostgreSQL instance, and you will be able to see more details about it. And in case if there are multiple operators who are working on the PostgreSQL instance, if you wanted to see who has initiated the on-demand backup or something like that, then you have to go to the specific log in your log section, and you will be able to find more details about it. It's a very obvious thing. If the instance is already deleted, you will not be able to take the backup because Cloud SQL is going to purge it within the 4 days. And if you see that an automated backup is not moving, there is no progress, it is halted. That in that case, sometimes it happens your entire instance gets freezed, and it is good to, if somehow you get the access to the IDs which were in your you can see if it is moving or not, or you can in some of the cases you have to forcefully restart the instance to come out of this issue. And if you are trying to restore using your uh, mm, pg dump or pg dump all, wherein some of the things will be skipped, if the roles do not exist in the target PostgreSQL instance, then it is going to fail. In that case, what you have to do is you have to pre-create the roles just to make sure that the import do not fail. Last but not the least, when we are doing a backup and restore operation in PostgreSQL, I'm not able to see some of the tables. It might be possible that the tables which have been created, they have been created as unlogged table, and the transaction logs for those tables are not generated, and you are not able to recreate those tables when you are doing the restore operation. There's all basics about the backup operation in PostgreSQL for Google Cloud under the Cloud SQL. I hope this. Hello and welcome. In this session, we are going to learn how to create and manage the read replica for PostgreSQL in Google Cloud. So we are directly going to follow the notepad, which has all the instructions. For now, we just need to understand a read replica is just a complete copy of PostgreSQL primary instance. Now, uh, I'm in the Google Cloud console. I'm directly going to create the instance, and then we will see how to create a read replica on top of that. So this is Cloud SQL console. I'm just going and creating an instance. So this is, I'm going to create PostgreSQL 13 instance. So I'll just say this is PostgreSQL 13, or I'll say this is primary 13 instance. Password, I'll mention some password for Postgre database, Postgre role in PostgreSQL 13. So I have selected the PostgreSQL version 13. In the region, I'm just going to select something which is near to my locations. I'll just say Asia South 1, and I'm not going to select the multiple zones. I'm just going with the single zone, and I'll just say customize my instance. I'm going to have not a very lightweight, but a medium size or standard size. So I'll just say 2 virtual CPUs and 7.5 GB of RAM. In terms of the storage, we are not going to perform any additional activity. So we are just going to use 10 GB of the storage. I don't want to auto increment it. And encryption, we are not going to use, whether it is customer managed encryption key or it is provided by the Google Cloud. We are going to have it with the public IP, and we are going to add the our IP. So this is my temporary IP. I'm going to I'll just say this is client IP so that I can connect to my primary instance, and later on I'll connect with my read replica. We're not going to enable the backups. We are just going to take it off. Maintenance window, we are not very concerned because immediately after this, I'm going to delete this flags, nothing, insights also nothing, levels also nothing, and just say create instance. Once it is created, and let me show where it will come up. Okay, we should go to Cloud SQL. It will show up over here, and it will the public IP will appear over here, and we will put it into the client tool. We'll try to connect it using pgadmin GUI tool. Let's go ahead and see what is there in the notepad. So the definition for the read replica for PostgreSQL in Google Cloud is a read replica is a complete copy of your PostgreSQL instance, and this is the instance which is getting created. All right. And when you create a read replica, it is going to have the replication established in real time, and the data will be the change, whatever change are happening on the primary. In the real time, it is going to be applied on the read replicas. You can create the read replica in the same region, and also it is possible that you can create the read replica in different region. Then you can choose the zone wherever you want, and that's what the read replica is. Mainly it can be used if you have to perform some kind of testing on your primary instance. It is good to have a read replica created, promote it to the independent instance, and then perform the test, and then delete it or whatever action you want to take. Let me check it out if it is created or not. Still it is going on. Okay, the main purpose of the read replica is if you have an application which is read intensive, and your primary instance or your PostgreSQL instance which is serving the application, you want to bifurcate your read operations on one instance and write operations on other instance. In that case, you can code your application in such a way that the read replica, once it is created, it is going to read the information from there, and any write operations it is going to write on your primary SQL instance. And the other important part of read replica is read replicas can be used for the disaster recovery exercise. Since they keep on replicating from the primary instance, it is having the data in the real time, and due to some problem, if your primary environment is not available due to some reason, what you can do is the read replica which is available, you can promote it. Oh, still sometimes it is taking a lot of time. Immediately after this, I'm not going to connect with this. I'll go ahead and launch the read replica. Come on. Okay, I've given enough CPU, RAM, and memory to this. It should come up anytime. Come up, come up. Okay, this is done. Let's go back to Cloud SQL. Okay, this is my primary instance. I'll hide this info panel. I'll right click on the three dots which are on the extreme right. What you can do is you can customize the column display options also. If you click over here, I just selected a couple of the options which is useful for me. And there are a lot of options available. Whatever is of your interest, you can select. For our case, we just need the public IP in detail. What we will do is we are going to create a read replica. You have the option to create it in the different region and the zone, but for our demo, we are going to keep it in the same so that the creation and the transfer is faster. And automatically it has taken up a name, and it has hyphen replica. It has given the name. Machine type will keep same, either same, or you can give more than this. Connections also, public IP it has enabled by default, and client IP it has taken from the primary instance which we had created, and we will just say create replica. So instance is being created. Let's go back to the Cloud SQL console, and if you click this, you can see there is something related with that. That means that is a read replica which is getting created. It is going to take 2 minutes or so. In the meantime, what we will do is we will click the primary instance. Now it can be called as primary instance because there is a read replica associated with it. We'll go ahead and copy the public IP, and I'm in PG admin, which is a GUI tool, and we are going to create a connection. You need to remember that when you are going to connect to this instance, uh, the the remote connections, the remote IP which is trying to connect to your instance, there should be a firewall rule enabled. So that we have already done. So I said this is my this is my client IP, this is my system, and you allow the IP. So we mentioned the IP over there. And password, I believe I have given the simple password only. Okay, we are connected. This is my primary instance, and you can see there is a system database called as Cloud SQL Admin, wherein you don't have the access. And if we go back to the console, this should okay, this will, there's still getting created. Once it is created, the public IP will come up over here, and we will see how do we connect to this. We will be able to connect because the client IP is already attached to the instance. And what we need to do is uh, the next step, which is about the promotion. Promotion means we are going to make sure that the replica, which is in the read-only mode, it can accept the read and write operations both. That means the moment you say promote my read replica to the to that way, in that case the replication will be broken up. The read replica, which was earlier attached to your primary instance, will be promoted. It will open up in read write mode, and it will be an independent entity. So this particular part can be used for the disaster recovery exercise, or it can be used for some testing wherein you created the read replica for some temporary purpose, and then you perform your testing. So this is the fastest way of doing the things. So before you promote your read replica, you have to make sure that it is in sync with your primary instance. Sometimes it really takes a lot of time. Okay, let me go to the primary instance because it is getting created. So if we simply say select star from pg underscore stat underscore replication, okay, you can see uh, the replicated instance is over here. This is my primary instance. And let us see if the read only came up or not. This is still getting created. So once it is launched, since we are not pumping any data on the primary instance, so it is not we are not performing any write operations, so there will not be any transactions generated, and the transaction logs will not be transferred to the read replica. So it should be already in sync, but we will see the commands which we will run on our PG admin tool, which will show like what is the status of the primary in terms of sending the logs, and what is the status of read-only replica, how it is accepting or not, if they are in sync with each other or not. Once that is performed, we will go ahead and perform the promotion. If you see, as of now, they are attached with each other, so it is still going on, so we cannot see more things about it. Once it is completely launched, we will be able to see it. I'll wait for a couple more. It should not take more than 1 minute or so. Come up. So I thought this much of the power would be enough, but I think that was not enough. I should have given more than this. Okay, this has came up. This is my read-only replica. I'll copy this public IP. I'll go to the PG admin tool. I'll say to the server, this is my host name. The password remains what it was on the primary instance, because this is a replica of primary only. I'll say save. Okay, we are connected. So let me check out which was my primary. Primary was having IP address 115, and 160 is for read replica. 160 is your read replica. If you try to create a database over here, I'll just say testdb. Cannot, it is a read-only transaction. So this is your read replica. What we will next do is we will check the status of replication on the primary. To check the replica's status from the primary instance, you have to execute select star from pg underscore stat underscore replication. So you go to your primary instance and then you execute this. Oops, I don't know what happens to this. There's the PID. This is the ID username which is doing this replication, and client IP address. That means this is the IP address of your read replica, the port where it is listening, and it has almost all the details which is required for the replication. This from the primary side. On the read-only replica, what we will do is to check the replica status from replica instance. We are going to execute this. This is our read replica. This is our read replica, and here what we will do is I'm going to execute the query over here. So I'll say select star from pg underscore stat underscore well receiver. So on the receiving end, we wanted to see what is the status of val, which is write ahead logging. So you can say the status is streaming, and it is showing the recent time, the slot it is showing, which is automatically created using the Cloud SQL, and all the details are over here. You can read it. And the next thing we wanted to see is you check whether your application is running or whether it is in the pause stage. You can execute and check the status. It is false, that means it is not paused. If it is true, that means the replication would have been paused. You fire it from primary or the read-only replica, you will be able to see this. And you can check whether the transaction that has been received from the primary, but if it has not been applied, you can execute this one. This is our read replica. You can see the Postgre last wall receive LSN is last three digits are 528, and the replay is also 528. That means everything is same. And now the final thing which we are going to do is, which was supposed, so as of now, if you click this, if you expand it, they are associated because it is a read replica of this one. The moment for I wanted to do some testing, or because of DR exercise, I wanted to check whether this is having the complete data of primary or not. I can go ahead and say promote. And this is important. The operation cannot be undone. Promoting a read replica stops replication and converts the instance to a standalone primary instance with read and write capabilities. That means that there is no replication established. So it is the read replica is no more read replica once you perform this operation. You can always, once it is converted to the read write, this one, let me execute this, promote. It is going to promote, and they will not be any more associated with each other. And if you wanted to create a new read replica, and if you are assuming this is your going to be the primary one, then you can create the read replica from here and you can delete this, assuming this is your new primary. Now this new primary and the actual primary, they are not related with each other. They are independent entities and there is no relationship between them. Once it comes up, you will be able to see that uh, the relationship would have gone. So we'll wait for a minute or so once it is coming up. Okay, you can see there is no relationship between this earlier primary and the new read write PostgreSQL instance. In case you wanted to create a new read replica, and if you assume this is your new primary, you can create and say create read replica. You can create it from here. So this is how the read replicas are going to work. We already checked. Okay, we are all set now. So this is all about the read replica. You can create a read replica of any instance which is already available, and you can select the region and the zone according to your requirement. And in case of any disaster recovery, or in case you wanted to do some testing, you can create the read replica, you can promote it, you can make it as the primary, and then you can create a read replica from the new primary. I hope this concept is going to help. In this session, we will see how to import and export data in PostgreSQL, which is there in the Google Cloud. So we are going to follow through the notepad because most of these topics have already been discussed in terms of either the AWS cloud or the Azure. So this is particularly for Google Cloud. Just in case you have not got the hands-on, this is going to be helpful. So exporting and importing data into Cloud SQL, this can be done using the pgdump and pgrestore. So either you use pgdump or pgdump all, that depends upon the scenario. But for speed purpose, for the purpose of the for the purpose wherein database size is large, just make sure that you use the parallelism which is available. So just keep a note that if you are migrating an entire database from a supported database server, which is on premises, or if it is on AWS cloud, or it is from the Google Cloud SQL, and if you are trying to go to a newer version of PostgreSQL, or if you are going to the create a new version of Postgre in Cloud SQL, then uh, because of the facility which is available in database migration service, then what you can do is just instead of doing the export and import, you can use the database migration service which is available, and you can take the advantage of that. If you are exporting because you wanted to create a new instance in Cloud SQL, you already have some instance, then what you can do is you should restore it from the backup. So restoration from the backup, which is for an already available instance of lower in size. Let's say the capacity of the instance is lower, just take a backup, then you can use the facility wherein you can restore the backup to a newer instance. That we will see how to do that. When you perform the export in PostgreSQL, it takes the considerable amount of database resources. Database resources means the underlying uh, capacity of your instance in terms of the CPU and the memory. But normally it is not going to interfere with your PostgreSQL instance which is running, unless or until your Postgre instance is under provision. That means it is not having the sufficient uh, CPU and the RAM just to cater the need of the export, and in other scenario the import as well. So you can export data from an on-premises PostgreSQL using the pdump, and if you have to export a data which is not managed by Cloud SQL, then you can import it into the Cloud SQL, right? So you can use the pg dump hyphen u. You can mention the username. Let's say this is on premises, then it will be your postgre admin user. If you wanted to perform a plain backup, just say format equal to plain. Just don't mention the any owner because that is something which you can change later on, and this is no ACL. Then you can write the database name. Let's say my demo database is DVD rental. I can mention it over here. Then as SED you can use. What it is going to do is if you have any extension related stuff mentioned, so it is going to take out those, and a text format of the SQL file will be created. This you can use to restore in your database. Just in case your database size is larger and you wanted to perform the customized backup, in that case, instead of format equal to plain, you can mention format equal to custom. And I like the way the Postgre export and import commands are there in the cloud, which clearly mentions do not use the no owner, so that it will be easier in case you wanted to change the ownership when you go to cloud. So this is plain format, this is custom format. When you are going to perform the restore, which is there from an intermediate system in Google Cloud on a virtual machine, you transfer your backup over there, and then you perform pg underscore restore. Or in case you have the connectivity from your on-premises system, you can just fire this pg underscore restore hyphen h. This is the name of your cloud instance, hyphen u, the admin user who has the privilege. No owner, that ownership you can change for the objects which you are restoring, the mainly the tables, and then you mention hyphen d, the database name, and then the SQL file which is created in the above command. One thing else also you can do is while you are restoring using the pg underscore restore, and you mention the dump name. This is the name of the dump which you have taken using the pg underscore dump. You can, using the restore command also, there you can remove importing the extension. So when there are extensions, and by default there will be several extensions available in your Postgre environment, and If you wanted to remove them during the backup and during the restoration also, you have both the facilities available. So it is going to take out those create extension steps that you can do later as well once your import is successful. What are the issues? These are the known issues with the importing and exporting of the data in the managed instances. If you are exporting the large objects in the sense, and in case of PostgreSQL, we say the database size, if it is closer to 100 GB, we say it is a large size database. That doesn't mean that PostgreSQL is not having the proper uh, storage capacity, or it is not able to handle. It is able to handle the petabytes of database. If you are going to data warehousing solution, something like Redshift, we are not going to talk about that. It is just like wanted to say that 100 gigs, it's a big or large size database. So when you are taking an export, your instance may become unresponsive. It is because of the way it has been designed. And if you have the blobs, that means the large objects, even if there is no, if it is empty also, in that case also your instance will look like hang. This is the behavior which it is. So you may find it unresponsive. That doesn't mean that your instance is unresponsive. It is just that you have to be cautious when you are exporting or importing the large size object in your PostgreSQL. It will be unresponsive for some time. And if you are trying to import the big size databases, then you have to make sure that you split it into smaller size, just in case you wanted to transfer it to the Google Cloud or any other clouds as well. There is a limitation that say it is 5 terabyte. In that case, when you are taking the export, you make sure that you split into smaller sizes so that you don't face any problem when you put it into the Google Cloud bucket. And then the next one is the transaction log and the disk growth. When we talk about the transaction logs, which is wall, and when we talk about the backups, we in normal scenario in PostgreSQL in managed instance in Google Cloud, we say that the log retention should be equal to the number of backups. So if I say log retention period is 7 day and backup retention is 7 day, then the retention period of logs, which is your wall logs, it executes every day. But when you talk about the backups, it is otherwise. It is on the number of backups which it has executed. So you cannot change or the scheduled backup. We are not talking about the on-demand backup, the scheduled backup. In case you have to take the export, or you have to offload the export operation from the primary instance, what you can do is you can take the serverless export. So serverless exports are non-provisioned one, wherein you do not have to provision the capacity, the memory, and the power in terms of the CPU. It is something which will be automatically calculated when the operation starts, and based upon the requirement, it is going to expand. And once your export activity is completed, it is going to shrink down, and then finally, once it is done, it is going to go away. So you should try, in case you are trying to take an export backup, you can use the serverless feature. And one other important thing is you have to use the correct flags when you try to create a SQL file. There's something like, if you are not using it and then you are trying to import into the Google Cloud for PostgreSQL, it may be possible that it may error out making you in a suspicion that whether it is successful or failure. Say for example the rules, if the rules are not existing, it is going to error out. In that case, you should make sure that you create the rules in advance, then only you fire the import activity. And if your database size is large, it is always advisable that Cloud SQL already is supporting the import and export using both the compressed and uncompressed files. But if you are using the compressed one, then you are going to save some storage in the cloud as well. And when you are importing also, since it has the feature, so it is going to decompress automatically when you are firing the import. What about the wrong running import and export processes? So when you are running the export or import in Cloud SQL, and let's say if I'm talking about the import facility, which is going to take a long time to complete, say for an example, if it is database size is very, very large, then in that case there are several things which can happen in the PostgreSQL. So you cannot stop a long running Cloud SQL instance operation. It is not possible for you. So what you can do is you can perform one import or export operation at a time for each SQL instance which you are managing. And you can decrease the amount of time it takes to complete each operation by using the Cloud SQL export or import functionality with the smaller batch of the data. And for export, you can use the serverless export. And there are some troubleshooting steps which you can follow. If your import operation is taking too long, and these are something which has been observed many times, you just check out the active connections which are available in your PostgreSQL instance. You try to close them as much as possible, and some of those unused operations, unused what do you say, the connections, they also should be closed, because once you do that, your import is going to be the faster. In case you have some downtime also available, you recycle your instance so that all the existing or the one which are not required, they will be gone away, and when you start the import, it is going to be very, very fast. So this really helps. Okay, and other thing about the import is it can fail if it is finding some referenced user which is not there in the dump file, and if it is not existing. So it's always advisable that when you are importing it, make sure that they exist. If not, then you should use no honors dump and the import, so that you don't face any problem with that. And CSV export also work well, and that's the way it works. And what else? If the export is taking too long, then just some of the scenario, like import is taking too long, that means you have to check the resources of your PostgreSQL instance, close all the unused and not required connections. And this one we already discussed. And if you have already the extensions available while you have taken the export, you try to make sure that you avoid them taking using the sed command, which we have seen, so that it doesn't put it into the SQL dump, and while you are importing also, it is not going to use them. You can create them later, because the extension in PostgreSQL, they are preloaded, and you just have to give a reference in PSQL, so that it will be aligned with your PostgreSQL instance. And if you are having the error while you are using the pgdump all, uh, the tool requires the super user role, and the super user role is not supported in Cloud SQL for PostgreSQL. The PostgreSQL role in managed instance in Google Cloud is entirely different from your Postgre role, which is available in your on-premises or infrastructure as a service. So this is just the basic, like if it is taking too long, if it is unresponsive, these are the non stuff. If you have the extensions created while you are taking the backup or while you are taking the import, you make sure that you do not import it to avoid any kind of error and the confusion. I hope this is going to help, and thank you. Hello and welcome. In this session, we are going to see how to backup and restore data in Google SQL for PostgreSQL. So as usual, you will see everything is there in a notepad, and we will walk through it. And after this, we will perform a small demo. So this is all about how to schedule and turn off the automatic backups, how to create and manage on-demand backups, how to view the backups of your Cloud SQL instance. So one of the thing which has been asked, like everything is self-managed. It is just a few clicks you do, and everything is done. What's so special about the special thing about it? If you are learning on-premises environment, and if you try to do the managed instance, if you try to do some hands-on on managed instance, the best thing which will come out is you will know the concepts very well, and that will help you in discovering more things when you work on infrastructure as a service instance, or if you're working on an on-premises instance. So let's directly go ahead and perform a small demo. We have the managed instance which is already running in Google Cloud. We have Postgre 13 which is already launched. So what I will do is I'll just go ahead and expand it. You can see there are several options. So in the backup options, what you will do is for the automated backup, that is the first thing which you have to do. This can be a configured during the launch of the instance, or this can be done later on also. So I'll go ahead and start the edit, and in the edit section you will see automated backup and point in time recovery. So when you say automated backup, you mention the timelines when you wanted to take the backup. Let's say I wanted to take the backup during the quiet hours when the application activity is least, and it is going to perform the it is going to utilize the minimum amount of the what do you say? It is going to utilize your maximum amount of the resources for the backup. And in the advanced option only, we will say choose where to store your backup. So we will say choose multi-region, which is going to spread across the nearby regions only. And by default, we'll say take 7 days of backup. This can be anything between 1, 2, 3, 65. So it is 1, 2, 365 by default. You can do it for the 7 days. And in PostgreSQL, you have something called as transaction logs, which are known as wall ahead the wall files, wall ahead logging. So what it does, it contains all the transactions which has happened in your database. So basically, this is all the update, inserts, and delete what happens in the data in your database. Whatever the operations happens which changes the data, those informations are captured and they are written in wall log files. So in case you have to restore your database to a point in time recovery, you have to use those. So I'll say enable point in time recovery. So it is saying allow you to recover data from a specific point in down to a fraction of a second, and it is via write ahead log archiving. Make sure that your storage can support the days of logs you are retaining. So in our case, we have an instance which is of just few GB, but in real production environment where you need to enable this, you make sure you have enough storage so that there is a room to store those wall files. I'll just go ahead and do save. It is getting saved. So what is happening is the scheduled backup you will be able to see over here. And immediately after this, Any backups which is the number of backups which are going to happen is 7. It doesn't mean that 7 days backup will be available over here. But about the wall files, which is write ahead login, we have said it should retain for the 7 days. In that case, every day the older ones will be paused, and the other ones which are there in the window, they will be available over there. But there is the same is not true for the backup, so they can go beyond that. So make sure that you have enough room for your backups and your wall files. So while this is getting kicked off, you will see uh, backup type, the location, and the description if you have mentioned anything. Otherwise, they can be. Let us okay. Let us see how it looks like once it is spin up. So the backup is getting configured. That's scheduled backup. They are not the what do you say? Okay, this is so you can see that backup is scheduled. This is automated backup. This is multi-region. And description, you can mention anything. In case you wanted to restore the backup which happens, you can restore it from here. So either you restore it on the same instance so that it is going to wipe out whatever data is there, or a compatible instance. Let's say Postgre 13 is there, so you can restore it on the Postgre 13 instance if you have created a new instance. So it is going to restore over there. In case I wanted to continue with this, I can do that. But we want to do one more thing. We'll go to the backups. We wanted to create add-on backups, and add-on backups, you do not, by default, the policy, retention policy will not be applied over here. So manually you have to clean them up. So I'll say this is ad hoc backup. The spelling is wrong. Okay. Location option. So it is going to take the multi-region, and I'll say create. Is there anything special about it? No, there's nothing special about it. It's just like there are different options and how to restore from them. We already saw when we have an automated backup, you can restore it from here. But when you have an on-demand, okay, let it come out. So you can see that type is on-demand, and this is automated backup. We'll go to the overview. And we go to the all instances over here. I'll dismiss this, hide this panel. And from here, in case you, okay, this is still getting backed up, the ad hoc. I wanted to see how can you restore from an ad hoc backup to point in time recovery to a different instance. So I'm going to hide this. We'll go here and we'll say create clone. I'll say create the clone. And this by default it has taken this kind of name just for the identification purpose. In case you want to do something else, you can do it. So clone current state of the instance. We want it to clone from an earlier point in time. So you can mention the point in time. So whatever wall logs are there, it will, if they have been backed up, they are available, they have some data, even though it is not there, it will put your instance to a particular point in time. So you can mention the time and it should be able to recover till that point in time. So I'll just say 8:01 p.m. So it is going to do that. I'll just say create clone and the instance will be cloned. So this is just the basics about the on-demand backup or the uh, ad hoc backup or your scheduled backup. So you have different options available, and you have the recovery window also available over here. Retention period also mentioned there, where it is between 1 to 365, and they will be cleaned up as per their retention policy. The only thing which you need to take care about the wall logs. So when you set the log retention to 2 days, that means, or the 7 days, that means every day it is going to see anything which is older. That means, let's say if I'm saying 8 days of retention period for the wall during the backup retention, then anything which is beyond that, older than 7 days, they will be removed. The same thing is not true for the backups. It is going to check the number of backups which has happened in the last 7 times. So those are the scheduled backups. So you need to just be very careful about that. And when we talk about the disk usage and point in time recovery, you make sure you have enough room for those logs to be stored there so that they don't get purged. So you just have to make sure about that. And that's all the basics about how we perform the backup and recovery from an Cloud SQL for PostgreSQL instance in Google Cloud. I hope this is going to help, and thank you. Hello and welcome. In this session, we will see the disaster recovery concept for PostgreSQL in Google Cloud. And as usual, we have everything mentioned in a notepad, and we will go through it. So disaster recovery means the disaster has already happened and you are not able to access your PostgreSQL, and you need some alternate so that your Postgre can run over there and it can provide the access to the application. So in Cloud SQL for PostgreSQL, the disaster recovery is how do you continue processing the data to your application when one of the region which is holding your PostgreSQL is unavailable. So in short, the managed instance of PostgreSQL in any cloud and Google, those are regional instances also. They are regional services only. In case you have made it only to that particular region, and if the region is not available, there is some kind of a natural calamity or disaster, or due to some XYZ reason, they are not able to cater your requirement. In that case, you need some alternate. So that's all about the disaster recovery. So there are different things which are available. We talk about the high availability. We talk about the replica as well. Those are the two things which are going to help us in all the scenario. So if the Google Cloud region that has the PostgreSQL database instance, if that becomes unavailable, that means the disaster has happened and you need some alternate. To overcome this situation, you need to have two things. One is the DR plan, so that your PostgreSQL can, if it is already have the cross-region read replica, you fail over to that, and your cross-region read replica will be your primary, and that will cater the need of the application. Or there may be a failover based on your export and import that is going to take a long time, and that is not good for the large size database. In case you wanted to make your plan in such a way that when disaster has already happened, I'm going to prepare something after that or during that time, then it's not going to work out. You have to prepare in advance. So there are a couple of scenarios wherein we can talk about the cross-region failover configuration. So it all depends upon the SLA. If the SLA of the application is greater than your regional cloud SQL SLA, which is 99.5 percent, then by failing to the another region, you can avoid an outage. So you need to configure your PostgreSQL high availability in such a way that the other region is available for you to give the managed instance. So there is another option also. If you all the tiers of your application, they are multi-regional. So that, what does that mean? That means their availability is not confined to one region. Even though one of the region is down where your instance or your services are located, you will continue to work from the other region. So cross-region failover configuration is good to have in cloud environment. So you need to talk about the required recovery time objective, which is RTO, and recovery point objective. So if your RTO and RPO, they are in minutes, and which is good for the, and that's a requirement for the business application. And if you cannot hold it for hours, then failing over to the another region will be better, which will be faster than recreating a database. That may take its own time depending upon several factors. We'll talk about the types of the DR process. So when a database fails over to a secondary region, and the database can be available for the application. So it is like failing over the new primary is not available because that is impacted by the disaster, and the standby that is available for catering the need of the application. So it is basically the database fails over to a secondary region. Uh, but in case you wanted to fail back to your primary region when the region has uh, what do you say, it has become healthier again, then you can do that. So there is another way also, there is another part of this also, which talks about uh, your primary region. Your primary region is closer to your application. Just giving a scenario, and you wanted to have your application running only in your on your primary region because you that's better in terms of the network latency and other factors. So when the your primary region is available again, you will like to fail back to your primary region only. So let's talk about the DR architecture. So your DR architecture supports your HA, which is high availability, and it talks about there are two instances of PostgreSQL. There is one primary instance, and another standby instance. They are located in two different zones in one particular region. And these instances are synchronized. I'll show the diagram also, which I have taken from uh, Google Cloud, and they are being synchronized using the persistent disk. The other one is one instance of the Cloud SQL is located in another region using the cross-region read replica. So we have two things over here. One is the standby instance, which is being synchronized using the persistent disk, and the another is cross-region read replica, which may have some sort of lag. So uh, the second part, which is about the cross-region read replica, that always lags behind the primary instance. So whenever a failover occurs, the cross-region read replica might support and some sort of lag from your primary. So let's talk about the basic DR process. In the basic DR process, the primary region becomes unavailable, and the primary instance fails over to resume the processing from a secondary region. The DR process, it can be invoked manually or it may happen automatically, or also to mitigate the regional failure, and you will have an instance of PostgreSQL running in the secondary region. So basically it is the primary region which is running the primary instance. Let us say it is it is R1, and because of some regional disaster, it is acknowledged that uh, there is no way that you can recover. So in that case, you have to fail over. So if a failover is required, the cross-region read replica in the secondary region is made the new primary instance. And the client connections are reconfigured to resume processing on the new primary instance, and they access the primary instance in the another region. So let me show you the diagram which is available. This is your basic DR for PostgreSQL. You have Cloud SQL proxy through which you are going to connect. You have the region R1. You have two zones, Zone A and Zone B. This is your primary, this is your standby, and they are getting replicated through the persistent disk. But if you have another region wherein you wanted to have the read replica, so it is the same region 1 having multiple zones, zone A, zone B, and zone C. And if this is unavailable, then you have to come to this to cater your requirement. But if everything, the entire region is not available, in that case, it is a complete disaster. The design is not good. The other way is you have multiple zones in a particular region, and you have the HA high availability where in the two instances they are continuously getting replicated using the persistent disk, and you have a read replica also available in the same zone, and if everything is impacted, this all will go away. But in case you have the another region available with the multiple zones, so that in that case you can fail over to another region using the uh, read replicas. So that is being supported, and from there, if you wanted to configure the entire stuff again, then you can create the another HA from there, and you can configure the read replicas from there just to continue working with the DR setup. So this all basic how the DR works, and it is almost same in you talk about any cloud. It is good to have the setup ready in advance so that when disaster happens, you will be least impacted. I hope this is going to help, and thank you. Hello and welcome. In this session, we are going to learn how to deploy the PostgreSQL 13 in Azure VM. So we are directly going to start the demo, and as usual, everything is being mentioned on a text pad, and we are going to follow the steps. So this is my Azure portal wherein I'm going to just create a virtual machine. So just let me show you what all we are going to do. So we are going to launch an Azure VM with our HEL8. We will create it using the username and password. In the networking section, we will create a new security group, and our idea is we wanted to connect to that virtual machine from my local system. So two things will be required. One is I need to open the port number 22 for the SSH, and another is the way to access PostgreSQL using 5432, which is the default port. So let's get started. So I'm here in the home section of the virtual machine, and let's go to virtual machine and simply just say create. So I'm just going to create a virtual machine. So this is the screen which is going to appear. So for me, it is pay as go. Resource group I have already created, which is Linux RG. Virtual machine name, I will say PG13. And this is the region which is I have pre-selected it. It is Asia region, and the image which I am going to use is Linux 8.2. And this is the charge encode, and I'm going to use the user ID and the password. The username which I'm going to keep it, I'll make it over here. So the username, I wanted to keep it for this demo, and this is going to be like this. So I'll just mention the username is this one, and I wanted to keep the password some alphanumeric password according to the requirement like this. I've just copied and pasted the username and password which is required to create the virtual machine. And this is important inbound port rules. So this is very, very important to define like how you wanted uh, the the access for the ports, particular ports. If I say none, just say allow, or I'll just say, okay, let's go for the SSH22, and then we will create an additional networkings. Just go to disk. Um, we are going with the default options. We are not going to select anything special. Networking is something which is very, very important, wherein you need to mention which all ports you are going to access using your uh, the okay, let me we'll go to the advanced. We will create a new network security group. So this is only thing which is important for our demo. So we are going to access our machine, the virtual machine, using port number 22. So you can see that port number 22 is open. You can see the tick sign over here. And I want one extra port for PostgreSQL. So in the service section, you just have to select PostgreSQL. I'm not restricting the particular IP address just for this demo, which is very, very disaster, but let's do it just for this demo, and we'll say add. So there are two things. One is the SSH port open, and another is port number 5432, where default PostgreSQL is running. I'll just say OK. And then go to management. Next. We are not going to do anything extra from here onwards. So it is all the default values which we are going to create. And it's just a very lightweight system which we are going to create. And on there's the final validation page where we will just say create. This is going to take at least a minute or so. So what we have done is we have selected a virtual machine of RHEL8. I think it is one virtual CPU and 1 GB of RAM. The username which we have given is Azure-user. So instead of the private key, we are going to use the user ID and password, and I have given some temporary alphanumeric password. In the networking section, we have given something which is very, very important. You need to control the inbound security rules to the virtual machine. For our case, we have given two. One is for the SSH, another is for Postgre 5432. So once that is done, we will be able to access the virtual machine, and from there onwards, we will log into to the system as usual, and we will do these things. One is we are going to deploy PostgreSQL 13. So using DNF install, we are going to download and install PostgreSQL 13. We will initialize the database, we will enable and restart it. Then we have to disable the SE Linux. So in etc SE Linux config file, there will be a value SE Linux equal to disabled. We need to change it, and we have to make it from okay, I think okay, let me show you when it is available. So the deployment is still going on. If we go to the home, and if we go to the virtual machine, the new virtual machine, its name, I think I kept it PG 13 or something like that. So you can see that there is a line which is still moving. That means the deployment is still in the progress. So we have to disable the SE Linux from enabled to we will make it disabled. Then we have to make sure the firewall is disabled for this particular demo. And when we install PostgreSQL on a Linux-based operating system using yum or DNF install, that time an operating system user, which is called as the service account for Postgre, will also be created. We have to make sure that we give the sudo access to the Postgre service account so that it can log in without it can switch to sudo without password, and it can perform some of the operations like recycling the service, which will be required in our case. Let us see where it has reached till now. Refresh it. Okay, it has come up. It is the one which we have created, PG13. This is the host name. And on the left hand side, we have some basic information. On the right hand side, it will show you the operating system, the size, virtual, this is public IP. So we are going to log in through that. So I have just copied it. This is my putty through which I'm going to log in. So just say, mention the host name and deployment succeeded. So it has just got succeeded. So this should work now. Okay, the user which we have given during the deployment, we wanted an admin user to be created like this one. So that's created, and we wanted to uh, give some password, so that we had set during the installation itself. And this is what we have done. Now what we are going to do, we are going to follow this. So we have given the user ID, we have given the password, we are able to log into the Postgre virtual machine. Sorry, the host name of the machine was PG13. Then here we are going to install Postgre using these commands. So we have done it at least 100 of times, and we are just going to repeat it for the uh, Azure virtual machine. So I have just copied and pasted all the 6 commands in one shot, and it is going to take at least a minute or so. And once this is done, we will be moving to the next step. What are these steps? So you just say sudo dnf. From where I have copied these steps I have copied from postgresql.org download Linux Red Hat section. So there I have selected Postgre 13 RHEL 8, and it has given me these commands. So I have just copied and pasted all these commands. This is going to be very fast, and within 30 seconds or less than 1 minute, this deployment is going to be over for PostgreSQL. That includes the initialization of the database as well. So this is going on fast. Our end motive is, when the deployment is done, we will make some necessary changes, and we should be able to log in through the PG admin GUI tool. And we will be logging in from our system. Okay, let's go fast. So it is doing the installation. Yes. There is a fast step which is going on, the initialization of the database. The database has been started. So the next step which we are going to do, we can check one more step as well. We will say check the status. So instead of so we'll say sudo systemctl status PostgreSQL 13, and you can see that database, the PostgreSQL cluster is running. So what next we have to do is we have to go to SE Linux configuration file, and we have to change it from enforcing to disabled. So we will modify this value from enforcing to disabled. For demo purpose, ensure that your SE Linux and they are properly set, the firewall. Otherwise, there will be a problem connecting to PostgreSQL instance when you are trying to access it remotely. Okay, so this has changed, so we can check it again. What is the SC Linux status? SC status that may sometimes require, or that is going to require your reboot. So now the next thing which we are going to do is we are going to stop and disable the firewall. So we are just going to check the status. If you say simply systemctl status firewall D, it is going to show you the status. It is up and running. We need to stop and disable it. This is disabled. Just check the status again. The status is inactive, dead, so everything is fine. Move on to the next step. What we are going to do is during the installation of PostgreSQL instance, it has been done in a service account. PostgreSQL has been created as part of the installation. What we are going to do is we are going to enable sudo access for the operating system, which is the service account for PostgreSQL. We are just ensuring that when it has to use the super user privileges, it should not ask for the password. So in sudoers, we are just adding one line, postgre all equal to all, no password equal to all. That means do not prompt for the password, ask for the password when you have to use the super user privileges. Now let's verify if you can do the sudo su space minus postgre, you are able to log in. And if you say who am I, so it was logged in as Azure user, and now you have switched as the Postgre user. You just say ID and you are able to see it over here. And what more thing you have to log in and change the password of the Postgre database user. So we have switched to the operating system user Postgre. Now we are trying to use PSQL command prompt. So we are logged in as the command prompt through PSQL, and now let's change the password of Postgre user. So we are just going to change alter user Postgre, password is password. Just say du and you will be able to see you have Postgre. That's the only user available as of now. We haven't created any other because that's not required. The other thing which we are going to do is, by default, Postgre doesn't allow the remote connections. Just to ensure that it allows remote connection, you have to change. There is a parameter in postgresql.conf which is called as listen underscore address. Make sure that you provide the IP address or the list of IP address of your PostgreSQL operating system IPs. In our case, it is Azure virtual machine. Make sure you mention the IP address or list of the IP addresses. So what we are going to do over here, we'll just mention star in case we have more than one, then it is going to pick it up from there. Once it is done, let's restart the PostgreSQL services. We have restarted it, check the status, it is up and running. And using psql-u username -h the host name, we are going to test it whether it is going to work or not. So we need to ensure that the IP address of in pg_hba.conf is mentioned. So you can see that the IP address is not mentioned. So we are just going to edit one more file, which is our pg_hba.conf, and there are some client IPs through which I'm going to log in. I'm going to access it using that. So this is the way how you manage your client authentication, like which IP address or range of IP address will be able to access your Postgre. So this is where you mention it. And now we will try to access Postgre using the psql-u postgre-h pg13. Let me recycle and reload if everything is fine. Okay, let me check the status of Postgre. It is also fine. And now try psql-u. Okay, I have given the simple password. The password is just password only. And we have been able to log in using the host name. So let's try. So everything is good so far. And now what we will do is we will try to log in through the pgadmin tool. So this is our pgadmin tool. We'll go to server, just say create server, mention the details, and you should be able to log in if everything is fine. Just mention the IP address. In the connection section, you go and mention the host name or the IP address. In our case, it is this is the public IP, and we will mention the password of the Postgre database user. The database name is also Postgre, username is also Postgre, and just say save. Okay, perfect. So our IP address was 58. So this is the one. So let's go back. Just say PSQL create database pg13. This is the one which we are talking. As of now, it has just one Postgre database only. And just to cross verify, we are logged into the correct database. Yes, we have pg13 database created. I'll just refresh it. So we have pg13 database which we have just created, and this is all about it. So we'll just do a recap. What we have done is we have spun up a post Azure VM RHEL8, the lightweight machine. We created we mentioned master user or the super user at the operating system, which is Azure hyphen user. We mentioned the password, and then the most important part was the networking part. We allowed two ports. One is port number 22, another is 5432 for remote access on this particular port. Then we installed the PostgreSQL binary. We initialized the database. We disabled the SC Linux. We disabled the firewall. Then we enable the sudo access for Postgre database OS user. Then we tried switching to that. It was successful. Then logging to the database, we changed the password of the Postgre database user. And in postgresql.conf, we ensured that the local host is removed with either the IP address or the list of the IP addresses. And then we tried logging onto the same server using the hostname, which reflected that the IP address of the hostname should have been mentioned in the hba.conf that we have done. And we have added the client IP address also so that we can connect remotely. And when everything was successful, we launched pgadmin 4. We mentioned the IP address of the server. The username was Postgre. The database name was also Postgre, and we fed in the password, and we were able to log in. So this is step by step how you launch a virtual machine in Azure, deploy PostgreSQL, and how do you connect it. It is very, very hello and welcome. In this session, we are going to see to create and launch an instance which is called as Azure Database for PostgreSQL single server. So this is a managed instance which is being launched in Azure. These are some of the points which we need to understand. So this is general information about the single server. So you can manage many databases from single point, the way you manage it on premises, wherein you can have a single host and you can deploy many databases on top of that. The same way it will be over here also. We will have single endpoint wherein there will be a server and many databases can be accessed, and that particular endpoint will be the parent resource for all the databases, and it is being used for providing a namespace for the databases, and all the resources, that means anything which is related to the database, they will be residing in a particular region. The way you manage your on premises, to a great extent some of the things are going to work, like the login, firewalls, users, roles, configuration, etc. Not everything, but some of the things. The major drawback for the single server is the version which it supports. As of now, it is 9.6, 10, and 11, with 14 being launched last a month. So I believe this is not the correct uh, version, or this may not be something fitting into your portfolio unless or until there is some kind of requirement, like we want it to be in either of these three major versions. So it is 9.6, 10 and 11. So you need to make a decision making, like you want it to be on all the three versions which are quite old, and you wanted to create a single instance where in many databases will be hosted. And you need to understand that many databases which are going to be hosted on the single server, they are going to consume the resources. So the resource sharing will be there. So just make sure that many databases on a single PostgreSQL single server, that should accommodate your requirement. Then how do I connect and authenticate to Azure database for Postgres? The way you communicate as of today, you give an endpoint, you give the protocol, and you give the IP or the host name or the port, let's say default port. You manage the firewalls. To a great extent, they will be looking same. In the demo, we are going to see this. How to manage your server? The easiest way is you can go through the portal, or if you are good in the command prompt, you have the CLI also. This is going to be very important. The admin user which is created during the setup, it is going to be Azure underscore PG underscore admin. It is not your usual Postgre super user who will be the owner of the databases. So it is not going to be that. So there will be a role which is predefined. So when you create an admin user, it will be the part of Azure underscore PG underscore admin, and this role is not having the super user permissions. So who is going to have the super user permission? The Postgre super user attribute is assigned to Azure underscore super user, which belongs to the managed instance. So you do not have the access of Azure underscore super user. What you will have is when you create a new user during the launch, that time you can create it, and that will be part of Azure underscore PG underscore admin. And that's the way how the managed instances work. They will not give you the full access. And these are the default databases which you can see, and this is entirely different what you see on the on-premises. You see Postgre, a default database through which you can normally connect to your server, and that this is created. And the same way it will be here also. Azure underscore maintenance, this is something new in Postgres managed instance. So this database is used to separate the processes that provide the managed service from user action. Again, you do not have the access to this. And the third one in this series is Azure underscore sys. This is entirely related to performance tuning of your PostgreSQL query, the historical data, and something related to that. We will see in a separate demo like how it actually works. So just to understand, there are three default databases which are available when you create a managed instance in PostgreSQL using the single server. Server parameters. So in on premises you have postgresql.conf, wherein you have, I believe, 606 or 666 parameters. The same way you have the parameters available over here in the portal, and there will be a lot will be enabled by default during the creation of your managed instance, and there are other which are available, and based upon your requirement you can make the changes. Some of them are dynamic and some of them are static, that requires the recycling of the service. In that case you have to take care of that. So to a great extent it looks similar but not same. And now we'll start the quick demo. So I'm in the Azure portal. I'm going to launch Azure database for PostgreSQL. I'll say create, and this is the first one on the left hand side, which we else it is best for broad range of traditional transaction workload, and this is enterprise ready, fully managed community PostgreSQL with up to 64 virtual cores and optional geospatial support. So we'll quickly create it, and just for this demo we'll say I have created a resource group earlier, so I'm going to use that, and I'll give the name it's managed PG13, and and we will say this is our demo instance. The data source, do you want to create a blank server, or you want it to restore an existing server? So we don't want to do anything. It is just a blank server. So if you put it blank backup, then you have to give from where you are going to restore it. So location, I'll give closer to my my home location, the base location. And let me see. Okay, I'll go with this one. Okay. And the version, this is another challenge. So you have only 3 versions which are quite older, and the most of the migrations, they are happening in and around to Postgre 13 and 14 in already launched last month. So we should be looking something closer to 13. We are not going to go for a powerful server. For this demo, we are going to take a very simple server with the least resources, just to control the amount which we are going to put it on this. So we'll say just okay. So it is 2 CPUs, 50 GB of memory, and that's the minimum which can be allocated. And I will say this is Postgre admin, and we will give some password. So nothing great so far. It is just we have selected the different components, and the versions which you need to understand. It is not like whatever versions you want, it will be available. It is just you have 9.6 till 11 in this particular region. And then we will say additional settings. And additional settings, if you wanted to encrypt, you can go for that. If you wanted to the infrastructure double encryption enabled, if you wanted to do that, that can also be done. You wanted to put some kind of tagging, that can be done. Review and create. So I'm just going to create it, and the important part after this will be when you put the security rules, or the firewall rules, so that you can connect from your system or the environment. So that is something which you need to take care of. Otherwise, you will not be able to access your PostgreSQL managed instance in a single server, and you have to control that. So let us see how it is going to come up. Once it is available, it is going to take a minute or so, and once it is available, we'll see how it is working. Let me go to we will refresh it, and it is going to take a few minutes. I believe it is going to take at least 1 minute. So just a recap of what we have done so far is we have deployed PostgreSQL uh, 11, which is the most latest version in single server, and we are going to establish the remote connectivity using PG admin. And one of the important thing over here which is going to be is the version of the databases, the managed instance, and how you are going to manage the connectivity. So all right, let us go back to some of the important points over here. Server parameter, to a great extent, it is going to be the same. It is like your postgresql.conf, and pg_hba.conf. There is nothing like that, wherein you have to do the client authentication. Here you have security rules, wherein you have to say my IP range is this, or this is my particular IP which wanted to connect to this instance. So you allow the incoming connection from there, so that you can do. Other than that, you have in your on-premises environment, you have Postgre template, template 0, template 1. But in case of managed instance, you have Postgre, which is the default database. And there are 2 more databases. One is related to Azure maintenance, and another is Azure_sys, which contains or controls the information regarding the excuse me related to the performance of Postgre database. And how do we manage the Postgre? Either you can use the portal or you can use the CLI, and the user management, or the by default when you create a on-premises Postgre instance, you have something called as admin user, which is Postgre, who is the super user. But here you will not be able to do something like that, because super user permissions are restricted and they will not be allowed. There is something called as Azure underscore super user that has been revoked, and nobody is allowed to use that. And there is something called as Azure underscore PG underscore admin, which is used for the administrative task. When you create a user, the master user in case of this instance, this role will be assigned to that. And the way we connect it on premises environment, the same way we are going to connect over here as well. So let us see how we are going to do it now. This should be up and running any moment. Where is it? Refresh. And once it is up and running, we will go ahead and we will create the server. That means we are going to create the connection. But before doing that, we have to ensure that proper incoming connections are allowed. I don't know how long it is going to take. Come up. Okay, I think it is up and running now. You can see this is the server name, this is the admin username, this is the PostgreSQL version instance, this is the configuration of the server which has been configured. And what we have to do is, this is activity log, like what has happened so far, what time this instance has been created, access control in case you wanted to go it through the IAM, you can do it. Tagging, we have not given any tagging. You can diagnose if there is any problem. We'll directly go to the connection security. In case you wanted to have the connections to your particular IP or a range of the IP address, you can mention that. In my case, I'm just going to give it to my application IP address, or the host name, which is dynamic in nature. So it is going to take that. So once it is done, you should be able to access your environment, because this is somewhat similar to your pg underscore hba.conf. And there is something called as connection underscore string. If you are trying to log in through PSQL, this is the host name you have to give, this is the port, your database, let's say I'm trying to use Postgre, and this is the username. So username comes up with the @ host name. So you have to ensure that you use these parameters while you are making the connections. So what I'm doing is, this is my host name, which I'm going to damage immediately after this demo. And username, this is not just the admin user which you have created. The username comes up with the host name as well. So just make sure that you understand that. Username is username which we have created, the admin user postgreadmin @ this is the host name which you have created during the deployment. And if everything is perfect, I'm feeding in the password. I hope this is correct. And if everything is fine, it is going to connect. So this is connected now. So if you go to databases region, you will see there is something called as Azure underscore maintenance. So permission denied for database Azure underscore maintenance. Who is going to connect? The admin user which we have created, and that is not the super user. The super user is not given to anyone. You have something called as Azure underscore sys. This contains the information related to the performance we will see in some other demo. And Postgre is like your normal Postgre database which is created. So this is all about how we create an instance and the details around that. So just a quick recap. So we created a PostgreSQL instance for Postgre single server. So it is just a single host name wherein you can deploy many databases according to your requirement. The versions are the quite older. It is 9.6 to 11, and you can have one database on this single server, or you can have many servers, I mean databases, according to your requirements. The resources will be shared according to your decision. Then how do I connect? The way you connect to the on-premises PostgreSQL, the similar way you have to do it over here. The only thing is you should have the proper user ID so that it can connect to the PostgreSQL instance. How to manage your server? So you have the super user, which is being create not the super user, I'll say the admin user, which is part of Azure underscore PG underscore admin, which is not super user like your Postgre. The super user is Azure underscore super user, who has been restricted so that nobody can access it. So you have three databases over here. You have Postgre, Azure underscore maintenance, and Azure underscore sys. Server parameters are the way you do it in your on-premises environment. It is same. So if you see the server parameters, come up some, okay, you can see these are the parameters which are available. I do not see the count how many of them are there. You can go for the replication according to your requirement. You can go for the replica or the logical replication. We will see in some demo, and it shows you the properties like what is the status, whether it is up or down, what is the location of the managed instance, what is the login ID, and logs it is going to show. Then you have the performance, query performance inside. It will show you performance recommendation. If it has run for enough time, it is going to show you. From the monitoring perspective, you can create the alert matrices. You can go for the diagnostic setting in case you wanted to view the details which is related to the performance. You can review the logs as well. You have the log analytics which can be used. You can go and see the server logs the way you see it on your on-premises environment, or the logs which you see on your Azure VM. It is going to be almost similar. You can create the task, and you can check the resource health, and I believe that's all. So that's all about the basics of PostgreSQL managed instance in Azure. Hello and welcome. In this session, we are going to learn about something called as Citus in PostgreSQL. So this is a managed instance which we are going to see how it is going to work in PostgreSQL. This is general information about Citus PostgreSQL managed instance. So when we talk about the single server was one with a lot of limitations in terms of the versions also. But those things, they have gone away in Citus. So as a basic stuff, this is the back behind the scene. It is just going to use the open source relational database, which is Postgre in our case. And the good thing about is the Postgre 14, which has been released last month only, that has been involved in this managed service as well. So it is a fully managed database as a service. Or the good thing, or what do you say, the new thing about Citus is you can scale your queries across multiple machines using the sharding. So sharding was originally the concept in NoSQL database, because the origin of NoSQL database came where there was a difficulty in relational database. So relational database, they can be scaled up, they cannot be scaled out. So you can increase the power of your machines, you can increase the CPU, you can increase the memory, you can increase the storage. So those things can be powerful in a single machine. But when you talk about the sharding, where the piece of the database has to be spread across multiple systems, That has been an idea for NoSQL database originally, but slowly when you see the advancement in the technology, the sharding has been included in PostgreSQL. So it is going to be a matter of realization, like in the future, how it is going to work out for the companies who are going to use it. So when you are going to use Citus in PostgreSQL, which is your managed instance, it is going to serve your applications that require greater performance. So performance is going to be big stuff, even though we are using PostgreSQL, which is our open source databases, open source database, and when you talk about this managed instance, it is good when your database size is 100 GB and above. If it is below that, then your performance requirement and those stuff they not be so much. This is a general statement, but it depends upon application to application. So it also queries the engine parallelization, so you can spread across your SQL query to run on the larger data set. So just a recap, uh, what is Citus all about? If you have a requirement wherein data set or your database size is going beyond 100 GB and you need the performance in you need the low latency and high throughput, in that case you should go for this particular Citus. So it is PostgreSQL hyperscale Citus server group. And what are the different features of Citus? It is or the hyperscale server. So the best thing about it, you can use the sharding. You can horizontally scale your system. And there is a limitation, like these many nodes are only possible in particular configuration. You can parallelize your query on multiple hosts, or you can shard your database, and it is very good for if you have a multi-tenant tenant application. So you just worry about one box of Citus with multiple nodes, and you can have your connection to multiple applications to one box. When I'm saying one box, it doesn't mean one box. I mean it is the Citus application, Citus hyperscale server group. Back behind the scene, there will be many worker nodes depending upon your requirement. So it is going to serve your high throughput, low latency, and it is going to distribute your database. So a bit of NoSQL database capabilities are brought in. What are the different versions supported? If you talk about the single server, there were limitations, and by default they are being done. So if they have to sell their topmost product, they put the latest feature, and considering the requirement of the businesses, the versions and those things are supported. So if you see this hyperscale Citus, it is going to support Postgre 11, 12, 13 and 14. So you can see the minor release as well. So number 13, if I say 13.4, 13 is the major release and 4 is the minor. So this you can see it over here. So this is all about the versions which are supported. Extensions, this is very important when when you work on PostgreSQL. There is something which bothers everyone, is the extended functionality. So extended functionality in Postgre is brought in by the different extensions which are available if you're working on premises environment, and if you have to use that functionality, you have to install that extension and you have to use it. But in case of managed instances like hyperscale Citus, you have those installations already done. You just have to use this. So they are already loaded. You just have to create it in your database, and it will be available for easy to use. Otherwise, in normal on-premises environment, or if you are using infrastructure as a service, in that case you have to download and you have to use it. So this is something great in case of managed instance, so you don't have to bother about the supported extensions. And there is also the limitation, you cannot brought in the extra extensions which are coming up on a requirement basis. So it is something which managed instance owner, which is Azure, they are going to do it. If you wanted to see what all extensions are available in Citus, so from your command prompt, you just say select star from pg underscore available underscore extensions, and this is going to show what all is available. So that's a kind of restriction when you talk about infrastructure as a service or platform as a service. So you have some restriction, you cannot download extra ones. If you talk about the performance tuning, and in case of your infrastructure as a service, you have the flexibility, you have the feasibility of using the extra extensions or extra features which you can brought in from outside. But in case of managed instance like Citus, you have to rely on what is available. So your understanding about the environment is very important. So if I talk about pg underscore stat underscore is statement, this is the extension which is preloaded in Azure database, and you have to track the execution statistics of your SQL statement using this. So you can check out what is happening about the all statements which are running against your PostgreSQL, or how is the behavior for the particular SQL statement. So those things can be checked out using pg underscore stat underscore statements. And let's quickly jump on to the demo part. So I'm in Azure portal, so so if you go to home, you just have to click Azure database for PostgreSQL. You just say create and then say create. So in create, we have already seen the creation of single server. Flexible server we will see sometimes later, but I'm going with hyperscale Citus server group. It is best for ultra high performance and data needs, which is beyond 100 GB. And if you are consolidating your application and if you wanted to bring on to a single platform, then this might be a good choice depending upon the success of your POC. You can consolidate all your application. You can move your data from on-premises to Azure, and you can go to hyperscale Citus server group, and you can measure the performance, you can measure the functionality, you can measure the different extensions which are available, how they are going to benefit you. And if you do not have any dependency in terms of the operating system, if you do not have any dependency in terms of the version of the database, let's say if you don't want to use anything below 11, then it is going to be a good stuff for you. So we are just going to create it. It's just a demo, so my subscription is pay as you go. So I'm just going to create a resource group, which I already have is Linux RG, and I will create a server group. I'll say it is Citus demo EMS. Okay, so I'm going to create it in East US because this is not available everywhere. If I talk about some basic configuration, so it is not available everywhere. For our demo purpose, we will go with the basic configuration. And if I say configure it, the basic one, so if you see, I'm going with the basic 2 to 8 virtual cores and up to 32 GB of memory, and it is going to have coordinator and worker nodes unified. This is good for dev and test system. Later on, when you feel you are good with your POC and you can go to the production, you can scale according to your requirements. So I'm going with the basic tier, which allows you to run hyperscale on a single node, and with basic tier you can scale out ready. Basic tier also gives you an easy way to try hyperscale as your need grows in the future. easily add worker nodes on your server group, seamlessly converting you to the standard tier without any time. So this is good stuff, and that is a great thinking by bringing in such feature for the probable customers. So let's see the node. So you have something called as node because you are going to use the sharding feature over here. The data set will be spread across multiple nodes according to the key which you feed in during the creation of the data set. So we are talking about the node. So tune your node performance for your database need by selecting compute virtual node and virtual cores and the storage capacity. If you decide to convert to a standard tier, this node will become the coordinator node. So this is something which you need to understand. So if you see it over here, so it's already mentioned. So you have a worker node. So we are starting with the two virtual cores, and this is the limit, which is starting from 128 GB. I don't want to enable the high availability. If you do that, then when you say enable high availability to have standby replicas of every node with automatic failover. So we don't want to do that for this demo. I'll just say save, and this will show me the amount which I have to pay for this testing. So I don't, and these are the supported versions, and that's the major difference other than the capability of the system, the versions of the databases which are supported. So I'm going with the 13, I'm not going with 14, we will see. And one important stuff over here is the admin user is as compared to your single server, wherein you can give some admin users, leaving the restricted ones which are not allowed. So here it is already hard coded. The admin user is Citus, right? So this will be used as a PostgreSQL user name to connect to the database. If you are talking about infrastructure as a service, wherein you have the flexibility, wherein by default there will be an admin user which is called as Postgre. In your managed instance like yours, single server, you have the flexibility to have your own, which is not going to be super user, but here this is predefined. This is Citus, and I will give some password. Let's give the confirmation password. Okay, just go to the next, and here is the network connectivity, who all is going to connect to your Citus server group. So I'm just saying for this particular demo, after this will be destroyed. I'm going to have the public access, and then we will have the firewall rule. This is very important. You need to control your firewall rules in your Azure environment, and especially Postgre when you have to talk on the particular port. So inbound connections from the IP address below will be allowed to port 5432. So you are not supposed to mention the port number if you, because it is already provided over here, and you just have to say add some client IP, where this is just for an example. There is some client IP wherein I have to connect from. So just so we have provided we wanted to have it from public access. We have given the firewall rule. We are just saying allow this particular IP address or the range of IP address to connect on the port 5432. If you are not doing this, you are not able to connect. We are not going to tag it, and this is the final confirmation, and we will say create. This is going to take at least 1 minute or so, and once this is done, what we will do is we will go ahead and try to connect using the PG admin. The most important part when you work in Citus is you need to understand that you don't have a Postgre uh, admin user the way you have it in your infrastructure as a service or your on-premises environment, or if you have worked on a single server wherein you can give your custom uh, admin user, which is not the super user, but it is assigned a role similar to that. But here, this is the username is hard coded. If you are trying the older way of connection, it is surely going to fail. So in the connections string, you will be able to see how it is going to work. So just a recap before this is launched. So we discussed about Azure database for PostgreSQL, and the name is Hyperscale Citus Server Group. The general information about it is a fully managed database as a service. It works on the concept of sharding, which was originally for NoSQL database, wherein you can add the nodes horizontally. You can have maximum multiple nodes, wherein your application query will be running on those nodes. The performance will be better. The same ideology has been used over here. So you have low latency, you have high throughput, you can parallelize your incoming SQL queries on multiple nodes, which are known as the worker nodes. And one of the baseline over here is if you have the data which is 100 GB and above, then you should start thinking about it. If you have a database which is lower in size, then it doesn't make any sense using a server which is of higher capacity, wherein you will have multiple nodes, and you will have to spread your incoming queries on multiple nodes. And then we saw the Citus feature. Citus feature, it is going to use the sharding. You can spread across your queries on multiple nodes, and you can have the operational analytics, and it supports the multi-tenant applications. The version, it is a very, very important part. So if you talk about the single server, it is almost using the all legacy versions. I should not just say the legacy version. I should say the versions which are quite older, and if there is a version which is available which is better in terms of the features, we should go ahead with the latest. The most stable version available as of now is PostgreSQL version 13, which is the major version. And if you have to see the minor release as well, you can go to the documentation, or there you can find it. So it is going to support your Postgre 10, 12, 13, and 14. Excuse me, it is 11, 12, 13, and 14. And extensions are the special feature in PostgreSQL, and by default extensions will not be available. So but in this case it is available for your use, and there are pre-installed extensions available, and you can use them. So the provisioning is still going on. We will come back to here. And one of the challenge when we work in on-premises environment, or infrastructure as a service, wherein you provision a virtual machine in Azure, maybe it is your AWS, it is your current Azure or GCP or Oracle or any other cloud service vendor. The challenge will be you have to install the extensions yourself, and you have to manage it. The good thing about this is some of the most famous and very, very useful extensions, they are already available in Citus, and it is ready for use. You just can go ahead and start using it, so you don't have ready for your PostgreSQL. So you can just check from select star from pg underscore available underscore extension, and it is going to show you what all is available. Another restriction over here is whatever is available, it is what you have to use. You cannot download anything extra. And that's what all the cloud environment all about. Provisioning is still going on. Okay. I think that should go away in a minute or so. And when we talk about the performance tuning verification, like what all is happening in my PostgreSQL database, there are a lot of tools available inbuilt with your Azure console. You can use most of them if you are familiar with them, and they are GUI and very friendly. You just click and you will be able to see something which is relevant or irrelevant for your usage. But this is Hello and welcome. In this session, we are going to learn about the extension in PostgreSQL, and specifically in this particular demo, we will see the Azure database for PostgreSQL on single server. The demonstration is not about the PostgreSQL single server and how the extensions are managed about that, but this is about the extensions whatever they are available in Postgre and the ones which are really in good use, they have been put in Postgre as well. So this is just a way to learn the different types of extensions which are available. So if you don't know what is an extension and if you're a newbie, it is going to be helpful. If you already know what the extensions are and what are the different types of extensions available in PostgreSQL, then you can skip this. So an extension in PostgreSQL, it provides you the ability, or it can help you to extend the functionality of your database. So if you are from enterprise database background, you would be knowing that any new capability or new feature which you wanted to add to your database which is already available, and in case you need to use it, you have to pay for that particular feature. Say for example, partitioning in Oracle database, or TDE, or some sort of encryption or compressions features which are available in your enterprise level database. Not all, but say for example the Oracle one, then you have to pay the license fees to use them. Similar stuff when we talk about open source relational database like PostgreSQL, they have been provided to you as an extension. So you download the extension, you create the extension in your PostgreSQL, and you are ready to use. So PostgreSQL extensions make Postgre a great open source relational database so that it can be used. So there are several so famous extension that can be integrated with your PostgreSQL, and you can use those extensions in your PostgreSQL environment. So that's general introduction about extensions in PostgreSQL. Readily, they are not available when you download a simple PostgreSQL software on your server on a virtual machine. When we talk about a managed instance, say for example, when we are talking about this particular case, wherein this is a managed instance and this is running on a single server in PostgreSQL. In that case, Postgre has the default extensions which are already available. They have been provided as a managed instance. So which extension in Azure, uh, how we are going to use those extensions in PostgreSQL? So you you don't need to install any extension when you have to do it in your managed instance, like the single Azure PostgreSQL. What you need to do is, from your PSQL or the command line, you just have to say create extension, whatever extension you wanted to use, and it is ready to use. You do not need to download the related package. Let's say you wanted to use the auditing in PostgreSQL. So you just have to download, and then you have to create it and you have to use it. The first phase, which is all about downloading, making some adjustments. Say for example, in your PostgreSQL, if there is some extension which needs to be put in your shared library, something like that, you have to put it over there, but those things are taken away. So in that way, PostgreSQL single server is good. You don't have to download it. It is ready for use from your command prompt. You just have to say create extension and the extension name. So what are the list of the extensions which are available in PostgreSQL in Azure on a single server? So I have already put it on the, so I have already created a single server managed instance in PostgreSQL on Azure, and simply if you say select star from pg underscore available underscore extension, it will show what is already available in your single server. So you are good to use it. So you can see over here, sometimes the setting goes away and it creates a lot of problem for me. Okay, let's go back to the presentation. And the best part of managed instance in case of Azure is they are already available and you are good to use. The bad part is in case there is an extension which is already not available in that list, there is no way to use them. In case your instance or your Postgre requires a new extension to be added, that's not at all possible. So this is a kind of limitation in PostgreSQL managed instance for Azure. There is no such flexibility. The way managed instance works, they do not allow you to make changes, so the same is available over here. I'll show you what all is available. So if you simply say, okay, let me expand it. Okay. So you can see these are the list of available instances. So I'm connected to a demo instance which I created just now, and this is on single server. The problem with the single server is the obsolete kind of versions are available. Not the obsolete, I will say, the versions which are quite older. So we are on Postgre 14 now, and it has just three options: 9.6, 10, and 11. So I have deployed a PostgreSQL 11 on a very small machine. And these are the available in the extension. So we have address standardizer, which is used to parse address into constituent elements. We are not going with these. So some of the famous ones. The famous ones is this is DB-Link. This is very frequently used, and it is used to connect to another PostgreSQL databases from within a database. So you can see about the Earth distance. It calculates the great circle distance on the surface of Earth. HStore, this is also a good way in case you are familiar with the JSON. So it can store your data in form of key value pair. Not only this, and the best ones are yet to come. Aura FCE, this is the function and operators that emulates a subset of functions and package from the Oracle. PG Crypto, so it talks about the cryptographic functionality, so you can use this PG Crypto. And you have PG Buffer Cache, you can use it. If you have to use the partitioning, you have this PG underscore partman. PG pre-warm, never used. Okay, so this is very oftenly used, which is PG underscore stat underscore statements, which tracks execution statistics of all SQL executed. Then this is the default one, which is already available. Then you have post GIS. That's very famous PostgreSQL extension. So this is PostGIS geometry, geography, and raster spatial types and function. We are not going to discuss about that. And Postgre FDW, very famous and very frequently used foreign data wrapper for remote PostgreSQL servers. Let's go down and see what all are available. Okay, so there are many more which are available, and you can look at those. So this is I have put it on the screen as well. This is just a copy and paste whatever is available on the screen. And okay, I think there are some which are repeated. So PG audit, this is very famous. PG crypto, this is also very famous. Then you have PG underscore partman. Then you have which one? Postgre underscore FDW. The idea behind this demo is in case you wanted to play around with the extensions, and if you don't want to spend time on deploying it and then testing it, so it's already available. You can play around it, and it is going to be useful if you have to do some POC on some sort of what do you say, the extensions. It is going to be really helpful. And that's all. So just to recap, what we have seen is the extensions are the added features in PostgreSQL. Unlike any enterprise database wherein you have to use some feature, you have to enable it and you have to pay the licensing fees so that you can use that. But in case of PostgreSQL, that is bundled as an extension. You download and you create the extension in the database and they are ready to use. There are a lot of extensions which are available. The cloud service provider like Azure has already made it available on the managed instances. The one in our case, it is just a managed instance of PostgreSQL on single server. Though the versions are quite old, 9.6, 10, and 11, we just installed a managed instance of Postgre 11 and we saw what are the available extensions. And you can see there are a lot of extensions which are available and they are ready to use. Like any other managed instance, it refrains you not to install, or it doesn't allow you to install any new extension on your PostgreSQL. So I hope this is going to help and thank you. Hello and welcome. In this session, we are going to learn about the read replicas in Azure PostgreSQL single server, or it can be any other managed instance in Azure PostgreSQL. So what are the read replicas? The read replicas are the kind of the replicated instance that has the data of their primary PostgreSQL server. And these are mainly used for read applications wherein you can redirect your application which are read only. So these are just the read only managed instance of PostgreSQL. And the most important part over there is they are updated asynchronously with the PostgreSQL primary server. That means the data which is being modified or updated on the primary PostgreSQL may not replicate to your read replica on real time because this is asynchronous, and it also depends upon what kind of workload is there on your primary server and the speed of replication between primary to the read replica. So you can have maximum up to 5 replica, and there will be one primary uh, replica. So in total, so you have six. One is primary, which can be used for both read and write operations. But if you are making your application in such a way that if there is any write application, it goes to the primary, and if there is any read operation, it goes to replica. Then you can have 5+1 settings available. What are the usage of read replica? They are useful when you have read intensive application. You can redirect your application to the read replicas, which is maximum of 5 in case of Azure PostgreSQL. So you can use your primary replica both for read and write, and your read replica for read operations. And the important part of this is read replica can be deployed onto a different region, and in case if it is required for your read replica to be promoted to a read write server during a DR exercise or something like that, they can be. So you stop the replication, that means it is already detached from your primary, so the replication doesn't exist. It is now an independent PostgreSQL instance that can be used for read and write operation. And what needs to be taken care when you are planning the read replica for PostgreSQL? So one thing to understand that it is asynchronous. So the lag which will be available, you have to accept that. There isn't anything which you can do, and this is mainly useful for the query offloading, and the latency may be from minutes to hour depending upon the workload of your primary PostgreSQL instance. So if the primary instance is not so much of write intensive, in that case, or you in other words you say, if it is not so much of workload on that, in that case the changes which are happening on to the primary, they will be comfortably replicated to the replica managed instance. So uh, one thing to understand, if it is your primary instance is too much of write intensive. That means too many workload is there, too much of workload is there, and the data is being changed like anything. The amount of the wall, which is your write ahead logging, which changes, it is too much. And because this wall has to be transferred over the network to your read replicas, if the rate of generation and the transfer rate from your primary to read replica, they are not in sync with each other, in that case it might be possible that your read replica will always lag behind the primary. That should be acceptable depending upon you have done the proper proof of concept, wherein you will say, when we are doing the proof of concept, you will overload your primary application which is connected to your primary replica. And what happens, you have to monitor the lags which are happening. So you put your primary application on maximum peak, you go to the Azure tab, and there you check the lag of replication. That way it will show you, if you are bombarding your primary replica with this speed or with this much of workload, there will be a lag of, let's say, 10 minutes, 20 minutes, 1 hour, 2 hour, or so you can make some kind of assumption like, at this speed of the change of application on my primary, there will be a delay on the read replica side. So that is something which you have to take care. These are some of the conceptual terms like cross-region replication, wherein you can create your read replica in a different region from your primary server. And there is something called as universal replica region. So you can always create a read replica in any of the regions which are available, and regardless of where your primary server. So it is like one region you have your primary, and then there are several other universal replica regions where you can create your replica. So that way you have your primary replica in one region and your read replica in other region. So they are geographically separated. There is something called a spared region in that case. Let's say there is one region in one continent and other in another. So in that case, there will be a bonding between these two regions, saying that if you pair these two regions, then there will be that much of delay. That means they are best suited for creating the replica. So you just take care of that in case it suffice your business requirement. And what are the general steps? First of all, you need to have a PostgreSQL instance which is created in your Azure. Then you do some kind of configuration required. So there are three configuration required which are available, which is off, which is by default disabled. That means you cannot use the off. You have replica and logical. So replica is by default, logical, this is the minimum level of logging which is required to make your replication work. And this is what we are going to do in the preparation of the primary server. So I have already created a primary server, and then we are going to create a read replica. We'll create it, then we will check the status from the replication. Then the testing which we are going to do is, we are going to stop the replication, we will delete it and delete the replica, and we will see how it works. It is just conceptual only, and sometimes it really helps uh, when you perform some sort of migration wherein you have to do some changes on your primary, which is not possible. So temporarily you create a read replica, you do the changes over there, do the testing, whatever it is required, and then you can say like, this is what is going to happen if the same thing is done on my primary. So it is a quick way of doing the things. So we will go to this. This is my primary instance, which I had already created. And if you go to, so there are several tabs available over here. You have to go to the replication, and there you will say the add replica. So you have three options. One is off, which is by default off, because if you don't want to use it, it has been intentionally. And there are two more options available, replica and logical. If you wanted to learn more, you just click it and it will take you to the required documentation. The documentation in Azure for PostgreSQL is fantastic. You should read it and you will be able to see a lot of things about that. I'm going to add the read replica. So read replica is going to create a virtual machine having the similar configuration with your primary, and I will just name it PG 11 EMS replica 1. So we are going to create a replica. So let me create it. Okay. It is going to take, I believe, couple of minutes. And once it is done, we will see how it is, how we are going to manage it. So as usual, we will go to over here. It is going to take minimum of 2 minutes, I believe so. And in that time, what we will do is we'll go here and we'll go to the replication tab, and here you will see both will be available. As of now, this is PG11 EMS primary. This is my primary instance. PG11 EMS replica 1. That means this primary instance has a replica instance available, and the deployment is still going on. You can see the lines moving from left to right, and the progress is happening. And once it is completely done, it will show you the status available. So you need to make sure that the status is available. Though there is nothing great about this session wherein everything is being managed by Azure, but from the conceptual point, it may be good, like in what scenario you can use. And if there is a business requirement to have a read replica, you need to understand the implications also. If in case it is too much of write intensive primary replica, then there will be uh, the consequences according to the way it is created. So I'm going to just wait for it to get created. Once it is done, we will see. And what is that we will see over here is what is the status of the what do you say, the replication. So we will have to go to the matrices, and in matrices you will have to check what is the status of the replication. And this is very important, because when you are going to check the replication, you need to understand what is the delay in replication from primary to the read replica. So you have to check for in latency, you have to check the maximum lag across replica. That means between the primary and read replica one. So we just created one read replica. That's why we will be able to see one. So you can see that max lag across replica. It will show you the lag in bytes of the most lagging replica. If you say replica lag, it will show you over here. Let's first go ahead and check the status. It is still getting deployed. So once this is available, then only we will be able to see. And how do we mention it? The first thing, you have to go to the replication. In the replication tab, you will be able to see, you can see over the top, here it is master, here it is replica. Come on, this is sometimes very annoying when you are in hurry and when we are trying to deploy it, and it takes its own time. So the few things which you need to remember is you have to go to the replication tab, and the other is matrices. In the matrix, you have to select the scope, which one you wanted to monitor. We wanted to monitor the one which is primary, right? So okay, let us go back. This is our primary. Deployment succeeded. That's good stuff now. And if you go to the replication tab now, you will be able to see that master is this one. When we are saying master, that means it is going to accept both read and write operation. When you are saying replica, that means it is a read-only managed instance, which is going to have the read-only capabilities. The changes are not allowed on this particular instance. And now if you go to the matrices, in the matrices region, it will show you what is, if you see the latency part, if you see the latency, though we haven't done anything, so it is not going to show you, but it will show you the latency in terms of bytes. And you can see the replica lag in terms of the seconds, minutes, or so. So this keeps on changing according to the bombardment on your primary and the way the lags go behind the primary. So these two things you can check it from here. And what is there for our so that's more than enough, just checking the latency. And the other part which is important over here is, if you go to the replication part again, you select, okay, I should not select it, I should just highlight it. I go to the primary again, go to replication, you will be able to see primary and dr, sorry, the read replica. If you just select it, don't click it, otherwise you will not be able to see the delete replica and stop replication. For some reason, I'm going to stop this replication. When you say I wanted to stop the replication, stopping the replication, that means you cannot re-establish it. That means once stopped, it is gone. So you just say the read replica will become a standalone server. You just say okay, and this is gone. It cannot be reversed. Now it is going to be your uh, individual instance which has no relationship with the master. So if we go to this is still progressing. So once it is completely okay, you can see earlier there was just one Azure database for PostgreSQL server, because the other was a read replica. So now both are independent, the primary instances, and this is what we had it. It was a read replica. If you wanted to delete it now, or you wanted to do some other operation, you can do it the way you do it on a individual managed instance. So I'm just going to delete it because I don't need it anymore. Whatever uh, changes or application testing I was supposed to do, though we have not done it, but you can do it this way only. I just delete it. This is done. And this is my primary instance. I'm going to delete that as well. So this is also deleted. So that's all about the read replicas. Just a recap, read replicas are asynchronous replicas of their master, and we did it on the the single server, wherein you can have the PostgreSQL instance of 9, 10, and 11. It was Postgre 11. And we created a read replica, which was in logic in there are two options which are available. So either you go for off, or you go with replica, or you go with logical. So by default it is replica only. We use the replica. We created the replica, then we checked the lag, though we didn't do anything on the primary, so we cannot see it. But using the matrix section, you can check the lag in terms of the bytes, in terms of the minutes. And if you try to stop a replication, that means it is going to be irreversible. You cannot uh, make it again the replica, and you have to treat it as an individual instance, and then we finally deleted it. So mainly read replicas are used for read-only applications. So you can point out your applications towards the read replica, and it will be going to be helpful. I hope this helps. Thank you. Hello and welcome. In this session, we are going to learn how to load the sample database in PostgreSQL. So we'll directly start with the demo, and this is going to be very, very important because this is going to be the base for the upcoming migrations in PostgreSQL, wherein we will assume that whatever we are deploying as a demo database, because it should have some data in it, and that will be used for further migration in Azure environment. So let's quickly start with what we are going to do is I'm going to the virtual machine section, and I'm going to create a virtual machine. Let's just create it. I'm just going to choose the virtual machine with the minimum resource. I have Linux RG, which I had already created. And I'll say this machine name is PG11, let's say PG12 VM. This is the machine name, and this is 1 GB RAM, 1 CPU. I'm going to use the password, user ID and password for this. So I'll say Azure-user, and I'll give some user ID and password for this. And I'll just say allow selected ports. We need 2 ports. I'll go to the next section. I don't want to save the password. In the networking section, we will have to do some changes. I'll go to the advanced section, and I'll say create new. And in this section, what we will say is we want the access to the port number 22, and we also want the access to port number which is related to PostgreSQL. I'll say 5432, and we'll just say, so as of now this is open for most of the IB, but immediately after this demo we are going to delete this, and we'll say just management, next, next, and create it. So what we are going to do is we are going to deploy a PostgreSQL 12 on Red Hat Linux, and we have enabled 2 ports. One is SSH and another is 5432, which is the default port number for PostgreSQL, and we'll connect it through the PG admin, or we will go locally onto the system. And there is a sample database which is readily available. If you search for DVD rental sample database, you will be able to see that it is available, and it has some 15 or 16 tables. This sample data can be used later on for some migration and upgrade purposes. So we are going to use it as a base. So this is very, very important to understand how we are going to do it. Though everything is very, very basic, so it should not be a problem when you do it yourself. The only thing is we need to make sure that we are going to use the port number 22 or 5432. SSH 22 in case you directly wanted to connect to the virtual machine using the PuTTY, or 5432 in case you wanted to connect it through the PG admin tool or any GUI tool. In that case it is required. And we are going to start this particular part like how we are going to install Postgre 12 on the Azure virtual machine. So you can go to Red Hat Linux in PostgreSQL section, and this will give you all the steps which you are supposed to execute on the virtual machine. Then we will disable the SE Linux, disable the firewall if any. We'll add the Postgre admin user or the service account in the sudoers, and then we will change the password of Postgre database user. In postgresql.conf file, we will change the listen underscore address to the IP address on which that server is running. And then we will try connecting is using the host name which we have just created. And it will not connect because the IP address is not mentioned in pg underscore hba.conf. So we will add the IP address in hba.conf. We will restart the service, and then finally we will be able to log in. And the same way you can try it for the PG admin as well. And what we will do is we will create a database DVD rental. I have downloaded this code on my system. I'll transfer it using WinSCP, and then using PG underscore restore, you can restore the database into your virtual machine which you are just going to create. So this should be over by now. Yeah. Okay, so the one which I created, I don't know what happened to that. Okay, okay, I don't see it over here. Let me refresh it. Let me go back to home, virtual machines, and see. Okay, that hasn't come up, but I have another one which I just created few minutes back. So we are going to use this. This is the public IP. We'll use this. We'll open a putty session, and we will paste the public IP. Then we'll just say connect, and here we have to give the user ID and the password. Okay, I'm logged in now. See, the next step which we are going to do is we are going to install Postgre 12 binaries on it. So I'm just going to paste all the 6 commands in one shot, because this we have done several times in the past, so we are not going to discuss about it. Rather, once it is done, we'll go to the next step quickly, which is already discussed earlier as well. We will disable the SE Linux, because sometimes it really creates a problem when you try to connect to your system on the mentioned port number. So for this demo session, we are going to disable it. Okay, it's the 6 commands in one shot they are executing. It should not take more than 45 seconds or so. Okay, move on, move on. Okay, 1 or 4, 3 or 4. Yes. The initialization of database 12 is done, and this is also started. Instance is also started. Let's say the status. What is the status? The status is up and running. Let's move on to the next step, which says you have to disable the SE Linux. For most of our demo, we are doing this only. Let's disable the SE Linux. We have disabled this. If you say SE status, it will show you. Okay, this requires a reboot that we will do, and we don't have firewall on this RHEL, So SE Linux is already disabled. We'll go to this sudoers and we will add um, Postgre so that it can recycle the services when it is required to do so. I have searched for no password section, and here we will add this line which says Postgre all no password all. That means when it has to work as sudoers, it will not prompt for any password. So that is done. Let's now verify if we have the sudoers enabled or not, that we just enabled. So if you say ID, you are in your service account, which is Postgre, who is the owner of the software. Now the next part which we are going to do is, by default there is no password for Postgre database user. So what you need to do is, just in case you wanted to use the so it's a very common password which I'm giving, not recommended for any environment. So I have created I have changed the password for the role which is Postgre. I'll quit out of this, and then we will try whether we are able to and one more thing we have to do is, in postgresql.conf we are supposed to change the there is something called as address, listen underscore address. So here the it has, by default it is not going to allow the remote connection. So you need to replace it with the IP address. In case you have multiple interfaces, in that case you have to give those IP address. In case you have many and if you don't want to specify everything individually, you have to mention star. For our demo we have done that, and what we will do is we will recycle the service. So we will say, I should have kept it over here. So this step will be, okay, it's already there. Why? Oh, okay. There should be 12. This is 12 because we didn't. Okay. Let's restart the services. Okay, this is done. The status is up and running. Now we will try to log in locally. The host name is this one, and using PSQL we wanted to log in. So let's try. So this should not allow because it will ask for okay, you can see that the IP address is not mentioned in hba.conf. So we have to add the IP address. So let's add the IP address. The IP address and some of the client IP address also I have added in case it is required. And just recycle it. We are going to recycle the service. This you might have seen many times, so we are not going to discuss what is all this. Let's restart. Okay, this is restarted. Now you try connecting using the PSQL and the host name. Password we had changed already earlier, and you can see there is Postgre system database, and there are two templates which helps in creation of the databases. So what we will do now is we will transfer the software from our system to here. So what we will do is, using WinSCP we are going to do it. So we will say, okay, uh, session, I'll create a new session and edit what I will do is I'll mention the uh, IP address, and username, it's Azure, and this one I'll just say save, and let's try to connect. Yes. And what I will do is I'll go to the location where my software is available. So the software, which is the name is the backup, it is dvdrental.zip. So I have transferred it. Now let's go to your system. cd/tmp, you will be able to see that it is over here, dvdrental.zip. So just unzip it. When you unzip it, you will be able to see that there is a tar file and there is a zip file. So what next we have to do is we just have to execute this command. So let's create a blank database in PSQL and just say /l. You will see there just a default database. So we'll say create database DVD rental. So the blank database is created. So if you simply say connect to the database, you will not be able to see anything. It's all blank only. No relations exist. So what you do now is you have to execute this command. So you will say pg_restore -u, the admin user, the database where we wanted to import it, and the location of the tar file. So this is the complete file location which is going to be imported. So using pg restore, we are going to restore it. So it is not going to display anything on the screen. Let's go back to PSQL, just say /l. DVD rental, we created a blank database, but we do not know what data has came up inside. So just say dd plus, and you will be able to see there are 15 tables which are imported, and the data inside this that will be used for the actual migration. And there will be several kinds of migration and upgrades involved in the Postgres. So we will do it step by step. So this is how you are going to import a sample database in PostgreSQL. I hope this is going to help. Thank you. Welcome. In this session, we are going to learn how to migrate your PostgreSQL database using export and import. Our source environment is going to be on-premises environment or any other infrastructure as a service, or in other words, we can say there is a virtual machine which is there in the cloud. We are going to take an export from there, and we are going to import in Azure database for PostgreSQL on single server. So quickly, I will go through the steps, then we'll do the demo. So this demo is about migration of Azure database for PostgreSQL on single server. So what we are going to use is we are taking the approach of individual databases. So in this example, we have a DVD rental database. So let me show you how it is. So if you say PSQL over here and just say list, you'll be able to see that there is a DVD rental database. If you switch to DVD rental, you will be able to see a few tables inside that. I believe there are 15 tables, and that has all the 15 tables has a few rows, and they all are in public schema. We are trying to migrate this to Azure database for PostgreSQL, which I have already created. It is a single server, and it is with the Postgre 11 version, because that's a limitation. And if you see here it is, this is my Postgre Azure instance, and these are the default databases which comes in when you create this instance. So what we are going to do is from on-premises, from this environment, which is Actually, this is also a demo on virtual machine on the Azure itself, but just to simulate how it is going to work, we are doing this. So in reality, this is just, I think the version is 12.5 and the target is 11. So this pg underscore dump, that has that feature. If you wanted to go across the versions, then you can use it. So what we are going to do is an Azure database for PostgreSQL. So we have a demo source environment wherein we have Postgre 12, which is already installed, and a database which is DVD rental available. And we have something called as pg underscore dump, which is going to take the export of PostgreSQL dump from the source. And from the same host, we have a connectivity to the target server, which is PostgreSQL single server, which is a managed instance in PostgreSQL, and we are going to import it over there. So how do we take the export? It is very simple, and one of the basic stuff in Postgre. So you just say pg underscore dump, then you mention the host name. If it is whole local host, you mention it local host. Then you mention the admin user who has the access on that particular database. Then you mention the database which needs to be exported and the name of the file where you want to take the export. So what we are going to do is we are going to execute this on our source side. So what I'm saying is pg underscore dump hyphen host, which is the host name, or I can say the local host also, hyphen username. So my admin user over here is Postgre. This is a normal virtual machine with Postgre installed, and this is the Postgre admin user, which is Postgre itself. And the database which I'm going to back up is DVD rental using pg underscore dump. And the location will be /tmp dvd rental.sql. And I need to feed in the password for Postgre. And let me try again. Okay, this is done. So it is not going to throw anything because I haven't used the verbose. So now if you see, you should be able to see that dump is created. And this is an SQL file with the text format with all the SQL commands which are required to recreate the database. So this is available. The next thing which you have to do is, though in my case I have already done it, you have to create a single instance which is just a GUI, and you have to follow the step. I'll show you what extra you have to do. You have to make sure that, and the important part of this will be when you get it configured, there will be something called as connection string. Make sure that you have the proper connection string through which you will be able to log in. So your connection string would look something like that. You will have a host name. I have the host name over here. The port is default port. The user will be the admin user. At the rate, it will be followed by the host name. So if you see over here, it is when I created it, it is when I try to connect, it will ask you for the username, and in the username, you have to mention the PG admin, whatever admin user, at the rate the database, the server name, which is PG13SS, and then only it is going to allow you. And we are not going to show this because this is going to be very straightforward. We have taken a backup also, and Azure single instance is also created. What we are very interested is the connection security. The connection security, you have to make sure that it should allow the incoming request from the virtual machine or the host which is going to throw the dump inside it. So I have mentioned the IP address of the virtual machine and I have opened the port. If you don't do this, it is not going to work. And that's the only important step over here. Now importing the data on the target PostgreSQL server for PG admin, using the PSQL, and this is the command. We say PSQL --, we say the location of the .sql file, the host the target host, the target port, the username, and the database name. So this is the example, and this is what we are going to do it over here. And one of the important part over here will be you have to make sure that the let me show you. You need to ensure the IP address is there in your hba.conf. So if you go here, you have to say the host, the database name, and the username and the IP address. And if you have to enable the SSL mode, then you have to say host SSL all and the IP address. And if you execute psql file, the location of the file wherein you have taken the backup using pg_dump, and you mention the host, this is the target host, and we cannot log into the managed instance because we do not have the access to the operating system of Azure managed instance in Azure. So what we have to do is we need any intermediate host where you have the binary installed, and then only you would be able to log in over there. And you just press enter now, and mention the password. The DVD rental database doesn't exist, so what you need to do is you need to go ahead and create a database over there. So I'll say create the database DVDRENTAL, and the owner will be PG admin. This can be, the ownership can be changed later on. Once you create a role, you can grant the ownership to that particular role. So it is getting created. Once it is created, you will be able to log in. And the most important part is you need to make sure that you are able to connect to the managed instance remotely like this. So I'm saying psql-u username will be pgadmin, which is the admin user which is created during the instance creation, at the rate host name. This is important, otherwise it is not going to allow you. -h, the complete host name of the Azure managed instance. -d is the database name. And this is the way you have to make sure that you ensure the connectivity, and firewall rules are very, very important. Otherwise, it is going to be very, very easy. Now you can see there is a DVD rental database created using the GUI mode, and that we had created. You can use this way or that way. And then we are going to fire the import. Before the import, you need to make sure that hba.conf on the source side has the entry of the target. Otherwise, it is not going to allow you. And now we are going to fire the import. How we are going to fire the import? PSQL file, the location of the file, host. This is the target host where it is going to import the data. Port is the default port where PostgreSQL is running. Username is the username of the managed instance at the rate hostname. -db where it is going to import, and SSL mode equal to true. If password is correct, credentials are matched, then it is going to allow you the. So you can see that create domain and other stuff other than PostgreSQL, Postgre default database user, everything is being done. So you have, this is the main difference when you try to import in a managed instance. This should not be treated as an error, but this is what it is. So it has It is trying to import the tables, and it is trying the altering, and then finally it is going to create the indexes. And hopefully this should be done at any time. Okay, this is done, and if you refresh it and if you go to the DVD rental database, you will be able to see we have 15 tables, uh, and that's all about it. And if you okay, let me do a recap what we have seen. So we have two steps over here. One is the source server, which is on a virtual machine or on premises or infrastructure as a service. We have taken an export using pg_dump. We have mentioned the location of the file. Then using PSQL, we have imported. The important part, everything over here is you need to make sure that you use the proper user ID so that you will be able to connect to the managed instance. And you need to make sure that the firewall ports are open between the source and the target. And and hba.conf pg_hba.conf on source side must have the details of the target so that they can talk, because we are trying to import it from the source only, and all the details are over here. I hope this is going to help, and thank you. Hello and welcome. In this session we are going to see how to migrate your PostgreSQL database from on-premises to PostgreSQL managed instance in Azure. So here is a draft of how we are going to perform this migration. So we have a virtual machine which is on premises and PostgreSQL is installed on it. And on this virtual machine, we have the DVD rental database available, and this database has to be migrated onto Azure PostgreSQL single server. And we are going to use an intermediate virtual machine which is deployed in Azure, and PostgreSQL is installed on that. The reason is we wanted to use the pg_restore utility from the Azure virtual machine which is available, and using this machine we will communicate with the target PostgreSQL instance and we will perform the restore. So as usual, everything is available there in a notepad, and what we are going to do is we are going to perform the restoration using the command line utility which is called as pg_restore. So you have something called as pg_dump, which is used to take the backup of your PostgreSQL database. But for restoration, you have two utilities available by default in your Postgre installation. So you have something called as PSQL and another is which is called as pg_restore. So what makes us to distinguish like whether we should go for PSQL or pg_restore? And you have taken the backup using pg_dump. If you have taken the backup of your PGSQL used in the SQL format, then for restoration you can use the PSQL. But if you have backed up your PostgreSQL in a custom format or in a directory format, then you can use pg_restore. Custom and directory backup formats can only be restored by pg_restore, and they have better features as compared to the plain SQL backup dumps which has been taken using pg_dump way. One of the other important feature of pg_restore is you can restore the particular table or the schema, and you can also choose whether you wanted to include any schema, you wanted to include only data, or you wanted to restore both. So there are a lot of options which are available in pg_restore when you dump your PostgreSQL data using the custom format or the directory format. And you cannot convert your SQL format to the other format which can be restored through the pg_restore. So for this migration, what we are going to do is we are going to use pg_utility, which will be used to extract a PostgreSQL database as a dump file. So I'll show you how our setup looks like. For simulation purpose, we have created two virtual machine. The name of one first virtual machine is on premises PG12. So if you see this, we have this public IP, and if you log into that, so if you log into that, you will be able to see that there is a database which is called as DVD rental, and this database which is present on our on premises, that has to be migrated to the PostgreSQL managed instance, and we are going to migrate this. Our assumption is this database size is quite large, and we are going to use pg_restore, and because of the size, we wanted to make sure that once the backup is completed, it is transferred to a virtual machine which is in the same region where our Postgre virtual or this single server is available. So just for an assumption, the virtual machine, okay, let me show it a little bit back. This is my own premises virtual machine, just for an assumption, though this is deployed in the Azure, but this is our assumption. And we deployed a virtual machine wherein Postgre binaries are installed. This is in the same region where we have created a PostgreSQL single server where in Postgre 11 is deployed, and this virtual machine and single server Postgre, they are deployed in the same region. So let's quickly take a backup from the single server. So what we are going to do is we are going to take a backup in this way. This is a standalone, what do you say, the on-premises environment, wherein we have something called as DVD rental database is available, and if we simply fire pg_dump hyphen capital FC hyphen V hyphen host. This is our what do you say, the on-premises environment. I'll show you the host name. It should have been, replace it with the host name of the on-premises host. So the host name of on-premises host is on-premise PG12. So if you just press enter, you will be able to prompt for the Postgre password, and the database is dumped. It has been dumped, and then what we need to do is we need to transfer this. We need to transfer this dump to a machine, which is a virtual machine, which is there in the Azure. So what we will do is we will SCP this dump, and the location and name of the dump is this, and we are going to transfer it to what do you say, the Postgre, or let me, so it is available over here. So what we will do is we will transfer this this dump, DVD rental dump, from on-premises environment to the Azure underscore user, and we need to mention the host name of the uh, the Azure machine. So we'll take the public IP. This is the public IP, and the location where you wanted to transfer it. We will feed in the password. Okay, so chmod, let me put it as cd/tmp, and although I could have done it using the simpler way, but I'm just doing it chmod. I think I already have it over there. Azure underscore user at this is the target, and let me see. I should have it already copied over here. cd/tmp. This is my virtual machine in Azure. Okay, I already have it. dvd rental.dmp. So I'm not going to resolve this permission issue. So I'm going to the next step. Assuming that I have already transferred it, which I have transferred it just a few minutes back. And then what we are going to do is we have already created a Azure database for PostgreSQL single instance. This is the single instance. And if you see the connection settings, you will be able to see the host name is this one, and your username, wherein I created a user called as Postgre, but the username will be associated with the host name. So when we have to test whether the connectivity is there from the Azure machine or not, you need to make sure that you enable the access. So when I say the enable the access, so I mean to say there is something called as connection security. In the connection security, what I am saying is allow access to Azure services. So anything which is there inside the Azure service, I'm saying enable that access. So this particular virtual machine is inside the Azure environment, and the PostgreSQL managed instance we created, that's also there in the environment. And what we need to make sure that the firewall security rules are properly enabled for port number 5432, because you will not have the access to the operating system in a managed instance. And what we have to make sure that the pg underscore hba.conf should have the IP address of the managed instance, just to make sure that when you try the connection, you should be able to do so. Let me do it this way. If we have to try the connection, if we are able to connect from using the PSQL from the virtual machine which is there in the Azure. We have to say PSQL hyphen hyphen host. This is the host name of the PostgreSQL single server, which is a managed instance. This is the port number. This is the username which you can find from the connection info, and this is the database name which I'm trying to access. If everything is fine, it will prompt you for the password. And most important part of this is, if you say simply say /l, it will show you. So I have already imported it, so I'm going to drop it. Drop database DVD rental. So once it is dropped, we will try to import it again. So what is most important over here is you need to make sure that pg_hba.conf file is properly configured. So I'll show you what you should be checking it over there. Okay, the database is dropped, there is nothing now, and I have a connection already established. Okay, okay, SSL mode should be on. Okay, the database has been dropped now, and now what you need to check is when you check your pg_hba.conf, if you go to the bottom, you need to make sure that the access to the particular database where you are trying to access through the user, it should be available over there. If it is not, it is going to give you the error. Host, I wanted to say for the Postgre database, this particular uh, user should be able to log in from here. This is the IP address of your PostgreSQL managed instance, which is single server. And here now we will try the import. And if you try this command, okay, this is the command psql -host. This is the remote host where PostgreSQL single server is deployed. This is the port number. This is the username. The username is attached with the host name -- database name where you wanted to access, and SSL mode should be required. Otherwise, it will give you the error. If you remove this, I'm not sure if I have set the environment variable. I think it is environment variable is already set. If you do not set that, it is going to give you this particular error. It is going to give you the error connecting to the database for restore. It has failed. One error it is going to give you, the entry of the managed instance should be there in the pg_hba.conf in your Azure virtual machine, which is an intermediate server where you have transferred the backup dump, and from there you wanted to restore it. You wanted to make sure that the dump which is available should be restored in a faster way, and for doing that we are using pg_restore, which is a better option. Sorry. So we are going to use this command which says psql -host. remote hostname of the managed instance, port number, username, DB name, and the SSL mode equal to require. So let me copy and paste from here. SSL mode. Okay, I had it over here. SSL mode. Okay, it should be this one. SSL mode. SSL mode. Oops, where did I keep it? Okay, shift and all right. It should be the command SSL mode. Oops, where is it? SSL mode equal to require. Okay, SSL mode equal to require. Let me put it on the notepad and this should work. Okay. Yes, this is pg underscore restore. We are saying no owner, host name, and database name is DVD rental SSL mode. Okay. I got the problem. SSL mode equal to require. Too many arguments. Where it is? Okay, username is this, DB name is DVD rental, and SSL mode. We will take it out because we have already exported it. Okay, this is happening now. DVD rental does not exist, so what we will do is we will create a blank database now. I had copied it twice, that's why it is not taking it. Okay, so this is my managed instance. There is no DVD rental database, so I'm going to create it, a blank database, create database DVD rental. And once the database is created, we will test it like the database exists. Yes, you can say that the empty database exists. Now quit out of this and now try the pg underscore restore. So the intermediate virtual machine where I have pg underscore restore utility, that means a PostgreSQL binary is already installed. From there, we are going to execute pg underscore restore, and it is importing the data into PostgreSQL managed instance. So you can see the restore is going on. The important part is the SSL mode, which you need to turn on for the managed instance. And we mentioned something called as no owner parameter, which causes all the object created during the restore to be owned by the specific user, which we have mentioned over here. So we mentioned the hyphen hyphen username. The hyphen hyphen username is this, so it is going to be the owner. So few of the things which we need to uh, make sure over here on Azure database for PostgreSQL server. So you have the TLS and SSL connections are on by default. So if your PostgreSQL server requires TLS or SSL connection, you have to make sure that you import PG SSL mode on equal to require. Otherwise, it is going to give you this particular error. And the error is, where is the error? Okay, here. The SSL connection is required. Please specify SSL option and retry. You have to make sure that you turn it on, or in the pg underscore restore, you mention that SSL mode on equal to required, so that it will be going through. And how to optimize the migration process. So one of the ways to migrate your existing Postgre database to Azure database for PostgreSQL single server by backing up your database on the source and restore it on the Azure. What you need to do is to minimize the downtime which is required for the migration. What we need to do is we need to make sure that we use some of the switches during the backup only. So -fc. So once you use that, we can parallel the restore. So if you have more number of CPUs on the restore side, you can increase the number of parallelism, because it is directly going to fetch the CPU power. And you have to make sure that you increase the number of parallelism depending upon the CPUs which are there. In this case, there was only just two CPUs, so we cannot. Otherwise, what you have to do is you have to say pg underscore restore hyphen h. This will be the host name of your target managed instance. Hyphen u is the username of the target environment. Hyphen fc. Hyphen j is the parallelism. How many parallel channels or power you wanted to give to your import using the pg underscore restore. So you can mention it over there. We are not talking about the flexible server, only about the single server. And few of the things which we need to make sure for the PostgreSQL managed instance, that during the migration we need to turn off pg underscore stat underscore stat statements. You need to turn off pg underscore qs dot query capture mode, and you need to turn off pgms underscore wait underscore sampling dot query capture mode to none. And you can use a high compute and high memory SKU if your migration allows that because of the criticality. And you can scale down these once your restoration is completed. If let's say your database size is 500 GB and you are using pg underscore dump and pg underscore restore, in that case you should use the parallelism on a virtual machine in which is an intermediate server, and from there you can fire the pg underscore restore in a parallel mode, and these settings can be turned off in your target managed instance. And if you're talking about the IOPS, which is going to surely and to a great extent improve your restoration speed, but you cannot simply turn off the IOPS. For that, again, uh, you need to make sure that you test it properly. Otherwise, you have to again do a backup and restore. So just a recap of what we have done. We saw that there are two ways of taking the restoration into your PostgreSQL. One is using the PSQL, which is the standard format. Another is PG underscore restore format, wherein if you have taken the backup using the custom format or using the directory format, then only you can use PG underscore restore, which is a preferred mode wherein you can increase the speed by increasing the number of parallelism, and during the restore you have a capability of restoring the particular table. You can restore the data only, restore the schema only. So there are a lot of options which are available during the pg underscore restore way. In our demo, what we did is we have an on-premises PostgreSQL instance. We took a backup from this particular machine, which is on-premises. We transferred it using SCP to the PostgreSQL virtual machine on Azure. And from there, wherein we had created a managed instance. So let me show you the managed instance. So this is the managed instance which we created a few minutes back, not during this demo, but before that. This is the host name of that server, wherein you do not have the access to the operating system, but you have the access on the port number 543, to which we had opened the firewall rule. So firewall rule is very, very important when you work in this kind of setup. That's the only point of failures. And when you are working on the intermediate virtual machine in the Azure region, you make sure that it should be able to communicate with the PostgreSQL single server, and the IP address of that managed instance should be added in the pg_hba.conf. Okay, so we were talking about we used pg underscore dump and pg underscore restore. As a prerequisite, we had an on-premises Postgre SQL virtual machine on the on-premises environment. There we created a virtual machine in Azure, wherein we can transfer the backup dump from on-premises to Azure virtual machine. And from the Azure virtual machine, we are trying to import the data into PostgreSQL managed instance. We have used pg underscore restore. In our case, this is the data dump size is very, very low, but in larger environment, you have to use parallelism so that the data can be imported in a faster way. And this is the command which we use to take the backup from the on-premises pg underscore dump -fc switch. We used the host name of the source environment, then the user, then the database, and the dump file. Then this was transferred to the middle server, which is in the Azure VM, and then from there we use the pg underscore restore. So there are a lot of capabilities of pg underscore restore, and one of them is the parallelism. And you need to make sure that you tweak some of the parameters like these one if they are available, and you have to turn them off because they slow down your import speed. So they are pg underscore stat underscore statement, pg underscore qs dot query capture mode, and pg ms underscore wait underscore sampling. So if these are enabled, you ensure them they are turned to none. And also when you are using for the import, you make sure the machine should be having a higher compute and higher SKU, so that if it is a more powerful virtual machine, then your speed of migration will be higher. This is in general like why should we use pg underscore restore, what should be the architecture, and how to speed it up. But there are some more things which we can tweak it and ensure that the speed is much faster. I hope this basic overview is. Hello and welcome. In this session, we are going to learn how to analyze the options which are used to migrate the PostgreSQL to Azure single server or PostgreSQL as a flexible server, which is there in the preview stage. So what we are going to do is we will see what are the different options which can be used, like what are the criterias that decides like which how to migrate PostgreSQL, which is there on premises, or there is a virtual machine in cloud, and how to migrate it to the PostgreSQL in Azure. So we are going to learn the different options which are available. So as usual, I have mentioned everything in a notepad and we will go through that. For the demo purpose, though we are not going to do it step by step, I have mentioned everything where the same things have been done earlier as well. So I have a virtual machine which is running in Azure, and the host name of that virtual machine is source PG. We have Postgre 12.5 running on it, and it is a lightweight virtual machine. The another one which we have is it is a Azure database for PostgreSQL server. This is Azure database for PostgreSQL flexible server. So the for our demo purpose, what we have is the flexible server and single server. From the demo perspective, the only thing which we need to understand is the user which we are going to use to connect to the PostgreSQL for managed instance in Azure. So that is having the username without the host name. But in case of the single server, you have attached it with the host name. So that's the only basic difference. But there are a lot of differences. We are not going to talk about that. So let's go and see what are the things which helps in analyzing the options to migrate the PostgreSQL to Azure single server or PostgreSQL flexible server. So we can migrate the PostgreSQL in Azure database for PostgreSQL by migrating your database into the major version. So when we say major version, let's say if I'm saying 9.5, 9 is the major version, 0.5 is the minor version. And if I'm trying to upgrade it to 12.5, that means 12 is the major version and 5 is the minor version. So for the migration purpose or the upgrade purpose, where in the destination is there in the cloud for PostgreSQL flexible server, it is going to the higher version, which is the 12. So we will see what are the different capabilities which are available. So for this setup, we have the source, which is infrastructure as a service. So we have a virtual machine, which is, let me show you. So this is my virtual machine. So I have connected through it to it through the putty. And if you say psql-u postgre-h, then the host name, I'm able to log in, and if I say /l plus, it is going to show me the different databases which are available. The database for our usage is DVD rental, which is 15 MB in size. And the target database, the target is there in the, let me quit out of this, clear the screen. And our target is, the target host name is target Azure pg.postgre.database.azure.com. And we are trying to connect to it using the Postgre admin, which is the admin user for the database. And if you see the list of the databases which are available over here, this is Azure maintenance and Azure sys. They are the admin databases which are available in Postgre Azure, and Postgre, this is the default database which is available. Then you have the two template databases available over here. And now we have seen we have a source database which is running in Postgre, and there is a target which is we have created using the Postgre flexible server. We are not going to see how to create this we have already seen. So we'll analyze what are the different options which are utilized to migrate from on-premises, or in our case infrastructure as a service, to Azure PostgreSQL flexible server. So we have two ways. One is the offline method, another is the online method. When we say offline method, we mean to say that the database during the upgrade or during the entire migration, that will not be accessible to the application. That will be a complete downtime during the upgrade or migration activity. And once the migration is completed, then only you have to switch to your new database, which is on PostgreSQL flexible server. So in offline method, you can use pgdump and pgrestore. So pgdump, which is going to used for dumping the database in a dump in a file, and using pg underscore restore, the dump file which is created using pg underscore dump, it can be restored using pg underscore restore utility, and the restoration will happen onto the PostgreSQL flexible server. The other way is online method. See, online method is applicable when you want your source Postgre database to be up and running during most of the time, and using the database migration service tool, which is available in Azure. This is going to fetch the data from your source database, and it is going to dump into the target environment, and whatever changes are happening thereafter, it is going to pick up all of them one by one, and it is going to replicate it to the target environment. So database migration service is used for one-time load plus continuous data change capture. So that is known as CDC. So it has one-time load plus CDC facility. So it depends upon your application what method they want. If they can afford downtime, you should go for the offline method. If the business criticality of the application is huge, they cannot afford a huge downtime which is required for backup and restore. In that case, it is advisable to use the online migration service tool, which is database migration services. And what are the deciding factor? First of all, you need to check the database size. So if you fire this, though we have L plus, which you can fire into your source database, and you can find out like what is the size. Otherwise, you can use the SQL statement as well. And if you see, it is going to, using this command, it is going to show you what is the size of the database. The database in this question, which is a user database, it is DVD rental, which is 15 MB in size. We are going to migrate it to Azure PostgreSQL. Not actually we are going to migrate, but we are going to see what are the different options available. What is the decision maker for the upgrade? Like, on what basis we can decide like which way we have to use? The first one in this is the size of the database. If you see the line number 1, a small PostgreSQL DB, if it can afford downtime to upgrade, you can go for the offline method, which is pgdump and pgrestore. So this method is applicable if your database size is less and it can afford downtime. Go for the offline method using pgdump, execute on the source, and pg underscore restore, that is going to restore the database onto the target Postgre Azure instance. And this method is not applicable for DMS because you can afford the downtime. The second is small Postgre database less than 10 GB in size, regardless of whether it is asking for offline option or online option. If it is independent of both, then both of these methods are applicable. You can use pgdump and pgrestore for the dump and restore of the database. During that time, the database should be inaccessible to the application, and once you are able to restore the database into the target Azure instance, then you can switch your application. The other way is your source PostgreSQL, excuse me, your source PostgreSQL instance keeps on running, and it is going to suffice the application requirement, and using database migration service tool it will keep on loading the data one time, and whatever changes happen after that it is going to keep replicating them. So if it is a small database and you do not have any choice, you can go and try both of them. If your database is of medium size, the size is between 10 GB to 100 GB it is, and if you there is no restriction whether you can go for the offline or online, then you can use both the method. You can use offline way, wherein it will be unavailable during the migration, and using the DMS it will be available for most of the time, unless or until you decide to switch over during the last sync process. If your database is large in size and if it cannot afford the downtime, better you go with the online service, which is database migration services. If downtime is not a problem, size of the database is also not a problem, then it is always advisable to go with the native backup and restore utility. In this case, you have pg underscore dump and pg underscore restore utility available. Better you go and use them. The other option is DMS as the option, which needs modification and some changes. In case you wanted to go with that, there are some prerequisites that has to be met onto the source environment. And if you are going to use the DMS as the migration tool, then in that case, you can freeze the changes on the PostgreSQL source instance. That means DDL and the tables with no logging, that should not be allowed. Or it should be considered that no table will be created, or there should not be any table with no logging, so that the changes they are to be captured into the WAL files. Prerequisite for dump and restore your source environment. First of all, you need to check the version of the source environment. In our case, the example which we had taken, if you go and check the source version, it is 12.5. It is always advisable to have the target or the intermediate instance of higher version. And our target PostgreSQL, in our case it is also 12.5. So in case you are going to use an intermediate server, in that case you need to install a client which should be higher in version as compared to your source, because from that middle server or intermediate server you are going to run pg dump and pg restore utility. In case you wanted to run it from the source server, you need to transfer those dumps to the intermediate server. And one of the recommendation will be the intermediate server, wherein you are going to install the PostgreSQL client, from where you are going to invoke pgdump and restore utility. It should be in the same region where your PostgreSQL managed instance is running. This is going to speed up the entire migration activity because it has to be there in the same region, and the availability of the data speed will be better. What are the additional important points recommended for the consideration? The first one in this is you should use -c c along with your pg underscore dump. What it is going to do is, if you use -c, then it is going to uh, put create database command as well in backup dump. So if you fire this command, if you see this pg underscore dump hyphen, this is your source database name hyphen u, source database username hyphen fc. So in that case, you are going to put it in the customized format, the database name and the location. So we are saying pgdump -c-h. This is my source server name. This is my username, and we are going to put it in this file. So if you use -c, what happens? It is going to create database command will also be included into the dump file. Otherwise, what happens during the restoration time, if you don't use this, you have to explicitly create the database on the target managed instance of PostgreSQL. So this is to be considered. Second thing is, you have to find out the list of the databases that you wanted to migrate. In our case, if you simply say psql -l plus, this is going to show you what all databases you have to migrate using the and in this case it is DVD rental, which is 15 MB in size. The next step which is to be considered is the connection string. So the way you install Postgre on a virtual machine, it is same, because whatever you have done it on your or on premises, the steps would be same. But if it is a managed instance, what I mean to say is the Azure database for PostgreSQL server. In that case, if you have to connect, better you go to the connection string, and there will be something as PSQL, and here you can see the detail. What is the host name? You can see this is the host name, this is port, this is DB name which you wanted to. It is not mentioned because you may have many databases, so I'm saying I wanted to connect to PostgreSQL. The important part over here is the user. In case of the single server, the user comes up with the username at the rate hostname. In case of flexible server, it is without the username. So that's the only difference, and that is something to be noted. And you can find all the information from the connection string. And if you wanted to use Azure Cloud Shell, then you can use that. We wanted to talk something about the offline method to upgrade the PostgreSQL and the different challenges which are there. One of the challenge which is available is the supply of the password. In case you have to migrate, let's say I have 500 databases, each one of 1 MB in size or lesser than that. And if I have enabled the password, which for security reason we should have been doing, in that case, every time do I need to enter the password? No. What you can do is you can export there is an environment variable which is called as the PG password. So you can uh, export that on your shell, and what it will do is it will help in supplying the password when you try to log in. So let me show you that and how it is going to be helpful. So if I say env pipe grep pg, there is a environment variable which is pg underscore password. I have kept the password just for this demo. So if I try to connect psql-u, this is my Postgre source database server, whose name is source pg, and the user is Postgre. If I press enter, it is not prompting for password because I have already feed in the password into environment variable using pg underscore password equal to password. So it is helpful when you try to do the migration. You don't have to pass these parameters manually again and again. If it is a Windows environment, you just make sure that you put the set pg underscore pg password equal to whatever the password it is. In our case, what we have done is we simply mentioned export pg password equal to whatever password you give, it is going to take that. And the next thing, when you try to import the dump which you have taken in one step, and when you try to restore it using pg underscore restore, By default, SSL is enabled on PostgreSQL server. So it is not going to allow you. It will throw you the error. PG restore tool failed, and it will show you without TLS the error may read fatal SSL connection is required. Please specify SSL option and retry. We will see this, and what you have to do in that case is you have to set the parameter PG SSL mode equal to require, otherwise it is going to fail. And what you have to do is you have to execute this command for restoration. We have already seen this couple of times, so we are not going to spend more time on this. So if I say pg underscore restore hyphen v verbose, no honor, don't put the honor, hyphen host, this is the target database name, this is the port name, and this is the admin user, which is postgre-admin, hyphen dv name is postgre, and this is the location of the dump file which is created. Ideally it should prompt for the password, but it will not prompt because we have set the environment variable, and the source and the target password for the user which is going to be supplied over here, it is same. And it is saying pg underscore restore connecting to the, and it has started the import. And this is happening. The important point over here is, let it finish very fast. Come on, it's just 15 tables. So what you need to mention is export PG SSL mode equal to require. If you don't mention it, it is going to throw the error which says without TLS the error may read fatal and the SSL connection is required. So what you have to do is you have to say export PG SSL mode equal to require, and this is mandatory, you cannot skip this, so you better you put export this environment variable on the shell and get rid of any issue which is going to arise because of its absence. What next? Okay, we have restored the database into the target environment, and the most important part is how to migrate the roles. We have migrated the individual databases only. What about the roles or the users? So they need to be migrated separately to the Azure PostgreSQL before you are restoring the database. How can we do that? You have to use pg underscore dump all along with hyphen r. Hyphen r is for read roles only, because you explicitly wanted to capture the roles only. So ensure that you execute this command first. What is the syntax? The syntax is pg underscore dump all hyphen r. This is the switch which is used for exporting the roles only. Hyphen host, this is the source host name, then port, then the username, then the database, and then you give the output. So what we can do is using the pg underscore dump all, I wanted to take the backup of all the what do you say, the roles. So I'll say pg underscore dump all hyphen r, which is the switch for users or the roles. And if I simply, I have only Postgre, so it is going to show me the Postgre only. So if you just do the cat, you have taken the backup of the roles. In our case, I have only Postgre role, which is the default one, so it is going to show you. Create role Postgre, and whatever privileges it has, it is going to show you. The important point to be noted over there is if you have no super user and no bypass uh, RLS, then you need to remove those from that /tmp/roles.sql. Just graph for that, and if there are any lines, better you remove them. And this is the first thing which you have to do is you have to restore them. This is going to be the first step before you start the restoration. So you just say psql-f. In our case, this is just not what you say making any sense, but just for this demo we are saying, okay, let's import whatever roles you have exported using pg dump all -r switch. Just import it all. So it is going to throw you the error role or Postgre already exists, or error it must be super user to create super users. So one important point over here, the dump script should not be created to run completely without errors. If it already exists, in our case it is Postgre, which is already existing in the target environment, so it will show you, please, the roles already exist, so we can ignore that. And what else? Then you have pg dump and psql. Okay, then we will see these three options. So option number one, if you just wanted to use pg_dump and psql, that means you wanted to take a SQL format output, then you use pg_sql, and using psql you import it to the target environment. If you wanted to use pg_dump and pg_restore, which is highly recommended for this particular scenario, or any scenario wherein you have database size bigger in size, then you should use this. So the first thing which you should do is pg_dump -fc. We wanted to in a customized directory format, and if you enter it like this, okay, what is the name is source pg, and just make sure that you understand it is not prompting the password, because that's already exported. It has taken a backup, and the next thing which it will do is you have to restore it using -v, no owner, port number, username, and the database name. This we have already seen, we are not going to see it. Then the third option is streaming pump data to the target PostgreSQL. So that means if you do not have a PostgreSQL client, or if you just wanted to use the cloud shell, in that case, what you do is you make the SSL mode equal to whatever it is. Let's say it is require, and then you fire this complete command. So using this PSQL host, which is the target host, port is the port number of the target instance, database, and the admin user, it is going to import it over there. If you simply wanted to do it using the one line dump and restore as a single line, so the backup part you put it over here, pg_dump -fc, which is the customized format, --host, this is the source database name, server name, --, port. Then the username is the source admin user, -db, let's say it is dvd rental. Let's see this one. Till here, this is your details of the backup. Then we are piping it output to the pg restore. So in one line you have the backup, and then you're redirecting the output to the restore. And if you have let's say 100 databases, you replace the name one by one and the dump name, and you can do it for 100 times. Anywhere it should not prompt for the password, because you have exported that in a environment variable, and it is not going to prompt for that. These are some of the results which have been posted by the Azure, and it says if you have 1 GB of size of the database, then using this backup using pgdump, it is going to take 1 to 2 minutes. If it is 10 GB, it is going to take 15 to 20 minutes, and if it is more than 100 GB, it is going to take 2.5 to 3 hours. These are some of the standard results for the restoration. So normally we compare it to the 100 GB. So if it is 100 GB with say 2.5 hours or 3 hours, that is an idle time. But when you are using pg underscore dump and pg underscore restore, then you have the facility to use parallel backups and parallel restore. You utilize the power of the CPU, put it in the export job and put it in the import job, so that your export and import is going to be faster. So if your PostgreSQL source database is having the tables which are larger in size, then you can parallelize the dump and the restore. Let's say if I have 4 CPUs, you can put it to the parallelism to 4 for the backup, and for the restoration, if you have more, you can put it according to. So one of the CPU will be used for the one of the job. And it has been observed, like if you use the parallelism, then the if normally it has taken 1 to 1.5 hour, the same job is going to be reduced in 50%. So it is so much faster. So it is always advisable to use pg underscore dump and restore in parallel mode. So how can we do that? You just have to mention, I'll show you how it is. So we are going to use this way. So it is pg underscore dump hyphen fd. This is the source. This is source server name. This is port. This is username. This is database name. Hyphen j. This is the parallelism. Though I am wanted to make the parallelism degree of 4. This is the file already exists. Let me remove that. It is very small in size, just 15 MB, and but this is going to be very fast, because there will be 4 CPUs used in the backup process. And the same way, when you use the restoration, in that case also it is going to be the same way. So it is always advisable, when for you are going to use the migration using the native tools, always use the parallelism wherever applicable, according to the power of your managed instance. If so, it is always advisable you use a powerful managed instance, so that you can extract its power for the restoration and the backup purpose. Oh, the database doesn't exist. So if I simply create the database, then it is going to, let me create it. Create database, DVD rental, and then we will say, okay, the database is created. And now fire the import pg underscore restore in parallel mode. Oh, what happened? Target DVD rental. Yeah, here it goes. though you will not be able to using our visualization, it will not clearly distinguish that it is much faster. But if it is a bigger database in size, let's say 10 GB or so, then if your import has earlier taken 10 minutes, it should not take more than 50%. And it actually depends upon the power of your system and the parallelism which you have given. And that's all. The final thing which is there is about the once the import is completed, what we should actually be doing. Log into the target environment. The data is imported, and you should analyze the tables. This is going to make sure that you do not face the problem. So it is highly recommended to execute the analyze command in each database to refresh the pg underscore statistics table. Else you may face the performance issue. And last but not the least, always compare the postgresql.conf file to ensure that the parameters which are there in your source Postgre, they should be at least same in your target environment. It should not be lesser. If it is higher, then make sure that you identify why you have increased it. But if it is a managed instance with the higher capacity, you can increase it according to the requirement. But it has to be apple to apple mapping, at least for the mandatory parameters. So you ensure that you compare the PostgreSQL .conf parameter of source and the target. Otherwise, you may face several other issues. And also to the different lines which are connecting to it, ensure that the firewall ports are open so that they can connect to the new PostgreSQL instance and they connect to it. I hope this all is going to help, and thank you.